I'm watching.
That's not a closed container.
Well, I mean, he closes a little door on it.
No, but the freaking
Oh, I
can
said
evaporate into
more.
the air. Eh?
Bacon got it right. Yeah, Bacon got it right. Good job,
Yeah.
Bacon.
Thank
Right,
You
but
little
the
whippersnapper, you.
The beaker
Rohit,
that is
you were
sitting
wrong. We don't
on
wanna hear
the
from you. You
beaker
were
that
wrong.
is sitting on the scales is not contained.
I bet you
Right,
what's
so all
happening
the condensation.
is condensation. Yeah, exactly.
Yeah.
It got cold. It's ice versus glass. Yeah.
Oh,
It-
that's
It'll
right.
evaporate and condense on the outside of the walls.
That makes more sense than my guess, because I think my guess would be very, very negligible.
It's if you did the experiment in a different way, like displacement of water, then you'd realize it's the same.
Yeah, so what you're saying is that the humidity is condensing at the glass, and that's being picked up by, that makes sense too.
Picking up weight, on the outside of the glass. So a way to do this is to fill up a glass with ice and water and like measure the height of it and watch. It's gonna stay.
Why is it getting heavier?
Do it
What's
in a
that?
vacuum chamber.
Why is it getting? Oh, he's okay. He's taking the vacuum out. All right.
No, it's getting heavier because condensation is forming on the outside of the container or the glass. I don't know if it's an actual vacuum chamber.
So this guy don't know how to weigh shit, you're telling me? What is fucking fancy scale there?
Yeah, your guy on
No,
TikTok may not be the world's best scientist.
I would say condensation's
Look at
forming
that
on the
scale though,
outside.
bro. Look at that scale, dude. This guy looks like he knows what he's doing. Come on. You got a scale that good, Ruben?
You're right.
Does anyone here have a scale that good?
You are right.
And he's using like surgical gloves, right? He can't be wrong.
Dude, the scale. Look at the scale, bro. That's that's gotta be thousands of dollars, that scale.
That was my next recommended TikTok. Oh dear.
Like, what the fuck is this?
Well,
I didn't believe it.
your TikTok watch is if you keep it.
Hang on. I'll delete that. I actually don't have TikTok. So it's not a. I'm not on TikTok, so there's no watch history that it's working off.
That's
definitely
not. That scale isn't a vacuum chamber. It can't be. Like, look how he closed his door. He closes the door. It's a little sliding panel, you know.
Yeah.
You can't weigh water in a vacuum. How would you do it in a vacuum?
Well, you're on Earth. You're getting 9.8 Gs. 9.8 Gs a sec. You're always
can you do this in a vacuum?
Probably not, right? I mean, if you melt, it's gonna also boil.
Yeah. Why not do it in a vacuum?
Yeah,
what happens to water?
You could seal off the flask and put that flask in the vacuum on the scale and pull the vacuum, and that would eliminate any atmospheric condensation.
Yeah.
So you seal it. You're saying you seal the container with the ice cube in it. You seal that, and then you put it in something and you put it in the vacuum.
Yes.
Yeah.
So that no condensation forms on the beaker.
This guy's got a cheap ass scale. I'm about to message him right now. I'm like, you need to step your scale game up.
Yeah, he did.
His scale's sick. He just needs to put it in a vacuum chamber and see if it works still. Yeah.
Nah, fuck that scale. I don't even got a vacuum with it.
The vacuum would affect the water, right?
Yep. I mean, it's very hard to try to measure how much the water.
Oh my goodness!
It's gonna weigh more than the glass.
It's so easy to measure.
No, it's not, because the water evaporates too quickly in vacuum, right?
Oh,
so
have you guys ever went out while it's raining outside and tried to look straight up without squinting?
Oh, you see corpuscular rays of water.
I mean, how would you weigh the water? Somebody said water displacement. Right? You can't go off water displacement to see what things weigh, right?
Yeah, you can if you know.
Doesn't sound like a good idea to me.
So what you do, you just
It's
fill
not-
up
yeah,
a
it's not a
glass
good idea.
half and half with ice and water, like a slush puppy or something. Measure exact height. And as the ice melts, does the height increase or decrease? And you'll find that it always stays the same. As long as the ice is free floating in there and it's not being held up by anything, it's displacing all its weight.
I wouldn't go by water displacement to see how much stuff weighs.
Well, you wouldn't, but you're gonna. It's an exact way to see how much elevation or decrease in the water level, like as the ice melts.
So what if I put a helium balloon? Can we do water displacement with that? How about a steel ball and a ping pong ball?
Well, you're figuring out volume, a volume of water. Like, if you're trying to figure, it depends on what you're trying to figure out. If you want to figure out the volume of a ping pong ball, yeah, you could put it in water and figure it out. Yeah.
Yeah, that's for the volume.
But not the weight
They-
though.
They say that's where the word eureka, like, had its origin. With what's his name? What's his name? Archimedes. Archimedes, they say, was the guy who, took a bath and realized that like his body volume made the bath water raise in the tub to an equal amount, and then he ran to the king naked because the king had asked him how to find the volume of irregular shapes, and he did that, and then he got out of his bath and ran naked to the king, yelling "Eureka! Eureka!" But of course, that's just another Benjamin Franklin Santa Claus story.
Yeah, man, imagine living. Imagine, it's still such a cool story because imagine living in a
gets
world
the
where
point
you're like
across.
amazed by bathwater. I mean, that'd be like such
Uh-huh.
an awesome time. Like if I, like what,
Yeah,
like
it's
to
a
be a
good story.
full-grown adult and be like, what is happening? This is magic.
Mhm.
Be fucking cool.
Yeah, and I was looking into the Benjamin Franklin thing. I think the claim that they like to say now is that he discovered lightning is electricity. I just don't know how he gets the credit for that, though. I discovered lightning is electricity. It's like, you sure that was your idea?
Yeah, why not just looking up at it? Like, wouldn't that tell you just watching it happen?
Yeah, isn't that enough? Didn't like everyone kind of think that?
They all thought it was something else, I guess.
Maybe he was the first guy to like get it to strike his kite, or like to get it to strike a specific location, because he accidentally figured that out, right? Apparently, so the story goes. I don't know.
It's a long story of accidents. Like the Big Bang was an accident, Earth
He
is
was
an
flying
accident.
a kite, and he was like,
The
"Oh, look,
apple.
we can make it hit it if we use a metal kite in a storm, or like, you know."
The
Uh-huh.
apple accidentally fell on the one guy's head, and now this guy accidentally got struck by it. It figured out lightning. It's just like
Yeah,
it's like
the
just
guy
accidents are a good.
Probably didn't travel.
over flooded the tub, hopping in it.
Yeah, accidentally up
Bunch
another
of accidents.
Yeah, we're all just one big accident. It's such a beautiful accidental design that we are. As we watch like TV and talk on our iPhones, it's definitely was an accident too.
I mean, if you look up Ben Franklin, it's like he invented the lightning rod, you know? So there you go. I mean, he invented other shit. These guys were good, honest, hardworking people. Like, the world wasn't always a satanic pagan holiday, you know? Good Christians and good men like did exist.
One guy's Satan is another guy's, Jesus, I guess.
Today it's just garbage. It's like, let's find out if God exists by smashing particles and creating black holes. It's billions and trillions of dollars spent on that, right? And it's disproving God. Fighting.
Was there any
fighting-
big announcements? So, I mean, I wasn't keeping up with it, but I heard lots that they're turning CERN back on after a couple of years. Was there any big news that came of that?
No, I haven't heard.
No one's heard anything. Oh, that's too bad.
Pay attention, honestly. I just said, what am I going to fucking do?
Other than they're
Yeah.
literally Einstein, or who was it? Hawking. He said Hawking's. He said that they might destroy the universe. Like it has the potential.
Yeah, and we don't take a vote on if we allow these people to play around with holes like that. It's like, yep, they can do whatever they want.
Do you think that's funny though about that video that I pulled up for you? Isn't that weird? Is he still here? Yeah, he's still here.
What video?
Well, the video of the setting sun, right, where it doesn't set on a horizon, just fades off into the distance and seems to shrink a little bit. Isn't it just so weird that
It's pretty cool.
Huh?
Yeah,
it
it's
is
pretty
cool.
cool.
But no, the weird
And it
part
doesn't
is
really
that
lower at all either. It does appear to just be moving away rather than lowering.
yeah, and there's lots of examples of that, right? So that's why there's that whole perspective idea. But that's not the weird part. The weird part is that we were going over the July 8th thing, and then that video is specifically labeled 4 years ago on July 8th. I just thought that was so kind of creepy.
The
we were talking about the whole July 8th, where the 68% of the globe, was covered in sunlight, whatever. I don't want to get back into it, right? And how the significance of the July 8th and July 4th, whatever it was, right? And then we were talking about something else. I said, I think there's this video of the sun like fading out, and it was just it's kind of creepy how then it's labeled right on there, July 8th, sun fading out.
It's all fuzzy and out of focus to me. It doesn't define.
Both are explainable. Both are explainable.
Why do you think it fades out? Like, what causes the fading? Did like a big cloud like evenly like roll in front of it, getting like thicker and thicker or something?
You don't need that.
Well, yeah. Why?
What made the sun stop moving, or the Earth? What moves? What made the Earth stop rolling?
What?
Well, the sun's
The
just
one where
sitting there.
it's at the same height, right? It doesn't lower and fade. It just fades. Why do you think it just fades without lowering at all?
That
doesn't
dirt
look like
video
what-
is just out of
going on.
focus and fuzzy. Yeah.
Yeah, so it looks like there's a lot of glare, and that circumference around the sun is what maybe you're picturing at the sun. And as the sun goes beyond the horizon, there's less and less light coming from there, so the glare shrinks. So it doesn't change position because that's all around the same point at the horizon, but it
It's
gets
not
smaller
height
because there's less and less glare. That's basically it.
Right, so we don't need a physical curve to have sunset. We just need it to fade away and not be able to shine any further.
Yeah, but you wouldn't do
The light
that
can't.
vertically if it's making circles above the Earth.
It's not really what we see either.
First of all,
I'll
put
try
your
to make a
mouse.
GIF or something of that
Put
part.
your mouse at the start. Like at the start, put your mouse like on the sun so that it's at the edge, and then play the video and watch how it does set the entire time it's setting. Like you can,
It's always setting, but what do we consider setting?
and it's setting, and it's what? Sorry, it's setting
Are we
as in,
saying that
as in
the Earth is
is
spinning?
rotating, as in the Earth is
Right.
rotating. Yeah, away. Like the viewer is getting further and further away, rolling. But it is definitely setting. It's not just shrinking. Good explanation, though. It gets there's less light, so it's getting less bright and less glare and all that. Yeah.
Yeah, the sun can no longer push through the layers and layers of our atmosphere, and it can't, and it can't shine its light on the
Oh.
Earth, and now it's nighttime.
If that's the case, how you would get something like what left lane sent?
He sent or
Yeah,
Yeah, we've got
You
much
posted
better
something?
footage, right?
yeah. The sun is cut by half, right?
Oh.
Right. And, I mean, if you have magnification on the atmosphere, as Jay something said,
It's a big
that would
sun.
be only vertical.
Rohit.
And
Yeah,
the whatever camera he's using can only it reaches a limit to how much it's going to capture. So eventually the whole thing looks like a red mess. The it's just so nothing. It's nothing.
What, left lane's post? Yes. I mean, it's nothing that we can figure out, or you. We can,
Yeah, it's so simple. It doesn't this plus the other video don't amount to anything, you know? Like they're both explainable. In my opinion.
maybe. Yeah, I mean, it's explainable. You're right. I mean, the first video I posted perfectly explains why we have day and night. Yeah. The sun has a limited amount of light that it can produce and cast upon certain areas of the earth, and it takes its light around with it.
So I posted the GIF, right, of it fading away, and it's a circular light. So why do you think it's appearing circular? Like
That's
you're
what
saying,
happens.
that's not the sun, right?
That's what happens
well,
when
that-
it's out of focus, as left lane mentioned. Like when something is out of focus, the light rays are not converging at a single point. So
Okay.
yeah, they spread around where they're
So you're
supposed to be.
saying, so you're saying that's like a very small portion, like maybe like 20 degrees of the sun still poking over the horizon, but it's not, instead of appearing like a sideways D, you know what I mean? Like a sideways capital D, it's appearing circular, even though what would really be above the horizon isn't this circle.
Yeah, that's good. And because the light rays are parallel, we can throw in that.
Yeah. So I mean,
This, the
you
capturing
got an option. So you
It's
have an option if you guys went out of this globe thing.
it's the capturing
Free
device
play.
as well. Like if you had a better capturing device, like this guy captured it with a shitty camera, and it's only capable of producing this kind of image. But if you captured it with a very sophisticated, you know, binocular
Find the other
telescope,
ones. Yeah. As like I was saying to Bacon, you see it's labeled number 3. He's done it like 15 times. I can't find the whole file of it. Like some with the solar filter, some without it. Same
Okay,
result.
they're all bad. Then doesn't
Okay.
matter if there's a bunch of bad data. It's just a bunch of bad.
Well, that's what I'm saying. They got different. I mean, if I'm right now, I'm just saying this. It doesn't matter. I got to sell it, but I don't know where they're at.
can we also say that if he suddenly jumped up 1,000 feet, like the Hulk, he would see the sun again. You know, it's only disappearing past this guy's horizon, and that
He's on it's a drone right now, and he does it where he rises up and stuff.
it's not fading out.
That would happen on a flat plane.
No,
Yeah,
on a
he's
flat
got
plane,
he's
still
using
be able to
a
see.
drone. No, he's using a drone with a camera, and he rises up to show what you know what you're talking about. I think
Oh, yeah?
if you watch the whole video, he's using a drone and he tries to rise to up, and this is the point where he like it tops out, where you can't rise and see it anymore. But yeah, that you could imagine that could happen, right? And I'm sure that can happen with certain things. Like you can rise up and see it because you're getting a bigger angle on it. You know, you're seeing it from a different, you know, better
There's
angle.
less ground obscuring your
Right.
view.
Yeah, like
Yeah.
people will say the thing like, how come things drop below eye level in the distance? It's like, what do you imagine is going to happen? You think the ground is going to rise up to make up the difference? Like for you, like imaginary ground is just going to start appearing and to bring it up.
When we were children, when we played outside before the age of computers in the house, we would go in the tree we climb up in the tree and we can see farther. Not
Yeah,
because
buddy.
we're bending, but because we had a higher perspective.
We just didn't know it was because Earth bent, past the fort. Yeah.
The
I thought the Earth was bending, but when I checked, it didn't.
you're talking about short
know, but it-
distances.
Yeah, short distances, like I don't know, I can't say everybody, but most flat earthers prescribe to one set of like physics. Like it's all the same, just about. Like like there's no astro light and like different types of light or different types of distance. It's all the same type of thing happening. So I don't know if it would really matter the distance. Once that light is gone, once it can't shine bright enough anymore, you can't. There's no amount of height that you can get to see it.
Yeah, there is. Yeah, there is. And first of all, you get really high, and then you get a certain distance away from the Earth.
Outer space, right? I got you.
No, you'll see the sun behind the Earth if you're still at that angle, of course.
I'm just an ant on a basketball, man. Don't ask me to do all that.
Yeah.
I'm like an ant on a basketball, but
Like
suddenly
there is
I
a
can
height.
rise above it.
You're saying there isn't a height, if this guy increased with a helicopter, there is a height where he would see it, and eventually he would need a spaceship. It depends on how
let's put these two ideas together, right? So I'm saying there is a height, right? That once you get to that height, no matter how high you are, you're not going to be able to see it because it's just not bright enough. And in your model, right, like what you're saying is no, but and then in yours, it's like I'd have to be high enough, right? It'll be on the other side of the globe, right? So
No,
we'd
in
have
your
to get in a
model,
spaceship and go to outer space.
in your model, it'd be the same. You'd have to go high, and then you'd look down, and you'd see it off in the distance, like just the same. And the further out you went, you'd be able to see it at all times if it was flat, right? Like once you got above the cloud line.
What I'm claiming is that at a certain point, no matter how high, you won't see it because of how much atmosphere is blocking the sun, so you won't be able to see it. You're claiming that at a certain height, you'll be on the other side of the ball, so you won't. It doesn't matter how high you get until you get to outer space.
Well, no, our model is clearly shown. You've seen it a million times. The sun's way out there in space, and you know exactly what it looks like and all that. You've studied this shit more than I have. So I don't need to explain my model, asshole. I mean, on your model, it would be behind the Earth if it like went behind the disk or the flat
disk,
whatever flatness, whatever. If it went underneath the horizon,
no, it doesn't go underneath. It just goes beyond what
bro.
you can see. Yeah, are you serious?
I don't
know.
It just stays on the top. Yeah, I know.
It just goes beyond.
So why?
You just yanking our chains here.
But then you can't escape the atmosphere. Like, is what you're saying is we can't get high enough. I get it. Like, but
within the atmosphere, right? So even you and me, right? We can't get high enough. We have to get into a spaceship. So you and me can't get any.
What we're gonna do
at a
is get
certain
in a
point,
balloon.
we're tapped out.
What's stopping us from like flying off into whatever it is? Like, what's stopping me from, say I had millions of dollars and I had a rocket, what's stopping me from, say, crashing into the moon?
Rockets are difficult. The most you could probably get your hands on would be a balloon, like Felix Baumgartner set the record for highest anyone's ever been, aside from astronauts.
Yeah, sure. But okay, so what's in the flat model? Like, what's stopping me? Some say dome, and obviously, like, what do you guys say?
Transportation.
Just like our lack of technology, or like our limited.
Yeah, we don't. Yeah,
You can't.
we don't.
there are people with rockets, but you know the amateur rockets, the Go Fast was the highest amateur rocket, right?
Yeah, it's creepy too.
So
But,
when
you
it
know,
when
that's
it hit,
the limit right now.
sometimes you guys say like the Operation Fishbowl, like where they hit it with a nuke and it like explodes or whatnot, right?
That's what they said they were doing.
So I
Yeah.
hear.
I don't know
That's
if I
what they
can
say
believe
they were
that
doing.
story, but you know,
Yeah, the government's the one
you might
saying
know
they
more
were
about
doing
that
it.
than me.
Well,
I'm not the guy to
to
answer
my
questions on that
understanding,
operation.
to my understanding, they launched a nuke above the atmosphere, and as it came down, it was designed to explode like at a certain altitude.
Why do you
So,
think they did that?
well, they're freaking ridiculous. They wanted to punch a hole in the ozone layer. I forget what it was. It's probably there's some kind of secret mission, and then there's the
You're saying
official
there's some
story.
kind of you're saying there's some kind of dome above us that they have to punch a hole into, man. Why are you?
Well, listen,
dome,
well, you guys bring up Operation Fishbowl like it's like when you crash into this thing. Are you hitting the stars? Are you hitting like what we see as like the painted sky kind of thing? Is it a
I don't
like
know, but the thing that interests me in that GoPro when it goes up and goes kerplunk or whatever the hell happens when it hits, I don't know, a different medium, right? Is that you can
I don't
see
think
the
that
moon that
happens.
should have the moon that should have been on the other side of the globe at that time.
When
That's
it
the thing
stopped
that sticks out. Who
rotation, I
knows?
think those were just air brakes, man. You know that
Right? It could have
you
been
know the
it could have
technology
been
they.
anything.
Yeah, I think those were just the brakes right there going on.
It could have been a bunch
whatever
of
it
different
was,
factors. Yeah.
whatever it was, that point in time in the video, what were you saying about it? Like the moon, what?
Why are you
The
bringing up
moon
the
was
moon?
supposed
The
to be on the
GoFast
opposite.
rocket has nothing to do with the moon. Oh, my bad. Yeah. Go ahead. Sorry.
Yeah, no. When the rocket is falling, whatever, spinning back down, it clearly gets the confirmed moon in its view, right? And it was supposed to be on the upside down other side of the globe.
It was supposed to
That's
be
what I'm
No,
trying
it
to.
wasn't. No, it wasn't.
I
That's just
I think
yeah. That's a bad time.
Alright,
Like
well, then maybe it
if you people who think the moon was supposed to be on the other side of the globe, they didn't get the time right. They used the timestamp for 3 hours after the launch, not at the time of the launch. At the time of the launch, the moon was not over
fast
Australia
moving
yet.
moon.
maybe someone can
Fast
link the
moon.
argument
Yeah,
or the
15 degrees
debunk
an hour.
of that idea that
Yeah,
explains all the
15
details.
degrees an hour from a certain distance makes the distance would also matter there. But
Well, it's
That's
there. The moon's there. Listen, the moon's there. Even though I haven't seen the video, the moon's there, okay? And the Earth is bathed in light, so it's not visible to set population, but then it's gonna be visible to the other when it rotates enough
if
underneath.
you can see through the Earth, I guess I don't know.
No, once enough time passes, like the moon's there for 1 day. It takes 30 days to go around, so it's there in the video, and it'll be there like 10 minutes later,
3
20
hours.
minutes. Yeah. The Earth is
no,
His
rotating.
argument is stupid. Okay.
My
yeah.
argument is that the Earth is rotating.
That is not the explanation for it. Yeah,
Oh.
we see them.
Go
Yeah,
ahead.
he was being launched from Colorado, right? So from Colorado point of view, the moon is going around the Earth around once a day. That gives you around 15 degrees an hour. So the GP of the moon moves around 15 degrees an hour. That the timestamp that people use to say that the moon is the other side of the Earth was 3 hours after the peak of the launch. And so yeah, the moon, the GP of the moon, the ground position of the moon, will have moved by around 45 degrees. Each degree is 69 miles, so that's like a huge distance. And
was
if you,
he
That
It's
was
another
a
side of the
plane.
ball.
was he
Sorry?
drifting? Was he drifting or like stationary above where he launched?
oh, it wasn't too far from where he launched. You can see like by the, it's a very quick launch, and
You got to remember, Coriolis
it's not
says,
that
it
significant.
keeps you in the same thing. You land, you shoot up, you land right back down where you came from somehow.
He didn't.
I hear
land
ya.
back down exactly at the same spot. It's not happened, but anyway, you
Pretty
can
close.
see.
He didn't shoot up and come down in China. With the
Yeah,
Earth spinning below him.
should it land in China? That
No,
makes no
that's what I'm
sense.
saying.
Where are you getting this from?
I'm dismissing
Depends
that.
on
That's
how
what I'm
long.
saying. Yeah.
Depends on how long and how high he went. Yeah.
Yes. So anyway, you can see from the footage that it's still above the US at least, right? And you can
I
pick the
have it.
position of moon and sun at the exact moment that the rocket reaches its highest peak, which is 73 miles high. And both moon and sun should be visible, should be about, I think, 15 degrees above the horizon, both of them. And that's sort of what you see on the video. So like, there's no problem
China
for the
confirmed that they had a moon in their sky. I mean, they said, "Oh, there's a moon. We see it in our sky." What do you mean? You shoot GoPro rocket in America? You see moon? No, it's on our side of the globe. It was
It
in
wasn't
China.
outside of the globe.
China.
It was.
It just was. I mean, it just was. It's what it is, man. I don't know. It's very strange. They refracted around. I don't know. It was in the video.
Yeah, you
It
don't
was
know.
supposed to be in China.
It wasn't.
Well, I'm gonna say it was
Where are you getting this from?
from the video.
How does the video tell you it should be in China?
Yeah.
China said that they got their moon. They confirmed it. How are they seeing the moon?
It's far out. It's far out.
Yeah,
Bro.
the moon should be visible for around half of the Earth. And if the moon is close to your horizon, it means you're close to the limit of how far the moon can be visible from. So why would that be a problem?
Yeah, because it was on the opposite.
Well, we've gone
side.
What? Someone cut out there.
I think it was Geo. Was that Geo?
I think he was picking up on my insincerity, and he was telling me to be more sincere and stop being a dick. And man of little words he is, but I felt him. I was being pretty insincere, but I am being sincere in pointing out that the moon was in that video, and there was people who have called out that it was supposed to be on the other side of the globe at that time.
It wasn't
And
supposed
Bacon
to be.
is saying, Bacon, you're saying that it was so far off to the left that both the people on the edge of that side and the people on the edge of this side could still see it because it's high up in the air.
I sent on Livestream one text where the terminator lines for both moon and sun should be. The US is between both terminator lines, so both should be visible from the surface. If you use the altitude of the rocket, that the radius of that circle, well, it doesn't look like a circle, it's a projection, but the radius of that circle increased by like 10.9 degrees, which gets even larger. So there's no inconsistency there. And the moon, it wasn't above Australia. You can see where the moon is.
I'm gonna have
It's just a picture.
Smoke some weed.
Yeah,
it's
that's
just a
the
picture.
picture. That's the picture where if the sun and moon are things above a globe and can be seen by a radius of 90 degrees over the surface, which what would happen on a globe, those would be the terminator lines for they to be visible. And the US
Listen, you know how it could happen. You know how it could happen on a flat Earth is the same way. Like listen, wherever you are, man, all I'd have to do is walk in a straight line and get there. Right? You're not upside down from me. You're just really far in front of me or behind me or whatever in that direction. So yeah, on a you can look up and at a certain angle see the moon in two different places. Of course, you can see it probably anywhere. I don't know, right? But there might be a limit. But Yeah, two people from different places on this earth can see it. Yeah, above
Right.
their
So
head.
if I see the sun on my horizon and the sun is overhead for you, do you think we can still be both? You're just very far from me, on front of me.
Yeah, we're just very far from each other. Yeah, so you're seeing it on a different angle as you walk away from it until it sets.
Not arguing
Right?
for. I'm not just arguing for a different angle. The sun is like half of it below my horizon, but all of it is above your head, and we are both of a flat surface. You think that makes sense? Think that sounds possible
Yeah,
to you?
I guess so. Absolutely. Whatever I think, if you're saying what I'm saying, then yeah. So the sun is above my head. Yeah. And you're whatever you start walking away from me, far, and the further you get, then the sun starts to drop lower because you're getting further from it until it converges into the ground, and then that's when it sets. Yeah, because
Yeah,
you're so
but
far away that the light no longer shines and reaches you,
there's no
and that's the setting
distance.
sun.
There's no distance that would give you half of the sun above the horizon and half of the sun below the horizon.
Yes, there is.
Of half of it above and half of it below. I don't know. Listen, man, but the world is
So
a
so you say
stationary
Different
then.
plane.
objects vanish
That's
from
what's
the
happening.
bottom up, not from the top down, obviously, because logic, right?
Yeah. Yeah.
Huh?
Can you demonstrate that?
It's just not how perspective works, God.
I
Perspective
mean, I
isn't
can
like
demonstrate it all
If
the time, every day.
if
Yeah,
there
like
wasn't
down
an
the
When I walk away.
atmosphere,
look
if
at
it
the
was
street lights down the street. You see, notice that the top's angled downwards. Angle down, 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 down. Now, what's the logical conclusion to that angle? Is it going to go up in the sky or down to the ground? Which way?
yeah, but it's quantifiable. The amount it gets, the amount it goes down, and the amount you get further from it. That's quantifiable. There's a relationship that is described mathematically by how
That's
much it's
right.
going to go down.
And if
That
you
that
just have to remember that at
let me
the
get
end
to
of
the end of my sentence,
energy,
Godric. Let me get to the end of my sentence. There's an amount. It's I'm sorry. It's mathematically described how much it goes down based on how much you go further away. And if you try to apply that to the sun or to anything at all, there's no way you can get over a flat surface half of it missing and half of it being visible.
What interested me was Ruhif, like when I first came into this conversation earlier, like 2 hours ago, was Ruhif was saying that we really need to put more study into perspective and start measuring these things, and we just don't have the data on it.
yeah, Bacon, you just forgot the part where distant objects vanish into the horizon.
Sorry?
No, the problem is when it comes to flat Earth, people like Bacon boil it down to just perspective, right? I can
No.
show you a demonstration on a flat surface where things disappear bottom up, and with other factors involved, like refraction, for example.
I'm not
I mean,
discounting
that's
that.
the one you pull out your ass when it's
No,
further
yeah,
below.
I'm not
But
discounting
when it
that.
comes, no, you just did. You said perspective is a mathematical thing you can measure. So
That's
I
right.
didn't
nobody's
say
It
boiling
measure. I
it
is.
didn't say.
down.
I didn't even use the word measure.
Let me finish.
First of all,
You finished.
you're misquoting
Okay,
me.
okay, I'm done. Go ahead.
Right. So what I said is that perspective cannot do that. I didn't say nothing can do that. So if we're saying that I'm making
So you're making a straw man.
no,
Yeah.
Godric said no. Godric's point was about perspective. As what no things just described. He said as you go further from it, the angle goes down. Like you have a smaller and smaller angle.
The word
That
perspective.
is perspective.
Okay. Let me clarify something. When
Can you stop
the word
making
perspective.
background noise?
Yeah, whatever
Yeah,
you're
he
eating
does.
is coming across the mic.
Yeah, sorry guys. I'm done. But when someone uses the word perspective colloquially, they mean just how you perceive things, taking into account all these factors. Because when I perceive things as a person, I'm perceiving perspective as well as refraction, as well as whatever other factors there are, right? So, in the colloquial sense, what Godric was saying when he said perspective, I don't want to speak for him, but if he can just clarify, like,
Well, you are.
maybe confirm. Well, I'm asking him to confirm or deny what I'm saying, or just clarify what
Finish
he
saying it so
meant.
he can confirm it.
I'm just talking about the colloquial sense. You can get sciencey with it. Go ahead.
Yeah, that's what I meant. I mean, when someone, like what Godric was trying to say is, with perspective, the word perspective is just how a person perceives things with all these factors involved. Not just perspective in your mathematical sense, as you put it, Bacon. He meant a holistic view of the word perspective.
Well, he explicitly exemplified what he meant by with the what do you know, what's the name of those? The thing that goes down as you go further away.
Yeah, that's part of
The
it.
light.
That's part of
Yeah.
it.
So he
That's part of it.
Is
Do
it
you
refraction?
deny?
Is
Wait,
it
hold on. Do you not
no,
deny that it's part of it?
no.
Okay,
Is
so he said, yeah, he
let me
said it's part
answer
of it.
you. Let me answer you.
No, I'll cut you off
Yeah,
because you're
chill,
You
man.
can't
hitting a
keep
straw
cutting
man.
me. You keep
No,
cutting me.
well, you cut me, but you
No,
claim that you had the right.
First of all, I was trying to get.
Hold on, Bacon. Just calm down. Calm down. Again,
Chill out, Bacon.
you're-
Why are you losing it, bro? You're losing it,
Yeah.
man.
Okay, because you
Yeah.
keep interrupting me.
You're I'm
Okay,
kidding.
I
You're
mean,
doing
he
good.
speaks for
Bacon,
5
the
minutes. I
floor-
said 2 words and I get
the
interrupted.
floor is yours.
Right, he specifically said that when you go away from something, the angle drops. That is not refraction doing that. He
Is
wasn't
that
mentioning
not
refraction.
true? Is that not true?
What is not true? No, I already
What he said?
answered that question and said no. Yeah,
Is
it
the
is true.
observation itself true?
So
It is true. I'm
Okay.
not challenging that claim. That has nothing to do with what I'm saying. But what
Yeah,
he's
but, did he-
exemplifying there isn't reflection. He's
he
exemplified perspective.
exemplified a part of perspective.
Let him
That's what I'm
finish his
clarifying.
explanation. Yeah, let Bacon finish his explanation. He gets halfway through it and he's getting cut off.
Right. If you want to claim that refraction is doing that, you feel free to do so. But that wasn't his claim, right? And I was addressing his claim when something goes down. For example, if you're trying to determine the size of a building based on how much angle down it is, that's perspective. You're going to use perspective for that. You're not going to use refraction for that. It doesn't make any sense to use refraction for that.
Yeah,
And
like
that's
the
what we're
example
responding
I
one factor to make an argument when you know that in a holistic view and in reality, it's not just one factor. It's not just perspective. that
Sure.
comes into
Yeah,
play.
But I was addressing
so what-
perspective.
Yeah, but
Explicitly.
you're like simplifying the argument and kind of taking it into a.
Oh,
I guess it's a straw man because nobody claims
his
it's
argument.
just.
Well,
No, but
if
I
you're
don't
going to
think
be
he
definitive,
claimed.
if
Oh,
if
so
you're going to use
now
a
I'm gonna
term,
get cut off.
well, if you're going to use a term like perspective to describe an observation, you need to be definitive. You can't just say, "Oh, it's just perspective," and I mean that in a vague way. What specifically do you mean?
So, how do you feel about when I clarified it? What's your comeback to when I boiled it down? The argument.
You didn't boil it down. You said it vague. It's just his holistic view. That's all you said. You didn't say anything.
Yeah.
specific.
Well, can you deny what I proposed?
If you're going to label something,
I mean,
as
these are the
defined by
factors
something, you
used
have to
yourself.
describe it.
Why are you denying them for flatter? I mean, you yourself would use the argument of refraction when it comes to the globe, but when a flat earther would bring up perspective, it's just perspective. Oh, refraction
I would
doesn't
describe
work
equal
with flat Earth.
I would describe
For
a
some reason.
refracted image if I noticed that it was refracted. That's what
So
I would
can
do.
refraction cause the sun to be, as Bacon put it, half below the horizon and half above it? Can it do that?
No, I wouldn't necessarily describe that as refraction. Its position, maybe, but it being obstructed, no, I wouldn't say it's obstructed because of refraction.
No, it can't be replicated, and
On a
On a flat surface.
on
no.
a flat
Off-
surface.
off
Are you
the-
saying it can't be?
Yeah.
With the observer above the flat surface without refraction. No.
Are you sure? What
Yeah,
if I
you
can
can.
show you that it can?
Yeah,
With
show
our
that.
Would you
atmosphere.
change your mind?
Yeah, show that.
Not with the
Yeah, let's
atmosphere,
see.
right? If it was on the moon, you could do it.
No, with the atmosphere. This is on flat ground on Earth and objects disappearing bottom up on a flat surface.
So
this has been
on that flat
replicated
surface,
over and over. So many people. It's
Yeah,
Have
it
you
seems
been
bad
observed?
that Yeah.
Yeah. How
Brought
did
them
you
up makes
confirm
sense.
the surface was flat?
Well, you can
I don't
confirm
think.
it
I don't
because
even think that's going to be the
okay,
issue.
I'll tell you how you can confirm it, because it's in a building, and how people tile, for example, or make flooring is level. They always shoot for maybe there is this possibility of slight deviation. I'll give you that, but still, I mean, yeah, it's not exact. Do I have an exact mathematically? I mean, you don't for your claim, but for some reason I have to believe what you say. But just proposing an idea from my side, where, I mean, in a sense, like just given the sense how people build shit, it's supposed to be flat, right? In a building, the floor is supposed to be flat, correct? Or should it be at a slant?
You got
When
level.
people build
You got
shit,
level.
architects, when they tilers, just someone who's tiling, would they want their ground to be level, or would it, like, I don't know. You tell me. Like,
I'll just say
what are you saying?
any demonstration of a flat surface causing obstruction has been questionable, in my opinion.
Because you have this.
It's been shown. It's been shown. I mean, have you seen? Have
Show
you
it to
really?
me.
Yeah, I think. Well, I think you just have to. Listen. Go. I mean, there's a YouTube Discord channels you can go to and really dive in. You can go to that Flat Earth Dave guy that nobody seems to like, but they're not his videos. It's just a collection place for videos, and just dive in and check it out.
Heard of
it's been shown.
Sky Free? Anyone know that channel? Sky Free. It's not
Yeah,
that
no, I heard
famous.
Their
but
observations their observations are replicated with other explanations.
Well, I mean, just watch enough of. I'm under the belief that a lot of the, globe, if you're hanging on that long, you must not have seen enough evidence, or you just haven't really just given yourself to the idea. Just
The
let
problem
yourself
is
think freely.
the problem is
without
we know
just, yeah.
we know how cameras work, for example, right? So when the light goes from an object to the camera, gets through the lens, reaches the sensor, the point in which read an amount of light is receiving, right?
Yeah.
So
nobody's challenging how a camera works.
I know,
I'm not saying
but I'm not
don't
done. I'm just
predismiss
starting
it,
to make
just
a
dive
point.
in. Yeah.
Yeah, I'm not saying that's my point. I'm just starting to make my point, right? So given that knowledge, if there's something circular looking above a flat surface, and there's light coming out of that, and the camera is pointed towards that thing, and it's above a flat surface, if there's no obstruction between the thing the camera is pointing to and the thing and the camera itself, the light leaving the bottom of that object should still reach the camera and should still reach the sensor of the camera that would form an image. But somehow we gotta have.
Please. I mean, you're making these claims like we know how cameras work, therefore
you
blah
don't
blah blah
think
blah
that's
blah
how
blah blah
cameras
blah
work?
blah 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 blah
Don't think
blah
that's
blah.
Listen,
how cameras
No,
work?
I don't really know.
that has nothing to
I
do
don't
with
know
how
cameras
cameras
really
work.
It does.
exactly. Yeah, and,
It does.
You don't
I
no.
mean,
You
It
start
does.
your argument with such a claim, like we know how
What
cameras
claim?
work, and then with the claim that you say we know how cameras work, and for some reason that's supposed to be following your argument, and it has nothing to do with what you're
How
saying.
does
I
it
mean,
not?
we know how cameras work, and then you go on to say some bullshit about circular
That's not
shit.
bullshit.
If you
That's
look,
still how they
no,
work.
it has nothing to do with how
It has
cameras
everything
work.
to do because
So
we're
citation.
analyzing.
Okay, give me a citation
We're
for
citation
if
for
it's
what?
if it's how we know cameras work for what you're arguing. Your argument. Give me a citation.
What was my
for what you
argument?
just.
Show me that I at least understood my argument. What did
Your
I say?
argument started with some circular shit. If we look through a camera with what the fuck
not
are
a
you
good
saying?
description.
That's not
so
my
you're
argument.
saying you
I
won't.
didn't say just that.
So Bacon, are you saying that you won't watch videos on that I'm telling you
No,
about?
of course
How
not. Of
camera
course I
works?
didn't say that. I studied how cameras work, right? I learned this.
You studied?
You can. Yes, we study
Okay,
how
so,
Maybe he
cameras
did.
work.
okay, wait, hold on. So make your argument in a clear form. Just say it
Right.
now so I can test
Yeah.
it. Go
Okay.
ahead.
So, do you understand how cameras work? Because if we do, we can get past that.
I understand in a sense. I'm not a professional, but I've worked with cameras. I know about lenses. I know about a lot of things. Aperture,
How an image
exposure.
gets formed.
Oh, yes. I know how
Yeah.
in the most simplest way how cameras work. That I
Right.
know. But go ahead and
Right.
make your argument.
So for a camera to make an image out of an object you're taking a photo of, the light from that object has to go inside of the camera, goes through the lenses. All those light rays are going to cross at the focal point, and they're going to reach the center of the camera, and that's how the reading of the picture is going to produce the picture. The picture you're seeing directly comes from what the sensor is reading. Correct?
Yep.
Right. So
Nobody's
the same
arguing
way.
against that. Go
Okay.
ahead.
Okay.
I mean,
I'm just establishing common
make
ground.
your
I'm just
no.
yeah.
That's what
That's
I said.
important.
Make your
Yeah,
argument.
that's
in
one of
a
the premises.
form,
That's one of the
without
premises.
premises.
What do you
Okay,
mean
go
without
on.
premises?
No. Go ahead.
Right. So the same way, you can trace back each of those pixels. So for example, if you're pointing a camera to a certain direction, and you're seeing just a light, a point source of light, like there's a light bulb very far away from you. It's just like only lights up a single pixel right in the middle of the camera. You can trace back that direction in a line that goes direct to that light
A
bulb.
straight line.
Yeah.
Okay. So you just ignored other factors that can, let's
Yes.
say, bend.
Yeah. Yeah. That's the simplest explanation. Right.
Exactly.
Oh,
So
it still.
it has nothing to do with the argument that we like kind of clarified. When you see, you're trying to pigeonhole the argument into something that nobody's talking about. I mean,
Well,
I
you're
wasn't
do you
talking
say
about it,
referring
but
do you
to.
say
it did
so
sound
so
like
so
that
do
you
you
were trying to
say
make it
light
really-
travels in straight
I'm gonna
lines?
head out.
Yeah, I think that for the examples of the videos we're referring to, like those videos that people try to
Yeah.
replicate.
And these
being
videos,
obstructed.
is the light
I'm not
traveling
finished.
in a straight
I'm not
line?
finished.
No,
Yes,
I'm
that's
not
my
finished.
point. That's my
Yeah,
point. On
so
the in small scales,
Come on, guys.
refraction is no factor. It's completely negligible.
when you say small scale, what's small scale?
I'd say it is a factor.
It's negligible.
Like it's constantly refracting and bouncing in all directions off of off the atmosphere.
What
Or
are you
off of
talking about? I'm in a room. I take a picture of my room. Refraction
Uh-huh.
is doing shit to what I'm. If I do that in a vacuum, it's not gonna look any different, right?
Well,
There's basically
is
no
it
change
scale?
in the.
Okay. So
It
scale.
is.
Hold on. Let me ask a question, like a pertinent
It's
question.
playing a big role in the lens. or type of lens.
Hold on. Does scale determine whether refraction would be significant or negligible? Is it scale? Is it the distance?
Yeah, it's one of the things. Like in a room, the refraction you have for
What
the atmosphere
else?
on the room is negligible.
What else?
What do you mean? What else? What?
What else is a factor? Significant.
I would say
I mean,
any
you're saying
observation,
in a room,
any observation less than 100 feet, refraction would be negligible.
even if you have
excluding the refraction in the glass of the lens. Just saying.
Yeah, that's one thing. And if you have
we're talking about the
drastic,
atmosphere.
if you have a drastic change of temperature, humidity within that room, let's say that room is like what, 5 meters wide that you're looking through, 6 meters.
Right.
And there's
So let me
drastic
bring back the context
change
of
in
this.
temperature and humidity
Let me
Yeah,
bring
maybe
back the
someone's
context.
maybe it's in
from
a
the
kitchen.
observer to the object.
Let me bring back the
That's not a
context on
factor?
what.
It's not.
It is.
It's
Come on.
negligible.
Let me bring back the context of why I'm talking about this stuff. You mentioned examples of.
Can hold on. So I'm sorry, Bacon. I'm sorry. Can I show you a video and then you tell me what you
Please,
think
you
is
should
going
have
on?
sent already.
Okay.
we're making it a lot more difficult by me not
Sorry, I
knowing
don't know
how-
where
Sorry,
we're at.
I'll just
in
give
this
an example.
conversation.
I'll just give an example, and we'll talk about that. Well, you tell me what you think is going on, and I'll tell you what I think is going on, and let's see which one is more logically sound and would relate more to reality and make sense, right? Is that good enough? Here,
Sure.
copy link address. I didn't even look at the video. This is just one of them, but I'll look through it as we go.
Yeah, maybe just play the video and mute it, and we can talk about it.
You saying with the
Yeah, well,
screen
that's
share?
clearly that's refraction.
Yeah, but that's in a room, which you said you earlier said in a room I would neglect refraction as a factor because they were talking 14 feet and 18
Yeah,
feet
because
from the viewer.
yeah, because
The
I was,
objects are 14 feet and 18 feet. You said
Yeah, but-
it's negligible refraction in that distance.
yeah, because
Yet you
because-
just, as soon as you saw the
I am
video,
agreeing.
you called. Hold on, let me finish. As soon as you saw the video, you called refraction, not even knowing the distance. And that's the
but
distance
that
where you
clearly
call
looks like-
refraction
Yeah, because
negligible.
you can see
correct?
distortions there.
Correct, Bacon?
Yeah, because
Bacon.
I was because
Yeah,
I was
but you-
specifically
so
referring to
does
yes,
that
because I was
change your-
oh my
does that
fucking god,
change-
let me answer you. If you make me questions, you have
God
to let
dang
me
it.
answer
Yeah,
you.
man. Come on, man.
Because
Chill
I
out.
was
You're like
yeah.
flipping everything he says.
Yeah, when we were talking about things being obstruction bottom up by a flat surface, I've seen multiple examples of that, of people trying to bring and make something further away, and then that getting obstructed, right? Like over tables, over things like that. In those cases, there's nothing forcing a gradient of temperature. There's nothing like that. It's just like regular people with objects over tables. That's what I was picturing. And for this kind of environments, of course, refraction is not going to be a thing. But of course, you heat up a surface, or if you cool down a surface, or if you throw some gas or something, sure, you're going to create refraction with that. But that was not the kind of scenario I was picturing.
Yeah, but that's what I referenced, and I told you within a room 60 meters, if you change humidity and temperature, refraction would become a factor, and you denied that. You just did.
I didn't
Before I
deny
showed you
that.
the video.
I didn't
Well, you
deny
didn't
that.
speak up, or you didn't deny it or confirm it. You didn't answer my question.
Because
You wouldn't.
because I was trying to give
Because-
you context for why I
No.
said that, which I just did now. I just
Okay.
gave you the context of why I said it now.
So I was right when I said in a room of let's say
Is this
6
really worth
meters,
it to you, Easy? If you want to
Yeah,
take this as a
what's
win, go right ahead.
Yeah, you can try to
What's
force
that
refraction
room?
you
It
can
is.
force refraction to be a factor
Force
in a
refraction?
room.
Me?
Yes.
I never use
Oh my
refraction as a
God.
factor.
Not you
It's
personally.
you.
That's just you can.
I'm hold
Let me
on,
get to
hold
the end of
on.
my sentence. You don't know
No,
even
I
what
was
I'm
just
trying to
arguing.
say.
No, Bacon, because I walked into the room.
This is so annoying, dude.
Hold
You
on,
don't even know what I'm
because-
trying to say. You're already
Yeah, man.
responding to a
Now,
comment.
y'all are gonna have to like
Left
back
lane,
and forth
left
more,
lane,
and
yeah,
you're like
but-
you're not letting him speak, just like you're not letting me finish speaking.
I mean,
It's the same
nobody's
thing.
speaking up when he's doing the same for me. I mean, he's interrupting
Yeah,
me.
I'm not
Nobody's-
noticing it.
Well, that's your problem. Then maybe you shouldn't be moderating this.
All right,
chat.
I'm gonna pay
I mean,
real close. I'm gonna pay real close attention
okay.
here. Y'all
I'll
proceed.
shut up now. So go ahead.
Right. You can force refraction to be a factor by introducing difference in temperature, something that you don't normally get on a room, right? And if you're doing that, surely refraction is going to be a factor. Is going to affect the whatever observation you're doing. But if you're talking about examples of people just moving a coin over a table and then the bottom of it disappearing, this kind of environment where you're not forcing difference in temperature, difference in humidity, or throwing gas on it, then refraction won't be a factor. That's what the kind of observation was referring to.
Well, you were talking about a straw man because, again, what we're trying to replicate is long distance observations, which refraction would come into play because you would have these temperature gradients and difference in humidity and so on. So someone talking about just a simple observation inside a room with no refraction, and you were arguing against that, that would be holding up a straw man. That's why I called out a straw man, Bacon. Would you agree? I mean, nobody's making a claim of
Yeah,
no
I was trying to
refraction.
answer.
I
You were
already.
putting me in.
Oh, so now you can interrupt me. Where are you, left lane?
Well, it
Is
sounded
that
like you
all
asked
right?
me a question. You
Oh,
asked me a
okay.
question.
Oh,
I
I'll
started
shut
to
up.
answer.
No, I
and then
didn't.
you.
I was talking, and you had to interrupt because.
Well, you did answer a question of him, and pause for a second, and maybe you had more. I'm fixing to mute your ass. Is what I'm fixing to
I
do.
didn't pause for 1 second. Not even 1 second.
Yes, sir. You did pause for 1 second. I'm paying very close attention, and you're allowed to complete, but quit being an ass about it. Now go ahead.
Missed the point.
Is that a pause? Can I come in now? Here's a point.
Yeah,
I said
I'm
you
trying
can
to.
complete. Yeah.
That
Yeah,
Sky
you're
Free
being
channel has some
completely
really nice
disingenuous
videos.
now.
Yeah,
Thanks for linking that.
disingenuous. Do you even know what that means, left lane?
Is that contributing to the conversation?
Would that make it if it's not contributing to the
Yeah,
conversation? Would that
you're
make it
just being a dick. You're being a dick. You're being
No, I'm
obnoxious
pointing
and
out.
obtuse.
No,
and
I made a
you're being
point, and
unable to have
I
a
didn't get
conversation.
one.
That's what this platform is about, a conversation. So can we have a
Well,
conversation?
That's what I'm trying to do. But you were calling me out for cutting him off, and then when he cuts me off, see when you do this double standard shit, you're gonna get some
No,
bullshit.
you did ask him a question, and there was about a 3-second pause, and then as soon as he
No,
started
there was
answering,
no.
you started speaking again.
Is this recorded?
Yeah, go back and listen to
Okay.
it.
If there's even
I'm
1
another
second.
mod here. Maybe I could help out. Let's just get on with the conversation to the topic. That would be more interesting to listen to.
Yes, please.
Sure. Okay. So going back now, do you concede, Bacon, that this observation, this video that I posted inside a building, does involve refraction? Because you omitted that earlier, and you said inside a room, refraction would be negligible. That's your words, quote unquote, negligible.
Instead of appreciable.
I agree with what?
No, I'm not going to repeat myself. Are you listening? Even I mean,
Egypt. Yes, he agrees. Right? He's clarified.
Oh, you're
Please
speaking
move
for
on.
him now, Ruif. No.
Please move on. We all want to move on with the conversation. Please move on.
Yeah, you made a very long
Well,
question.
that was my point. That was my point earlier.
You started
Because
asking.
Bacon. Okay, I'll boil it down for Ruif because he wasn't even here for the beginning of.
Oh, I've picked up the stream of the conversation very quickly.
Okay, so what I was calling Bacon out for was the fact he was boiling down when flat earthers try to make an argument and calling it like Godric was actually calling it perspective, right? He was using it in a colloquial sense where this word perspective involves all these factors, whether the actual perspective, things like that, all these factors when perceiving as a person per se, right, or through a camera or whatever, through long distance, there are all these factors that come into play, right? The most basic being perspective, the law of perspective, where higher up objects would seem to fall to the horizon and the opposite with lower objects, correct?
Make your
Correct,
point,
Bacon?
I wouldn't describe perspective like that, but go on.
No? How would you describe it?
Oh, it's a specific type of projection. It doesn't necessarily mean things are going towards the horizon. Only if both you and the horizon are making parallel lines, then yeah, they would go towards the horizon. Because parallel lines share a vanishing point, but it has nothing to do with the horizon. Like it's something more general.
Well, you could say everything approaches the center point of vision.
That would also be incorrect.
That is called the Riley criterion. Yeah, it's like
That is
you walking down the
low
street
more.
with two pieces of paper, one on each side, one on the right hand, one on the left hand. As you walk down the road, it will look like those two papers going to merge into one because of
Has
perspective.
nothing to do with relative, George.
The same thing would apply if they are on the vertical rather on the horizontal. They will still emerge into one paper. And eventually, you
Perspective
will
has
see
nothing to do
no
with really
paper.
criterion, George.
That's exactly what it has to do. And guess what? The obstruction will start at 1.2 miles away.
When things travel parallel to your center point, for your line of sight to the center point of vision, they also approach the center point of vision.
Sure, when they travel parallel to their line of sight. That's what I was saying. Every parallel line share a vanishing point. So if you're using your line of sight as one line, and another line is parallel to that one, then sure, they're going to share the same vanishing point. But
Yeah.
it's not about the center of your vision. You just pick that one
We're just
specifically, but you
we're
could
just
pick any
laying
other one.
we're just laying down the basics there. I think I summarized it well. Just laying down the basics, right?
Well,
think
the whole point was right is when it comes to the flat Earth bacon, you seem to ignore all the other factors and just want to argue perspective and saying, "Oh, that's not what's going on," which would be a straw man, correct?
If I say there's only perspective, that would be a straw man.
Yeah, that's what you.
You're being correct.
That's what you did.
I didn't say there was only.
You
perspective.
argued against Godric's point of perspective.
Yeah, I said perspective
saying
cannot do that.
Yeah, perspective alone can't do that. But I just showed you an example where perspective plus refraction can do that on a flat surface.
Yeah, but
Would
that
you-
doesn't
would
need
you-
perspective. Like it has nothing.
Okay.
Like you can have bottom up obstruction using refraction. That has nothing to do with perspective. Like that, it's not just one plus the other. It's just the other. If you had an orthographic
It has to
view
be
of that-
both. Okay, well,
No.
is perspective not involved in this observation?
It is,
in
but
this
it's not
video
needed
that I
for
put. Not needed.
It's not the cause
It's
of bottom
involved.
obstruction.
It's part of it.
No,
it's
it's
how
not.
we perceive. Well, if perspective didn't work in that way, then even with refraction, we might have seen these objects. I mean, it's part of it. It's a contributing factor. It's how you perceive things. Again, parallel lines converge, and that would cause plus refraction would cause these things. If it's refraction alone and you don't have perspective, i.e., parallel lines do not converge, I don't think this observation can happen. Would you agree?
I think
Perspective is not the cause of it.
Yeah.
Sorry, Bacon.
Cause as in the singular. Yes, I agree. It's not the singular cause. There can be many causes of one effect. Because, I mean, that's even one of your comebacks as Globers is like, it's not just one cause, right? Of course, there are many causes to one effect, but in a scientific experiment, in that context, you want to boil it down to one cause to establish it as such in an experiment. But that's not what we're talking about. But yeah, something can have many causes, right?
Well,
And contributing factors.
Yeah, seems like we're kind of circling around without really making any good point, anything specific.
Yeah, so let me just try to address what he's saying is a straw man. I was put in a position to argue against the video that he didn't even saw. So I was picturing those attempts of showing that like dragging an object over a flat surface can make that disappear bottom up.
Did you just say I didn't see the video?
I said
Was that-
I
was
didn't
that a-
see the video. I
Oh,
said I
okay.
was put in a position to argue against
Yeah.
the video I haven't ever seen because immediately as soon as you mentioned the video, I said post it, and it took like 10 minutes for you to post. And along those 10 minutes, you were asking me to account for like the video I haven't ever seen. So I said, well, if you're doing that something on a room, refraction is not going to be an issue. Of course, that's like normal conditions. If you force refraction to be an issue, like warming up a surface or dropping gas on it, sure, you're going to create some refraction. But normally, when you take a picture of something on your room, refraction is negligible, and that's a sort of scenario I was picturing. That's why I was giving you that answer. And now you're showing me a video and saying, "Well, I said at that scale there's no refraction. Here's refraction." Yeah, sure.
Yeah, but
that case, yeah.
The argument was never about making observations, right? The argument is about long distance observations on flat Earth versus globe Earth. Correct. This is the initial argument. This is what we're talking about.
Yeah.
We're just analyzing. Hold on. We're making analogous observations on a smaller scale, where you even said on the small scale this is negligible and we shouldn't even take them into account. And I just
Egypt, he's clarified it multiple times. Move on.
Yeah, you can induce refraction on a small scale, but under normal circumstances, normally the distance across a room, refraction would be negligible.
Okay, Ru, if you're asking me to move on, that was his argument. That's how he discarded these factors by saying, well, in a small scale observation, these are negligible. Therefore,
he's clarified.
Yeah, I didn't discard refraction by mentioning smaller scale experiments. First of all, I was specifically trying to address perspective. And then you said Godric actually meant perspective plus refraction. And then you start asking me about replications of this effect in smaller scale. You brought this up and asked me if that was possible. And then I was trying to address that.
Fine. So therefore, observations, therefore you can never, like, what's your determining factor then in a long distance observation that the Earth is a globe? It can be both in this sense.
Yeah, if you're clueless about how refraction works or what's the profile of the atmosphere, then sure, Earth could be either way, right? But as soon as you start taking into account that the light bends towards denser mediums, that in normal conditions the atmosphere is denser at the bottom, so you get downbending refraction. When you take that into account, then a flat Earth, like a sunset, stop making sense on a flat Earth.
Why not?
Because if it's lights bending, like if you want to see something being obstructed by the horizon and over a flat surface, you need light bending up. And according to what we understand about refraction, that requires that the atmosphere is the opposite that the way it usually is.
Yeah, but what if the sun and its distance is in a lighter medium? You're saying the light bends towards the denser medium, correct?
Yeah.
Okay. Now the sun is above your head in a lighter medium, correct?
Okay, so light's bending down.
You just said it bends down in a denser medium. In a lighter medium, it would bend up, correct?
No, that's not what I said. I didn't say it bends down it's towards. So if the medium is less dense above you and it's more dense below you, that's the direction of the denser medium. So light's going to be towards the ground.
Yeah, but the sun is above you on a flat Earth. It's not below you. When the sun is setting, it's not below you on a flat Earth, is it?
Should I bust out the crayons?
Appears to be.
What?
Looks like it is.
Should I bust out the crayons?
Looks like, what on a flat Earth is it? Above you or below you, the sun?
Yeah, it would be above you.
So lighter medium or denser medium?
Oh, Jesus.
Yeah, high is lighter than the bottom, which means that the light would bend down because that's where the denser medium is.
What?
Do you not understand the structure of our atmosphere?
Yeah, it's difficult.
I'm difficult.
Do you understand the direction light will bend in our atmosphere, given the structure of it?
It needs to change from a medium to another in order to bend.
Oh, George,
You're
you're
begging
just
the
ruining up.
question.
You're ruining up Egypt's argument like that.
I've
You're
got
begging the
George turned
question
down, by
that
the
the
way.
sun is in a vacuum,
George
bending
just
once
said.
it reaches the atmosphere. You're begging the question, man. The
George said
sun
that
is
you
not
need two
93
mediums.
million miles away.
So
Yeah,
he's
cool.
ruining up
Just
Egypt's
wrong.
argument.
But Egypt, do you know which way it will bend given the structure of our atmosphere?
It won't bend anywhere. That's
Structure
my
of our
point.
atmosphere. Again, what are you saying? On a flat Earth or on a globe?
On any,
What are you?
given the actual structure of our atmosphere, in that it's more dense at the surface and less dense higher up. Which way
Yeah,
does
but
light bend?
How many mediums are in the atmosphere?
Where when you're looking when you're looking at the sun is above
Right.
you, correct?
Right.
Is that above you or below you? I mean, is that in a
Above
lighter
you.
medium? Okay,
It is in a lighter
that's
medium, but what's
yeah,
below
that's-
it? Which way does the gradient go?
Who cares what's below? You're looking at the sun,
That's
which is
what
above you.
determines the direction of the gradient determines which way light will bend.
Yeah,
Do
but
you
you're
understand?
not looking down when you're
No,
looking.
that doesn't matter. That doesn't
Oh,
matter. Come on, Egypt.
Gradient
You
is
can do it.
what?
So, hold on. So on a flat Earth, when you're looking at the sun
Yep.
at a distance,
Right.
Is it going through a denser medium?
It's going from more dense at the surface to less dense higher up. Which way will
No,
light bend?
listen to my question, Ruth. Why aren't you
Yeah.
listening?
I'm
When you're
hearing
looking at the
you.
sun
I don't think
setting,
you have any idea how
Okay.
refraction works.
well, is that what you have as a comeback? I don't know
Yes. Yes.
how it works. Okay,
Yeah.
so
Which way will light
why
bend?
not? Which
That's the
way will
question.
light
Which-
bend where?
If I'm looking, let's say the sun is above you, right? But the gradient is still more dense at the surface and less dense higher up. Which way will light bend?
The gradient, that means one
Which
medium.
light coming from a source that's above you,
Yes.
or coming from a source that's below you?
No, coming
Yeah,
from
but
the sun
when
that's above you. Which way will it bend?
gradient,
It will bend
you
up.
can only have gradient.
No,
You can only have a
incorrect.
gradient
Fuck.
inside of the same system.
Do I have to draw like a Snell's law diagram?
Snell's law diagram. Yeah, that requires two mediums. You are saying
This
there
is
is a
such
gradient. A
fundamentally basic
gradient,
shit.
the gradient, yeah, is in the same medium. Snell's law requires two different mediums.
I think the question is, how do you differentiate between the effect of perspective and the effect of refraction? So say you have something at the same height, like a kilometer away, and then like 5 kilometers away, there's going to be more dense medium that's because you basically made it more of a diagonal line. It's a longer distance away, right? It's going through more dense medium. So by that logic, it should be lower in your field of view due to perspective. I mean, due to refraction.
Literally,
But how do
I'm
you
literally
differentiate
busting out
that
the crayons.
between what perspective is?
What's the
Literally
best
busting
word
out the
for
crayons.
what?
Yeah,
What's
but the
the
guys
best
already
word
pointed
to
out.
put into one word? All of what's included that comes in that plays a part in your sight.
Yeah,
The
but
laws
Well,
of
Godric
hold on.
Godric
laws
said
of
it.
sight.
He used
Reality.
Optics.
He said he used the word perspective in that sense.
Yeah, but hold on a second. I cannot speak too
All
loud.
of optics.
It's late.
All
It's
factors
late
of
where
optics.
I
Maybe.
am. I cannot say too loud. But I've forgotten what I was going to say. Sorry, guys.
Let's add on. There's actually a height.
Nobody can explain what the hell is optical corridor.
The optical corridor. That's
Oh,
basically
remember now.
It's
Remember
the
now.
framework to whatever you're looking at, and it
Give me a
basically
second.
speaks as the refracted data to that object.
Give me a second. We're talking
All right, I
about
have busted
when
out
there
the
are
crayons. Give me a
atmospheric
second, I'll post it.
when there are atmospheric conditions that are blocking our view. All of that is applicable. The problem is not that. It's when there is no obstruction, when nothing is blocking your field of view, you can see further away if you zoom in. If you have good optics, and none of those conditions that you guys are talking about, this is when you can actually see far, far away.
That's true, but I
Obviously,
think it's out of the scope of this discussion because they're talking about obstruction.
And that'd be
yeah,
no
we know that there
atmosphere.
is obstruction.
Egypt.
Yeah.
Can you see the diagram that I've posted?
Real quick, to the guy that said optical corridor, think of it as just as line of sight. And then what would be required for any kind of refraction claims would be the data for the pressure and the temperature throughout that optical corridor, that line of sight to whatever you're looking at.
Can you see the diagram I posted, Egypt?
There's a little bit wrong with that diagram, just like a caveat, which is at the surface, closer to the surface, it gets less dense than
No,
the
it
air
doesn't.
above it. Yes, it does.
What?
In general,
What?
the gradient is less dense to more dense from top to bottom. But as you get
From
closer to the
top to bottom,
surface,
yeah.
because of evaporation, because of the vapor, the gases that we have down here, it gets a little bit less dense, especially over large bodies of water.
Sorry, you're saying that the atmosphere at the surface is less dense than the atmosphere
Yeah,
at
I
altitude.
think the value, it varies, but it's like, around 8 feet is when it like kind of equalizes. Sometimes more than that, 4, 6,
Have
8
you ever
meters.
flown on a plane?
Yeah,
How's that relevant?
that's what I was going to say.
Do you realize that
doesn't
the
agree.
cabin is pressurized to keep you alive?
What's your point?
That you think it's more dense at altitude than it is lower. I don't understand how you think that.
Maybe you're not listening to what I said. I said 8 feet,
can
maybe up
go
to
ahead.
like 4, 6, 8 meters above the surface of the Earth.
Oh, okay. Who gives a shit? Sometimes that's true, but in
It's
general,
always true.
it's not always
You
true.
could
No.
use
It's
your
always
phone.
true.
No, it's not.
You can measure a difference in the pressure in your room with your phone. I mean, it's always more dense at the bottom than it is at the ceiling.
Yeah, but at the
That's
layer
not
that
true.
at the layer where the sun is being projected from, at that layer, the roof, the ceiling, that layer is still more dense than the one that you're standing on, than the air. So
The
the ceiling, you're talking about why is the light going away and disappearing of the sun? There is the floor, and then there is the ceiling, and there's a point, depending on the angle of the light, that you're not gonna be able to see that light anymore. That's why you don't
Anyway.
see the light anymore.
Egypt. Can you see my diagram?
Yep, I see it.
Okay. Which way does the light bend? A or B?
Hey, percentage, the medium
He's offering
above
you a false
is
dichotomy, man.
closer.
Why are you offering a false dichotomy? A or B? It's none of them.
Egypt?
You seen the light? You seen the light bending on that?
Hold up, George. To be
On
fair,
that drawing.
he's asking Egypt. And Jemmy, I got like you could ask your answer. Sorry, ask your question.
Yeah, Gemsy. Can you turn your noise filter on?
The light bends a little bit towards the intermediate, but it's negligible for measuring light.
I'm just asking Egypt, which way does it bend? A
Well,
or B?
obviously to A, but A is.
Thank you. Fuck.
Yeah, but.
Right. So it bends down towards the denser medium.
Anyone disagree with that?
I mean,
did
that's
half an hour ago.
No, that wasn't that's not the point I'm making.
Is he talking about the water? Is that
You've
the
got the
medium?
sun
that he's
above
talking
you,
about?
right?
Yeah.
The density gradient is that way. The light bends down. You said
Yeah,
it
but-
bends up.
It's still on the same medium, isn't it? The air.
No, what he was saying is it depends on whether the sun is higher than you or lower than you. So on a globe,
No, it doesn't.
where the sun is actually
that's what I
below
was
you,
comparing.
there's
Exactly.
a difference, right? If we're imagining a planar Earth and the sun is moving away, it's covering more and more dense medium, right? Just on account of it moving away, it's gonna decrease in the field of view. It's gonna like lower in altitude in terms of like our field of view.
You guys are
I should
comparing
say
the
What he
altitude.
said,
medium of
what he
Lower in our
said
field
is
of
that
view, right?
because the sun is above you and it's in a less dense medium, then the light will bend up. That is what he said.
No. Given
Come
the
on,
distance,
Play the
that was
tape,
the point.
Jim.
I kept
You guys
saying
are comparing the medium of air with the medium of water. As far
you're
as
looking
I
Hold up, let
remember,
him
looking at
defend
the
himself.
sun in a distance.
as far as I remember,
Because when you're looking
on
at it,
Snell's law, yeah,
Too many
when
at
the
once.
straw bends, when
George.
the straw bends on the glass, Yeah, it's in the medium of water. Two different mediums.
He's claiming that he knows what the medium of the sun is. He actually knows what that medium is.
You just said there is a gradient. It's the same medium if there is a gradient.
That's not
He's
true.
saying it's a lesser medium than the medium of near the ground. But how does he know? How does he knows that?
Yeah,
This is
saying
like a
the gradient
2015
is
argument,
different.
man.
Yeah.
I thought all this had been hashed out.
It's like saying, you know, in the bottom
Well,
of the ocean, the medium is the gradient is different than on the top of the ocean. I mean, it's silly, isn't it?
what if all perspective is refraction?
It's just not.
Because you
Oh.
expect with the more distance, more dense medium that is covered, there's going to be more light bending downwards, and as a result, it's going to be lower in your field of view, right?
If it wasn't predictable and measurable, you might have a point there, but it's very predictable.
No, but it could be, it's predictable in terms of the
Good
general
question.
gradient of our Earth. It's predictable, it doesn't there's not too much variance, right? So, if things are moving farther away and they're covering more distance that has more dense atmosphere, we can expect that it's going to get lower in our, towards the horizon, because it's moving away, right?
But it should never drop below our line of sight for sure, which it does.
How do you know that? Well, are you claiming that that's what is actually happening?
What if it vanishes? Is that below your line of sight? If it's gone, you can't see it at all.
That's what it looks like. It looks like it is. Yes, it does. It looks like it's dropping below my line of sight. Yes, sir.
So if it's
I'm just
vanished,
naming
you
those.
can't see it, can you?
Yeah, and it goes below your line of sight.
Anyway, have we sorted out that light will bend down?
Yeah, you'll need two mediums for that. Like in Snell's law,
George,
you need a
you know
medium
that
of
I've got
air.
you turned down, right? I can't
Yeah,
hear you.
you need a medium of air and a medium of water, and you put the straw, and you'll see the straw bending. Now,
So you can have a
unless you
medium
guys,
of atmosphere.
unless you guys are equivocating, the light in question, is in the same medium.
Yeah, it's a fallacious example, Ruhif, because you're showing the Snell's law of one medium to another. We're talking about the same medium. So my point is
No.
your refraction or your bending down would be negligible. You wouldn't observe it in reality. Okay, go.
There's a density
Conversation
gradient.
is
Snell's law
default.
is just a simplification.
Yeah.
Yeah, and then you have the medium
What is
of
Ruhif? There's
hot air
there's
versus the medium
another.
of cold air.
Yeah, Ruhif, isn't there another equation that they actually use for atmospheric?
Say again. Finish up.
It's based on Snell's law, but
It's
Ruhif
not
is trying to.
Snell's law. It's another
differential.
equation.
Fermat's principle.
Yeah, Fermat's principle. That's what I think that they were using the other night to actually make predictions of how much light will bend in the atmosphere.
Yeah, but you can approximate it with Snell's law and, infinitely thin layers. Same thing.
I got you.
Yeah, but you'll need more than that. You'll need gravity and many other things.
Why?
Because you are begging the question. It wouldn't work any other way.
Oops.
So since we do have gravity and there is a density
No,
gradient,
yeah, we do
What?
have gravity, depending on space time. Yeah, we do have. But no, we don't have a force of gravity.
I don't know. It's
Everybody
kind of
knows
like
that.
a dead end. It's like we're not getting anywhere with this.
Well,
Yeah, we've actually got to move the conversation along.
Yeah, let's do that. So where do you
Right.
want to take it, Ruhif?
Okay.
Take it to your
so
favorite place. I'll go
as
there.
Bacon was saying before, for you to
going
see
back?
the
Are we
sun.
moving on or going back?
We're tying up a loose end. So as Bacon said before, for you to see the sun below your eye level, yet the sun be physically, like its true position, be above you, you need upwardly bending light. You don't have upwardly bending light.
No, because light
You
is
don't
going
need
above. It's moving above your head, and you're experiencing the light in the medium in the air, right? You see the light from this perspective in this medium, but then where the light is coming from the medium of the ceiling, where the sun is moving across, that ceiling is gonna cause a terminator line between the floor and the ceiling. That's why you don't see the sun anymore.
I have no idea
So
what you
that
said.
medium,
Yeah,
that medium where
it's
the sun is
describing.
in, that medium where the sun is in is different from the medium that the one that we're in, the air.
So you're ad hoc proposing a different medium that no one has ever discovered?
You're the one saying that the medium above is this, and you're claiming something. You're claiming that
Yeah,
it's
I've
this
got
and that.
measurements. I've got
You don't know.
measurements.
You don't know in which medium the sun is. You don't know that, but you're claiming you know.
Yeah.
I don't know if it matters
Exactly.
much, Gem.
Right. We have an ISS up there in basically a vacuum.
There you go. You see, Persona?
Yeah, but okay,
That's
so for argument's sake, let's say the medium that the sun's in is a very dense medium, okay? And then in between we have a light medium. Then the light from the sun would still would kind of just like stay where the denseness is. Like if there's density above, it would just go up and we wouldn't see the sun. You know? So the fact that we see it means that the light is coming to us somehow, which means that it's being bent towards us somehow. So I don't think the injection of other mediums really helps.
Right, but we're all talking about light traveling through the atmosphere and which way it bends.
Yeah, but what medium is the sun in? I mean, there are so many factors. You're just again trying to like.
Yeah,
So imagine the sun now is in a light medium, and then in between we have a very dense medium, and then it becomes light again, and then dense towards the Earth, right?
You
If
can
in between we have a
describe
very
the
dense
medium-
medium. Hold up a second. If in between you have a very dense medium, then it'll bend towards that dense medium, and then it'll stay there. It won't go down towards the less dense medium beneath, and then we still won't see the light of the sun.
So you're proposing a medium that we haven't measured.
What about
have
the
no
other way?
reason to think that it exists, other than as
What
an
about
ad
the
hoc
other way?
explanation for your idea.
The other way is the
Like
first way I
space,
said.
Hold on a
like your
second.
vacuum that you haven't measured,
Wouldn't
like
Well,
that.
we actually
Wouldn't the
have been to
sunlight-
space. So yes.
When you say
wouldn't
we,
the sun-
what
Yes,
does that
the
mean?
human race. The
Does that
human
include-
race has been
Oh,
to space.
so it doesn't include you, right?
No.
Okay, so we're talking about you, Ruhif. Now you're
Right.
making the argument.
Yeah.
Have you been to space to confirm
No,
it?
I have not. But
Okay,
I have
is there
confirmed space
how?
with the ISS. Is in space.
How do you know that?
Because it's 400 k's up. It goes
I
28,000
know space
kilometers per
exists
hour.
because
The International
the
Training
ISS
Station.
exists
Hang
in
on a second.
space.
1 minute. 1 minute.
Yeah, that's circular
There you go.
logic.
It's gonna disappear.
There's still got to be a lot of air at the height of Felix Baumgarten because of course he was using a balloon, right? So even if the air gets thinner at the top Mount Everest, there's still plenty of air to even like float upon, right? With a balloon, even
Yeah,
like
But hold on a
5
second.
times higher than that.
That
If
balloon
the
quit
sun,
rising.
if the sun
The-
was at 93 million miles away, you know, you wouldn't see a dark sky at night. You would see the sky illuminated by the sun.
I don't know about that.
You're talking about the
idea that at some point there's
sunlight
not
coming
some air.
down to the ground. What about the sunlight going upwards? Would it bend if it goes upwards?
That's an
Why
interesting
is
question,
not
actually.
Why
So-
is not illuminating the sky at night?
So what does happen to the rays of light from like the top of the sun that go up? It would slowly bend towards the more dense medium, right? So you should see, if you were like farther than the sun, you should see no sun, basically, because none of the light should be reaching you. So the sun would be effectively invisible. Do I have that right?
The optical effect of the light bending down is negligible. You can't tell the difference. So I don't know how
Not
Ruhif
negligible.
can tell us that the light and what we see is actually bending around a curve. Can you prove that? Can you go into that? I'll listen.
We have a density gradient that causes light to bend down. We know how
You're
much it bends
saying
down.
that, but you don't know that happens in reality. Can you show us how much it bends? If it bends to a 7/6, if it
Hold
bends
up. How do
upwards,
we see?
if it goes left or right?
It
How
doesn't
do
go
we
left
see
or right.
the
but
lights of
it's-
stars?
What do you mean?
If
how
the
do we
light
see
is
it?
always
Hold
bending
on.
towards the more dense medium,
Right.
how
Hold on a
is the
second.
light
You say that light bends around
leaving
the
the
sphere.
star? Or is it supposed to be like, you isotropic at the very top, and we're just seeing only the rays that are straight above the star?
What? What are you talking about?
Yeah, because if light is always bending towards the more dense medium,
Right.
and the star is the more dense thing, then the light.
What? The star is the more. What the fuck are you talking about? The star
this-
is the more dense thing.
Yeah, relative to the space around it. There's a gradient of, from the above the star, basically altitudes above the star. It's going to be a gradient from top to bottom, light to more dense. Less dense to more dense.
He's sort of talking about a photon leaving a dense star, and then like as you get further away from the star, there's less density of something. I'm not sure what, but
Yeah, so
less
you would expect
gas.
that these lights are bending away towards the more dense medium. So as you're leaving, you're going to be seeing less and less and less of it. To
No.
the point where if it's very far away, you shouldn't be seeing any of it unless it's the one kind of ray that's straight from the top going through this perfectly isotropic medium, which doesn't happen.
You understand that if you're hitting the gradient at 90 degrees, there is no refraction. Do you understand that?
Yeah, if you have
Okay.
a perfectly isotropic medium, that would be the case, right? For the rays that are going straight up, that are perfectly 90 degrees.
You're gonna have to draw this because when you're at the star, I have no idea what you're talking
Just
about.
imagine like
Please
this.
draw it.
Imagine you have, like, a head with hair, right? With long hair, and the hair's all over the place. The hair on the top of the head is going to be kind of curving, falling to the sides, right? At higher like heights.
Please draw a Snell's diagram.
Oh man.
Because this has.
I'm not drawing shit, man. I'm trying to explain
You,
it verbally.
you're trying to say that
could I
as the
draw a
light
picture?
leaves the star.
Sure, if you want to draw it, if anyone's understanding what I'm saying, the light
Can I
should be
do
entering Earth.
Can I do a screen share drawing that you can like correct
Sure.
me if I'm getting it wrong?
Yeah, sounds good.
Okay, let me just open up the art program.
I think you're trying to say that light bends as it leaves the star. First of all, probably not, because they're basically spherical. And secondly, there will be rays that head towards the Earth, regardless of how they leave the star. You're making a nonsensical point.
I would say
I
the
think
light
that's
that we're
nonsensical
seeing
reply.
from the star is leaving the star at
Straight.
perpendicular to any medium.
Yeah.
Yeah.
Exactly.
Okay,
yeah.
I'm doing a screen share, and if we got
Give me a second.
if we got a star with like many layers getting less and less dense, then the light coming from the center here is going to hit this and go a little bit that way, and then hit that and go
No,
a
it's
little
not.
bit
It's going
that
to go
way.
straight through it. No, it's not. These are concentric layers. It's going to go straight.
What do
Okay,
you mean?
well,
Wouldn't it constantly be?
So not bending then.
You're
Yeah,
assuming
like that.
that it's perfectly ubiquitous then.
They're spherical, aren't they? Well, at least in our model, they're spherical.
all right, but hold on. So this light right here, right? This light right here is giving off light in all directions,
Correct.
right? And including, so let me change color, including the part right here, this red dot is also shooting light, and that going there, right?
Mhm.
Because for even like one spot like along an arc, right? They're all going like that,
Okay. I think I get you now. Okay.
right? So
Right.
this red spot right here doesn't only shoot this direction, it also, the side of the sun also shoots this direction.
Okay. I got you. All right. Now, then the question is, are there rays that leave this headed towards the Earth? Wherever the Earth may be.
You would think that there would be probably, just one area of the star would be going straight to the Earth, and also in line with the Earth. You know what I mean?
But this would
the ones,
still
the ones
end
that
up.
are pointed to the Earth, but are on the sides of the star, like those two dots that he made, they wouldn't. They would be subject to curving as a result of the gravity or of the density of the star, the density of the star's medium.
This situation would still end up with light exiting whatever medium there is in all directions, correct?
No, it would be. Let me.
The spherical object.
Let me expound. In any given area, there would be light going in one direction, outwards, unaffected. All the other ones would be affected by the density because it's off-center. Only the central, point source of light would be going out from any kind of part of the star. You understand?
There is no situation in which that's in that diagram that light would not end up going in all directions as it leaves the star.
Did you understand what I just said? Or no?
Yeah, I do.
Honestly.
I agree. Yeah, it's at the end result of it, light's still going to be shining out in all directions.
Right.
Yeah, now you introduce the fact that the Earth is only one area, and then so it's only going to be one of these like little parts that's shooting straight out is going to have the light going to the Earth, and then you introduce the fact that it's not a perfectly isotropic medium. So, how the fuck are we seeing the light from the stars?
Right. We like Jamesy just was it Jamesy that just agreed? It would still end up. Oh, Fundy all agreed. It would still end up a situation where light has exited the star, but traveling in all different directions. Some of those directions, a very, very, very small amount, would be headed towards the Earth. The end.
I don't think you're understanding the scope of it. So, let's say let's take two antipodal source points of light from the same star. Okay.
Yep.
Now, the only ones that are going to go straight out are the perfectly central ones. The ones that are shooting out in any other like the ones 90 degrees shooting out. Every other one that's not 90 degrees is going to be affected by the density of that star. It's going to bend. You with me?
Yep.
All right. So in any part of the star, there's only going to be like basically one kind of the 90-degree rays that are going straight out. Right?
Right.
So basically, we've limited like all the 360 degrees of these stars that are. I mean, I guess the internal 90 degrees that's going straight to the center of the star is also going to be going, but that's irrelevant in this scope of this, right? So we've limited like basically 360 degrees of rays to now basically 1%, the ones that's going straight out 90 degrees in any part of the star, right? Now, only in basically like one of these parts, above one of these parts is where the Earth's going to be overhead, right? So now out of all of those different source points of light, all those different rays, we have one that's pointed towards the Earth. And now you have to introduce the fact that the medium itself, the like light years, isn't perfectly isotropic, and that you're going to expect that there's going to be some sort of variation and stuff like that. Except you don't see that. So, and over such a long period of time, a long period of distance, I should say, over such a long distance, you would expect that the inverse square law of light would affect that. So how are we seeing the light from stars, according to your model?
You look at my
because there's light reaching our eye. Yeah.
Yeah, of course we see stars because there's light. We see them, but it's not in coherence with your model.
Really?
Yeah.
Can you look at my screen share again.
Yeah. Let's watch this again.
So even though light is going to go through refraction through the different layers of density, the net result will not only be like light going out in all directions from the core, but from every single point on the surface. This one point right here is its own little light source, and one of those lights is going to go that way, that way, that way, that way, like that. So even the side of the sun is going to be shining directly at Earth over here, whatever.
No, that's wrong. Though. Hold up, let me stop you right there. Those ones that are shooting sideways are going to be affected by the density, because as you see, it's passing through like the more of the medium of the star. Yeah, exactly. It's going to stay in a circle around the star, basically. The only one that's going to make it out is see on the right side. Hold up, let me finish. See on the right side how you have two parallel lines, kind of. The one coming straight from the center, going 90 degrees out, like right around right there where you just were. That would be the one that's going straight out. The one that's perfectly tangential to the surface of that star.
Really?
What you're effectively saying is that there's no way for the light to end up pointing at the Earth, and that's just obviously
what happens when you're looking at the
according to
star?
your model, it wouldn't work. Convince me otherwise.
It does work.
So what happens when you're looking at the star? Is that light bending as well? So when I see the
trace
sun,
the path back, right, from a
when
line
I see the sun,
from the light that goes to the Earth, trace the path back to like this halfway of the side of the star, and just trace it back to wherever inside the star that refractive gradient makes its origin.
but if if I'm looking at the sun, for example, taking the elevation angle, for example, and take it minutes apart in order for my reading, isn't it? I mean, the light cannot be bending.
Can you like refract those lines at the side? So obviously the center one goes straight to the center of the sun, but the ones
that's
to
the
the
only
side,
one that doesn't bend. The center one.
yeah, but even all those other ones which are parallel are going to the Earth. So refract them.
Those ones would bend.
back.
They'd be subject to the density of the star.
Right, but they've left the star, so refract them back to where their source
You
was.
can't just say they've left the star. They would actually not leave the star because they'd be bending towards the more dense medium, which is the star itself.
Oh, fuck, do I have to draw this myself? Fuck.
Ideally, this would be something that would be. Don't get me wrong, Fundy, your artistic skills are top notch. I mean, you're killing it.
I'm
But
busting
ideally,
out
it would be
the
something
ground,
that would be like 3D rendered with like Blender or something like that. But think of like a disco ball, you know, the light going outward from every little part straight out would be the only one that's going.
No.
Like unbent.
Incorrect.
It's not incorrect, man.
This is obviously horribly fucking. Yeah, it's a bad diagram, actually. That's a horrible one.
So why are you guys presuming that light travels in rays, straight lines?
Unless it's refracted, that's what it does.
Really?
Yes.
All right, help me out here, guys. So I got a ray of light coming from the right side of this. All right, it's gonna go straight. Now what do I got? Left or right?
It would go left.
Left, yeah.
Okay.
Yep, bend it to left,
And
and
then
bend
it's
it left
gonna go
again.
left again.
You keep on going left.
Yep,
Exactly.
and then it's going straight from there, right? Okay,
So,
what is that? Can that be the direction of the Earth?
Hold up.
Can that be the direction of the Earth? Yes or no?
You're assuming that there isn't enough
Can it
density.
be the direction of the Earth?
Hold up, you're assuming that there isn't enough density for it to remain trapped in the density of the star.
Hold
Okay,
on.
then we wouldn't
Percentage,
see any light in
percentage,
the black
hold on.
hole.
Yeah.
But you guys are wrong though. It's
Hold
gonna-
on.
it's
Let
gonna-
Rua finish.
Okay.
Like he's saying, can that be? Let's say it can be.
Yes.
Therefore,
done. The end.
therefore, what? The end. What? What? So you're
That light-
perceiving
that refracted light receives that light.
So you're seeing the part of the sun which is actually looking away from you as
sure
you're positioned, and so that's what we're seeing. We're seeing the sun upside down, or like the back side of the Earth.
And Fundy, can you draw the straight one that goes straight through? Draw the straight one that goes straight through from the top left. From the top left to the same. No, not that one. In the same direction as. No. Go back. All right, in the same direction as that arrow. No. The straight line from the top left. From the top left, going top left 45 degrees. From the center. No. From the center of the sun. From the center of the star. Going 45 degrees left. Top left. Yeah, well, yeah, same direction, but yes. Yeah, parallel to that. We received that as well. All right, there are infinite number of paths to reach us.
Yeah, but how would you perceive it? How would you see it? Comes
the same way as we see it today. We can't tell that a light's been refracted. It just reaches our eye. That's all we know.
Yeah, you're not making sense, man. I know you're trying to make sense in your model in accordance with
the thing
fact
is,
that we do see stars, but it's not working.
In your model, it kind of limits the way you perceive things, because
why?
They're positioned in certain places as you perceive them. They have a distance, they have an angle, they have. There are so many.
We're talking about a hypothetical here.
Oh, hypothetically. We
I
can
don't
do that all
think
day
this should
long.
exist, by the way.
Okay, so what do you think exists so we can
Yeah,
demolish that?
I don't think this
Or
idea
then-
of refracted light not being able to reach us is valid. I'm just showing you that it can happen. I think this is bullshit.
Bro, you see it right here that all of these lights are, like, they're going in every direction, sure, but there's only so much that can actually hit a target, right?
Right.
They're hugely reduced. Because
They're not hugely
refracted,
reduced.
They're refracted equally in all directions.
Right. So every single point, there's no bias on a sphere.
You guys be easy on Rohit. He needs just to work. He needs just to work for his globe model. So just be easy on him. Just hang on. Just chill out.
Now,
Percentage.
Fundy actually
Percentage.
agrees.
Your DMs.
Fundy actually agrees that from a sphere, the light will still end up going in all directions equally. Right. So this whole idea is bullshit. It's just invalid.
Yeah, definitely, Gemsy. If the layers of different density have, if they're like have shapes to them, if they're convex or concave, that definitely changes things. I was just thinking like if it was just a, level layer.
Right, but as our current understanding.
Come on, percentage. Don't use that word. The sphere. The word level.
Oh my goodness. I want to be able to tell you exactly what
about the other thing.
I want to be able to tell you exactly what the shapes of those layers are, but there's definitely layers.
That's fine, but it's still a sphere, so there's no bias towards light going in any particular direction.
No sphere on the ground. No, the ground is not a sphere, bro. Sorry about
we're
that.
talking about stars. You guys are trying to, debunk our model. Our model is that stars are spheres. All right. So if you want to say that stars are not spheres.
Yeah, you're right. Your model is a sphere, but reality is not a model.
Okay, whatever. You're trying to debunk our model. If you want to straw man it, go ahead. But I don't care.
No, I am with your model. You do have a model. You make cartoons about it and ideas in your mind about it, and you picture yourself standing on that model like a cartoon. But that's not where you are standing right now, reading and
Thanks, champ.
taking a nap and doing the things that you do.
All he's doing, Gemsy, is he's just confirming that all he has is a model. It has nothing to do with the reality. It's the model, and it works.
Correct.
That's
and he speaks to us like he's in the model, and that's why he says, "Oh, this model works." Yeah, it works in the model. Yeah, it does in the model.
Yeah.
Our model matches reality. Thank you.
Oh, it matches reality.
Yes.
And in all aspects.
If it was contradicted, then we would have changed it. So, I guess so. Yes.
Well, it does. It hasn't changed ever.
What if it was
the distance to the sun has not changed
after it? Right?
Okay, hold up. Let's think about this.
Which model are you talking about?
Again, the ray tracing thing. So let's take the moon. If with the moon you see the lights that are going straight at you plus the refracted lights of other parts of the moon, then how can we see like an image that makes sense?
What?
How can we see the texture, the actual craters, and they mix, like they fit with each other? If they were all different sources, different lights from different parts of the moon that were being refracted to us, and then only one was coming straight at us, then it should be a jumbled up image. We shouldn't see the texture that we do.
No, everything cancels everything cancels each other out to make a perfect image.
Why would it be jumbled?
That's actually what you're looking at. It's an image that is at one of the layers above. So let's say the ceiling that is above us. So you're looking at an image actually that is on the ceiling, like a plasma TV, basically.
Do you know what the twinkling of stars is? Do you know why it happens?
I would say probably because the imperfection of the medium.
No, you're gonna tell us.
The imperfection of the medium. Exactly the same as when you do a real close-up of the moon. You get this little wavy effect.
Because there's so much nebulae in between us and a million miles. There's all these satellites and asteroids and gaseous clouds that are interrupting, and it gives us a little blink, and that proves that it's 150 million light years away.
We're just talking about the moon, Godric.
But Ruben, that doesn't address what I said though, because I'm not speaking to the lack of perfection of the medium in between, the fact that it's anisotropic. I'm speaking to the fact that you said that the lights, and we agreed that the lights that aren't coming 90 degrees are going to be refracted as a result of the density of the thing itself, right? Now, the surface of the moon is more dense than the space that's above it. So
the
ones that are off center, like at the surface of the moon, it's more dense than above it. So the ones that are off center are going to be
It
bending.
doesn't have an optical density. Like, it's not a medium that light travels through.
So you're saying that the actual density of the gases of the medium is the same?
The moon doesn't have an atmosphere. The moon does not have an
So
atmosphere.
there's no density. There's no dense medium whatsoever.
The surface of the moon does not have an optical density.
Okay, but let's say from 100 miles up to the surface of the moon, you're saying that there's no difference in the actual barometric pressure?
The moon doesn't have an atmosphere.
You're not answering the question. Is there a difference
Yeah,
in
that
pressure?
is zero.
That is false.
Does that go against your model? Or
Yeah.
What's the pressure on the surface of the moon?
Well, maybe you should ask the question
on
before giving the
surface
answer. If you
of
don't know.
moon. The pressure on the surface of the moon is 3 times 10 to the negative 15 bar, which is fucking
Do we
zero.
need to quote NASA?
Okay, and what's the pressure?
100 miles
NASA
up
when
from
we say-
100 miles up from the moon. What's pressure?
Do we need to quote NASA?
Also
when we
very
say
close
the
to
moon
zero.
is in-
Yeah.
Maybe my mic's fucked
Yeah,
up.
but so.
I have
but,
a question for
is there a
Ruben.
difference?
No,
Jeremy.
hold up, Godric. You heard.
Calm down, children.
All right, go ahead.
Hold up. Finish Egypt, and then Jeremy, you can go after.
No, I was just saying there's a difference between the surface and 100 miles up. The gradient, whatever.
Gradient's
like that's what they
fucking
call it. Right?
Zero. The surface pressure of the moon is 10 to the minus 15 bars.
Oh, so it's zero because it goes from more zero to less zero.
That's barely measurable in terms of pressure.
Yeah, it's a
Barely
third of a
measurable. You can't even tell
nanopascal.
Yeah, it's absolutely minuscule. It's
How-
virtually
how-
nothing
correct?
in the argument set.
How do you confirm that without NASA?
It's our model.
They
It's
can.
our model.
How do you confirm it though? That pressure
Yeah,
on the
we
moon without
can't.
NASA?
Are you?
We can't.
Do you want to
I
say
think-
there is pressure on the moon, Godric? Is that what you're
Yeah,
trying to
how are
say?
you going to confirm
That's
it,
right. I
jackass?
think it starts out heavy, then it goes light, then it goes heavy again at the firmament. That's right.
How about the fact that
are you
the
gonna
moon?
prove that?
Sorry, Jeremy wanted to go. Go ahead, and then I got a question.
Yes,
That
Jeremy.
wasn't my question. I have a question for Ruhif. Ruhif, listen.
Hmm.
If there's no bendy cranes in the observation, then how can you claim it's refracting?
Sorry? If there are no bendy cranes.
There are no bendy cranes in your observation. Then how
All
can
right.
you claim, if there's no bendy anything in your observation, then how can you
Mhm.
claim it's refracting?
All right, we're looking through an atmosphere. The end. QED.
Yeah, there's always going to be a certain amount of refraction within the atmosphere. It could be absolutely negligible, in which case, then, if you're saying about the
I
horizon,
think it's
very,
negligible.
very,
I think
very.
that observation is negligible in the
Hold
statement.
on.
Hold on, Godric. Hold
Very
on.
close. It's going to be very, very close to the geometric horizon. It's negligible, but it's always going to exist. You would never be able to actually physically see the geometric horizon.
And so here's another
That's
question.
a fact.
If the
Argue
moon
if
has
you like.
mass,
Well, that doesn't make any sense.
Why doesn't it make sense?
Jeremy had a question.
The terms you used just don't.
What terms did
Well,
I use then? What's
the
use
word
of
horizon. Horizon.
Well,
must be
you understand
visible for
what
it
the
to be a
geometric horizon is. You understand what the geometric horizon is. It's like the physical horizon, right? You understand what I mean by that?
No, that's exactly what I'm attacking. The word horizon, in of itself, makes it the thing that you're observing and calling it as a horizon as visible.
The thing that everyone is
If
not
it's a
visually
horizon that is
impaired can
visible.
see. Everyone
you're
that's
saying
not
a
visually
horizon is not
impaired can
visible.
see
No,
it.
hold on. Let me
That's a
explain myself.
contradiction in terms.
No, it's not a total contribution at all whatsoever. Okay, so let's just pretend we don't have an atmosphere on the Earth, right? Let's just pretend for a second, all right? So just please try and do that. If you look directly at the horizon, that is your geometric horizon. However, we have an atmosphere. Okay, so you're not going to be able to actually see the geometric horizon because of the atmosphere. You just can't.
technically you'd see it, you just don't know where it is.
Okay, yeah, you could say that, yeah.
The location. You would see the location where it
But
would
you'd
be
also,
if we had
I
no.
would also, if you're
yeah,
going to say like
because we are.
hypothetically, just imagine it. I would say also you're far away from Earth. so
You
you'd
can
actually
laugh all you
appreciate
like,
that it's a
Rob.
curve.
You can laugh all you like almost if you want to, but that's just a fact.
I will, and I do.
Go
I'm
ahead,
laughing.
go fine. That's fine.
Yeah,
Go ahead, and
Make
laugh.
a fool of
fine,
yourself.
yeah.
So
I
here's the
don't need
question.
your
Why-
permission.
Go ahead,
to
laugh, and
laugh.
it's fine.
Laugh it up, fuzzball.
I just want to switch gears for a little bit. If Jeremy, you're good to answer or ask a question now.
If he
I
remembers.
mean, there's even a lot of flat earthers will say exactly what I've just said because I've heard them say it.
All right. So here's the
So
question:
what?
why is
what
the,
is
the
that?
pressure?
Are you lending credence to your argument because flat earthers made it?
Yeah, well, some
Is
some
that
of your
make it true?
because some of your crowd actually do agree with it, and
Some
they
like
realise that that's the
crowd.
fact. Yeah,
What
some
do
of
you
your
mean
guys
my
actually believe that.
crowd? What do you
Flat
mean
earthers.
my crowd?
Flat earthers.
Flat earthers? Who said
Yes.
I'm a flat earther?
Oh God, here we go. What shape is the Earth then?
It's level.
It's level,
And
so it's not flat then.
it is flat. Flat is
So
synonymous
it's
with
flat then. Okay, so you're a flat earther then.
level.
QED. There you go.
No, what do you mean?
What the hell
This
is
is,
QED?
you
What do you
see,
mean
this,
I'm a
is, this, is,
flat?
this is what like,
That's
you
not,
guys
that's
do.
not even a word.
It's just shifting of
Flat
the burden of
earther.
proof. I know what you're doing, dude. I know exactly what
No,
you're doing. You're shifting the
because
burden
you
of
don't
proof.
have an argument.
You are doing
You're
that.
just attacking my person. I mean,
I do have
who
an
cares?
argument because I've just stated some facts. The geometric horizon
No,
cannot be
you
seen
made a
because of a refraction in the atmosphere. That's a
you made
fact.
a generalization because some
No, I
other
didn't make a
flat earther made.
generalization.
You did. You said
No, no,
because
it's still a
some flat
fact.
earthers.
Regardless
Oh,
whether some
can I finish?
flat earthers agree with it or not,
Okay.
it's still a fact.
No,
It remains a
okay.
fact. That doesn't change. You can laugh at it. It's
Well,
fine.
what's the fact?
But it still doesn't change
Where's
the
the
fact.
fact here?
I just
What's
told
the
you what the
fact?
fact is. I just told you what the fact is.
What's the
Do we
fact?
have a
You
do we have
You mean
are we
in your
are we
model?
looking are we when
Okay,
you look at the horizon, are you looking through an atmosphere, yes or no?
No.
You're not looking through the atmosphere. So therefore we're
No.
not in an atmosphere. What a fucking ridiculous
Well,
thing to say. That is
no,
stupid.
because again,
That is the most
what's an
dumbest thing I've heard.
atmosphere?
Hold on, Matt. Calm down. A little bit.
Okay, all right.
We're
dude,
looking
sorry.
through air. I would
Yeah.
agree. Yeah,
Let's
we're
just
looking through
move
air.
on away from it.
Oh, so air is an
that would
atmosphere
be-
then?
No, it's
Oh,
not.
they've got.
I'm
they've
not
got
Air
a
is an
flat
atmosphere.
earther.
Because
You're
you
not
said
looking-
atmosphere.
If it's
okay?
on a flat
you're
Earth, it's
presupposing
not
your shape.
atmosphere.
Say atmos, and then you'll say yeah.
Okay.
Yeah,
I'm
we
gonna
just
agree
agree
with
that
that
atmosphere
argument
doesn't
here,
have
but
its
I'm
own
gonna
It's all right,
agree
dude. It's
because-
all right, dude. Just keep your head in the sand. That's okay.
that I'm keeping my head in the sand.
Anyways.
Yeah, yeah.
So here's the question: if the moon has mass, then it has gravity. So
Right.
and if there is gas in in the volume above, in the space above, then shouldn't
No.
it be pulling the more dense gases over time? So shouldn't it have more of a gradient?
No.
There isn't. No.
There's fuck all.
Why not?
Fuck all stuff.
There's no. There's not enough. There's not enough up there to make a gradient.
What are you talking about? There's constantly from Earth. There's constant helium
You
and
got-
hydrogen going
No,
towards
no.
it.
We got
No, there's
you got
not.
the magnetic field, you got the ionosphere, you got a lot of things that protect our atmosphere from solar wind. The moon doesn't have some of this stuff that would hold an atmosphere, so it just blows off.
stripped away. It's just it's just
What do
stripped
you mean?
away.
It has mass. It has gravity.
Yeah, but it doesn't. Yeah, but it doesn't have to. Yeah, but but like he just said, did you not hear what he just said? You need
Yeah,
more
okay,
than
but
just
that doesn't mean it should
Hold-
take
hold on.
away from the gravity effect.
Yes, it will. Right, okay. You didn't listen to what he said.
Alright, go ahead.
There's more. It's more than just gravity to hold an atmosphere onto a body, right? First of all, yes, mass does have an effect. You need a big enough mass to begin with. Secondly, you need a magnetosphere to keep it on there. And thirdly,
Why?
you've got this. Hold on, let me finish what I'm saying, and I'll finish, right? But thirdly, you've also got the solar winds, which strip away atmosphere anyway. It's the same with Mars. The reason why Mars has got such a thin atmosphere because it's got a very, very weak magnetosphere. That's why there's not
Okay.
enough. There's not enough
So
of
let's
that
go
to
one by
actually
one.
hold an atmosphere on
Alright,
the
so
moon.
one by one. The first thing you said was that you need to have enough mass. Now, isn't that something that would be proportional? You would assume that the more mass
Yeah, but
you
it's
have,
not
the
just
more
that. It's not just
gravity
mass
you have.
though. Yeah, but it's not just mass though. That's what
I know, but hold
that's
on.
what I'm
We're
trying to
going one
explain
by
to
one, step by step, bro. So the first thing you
Alright.
said, you need to have enough mass. That means that there's you need to have there's a critical limit of the mass that you need in order to attract any matter.
I'm not sure about a critical limit, but
Well,
yeah,
that's
there probably
basically what
would
you're
be.
saying.
But
You
if
need
you're
to
going
have
to
enough
ask
mass.
me,
The planet has to be enough of a size.
yeah,
I
okay.
disagree
But
with
if you, but what I'm saying is, if you're going to ask me what that critical mass is, I don't know.
I'm saying I disagree with your notion that you need to have a set
That's
amount
part- yeah, that's
for
part
you
of
to
the
have any
equation.
effect. I
Yes.
think it's
Yes.
proportional and to scale.
Yes, that's
Okay?
part of the equation. Yes.
All right, number 2. What was number 2 again? The thing that I interrupted about. Oh yeah,
Magne-
about
a magnetosphere.
magnetosphere.
Yeah.
Yes.
uh-huh.
So what about the magnetosphere will take away from the gravitational pull of the matter of the planet?
No,
Or
it doesn't
of the
take it away. It adds to it. It holds the atmosphere.
I know, but you said
Because
that
it
without
protects,
it.
it's a protection. It's a protection from the solar winds.
Okay, so if it doesn't take it away though, then over time it might take longer time, but over time we should still see this pulling of matter. It won't
No.
be catalyzed by the magnetosphere, but you
Because
still
it's getting
exist.
stripped away. It's got nothing to hold it there. It's
No, hold
the
on. That
only
was
thing
your
you've
third
got is
point.
mass.
Your third point was that stripped away by the solar winds. We're talking about the
Second and
magnetosphere.
third are the same. Second and third are the same.
So
Yeah,
the
that's
magnetosphere is
the
solar
same
wind.
thing. Yeah, exactly. Because the magnetosphere is a protection from the solar winds. So if you don't have a magnetosphere, which the moon has very, very little of,
Why
then
not?
the solar winds will strip it away.
Why does the moon not
That's
have
a good
magnetosphere?
question. I don't know the answer to that one.
Okay. And number 3, if you have solar winds, which is basically, as far as I know, like electrons from the sun, right?
Mm-hmm.
How is that?
There's a lot of protons as well.
Sure,
Yeah,
electrons and
mixed
protons.
mode.
How
Yeah.
is that pushing away physical matter from that has already been, or like that's kind of being gravitationally pulled to the moon?
Again, I don't know the ins and outs of this. Somebody else knows more, but I would have to explain.
Bacon, do you know?
No idea. That's a great question, by the way.
It is a good question. Yeah,
a lot of
absolutely is.
holes in this,
But there is a physical means of doing that. And it's
Not
something
knowing
I
an
fully
answer
understand.
is not a hole. Like if
It
we
is a
don't know
hole.
how something works, that's not a hole. It's just
Hey,
like
the-
we
We're
don't know
ascertaining
how
whether
they
or not
work.
it works as you guys say it does.
Well,
You got-
if you had reason for why that
They
would
haven't
not
reached
work,
that-
that's a
that-
hole.
that- They haven't
But
reached
Did
that
you
we
hear,
just
did you hear
don't.
the context, Bacon, or did you just get here?
Oh, I know what a hole is.
No. The context was if the moon has mass, as much mass as it has, then why doesn't it have more of an atmosphere? Wouldn't you
Yeah,
expect
I
that
understood
over
that.
time?
We just explained.
Yeah, that's what he was explaining. But the question on why would solar wind remove the atmosphere, like would prevent something from having an atmosphere? That's a good question. I don't know the answer for, but I don't think that's necessarily a hole just because we don't have an answer for it. It's just something we don't have knowledge
No,
on.
because otherwise, I mean, if you're saying it does it without knowing how or anything like that, that's an argument from ignorance. You're saying it's true, but without.
No,
without
that's not what an
evidence.
argument of ignorance. An argument of ignorance
No,
would
we
be
can-
I don't know,
I can learn it.
therefore it would be I don't know, therefore it can be X, for example.
Well,
No, you're
here's
saying you don't know
what
why,
we do. Yeah, but
it is.
here's what we do know. We do know that planetary bodies that have very little magnetosphere don't have an atmosphere. We just know that. So what the logical conclusion to that is that somehow the solar winds are stripping away the atmosphere.
Yeah, that's if you're
That's a
presupposing.
logical conclusion, right?
Oh,
No, it's not.
that's-
It's not
No, let me
presupposition
finish.
at
Let me
all.
finish, because my
It's a
whole point
logical
in
conclusion.
the whole
Even
math.
if you
1 second.
hang on, let me finish. No, let me finish what I'm saying.
Go ahead.
What I'm saying is, so like I said, that's a logical conclusion. So we witness this
Inference.
throughout the solar system. We see this all the time. So the logical conclusion is that somehow the
Inference.
solar winds are actually stripping away the atmosphere.
I hear you.
So
I
I can now you're actually asking why. We don't know the reason why, but I could go away and I could learn why. But
Alright.
just because
Let me
I don't
just
know
respond
something
to your logical conclusion part.
doesn't mean I'm arguing from
I hear you.
yeah. Do you see what I mean?
But in terms of your logical conclusion part, that's
Inference.
with the premises that you have. And my whole line of questioning was that maybe you have a faulty premise in that your claim, that there's not much of a gradient, or that it's basically a zero and then a little bit more zero at the surface or something, stuff like that. I'm saying maybe your premise is faulty. So sure, if we take your premise, if we automatically presume it's true, then it would be logically sound. My whole point is that we don't have evidence to say that it is that, though.
Okay, so
you
if
can't
I
just point to other
explain,
planets that you haven't
all right.
proven that they are too, because that's the same
Okay,
issue.
so if I explain to you, if I knew the answer, if I explained to you how the solar winds were actually stripping away the atmosphere, what would be the next step then? What would you say to that?
Well, it would just be less holes for this claim that there is.
Yes,
very
there's
little
less holes.
gradient on the moon.
So you're gonna still say that I'm arguing from incongruity because there'd be something else that I don't know.
No,
listen, we don't know. Hang on. We don't know everything. Okay, not everybody knows everything. Okay,
That's
so
not
you can
what I'm saying.
go from one step to the next part, but
I
you're
think
still
you're
going to find
strawmanning me right
something
now.
that I'm arguing making presuppositions.
No, that's not
So it
where I
really
would
doesn't
go
make
with
any. It really doesn't make any difference whether I knew that or not. To be honest,
That's your
with you.
opinion, man. That's not what I'm saying.
Yeah, it
I'm
is an
saying-
opinion. Fair enough.
I'm saying that the actual evidence that you would need to say that there isn't much of a gradient on the moon is actual samples or
Well, there is no
pressure
gradient.
readings from the moon, and
Right.
comparing that with in space or something like that. then you're not starting off with this circular logic that you're trying to this self-confirmation bias that you have to try to prove because of your premise that you've set up that hasn't been proven. I say first prove the premise.
And none of us have gone there, so no. We can go to China or Australia, but we can't go to the moon.
People have gone to the moon, Godric, the end.
I guess that's where it boils down to, yeah.
Who's gone to the moon?
Like 100, not 100 people. How many people on the moon?
It sounds to me the question of why doesn't the moon has an atmosphere? It sounds to me that question is within the globe model, So if you stop in the middle of that discussion to ask for evidence that like the moon is actually what we say it is, I feel like that's a different conversation.
I feel like according to the globe model, without these like ad hoc arguments that you guys made, that the moon would have an atmosphere. It would be.
It's not. That's not ad hoc.
Especially with NASA's especially with NASA's thing like from 3 years ago or whatever, saying that the moon is in our atmosphere and that there's always this low-level amount of hydrogen and helium gas that's being pelted, like that's going to the moon and extending far, far, far beyond it. You would think that it would catch some of this with its gravitational pull and keep on like slowly and surely having more and more of a gradient over thousands of years. You would expect that to have more and more of a gradient.
Hold on, I think
but
you need
it
to withdraw
doesn't.
with.
So there's no refraction coming from the moon.
You can't say that it doesn't because we haven't
which is where we were
been
half
up
an
there
hour ago.
and tested it.
I think you need to withdraw that statement when you're making an ad hoc argument. We didn't make it up. Ad hoc basically means you just made it up. That's not. We didn't make this up.
I didn't say it's your ad hoc argument.
You said it
sounds like an ad hoc argument because there isn't evidence for the stuff that you guys claim, or at least.
Well, it isn't. It isn't. What are you suggesting that we made it up on the spot? Then is that what you're saying?
Did you hear what I just said? I didn't say it's your ad hoc argument. That means that you didn't make it up. But
okay,
it could be potentially made up
somebody
because you guys don't
that
have the evidence for it. You're saying you don't know
why. I said I don't have the evidence for it. No. You're making an assumption that nobody has the evidence for it. That's not true. I just said that I don't.
I didn't say that no one does. I said you guys don't know it, so it could be.
Yes, exactly. Yeah, but it's not ad hoc then, is it?
It could be. What do you mean?
No, it's not. How can it? We didn't make it up because it's known.
Okay,
how is that ad hoc?
If you're parroting this information and there isn't actually any answer as to why the moon is like the solar winds are getting rid of the matter of the moon's atmosphere,
and you're just making a circular.
There isn't any answer to that. Then what would you call it?
That's what you're suggesting. Just because we don't know the answer, that doesn't mean it's an ad hoc
saying if
argument.
there isn't any.
You're not even letting me finish.
Well, I'm correcting you.
So yeah, but you're basically saying because an ad hoc basically means you just made it up, right? Okay, just because I don't know the answer or somebody else in this chat doesn't know the answer does not make it ad hoc because other people do know the answer. So therefore, it's not ad hoc.
That's a positive claim. All right. Then,
yes,
then show me
somebody else does know. I can
100%.
I could quite easily get somebody else who could actually explain how it all went.
Okay,
I could go, or hang on, hold on, or somebody, I could go away and I could learn how that was done. But that's what I'm saying is that if I then went away and did that, you'll find something else that's saying, oh, that's
no,
still
hold on, don't jump, don't skip ahead. All right, if you find that,
you would though.
Then hold up. If you find that, then it will not be ad hoc. If there's an actual evidential explanation for it, then it wouldn't be.
Well, listen, we're going around.
Anything.
We're going around a circle because we're getting nowhere because it's ended up in a bit of a circle.
I feel like you're backtracking now.
No, I'm not backtracking at all. I'm not back. It's pointless because we're going around circles and we're just having semantic arguments and it's meaningless.
No, you're disagreeing with my usage of the word ad hoc. It's potentially ad hoc without knowing any more, without having evidence.
All right, okay, I'm having an ad hoc argument. Okay, all right, okay, you win. Okay, all right.
It's not to win, man. Come on.
It's just a pointless argument because it's semantics.
All right. Words have meanings, but semantics.
I'm not into arguments about meanings of words and all the rest of it because that can go on for hours and hours and hours about the meanings of things.
That's not my intention either.
Okay, all right. Well, it might be your intention, but that's how we've ended up, though, isn't it? So it's pointless.
No, we've ended up because you got hung up on my correct use of the word ad hoc.
All right.
So as much as you say you want to avoid semantic arguments, you're the one that got us.
Okay, yeah, it's more my fault. You win. Okay. Gordon Bennett.
God keep you, man.
Fuck you too. Where did that come from? Wow.
I said God keep you. What the fuck?
I thought you said fuck you. Okay, my bad. Sounded like you said fuck you.
No, I said God keep you, man.
No, you don't need to say that because I don't believe
That
in
was
God
a funny
anymore.
reaction, though.
Yeah, so you don't say that, mate. People miss it.
How the globe works, I get it.
Whoever just spoke, I have no idea what you just said because you broke up.
That's not how the globe works, guys. Okay, understand? Because science.
Yeah, globers don't know how the globe works.
Here's the thing, though. Let's say, for argument's sake, that the solar winds are actually affecting the moon's ability to gravitationally pull these molecules, these gases, right? Let's say it's happening. The moon still has a little bit of a gradient, as you guys said.
No, we didn't say that. We didn't say that at all.
Hold on. It's not perfectly zero, right?
No, we didn't say it had a gradient either. Nobody said that.
Okay, but implicitly, it has a bit of a gradient if it's not perfectly zero.
No, it doesn't. It doesn't have a gradient.
Okay, so what are the pressures at the surface of the moon and then
Right.
space?
Okay. Well, listen. There is a tiny amount of gases that are actually leaking from the moon, and I mean minuscule. Okay, but the gases that have been detected, okay, again, minuscule amounts are actually coming from the Earth. That's basically what the very limited amount of gas molecules that have been found on the moon are from the Earth.
Okay.
And a mixture of some actually leaking. So there's no gradient.
Sure,
there's no
but in terms
detectable
of,
gradient on
no, hold up.
around
In
the
terms
moon.
of the differential between the gas, the pressure on the moon, on the surface, versus out in space. Out in space is like 1 times 10 to the negative 17 torr. That's like the common toted value, right? What's the pressure on the moon?
I can't
More or
remember
less.
what he said. I don't know. I think who was it? Somebody said that before earlier on. I don't know.
I think you said
10
3
to
times 10 to
Wait.
10 to negative
5.
16 or something like that. Something on those range.
Wait, you made a claim. How do you know the gases on the moon are from the Earth? How do you know they're not from Uranus?
Hold up, Godric.
What's your
Let me just follow up.
Yeah, I caught that.
Nail down my thing first. The whole point is, though, it's not zero. The difference between space and the moon's surface is a non-zero value. Sure, it's a very, very small, we could say negligible value, but it's non-zero, right? Are you with me?
Right, yeah, I'm with you.
Okay. So that being said, if the solar winds are getting rid of the moon's ability, or like reducing the moon's ability to hold on to these things, if it was a net negative, then we would assume over time that the pressure would be exactly the same as in space if it was a net negative, right? Because the gravitational effect would be zero.
Yeah, but that's
Hold on,
only
let me finish.
assumed.
Hang on. If it's not
okay.
a net negative, it's just heavily reducing it. Then all you're doing is stretching the clock farther. Where now it takes where it took 1,000 years to get X amount of pressure, now it's going to take like 10,000 years to get X amount of pressure. You understand what I'm saying?
You could probably say that, but the thing is that the amount of gases that are actually leaking from the moon is so negligible. It's really down to the ability.
I'm not talking about the source of the gas.
Yeah,
Doesn't
hold
matter whether
on.
it's from the Earth or the moon.
Okay, yeah, hold on. But I mean, that's assuming. But you've got to be able to have a planet that can actually produce atmospheric gases to begin with, whatever that consists of.
Sure,
Which
but that's not relevant right
the
now.
moon actually doesn't.
We're not
the point.
disputing whether or not the gases exist. The gases
Okay,
exist,
so
whether it's from Earth or the moon doesn't matter. My point is, if the solar winds, if the moon's surface has a pressure that's negligibly more than space, that means that there's still an effect of gravity. There's still a little bit of gravitational pull. It's not completely eradicated by the solar winds. You understand me?
Yeah, but it's probably not sufficient enough to do that. That's what I'm saying.
Even so, that means that over time, because it's a non-zero value, it's a positive value, that over time, the atmosphere would get more and more dense at the surface. That's what
if you had a strong enough magnetosphere, yes, but there isn't. It's almost non-existent.
So you need
I
a
don't know if you're
planet.
understanding what I'm
So
saying.
I don't understand your point. I don't get your point.
Bacon, do you get my point?
I'm sorry, I wasn't following.
Go ahead, Jeremy.
So you need a planet that's producing gases to have this gradient. You said,
And a magnetosphere to hold it. Yeah,
so the Earth is producing gas.
correct.
So it's not a net zero. I've heard a lot of globers tell me it's a net zero thing. It's a cycle. So it's not a net zero. Not net
aware of
zero.
that. What do you mean by that exactly? Just
gases get produced, gases that get consumed. There's a net. There's no gain.
See, we would
Yeah.
have to be gaining pressure.
Hold on,
all the
Godric.
time.
You're next, bro. You're next, bro.
Okay.
I'm gonna be 2 seconds.
Sorry, go ahead.
So you're saying gases are getting produced and there's a net gain of gases on Earth?
No, I'm not saying that. No, because obviously gases can only change into other gases, right? Okay, so we breathe in oxygen and we breathe out carbon dioxide, right? And we don't consume the rest, right? So it's changed. So then things like plant life, algae, and all the rest of it is replacing that oxygen. So don't think there isn't a net gain. No.
So Earth's not. So you don't need a planet that's producing gases.
Well, yeah, you would do because those gases need to be produced to begin with. But what you're talking about is a net gain or again net
Well,
loss.
Matt, you're kind of contradicting yourself, but let me try helping you out.
No,
Basically,
okay,
you're saying that it's not the gases
I'm not
aren't
explaining
being
myself.
created. Yeah, the gases aren't being created; they're basically being recycled.
Correct. Yes. But you need something. You need something to actually produce those gases in the first place, right? Because otherwise, you're not going to have that atmosphere. Correct. I mean, you can't. The gases can't just sort of appear on a planet just out of nowhere.
Well,
You need
if you have
something
mass
produced to begin with.
if you have mass attracting mass, then when gas goes near the moon, you got mass and you got mass, right? Gas in the moon. You should have an attraction there, right?
Yeah, but like were you not listening to the conversation before, Jeremy?
Yeah, no,
About
that does
the
happen,
atmosphere and all
Jeremy.
that kind of thing.
That
Yeah.
does happen. They say that it's hugely like reduced by the solar winds of the sun blowing away this attracted matter, right?
Fine,
But
go ahead,
still,
Godric.
it's still a net positive. It's still there is still a little bit more atmosphere at the moon's surface than in space. So therefore, if it's a net positive, you increase the scale of time, right? You would expect that there'd be more and more atmosphere on the moon's surface relative to space, because it's going to keep on very slowly but surely accreting all this matter.
Yeah, but again, that's providing that those gases can be held to the mass. Because it's like I said, it's not just the mass that's involved. That's only part of the equation, like I said before.
No, that's provided for already, given the fact that it's not a zero difference. If it couldn't be held on to the planet or to the moon, then the difference in pressures would be equal. The fact that it's a non-equal value, it's a non-zero value, it's a positive value at the surface, means that it has the capability of holding on, even though it's hugely limited because of the solar winds. It still has a little bit of capability of holding on to this matter. You understand?
I just have a thought. If gases
go ahead.
if gases are being produced, wouldn't that mean the exact amount of gases would be escaping Earth? That way we have an equal balance, like a net zero. Or else what happens to these gases that are being produced?
But they're being changed, basically. They're being chemically changed to something else. Because, like I said earlier on, we breathe in oxygen, right? We don't absorb the other gases, only oxygen, and that's turned into carbon
Well, we
dioxide.
can say that the plants have a cycle. The plants take in the carbon monoxide and make oxygen, and we breathe the oxygen.
Correct.
That's like a balance. But are you seeing other gases turn into coal or something? Because they are being produced, aren't they? So what is?
Yeah, but it's recycled.
Excess,
like percentage said early on, it's being recycled. There isn't exactly what we were saying to Jeremy earlier on. There isn't a net gain or a net loss.
And you could say
Is there underground gas? Is there underground like natural gas spots?
Good question.
When we, tap into the
yeah,
ground and there's like this massive amount of natural gas under there.
There is, yeah. I'm not quite sure what happens to that. I don't quite know. I
A volcano goes off. Is there any gas
Yeah.
that comes out of a volcano?
I should imagine that's probably all recycled as well. But how that happens, Jeremy, I don't honestly know.
I personally don't think it's net zero. I've argued for a long time that it's not a net zero.
So do you think it's a net gain then or net loss?
I don't know. In your I mean, even in your model, you claim to have 150 metric tons a day of gases escaping. So,
yeah, I think.
I'm sure they also say that because of solar. Actually, I don't know what the argument is. Because of our magnetosphere, do we not gain like this from solar winds from the electrons and protons of the sun?
Not I'm aware of. But no, that is actually a good question though, Godric, and that's a good point. I don't know the answer to that. I don't exactly know what the process is, but from an educated guess, I think they're also probably being recycled as well, because I'm pretty sure that plants don't just absorb carbon dioxide and turn it into oxygen. They probably absorb other things as well. I'm pretty sure. But again, I can't really speak authoritatively on
And a
that.
side question: do you know how many pounds of meteors are hitting the Earth every day?
I'm not even sure
Off
a
the top of my head,
plant.
I've no idea.
I'm not even sure a plant is one for one, because it's not like it takes in a carbon dioxide molecule and spits out an oxygen molecule. Like it doesn't transmute or change the molecule. It uses the carbon dioxide to it's the Hill reaction.
Why
The
wouldn't it?
the
Why wouldn't it
weight
do that?
the weight
It
of the
doesn't take.
tree
What do
comes
you mean? Why
from
wouldn't
carbon
it?
dioxide.
Sorry,
It
Bacon.
doesn't.
What
That's
were you
not
saying?
how it works.
Bacon.
I
What
said
were you
that's
saying?
not how it works.
Hey, Jeremy, can you let Bacon? You had a point there.
No, I'm not. Maybe I'm not sure if this is relevant to the conversation, but like the weight, almost all the weight from a tree comes from the carbon dioxide that it was breathing. So a lot of the carbon dioxide that it gets absorbed by the tree itself.
Yeah, because it doesn't take a carbon dioxide molecule and like do something with that molecule where it changes it into an oxygen molecule. It doesn't work like that. It's called the Hill reaction.
Oh yeah, it absorbs it, but doesn't change it into it. But then the
Yeah.
process for other processes like because of the sun, then produces oxygen. Yeah, but yeah. So I misspoke earlier on. Yeah, that's okay. That's fair.
What do you mean? I thought it does use the carbon dioxide.
Like
photosynthesis, right? You have the carbon dioxide with water, and then it uses that and it makes glucose.
Right. Yeah.
By way
Yeah,
of
right,
like the
okay.
chlorophyll that basically absorbs the light's energy, the sun's
Yeah.
energy.
Fuck, it's been a long
Look
time since I
into
looked at that.
look into the Hill reaction. I don't think it's a one for one. The Hill reaction makes me think it's not a one for one. That's all.
Anyway, I'm going to go to bed. Listen, it was
I
a
don't
good.
know about whether it's one for one or not.
That was a good discussion. Yeah. Sorry if it got a bit heated. Percentage. No offense. It was still
No, you're
still
good,
fun.
man.
Appreciate it. Yeah. You have a good night, guys. See you later. Have a good one.
Good day.
Night.
What was that guy's name? He seemed okay.
Matt.
What is it?
Matt. Matt something. Yeah. Matt. What was it?
M2M.
M2M.
Yeah, Matt M2M.
Oh, no doubt. Yeah, like it doesn't take a carbon dioxide molecule, right? And then like change that molecule into oxygen. Like it takes it, and then the oxygen comes from water, right?
Yeah.
Where do you think it's getting an oxygen molecule from?
No, the oxygen's from water. Yeah.
Yeah, that's what I'm saying. That's why I'm not 100% sure it's one for one. And plus, I'm pretty sure the Earth is not a one for one either, because, like I said, there's just gas under there right now. That shit an earthquake might happen or something and blow a giant pocket of natural gas out, and where's the one for one in that? Or a volcano or something. What about when meteors hit? Godric just said a million meteors. 15, I think it's 15 million micrometeors, meteorites, and meteors enter our atmosphere a day. 15 million.
Yeah.
There's got to be gas on that, no?
Yeah, they'll just say that that the gas is escaping at the same rate, so it's in net zero.
They do say 150 metric tons a day we lose. I think it's probably a net loss. I think they got the globe burning out. Oh boy, fucking party's over, guys. Here we go.
And the to avoid 99.9999999% of those little meteorites whizzing
Well,
past.
they burn up, but
God, you guys are insane.
Well, they're really burning up to that huge level at the height of the ISS.
That's what they say. They say it. Go ahead, Banta.
I was going, how can they?
I thought they burned up like closer to Earth. The huge majority of them.
Yeah, they say they burn up when they hit Earth's atmosphere. I don't know where that line is. Good luck trying to get that out of them. I've been trying to get that one for years, but
that starts at Neptune.
Neptune, that's it. I thought it went to fucking forever, infinity and beyond. Buzz Lightyear.
Oh, exactly.
I think it's Uranus, guys.
Well, it's definitely Uranus.
Seriously, where does that?
Oh my god! Can't believe you guys are arguing with a light expert like Ruhiv.
Dude, did you ever see his fucking formula for refraction? You got to be kidding me with that shit. It was 3 pages. He didn't know what any of it meant. Ask him what the K means next time.
Okay. It means confused. The K, confused. So what do you guys think? Bloody light travels in straight lines in rays.
I don't know. It's got to be. I think it has to be bending.
But why do you think it travels in rays?
Oh, I don't know about all that. Even their guys say those light rays are just conceptual things and don't actually exist.
Yeah, I don't know.
Yeah, I mean, it would be if you trace back the photons, the rays would be the path.
So
Photon path.
percent, if you had, like, because you were talking about the sun there and you were drawing all these lines, arrows and all that sort of stuff, right? So how would your perception of light be instead of those light rays being like straight lines or photons and stuff doing what they're doing, if it was like a bubble that was emanating out from around the sun constantly, if you know what I mean? Trillions and trillions of like little bubbles just emanating out from the sun. Would that change the way that little model
If bubbles were emanating from the sun?
Yeah, exactly. So the light itself, right? So you got your energy source being the sun, okay, and then a bubble coming from it, but not bubbles like little bubbles popping out from around the surface, like there was a bubble around the sun itself, and that bubble then got bigger and bigger and bigger and bigger. If you know what I mean? Does that?
I think I know what you mean.
Yeah,
I don't really visualize it like that. Like I think what it is that the sun is in a medium, and we're all in a medium that basically it's this medium of whether you want to call it ether or electromagnetism or what have you, and then at like the impetus of a signal or like a stimulus, there's kind of this interaction wherein you have like the excitation and at the source, right? And it travels through this medium to the receiver.
Yeah.
And I imagine it traveling like in every direction, like any other wave, you know, like when you drop a pebble into a pond, it goes in every direction, right? But it's only going to be received at a specific point, you know. That's how I imagine it. And that specific point that it's received is going to be a straight line from the receiver to the source, you know.
Yeah.
Let me get in here real quick. Let me get in. So if you got a sphere, right, and these little photon balls shooting out of a sphere, there should start to be gaps after with more distance, the bigger the gap will be.
Yep.
You feel me?
Yeah, if this kind of thing had a set size, right? But if it's just something that kind of, if it's, how can I explain it? Like a shock wave, you know, it's gonna maybe lessen in magnitude, in intensity, but it'll bridge the gaps. It'll be like smooth, and there won't be any kind of cracks, as you might call it.
Yeah, that's what I mean. If it was like a ripple from a pond, yeah, it would get less intense. You throw a rock in a pond, you get those waves. But if it was physical balls shooting out of a sphere, you're gonna have gaps, bro.
Absolutely.
The farther out, the more gaps you're gonna get.
Yeah, and that's why photons aren't physical things. Like, it just doesn't make sense.
Well, so I know a few people that would argue that one with you.
No, but those same people would say that photons are packets of energy, right? And you could have photons of different, energy levels, which contradicts that first thing. Because if it was a physical thing with a specific size or energy level or what have you, then it won't be decreased. It'll just kind of, there'll be a crack from where it isn't to where it is, But if it actually is like a ripple of water, then you would expect that, with the inverse square law of light, you expect that the magnitude of it, the intensity of it would decrease, even though it's like, not kind of really cracking or being like having gaps.
I mean, if it's these physical balls, I would expect it to not decrease unless you're in like an atmosphere or something, like in space, and there's space where there's like not, they say there's no atmosphere or anything. Like, I wouldn't expect distance to make it get less dim, because there's nothing stopping it. Why? What's stopping it? It's this little ball that left and it didn't hit anything or interact with anything the whole way. What would stop it? Why would it get less bright with distance? Right? Is that crazy or?
No. I think that's a kind of a proof for the fact that it's not like this physical ball that has no interactions or what have you. That it is kind of energy that's losing energy as it goes. I don't know. That's how I.
You think the photon balls are like just losing energy?
I don't view it as a photon ball. I view it as just like basically this wave, like the excitation from one part to another. And obviously, as it goes, as it expends energy to move, it's gonna decrease in that energy that it has. I think the only reason.
I mean, I think there's more. From what we see it doing, I think there's more evidence that it's like ripples in a pond.
Yeah, absolutely.
Like the light's already there and it's just being excited or something. I don't know.
They kind of get this idea that it's like a ball, like a physical thing, from when they detect it on like the screens in terms of like these, quantum eraser and different experiments. But basically, what they're doing is they're just registering this, this energy where it hit. And I'm not saying that you can't affect like the kind of, because I said it's between the source and the receiver, right? And I'm not saying that you can't somehow affect that path. Like normally it's a straight line, but it's possible that you can affect that path somehow, or it's possible that you're thinking that your source is straight ahead, but maybe it's actually off center or refracted or something like that. Who knows?
I think if you have a ripple, you throw the rock at the pebble in the pond, right, and it ripples out. But say you have a pole coming up from the water to the air, right? It's gonna fuck your ripple up.
Exactly. Say there's a gust of wind, and all of these ripples instead of it being a perfect circle from around that pebble, it's now this ellipse, this
little gust of wind. I like that one. It's better, yeah.
But when you're doing this QE experiment too, percent, you are experimenting with a man-made light in the form of a laser that you are shooting. You are actually directing it.
Mm-hmm.
You know what I mean? So, and so is that actually how, say, the sun or the stars work, like a laser beam?
Yeah, I don't think that's an issue. I mean, this is my opinion. I would imagine that if you were to just redirect the sun's light and with the use of lenses and mirrors, have that as the source instead of like this laser, I think you would probably see the same effect. But that's just me, my opinion. I don't know.
Well, you've got coherent light and incoherent light, right? And the sun and a laser beam are two different ones.
Exactly.
Yeah, but if you were to redirect and using lenses converge the sun's light, then you'd be basically making it coherent with all the mirrors and stuff.
Well, it'd be interesting to do the same sort of experiment, right, and put the source of the light being outside in the sun itself, right? Instead of using a laser beam, like I said, it's a man-made device. You are funneling it, you are directing it in a very, very particular way. With
We
the
have
motion.
Could you make it tiny? Oh, go ahead.
we have the
Okay.
sun's light, we have laser light, then we have what we see in reality.
Could you make a tiny enough hole so that just one photon could get through or something? And do the double slit with that, you're saying?
Yeah, I mean, it's
Possibly.
theoretically possible.
Yeah.
You'd have to like have this kind of chrome exterior or something like that to reflect all the other light.
But once
Well,
again,
why reflect it though? Why not just have a tiny hole so
Hmm.
that you could just get
No,
one
I'm saying
photon?
for the full contraption, you wouldn't want other light to be getting in and fucking up your experiment, right? So aside from that little hole, you'd want the rest of the sun's light to be reflected or something, unless you just actually like converge the sun's light and use mirrors and everything and have already a beam to begin with.
Yeah, don't know.
All this shit you got to do to prove a globe, and yet when I look at the horizon, that shit's a flat line. Like, what about that?
It's it's flattening the curve, refraction and all that. They know how this shit works, man. Ruif has a 3-page formula for refraction, right? These guys are fucking experts.
Wait, the formula is 3 pages?
3 fucking pages. That
What
son
the
of a
fuck?
bitch.
I think the pages are to derive the formula, not the whole formula.
I asked him for a formula for
How does a
refraction.
Glober
He
explain
sent
the
me 3
Pacific
fucking
Ocean?
pages.
Yeah.
How does a Glober explain the Pacific Ocean? Is the entire surface level?
When you
Well, they're
talk, when you
tied, so
talk to
no.
him, when you talk to him next time, percent, ask him how many terabytes of weather balloon data does he have? He's got like 723 terabytes downloaded of weather balloon data to prove his refraction.
That's crazy.
Well, isn't
Yeah.
more data better?
I wonder how much he's actually looked into of that 720.
Weather balloon data cannot prove what we see.
Oh,
I'm not asking that.
he's got graphs
I mean,
for all over the world, Excel spreadsheets. That's crazy.
it sounded like having a lot of information
Yo, I
would
gotta
be
go,
a
guys.
bad
Catch you
thing.
guys later.
All
I
right,
don't
Zed,
get
catch
that.
you later, buddy. Sorry, Bacon.
I'm saying it sounds like you guys are saying having a lot of information is sort of like it's sort of a bad thing. Somehow weakening his position that he's using a lot of data for the stuff he's doing.
Oh, no, he's a very impressive globe pusher. 100%. It is
Well,
a passion.
trying to,
It's a passion of his, definitely.
but the more data you're applying to a model, if the model is wrong, the worse it would be. Like it's harder to match more data if the model is wrong, right? So like having a lot of data is it's not like you're trying to push your model. It's,
Oh, he definitely pushes the model. 100%.
that's not what I'm saying. So,
Yeah,
that's
I'm
all
just
saying.
wondering, what shape do Globers think the surface of the Pacific Ocean is?
Yeah, well, the whole Earth is very close to a sphere, so Pacific
All right,
Ocean is a
so
very
is
part of
water
it.
level on the Pacific Ocean?
Well, there are tides, so no.
So the shape of the ocean, there's no curvature. It's just determined by tides.
That's not what I'm saying. But like even on a flat Earth,
Explain
if there
what
are
you're saying.
tides,
I repeated what you said.
yeah, no, you didn't. You said something different.
Okay, so
but
what's
even
the
on a flat
difference
Earth,
between curvature and tides?
yeah, even on a flat Earth, if there are tides, there are different elevations on the ocean, so you would still not be level, right? Do you agree with that? Do you understand what I say? I can try to make it easier, maybe.
So you think that the elevation is just rising and lowering based on tides, and that there is no actual curvature to be accounted for?
Didn't say that. I'm
And that
asking
it's
if
like
you
a
agree.
curvature. The waves are following the curvature. Like, I don't understand what you're trying to say.
Yeah, I'm trying to say that tides are if there are tides, then it can't be level, right?
Okay, let's say that there's not a lot of tides in like 100 miles. What shape is that? Is the surface curving?
Yeah.
Just yeah, that's it. Just yeah.
Well, you asked a yes or no
Are
question.
you
The
even
answer is
thinking
yes.
about what you're saying right now? I don't have time for this. I
What?
don't have patience for this.
Okay, you asked me a yes or no question. I answer yes, and okay.
So you think that the surface of water can curve?
Yeah, we all know it does.
Yeah,
Like,
yeah,
even you know it
yeah.
does.
No,
Okay.
it doesn't. It doesn't. Sorry.
So you don't believe in water droplets?
Bro, it's okay if there's evidence that you're not on a ball. It's not that crazy. You don't gotta be so
It would.
subscribed to
It
what
would
you
be
learned in
crazy.
elementary school.
No, it would be crazy. So many this oh, he just left. Okay.
What were you saying about it, Bacon? You think it would be surprising to you if it's not a globe for you, or
Yeah. I'm sorry. I think I'll have to go in a couple of minutes, so maybe this conversation won't be too long. But yeah, the number of things that I think would have to be different if the Earth was not a globe. It's just it's just too much things, and yeah. So he said this wouldn't be crazy. I think it would, because there's just too many things that depend on Earth being a globe that would have to be different.
just in the model, or actually in reality? Because I mean, in reality, nothing would change. We already fly airplanes as the Earth is stationary. We already travel upon it. Nothing in that term would change. You're just talking about like people's philosophies would change, people's mindsets.
No, I disagree with that claim that we fly airplanes as if the Earth was. Well, maybe stationary. I could give you that, but definitely not a flat surface.
Well, I guess what I meant is this. Let's just say right now there was absolute, for you, 100% verifiable measurements or proof, whatever you would need to be like, okay, yes, the Earth is not curving, etc. And if you knew it was stationary, just on that alone, I'm just saying, like, we would still do what we do as humans on the Earth. Like, engineering would all work, travel would all work, everything would all already be working. It is what it is. Now, there would be a lot of like philosophical changes, financial, media, government, all that stuff. There's all that kind of, uprooting the deceptions within quote unquote science and the way that this sort of occultism has come in to kind of deceive people. But what I was just saying to you is that, like, just the actual, if you were to know that right now, wouldn't you just have to change your own philosophy and understanding of things? Because everything will still be going on Earth. We'll still be
No, not
traveling
everything.
and building
For
things.
example, in my job, I had to, like a month ago, I had to, one of the rules of the anti-fraud department where I work relies on the distance between locations, right? So there I would have to go back and change that, because if Earth is not a globe, then my math there is wrong.
Right.
But
No,
I'm sorry, I'm not
you
gonna be
definitely
able
would
to
have
do.
gotten some things wrong, but I mean, you just have to go back and correct those. Like, I'm just saying, where does the kind of, because you were saying it'd be crazy. Like, what did you mean
Well,
by
not
that? I
for
guess.
me specifically. Like,
Okay, just
but
for the
I'm
world.
sorry,
for
I
the-
won't be
for
able
the-
to. I won't be able to answer now because I gotta go. But we can try to move on from this point. Next time I'm free.
Yeah, man. Yeah, no worries. Yeah.
So see ya.
Cool.
Yeah.
All right, Bacon.
Have a good one.
Yeah, not too much would have to change, would it really? Like the distances between places, Geo. Like that's a number in an equation. So they just change that number. Like if they had the exact distances, say, between California and Adelaide, for argument's sake, all you're doing is just changing a number. So nothing would
Right.
have to change dramatically at all. Maybe just the exact layout of things may change.
Yeah, like some subtleties of the map would have to be
Yeah.
tweaked and set correct. Yeah.
Yeah.
We'd basically just we would be able to see how they spoofed it, like how they fudged it, how they basically created the falsities within whatever the geometry of the coordinates they're using. So yeah, that would have to be kind of sussed out, because we'd have to really compare what they're giving us to what the actual land is. And what's even more interesting is that if these people at some point are kind of removed from their power position, they may already have the correct map. I'm sure they do. I mean, with all the military and high altitude devices, I mean, they've already got the layout. So whether we figure it out ourselves and remake it, or whether we just get it kind of back from them, either way, or get it from them in a sense. Yeah, we would just compare the two and say, yep, well, that's what they did. That's where they fudged it. That's where they did it.
And in reality, right, if things work at the moment, right, even if the revelation comes out, yes, it's a planar surface, you don't technically have to change anything, do you? To fly aircrafts or to do what Bacon does, you could still use exactly the same equations without changing a thing at all, because they'd still work.
Yeah. Yeah, even the 3959 number, that's actually interesting as well, how that links into it all.
I just think it would change people's philosophical outlook on where they are and who they are and where they've come from, actually. But as far as the day-to-day workings of how we go about conducting our lives here, I don't think anything would have to change at all. In all seriousness, we might have to add a few more continents in the outer ponds that haven't yet been revealed.
Yep. Yeah, pencil a couple of those in.
Exactly.
And have you heard the idea that there's, when you go into the outer region, as it were, like beyond Antarctica, that it might be icy and cold for a bit, but if you keep going, you just start coming to another sunny, warm area.
Yeah.
And then there's like another sun circling the entire Antarctic region.
Yes.
And then the idea that because that's so much a larger radius out, it's so much more distant out, there would actually have to be like the idea of two suns that are both 180 degrees from each other, and then they make like a type of a day cycle with two of them.
Well, that's how over the years there's been reports of people seeing two suns or two moons. There've been these reports out there that we have our constellation where we are here, Geo, that is in perfect synchronicity, okay, just like a clock, right? And if there are outer ponds, they all also too have their own constellation of stars that are in perfect synchronicity, like a clock. But every now and again, that minute hand, that hour hand, they slightly cross over and, overlap, each areas.
Did you say outer ponds by itself?
Uh-huh.
Somebody said outer ponds. I had to come in and talk because
Yeah.
the group I was always in before, they would sometimes say outer ponders just to get me to come in, and I would be like, someone say outer ponders, because I was like the one that was like coming up with all the outer ponder talk more than anybody.
Ponders, yes, yeah. I think it was you that said I heard that phrase from. I just called it in the past as other lands, I suppose. But yeah,
it has a nice sound to it. Outer ponders.
It does, Dave. 100% outer ponders.
Have you seen all the outer ponder artwork that I have? It just makes the most sense. I mean, it has to be, a lot bigger, right? Even within our own pond, I think there's extra continents for sure.
Yeah.
Like maybe even large continent, maybe like at double the amount.
Well, I think when you're talking alien craft and these sorts of things, UFOs, I think there's a high possibility that this is where these things are coming from too.
Right. And even if it's not, they may tell us that's where they're coming from.
Yeah, well, yeah.
And just say, yeah, we have a special connection to the outer ponders. You better do what the outer ponders say. Look at this tech.
Exactly.
Look at these directed energy weapons that blew up your neighbor's house. You didn't follow instructions.
Oh,
Yeah, like I'm not saying this is the case, but have you guys ever thought about this idea where what if there is outer civilizations beyond Antarctica? And what if the people that are asserting themselves as controllers, as it were, like whoever this cabal like of people or of entities, what if what if they use the same money that we have here on the outer civilizations? It's just an idea. Like I said, I'm not saying I think this is the case. It's just an interesting idea to where if it's the same if it's the same currency, then they may be trying to take power or are in power in those areas by using us as these money machine, worker bees, essentially. While they already took us over with the gold standard because of the other land that they had all the gold originally. They sold us the globe, which removed the awareness of that other land. They came in, secretively, essentially, and then just began taking over the whole world with that gold. And then now, if that currency is being interchanged with other civilizations, beyond, then they are trying to get as much of it from us so that they can then, rule there as well.
Rule there.
And they live to be like 300 years old on average or something, like they've got it all figured out health wise, they're not going to give us those secrets because it wouldn't keep the system going the way they've got it all set up for us to have just one generation of, adults. And then the next, you don't share the generation except for maybe, father and son, but the third generation comes along and the grandfather's dead by the time there's enough time to get any kind of allegiance going that's too threatening. I know that sounds a little wacky, but you know what I'm saying? I think there's definitely people living longer. That makes a lot of sense. They would have figured that out before a lot of other things that you would think, right?
How much longer do you think?
I don't know. It just doesn't seem. It seems like you get like your prime. You get in your prime, and you got about 20 years of your prime, and then you start going down. And you waste half the first part of your life in the educational system. I mean, they're just throwing away all the great things you could be doing with this rote memory and like miseducation in a lot of areas. So think of all like the talent they're missing out on by putting these kids in the school systems. That never even got discovered because they never even knew that. I mean, they just thought it was all about becoming a worker bee.
Mm-hmm.
They're not mining that type of thing very much. Yeah, we're kind of like just an excavated dumping ground. What's up, Riding? Long time.
Oh.
Hey, Zia. Hello.
Riding.
Haven't spoken to you for ages.
Hey, Riding.
Ages. Oh, he's typing.
Noisy.
He's not ready to talk. He's being shy.
He's in a noisy cafe.
He's a little nervous about coming back.
I'd like to hear Ruhif and Riding debate, but Ruhif has to debate for what he seems to absolutely just love, which is his flat Earth. So he's the quote unquote flat Earth side, and then Riding will be the globe. I'd like to hear that debate.
Go 1-on-1. Damn.
Yeah, I would love to hear Ruhif make sense of what common sense we make all the time.
Yeah.
Yo.
Do you want to debate Riding?
What? He's in the cafe. Can't talk.
Joking.
All right, we'll be the Globers, and you be the flat Earther.
No, I'll be the Glober. Debate me in your perspective. What's your flat Earth evidence? Come on.
The whole idea was to reverse the roles. You can't even do it in pretend land, huh?
I'm fucking terrible at it. You know why I can't do it?
Are you afraid that if you start trying to make logical arguments on our side that you might realize we're right?
No, because I can't make logical arguments for you. I just end up talking shit that I know is wrong, and I
I think
can't
that's
do
why
it.
Gio thought it would be funny to see you try.
Yeah, I think
Yeah.
I've tried before.
You know what's interesting about it though? Even if you guys try it, it doesn't have the authenticity. Like there's something about when you know truth and speak it, there's a resonance to that. Because I've just noticed, like with I remember one time Kosho, he obviously knows like the idea of a flat Earth pretty well. Like he obviously does. So, and when he was debating it, I was like, wow, like the resonance of not actually. It's like that concept of actually like resonating with truth when you're actually saying it is different than just repeating words.
And Kosho seemed to be resonating with truth. Like he
No,
already
I'm
knew. He
saying,
already
and I'm
knows.
not trying to like call him out. I was actually surprised that he was saying certain things that he's heard, but like it didn't, like it almost sounded like an actor. You know what I mean? Like it didn't have like.
That's an actor almost.
Yeah.
Oh! You mean it was like he was acting rather than actually believing it?
No, I'm not really saying he was well. I don't know. That's a whole nother kind of topic, but I mean, like,
Yeah.
look, I guess what I'm saying is that like you can tell when somebody, let's say somebody knows something that's true, and then they're speaking it. If they know it's true within themselves deeply, and they're speaking it, what I'm saying is that there's like a resonance to that. There's an actual vibratory frequency of that. Whereas if you don't actually know it's the truth, but you're just repeating words, it's different. Like it doesn't have the same.
Right. I agree.
Yeah.
But did Kosho live up to that resonating? That's what I'm trying to figure out. What you're saying, he did a good job as making it sound like it authentic, or was he just kind of arguing the point that side?
Well, I mean, actually, what I'm thinking of is there was this one time where everybody was like flipping sides, and so everyone was trying to like do it like in terms of that. And I just remember, I think even Ruhif was there. Remember that? Anyways, maybe I don't know, but we did. Yeah,
Mailman did a good job, or what? Mom, where you?
Yeah, he was one of the better. Yeah.
Yeah. No, I mean actually flipping sides. Like Bandy was a Glober.
For a second.
Yeah, for a second.
For a second.
Ruhif is going to hang on to that bandsaw until the very bitter end.
It gets thrown in my face so much, like it actually. B-Ball was on a mission. B-Ball was on a mission because I did it on a Sean G stream actually, Geo, and he DM'd Sean G so much wanting to know exactly what episode it was because he wanted to cut it and clip it and just kind of spam it relentlessly in chat. And Sean G just had a little chuckle to himself and never gave up the information, which I found quite amusing. He goes, "No, you want it, you go find it." Because he had like, I don't know, 500 or 600 videos on his YouTube channel at the time. Well, that was funny.
Ruhif,
yes.
I'm going to post this thing in chat. I mean, as you know, I'm not a big fan. I don't really resonate with the term flat earther and all that, but this obviously uses those words. But I mean, it does kind of show, like, I'm not saying it's exactly like that for everyone, but it often is a process, like coming to any awareness that's different than what you currently have is usually a process. And for some people, it's different. So, I mean, that's, to me, it's different to like go through different stages in a process than to come to a conclusion and then just flip it when you already said you already got to it, to the truth. You know what I mean? And then flip it. That's different than actually going to a process and getting to that point to where you then know.
Sure.
Issa's here. I remember back in the day, Issa actually started arguing the ball side just for the kicks, for the fun of it, or actually he was like disappointed and kind of frustrated that the ballers weren't doing good enough with their arguments. Isn't that right, Issa? You're here.
Yeah,
He was like, I'm just gonna argue for the ball.
But I just thought like they if the ball made a couple of concessions in their arguments, for instance, that's what always surprised me so much was that. Give me 1 second. Hold on 1 second, bro.
Yeah. What concessions do you think we should make?
1 second, Chris. Get out of here.
This idea of concessions is a bit weird because I'm I will say anything that's true, right? But for someone to see it as a concession kind of means they take it as the globe model being wrong in some way, which...
Yeah. What I'm saying is this: is like in the argumentation for the globe, there's certain old arguments that I think are proven to be invalid, and if those arguments were given up, and it's like, in my opinion, the globers have made a mountain out of the molehill of that you experience flatness. So, like, let's say, like, if you gave up the argumentation of seeing a boat go over the curvature, right, and you were to make your argument that, well, it's really actually just because refraction, people were deceived into thinking that that was evidence for the globe. However, it's become, throughout technology, it's become apparent that, maybe that isn't true. But but I could see where at 120,000 feet, what I mean, there you might be able to make the argument for curvature. But at the ground level, you would have to concede that, well, this is a process of light, and we agree with the flat earthers that this isn't evidence for curvature. But
I don't agree.
Based on a blatant,
but because
there's a blatant contradiction that you have to make it a concession on.
What's that?
Yeah, I'm not going to concede that boats disappearing is not evidence of globe.
Right, and
that
that's
is
why,
evidence of globe.
Well, but the thing is, you
that-
don't say there's a geometric horizon. You say all the horizon is always refracted. So if it's a refracted thing in the first place, and if it can cause things to be cut off or seen really far distance, then you wouldn't really be able to say that that's the curvature cutting off the boats. Yeah, you would just say it's a refracted horizon, therefore it's not proof for a globe.
Right. Objects are hidden below. Sorry, boats go over a refracted horizon.
Ruhif, let it go. The point is that, like, the more you guys hold on to that, the more you make a holy mountain out of a molehill that is the holy grail for flat earthers. If you guys,
why would I let go of that?
Listen to me. Listen to me 1 sec. If you were cool enough to recognize why you would let it slide, the flat Earth would have come and gone.
The thing is,
you guys have done that.
If they went over it, it could be proven. But if you zoom in on something that allegedly went over a hill and it reappears, that means it never went over a curve, because there's no amount of zoom that can zoom in on something that went over an obstruction.
Right.
It just doesn't happen.
So therefore, if you just based your argument, if I was a glober and I was dead set on arguing for it,
yeah,
I would update my argument to then I would make your argument acceptable to fucking people through the terms of logic. And because your team has not done that, you lost 5 years ago.
Why would I ever give up that boats going over the horizon as evidence of curvature? Why would I ever give that up?
Because you can't ever show us the curvature. And you go up high enough and you can't see any curvature. It's flat. When you go up high, you can see how flat it is.
Hang on.
Your argument would be that it's a matter of light. Your argument would be
It's not a matter of light.
Okay,
it's a
this
matter
is why
of
you
going
lose.
over the curvature.
That's why you don't get it.
You cannot say evidence. It is not evidence if it can be debunked.
How have you debunked that? I've just posted Kanagu in the chat.
P900 camera or a telescope.
Ruhif, you could post 1,000 pictures. It's just why you guys lose. It's like, what I'm trying to tell you is that it's like me trying to help you pick up a girl and you just can't get it.
Oh, those days are over.
Don't you get it, man?
But I'm just saying allegorically, like, what I'm trying to give you is an argument, or you know what I mean, something that works, and you guys refuse it.
If you've been proven false, your concept of something disappearing, if it's been proven false, you have to come to reality. I mean, you could delude yourself forever, but there's a certain point at which you have to accept reality.
How has this been proven false? The picture that I posted in chat is Kanagu.
Millions of cameras, dude. Millions of cameras.
How does the camera prove this false?
Because
Please explain how the camera proves it false.
Let's say I was driving a car and I drive over a hill in my car and you're filming me. As soon as I drive over the hill, You can zoom in from here to infinity, and I'm gone, dude. I'm on the other side of the hill. I'm invisible to that camera. Now, if it happens with a ship, the ship is invisible. You start zooming. Oh, fuck, there it is. That means it did not disappear over the curve.
No, it either has gone over the curve or it hasn't.
No, it
If it
hasn't.
hasn't,
Dude, your logic is flawed. You have no
if it hasn't gone over the hill, then you can zoom in.
We don't care.
It has, though. You're saying there's a curve to the Earth, but there's not. We can zoom into infinity over 60
and you
miles.
can't bring it back.
Oh my god!
Yes, you
bring
can.
it back. No, you
Everybody
can't.
just chill for a second. Hey, yo, guys. Okay, guys. There's check it out. There's other arguments that you could concede too. This is why flat Earth. I'm not going to wait 5 years to continue my conversation here, because like that's what happens with whether or not you can see the curve and you can't, because you guys just want to argue about it. My point is that if you wanted to win this grand debate, my point was years ago is that I could update your argument for a certain amount of money, and then you would win, and then, you know what I mean, we'd be all good. But like, because you guys don't want to really do that, you just want to win on these points that you've accepted as reality, and you don't want to adjust or adapt, and that's the whole evolutionary thing, right, Ruhif? If you don't adapt, you die, right? So the whole thing is that because you guys won't adapt to the fucking P900 revelation that nothing fucking disappeared over the thing, you lose. And
So
if you did adapt, you would win, and you would concede that it's like I'll take that little bit of loss of like maybe Galileo didn't see the fucking curvature with his fucking telescope or whatever, and you just accept that as like, wow, that's I'm not Galileo, so it doesn't really affect me, right? So it's like, Galileo was wrong, not you, Ruhif. But the point is that maybe historically these people were wrong, and if the Globers had any kind of semblance of an update, that's where they would be, and they would say like, "Hey, this is." They would say, "Hey," they would take on the argument of like, the moon landing. Hey, I don't know about that, and you would take on the position of, I don't know necessarily about Elon Musk, but through these particular things, I tend to agree that this is why it's a globe, and you could extrapolate and be honest, and you'd get people that want to listen to you. But because you guys come in and say people are stupid, you're retarded, you didn't graduate school, and this, that, and all these accusations, and you have no substantive arguments to change people's minds.
Isn't what you're asking basically, because you don't accept the things I see as fake, you're therefore being dishonest?
Well, no, I just think like this. I believe in objective reality, certainly, in my own right? And I just think that because we can all agree, let's say, that we experience the world as flat and motionless, it puts a lot of that extrapolatory kind of information you guys bring into question.
Hang on, Harry. I got to ask Wolfgang, in the photo that I've just posted of the ships. Wolfgang?
Yeah.
The photo that I've posted, are you saying that if I zoom in more, that I'm going to see more of the ship?
Well, what happens to things that disappear at the horizon, that's just the vanishing point of your, like, whatever focal distance your eyeball or your camera or whatever, everything has a focal distance, right? You can extend that, your horizon, by adding more magnification. You can extend how far you see. You're increasing the angular resolution of it. So it's only, what happens is everything compresses. It compresses downward at the vanishing point, the sky and the land or
I've
the
asked
sea.
a yes or no question, Wolfgang. If I zoom in, am I going to see the bottom of that ship?
If it reappears, then it hasn't disappeared. I'm looking through my. I'm scrolling through my.
If I zoom in on that boat, if I zoom in more, am I going to see the bottom of the boat?
You may or may not. It depends how far it is.
The answer is no.
There's a layer of vapor. Well, the thing is, there's vapor, and then there's waves that cut off. You got waves, like say 4 feet from the water. You may not see that, but the point is, let's say the entire ship should be beyond the curve. Let's say when in the Navy they use the term "over the horizon." That doesn't mean they physically went over the horizon, because there's, let's say you zoom in 10 times, you see the ship, right? But okay, maybe you don't see it at 10 times zoom, and then you add 50 times zoom, and aha, there it is. So in other words, if you went over a hill, it shouldn't matter if you went 50 times zoom or 1,000 times zoom. You're gone. You're around the corner. You're gone. There's no
Right,
amount of
but-
magnification that helps at that point. My point is, we've seen things beyond that point, beyond the point where there physically should be over an obstruction. We have seen them reappear. Millions of people. So it's undeniable to millions of people who've done it, their own observations, and have seen things beyond this curve. And then they realize they've been gaslit.
You seem to be saying yes, that if we zoom in more, we will see the bottom of that ship. Is that what you
Dude,
are
what do
saying?
you
Yes or no?
quantify on the bottom of the ship? You either see the ship or you don't. If it's
No,
gone
this
over,
one, the one that I've
Wolfgang,
posted.
Wolfgang,
The one that
can you
I've
hear me 1
posted.
second? Wolfgang, check this out. What Ruhif is asking is that, no, Ruhif, if on that image, if you zoom in any further, those pixels are fixed, therefore you will not see any more of the boat.
Excellent.
However, if you were live, was that really your fucking question, Ruhif? That's so pedantic.
Yeah, because he said that.
I know, you're such a dick. Now listen,
Yeah, but he's using a 2015 stupid argument.
Okay, now to add to Wolfgang's point, okay, Wolfgang, it's a shame you have to go here, but you really do with these folks because this is how nitpicky and fun it can be. Is that when if you were actually filming and watching that, Ruhif, not that image. Obviously, you can't zoom in on that image and see any more of the boat because everything's fixed. However, if you were looking through the lens and that's what you were seeing live and direct, being that the waves might be moving and being of all kinds of things and different heat, whatever it is, over time, there will be different things that will happen in regards to an image you might get a still of. And some of them you might be able to because you'd zoom in further. Some of them you might be able to because the wave dropped. Those are
look at the one I just
hold on,
posted.
real quick. Those are just optical things that happen. Now, if we could all just agree that there's an optical phenomena going on and it's really not evidence for anything, then you would have a moot point regarding this matter.
here's what I wanted to show him, this gift of the sun, right? You see the sun has disappeared at the horizon. It's blended
No, I
into
don't
the
see
horizon.
that. I can't
You
see
don't
that.
you don't see the orb of the sun. But then when you zoom in enough, there's actually separation between the water and the
Right.
sun.
Right, but we can't see that when we're zoomed out. We can't see that there's separation.
That's
Just the
because of
same.
perspective, dude. How many
No,
times do we got to tell you perspective?
Just
Perspective.
the same as when you zoom in on a boat that has not gone over the horizon, you can't tell whether
Do
it's
not
hidden
go
or not.
over the horizon. That's my
Yes,
point.
they
They do not. No, they don't.
Hey, Rudolph, what about the one I posted right above that thing that he posted? That looks like, I mean, would you say that that's curvature blocking the boat?
Probably.
Probably.
How big's the boat?
See,
Yeah, I
that's
don't know
why
how
he
big the
was-
boat is or, where you are or whatever. Probably.
Well, the thing
how
with
would
it,
you know?
I mean, I think what Issa's saying is a really good point, that if you guys did make some concessions of things that are really just poor arguments, I think at least that way you guys wouldn't resonate with just like so much like lack of like logical stability. Because the thing, like in terms of this, like this is the classic one, like boats over the curve. It's like everyone, it's like kind of the first globe proof you hear of or whatever. And then the thing is, when you really actually talk to some of these guys, they'll start to admit, oh, well, actually, it's always a refracted horizon. It's never actually the curve of the Earth. It's always refracted, so it can be here, there.
Whoa.
Here,
Excuse
there, or
me. Who
elsewhere.
said it's never the curve of the Earth? Who said it's never
Sorry,
the curve of the
you're
Earth?
just interrupting.
Well, you
for what
can't
reason?
ever point out the curve. That's the problem. Go ahead, Gio.
I was trying just to finish my thought. Ruhif just rudely interrupted. What I'm saying is that you guys call that a refracted horizon, and it can be up, down, in all kinds of different situations. And when we see too far, you say, well, then that's because the refraction is causing you to see too far. So to then have that as your actual argument, but then be out on the surface being like that's the curve, is completely logically inconsistent. So to keep pushing that is really just hurting your position. I mean, I don't think you guys will ever ultimately win, quote unquote, this kind of discussion because the Earth isn't a globe. But if you at least want to kind of have a little bit more, fight in it to actually have a chance, if in terms of talking to people, or if you want to have whatever debunking or convincing thing, you would do better to concede certain things that are really just like weak, kind of worn out, like old propagandized concepts, and actually try to come with the actual argument that people can actually look at.
You might hold off the floods of people realizing how fallacious your arguments are, basically.
Because a
Just
lot of
little
people
bit.
are going to be able to
Fallacious about it.
resonate with the inconsistency with that, and it's like a loose bolt in your argument.
I'd like to hear what's
The thing I think
fallacious
they're
about it.
saying- the thing I think they're saying, Rufus, is if and I've heard you say this before, things can be refracted or like hidden bottom up due to refraction, not Earth curve. And so I think the point that he's making is
An inferior mirage, yes.
Yeah, and for other effects, if it's possible for that to happen, then it makes whether something is obstructed in that way irrelevant. Sort of a moot point.
No, because the inferior mirage, you can see an inferior mirage, right? That is one way to not see the bottom of something, but you will see an inferior mirage.
Right, but do you see? I'm not disagreeing with what you're saying, but I'm just trying to clarify why to them it seems like sort of flogging a dead horse or like keeping going that argument.
Yeah. But they want me to concede that boats going over the horizon is not evidence of Earth curve, and that's just insane.
No, your argument is delusional, dude. You have to realize that at a certain distance, whatever the distance of the horizon, the physical obstruction should completely obscure. Now, but what about the bottom? There's a point at which, let's say there's 200 feet of curvature and your boat's 20 feet high. You're well beyond the alleged curve. It should not be visible. Don't you have to come to reality? If you see it, something doesn't add up. It's like arguing Santa Claus is real. I know I've never seen him, but he's got to be real because I get presents every Christmas morning. He must be real. That's what you're holding on to, this delusion.
Yeah, when the horizon is only 4 miles out in front of you, intuitively, and you're looking at that and you're thinking, okay, well, if I could go to the side and get an orthographic view of this, I wouldn't see a curve between where I was standing over there on the beach and where this boat is. I would just see it look straight across to where the boat is. And you could tell without even doing that's what would happen. Your orthographic view wouldn't show that curvature at all. But you're saying
Wolfgang,
4 miles out in front of you, we're seeing
I
obstruction.
haven't responded to Wolfgang yet. Wolfgang said the word physical curvature. Do you mean curvature ignoring refraction?
No, the actual point at which there should be a physical obstruction, a physical horizon point, right?
Yes,
so
but ignoring refraction or accounting for refraction?
No, I'm talking about a physical geometric curve. So let's say the top.
So ignoring refraction.
Dude, are you listening to a word I say, or are you just gonna?
Yeah. I want you to say the word I'm ignoring refraction or taking into account refraction.
I don't give a fuck about refraction. If you're hundreds of feet beyond it. Okay, but have you ever refracted something behind a hill? No, you haven't. So your argument is nonsense. No, you haven't.
Well, that's what they claim, essentially. I mean, the whole, like, their ultimate answer for we see way too far for what the geometry of a globe would allow for is that's what's happening. Basically, it's refracting to allow you to see around, like seeing around a corner, like seeing around a hill.
Nonsense.
And in their case, it's seeing around the curve of the proposed curve of the Earth.
Why is that nonsense? Do you accept that light bends in our atmosphere? Yes or no?
Over a hill or a mountain? No, you have not. You can't see what's in the valley below. You just see the side of the mountain, and that's how it always is. No one's ever seen over a mountain looking straight ahead. It's complete nonsense, and I don't know what you sound fucking stupid trying to grasp on that.
You're proving the point that this argument makes you sound like you're just.
I'm just waiting for an answer. Does light bend through a density gradient? Yes or no?
Can you film something on the other side of a hill or mountain? No, you cannot.
I can film stuff that geometrically should be on the other side of the horizon. Does light bend through a density gradient? Yes or no?
That's what they claim. Yeah.
I'd like to see you prove it. I go film shit all the time.
Examples.
I mean, they have to, because the Earth has apparent extended planar geometry.
Does light bend through a density gradient? Yes or no?
And when I say apparent, I meant apparent in the terms of like.
We know all about
apparently. It's apparently observable, not that it's in an apparent position.
Okay, if there's a density gradient, Wolfgang, does it bend? Does light bend through a density gradient?
There's limitations to what will bend, right?
It's a yes or no question.
You cannot bend beyond a physical amount. That's what you're talking about is orders of magnitude, 1,000 times orders of magnitude, seeing things, right? So your argument is nonsensical.
Okay, is it a yes or a no? Does light bend or does it go perfectly straight?
No, what you're talking about is minutia stuff. Like, and I can put a pencil in a glass of water and the pencil looks bent. I understand refraction, dude. And your argument.
I don't think you do.
Yeah, I would say, Ruhif, that light travels in absolutely perfectly straight lines. However, it's refracted in the medium and therefore can change direction, but it's always straight induction of light, which is then refracted into different directions of straight light.
I think I understand what you're saying in that on a molecular level, the path between molecules that it interacts with is straight, right? But if you zoom out and take all the molecule interactions as a whole, that makes a curve.
Well, I'm not talking about molecules because I'm not ascribing to that theory or that idea.
Right.
I'm just saying that light itself is not bending. It's not the induction itself of the light transfer that bends. It's the medium that refracts it. Sort of like, like in the Pink Floyd on the Dark Side of the Moon, with just like a triangle prism, like a glass prism, and the light comes in and then it refracts out in the rainbow.
Yeah, but we're talking about a gradient, not like a hard barrier between two mediums.
So yeah, I think the gradient, that's why we get bendy, warp, warpy kind of, like if you're at like a bonfire and you're looking at someone on the other side of the fire's between you and you're looking just above it. Like, yeah, the heat waves, like you can definitely get that. That's the medium that is altering the transduction of light. But what you're claiming is something that will somehow allow your vision, your sight of view, to see, like Ron was saying, essentially over a mountain or over a hill.
Right.
The others, yeah.
And that's why I'm asking a very basic question. Does light bend through a density medium? And does it curve? And which way does it curve?
You have to understand the magnitude. You're talking.
Yeah, I do understand the magnitude. I'm asking yes or no.
Let's say I weighed myself at the top of Mount Everest and I weighed a half a pound less. Okay.
Yep.
And then you're arguing minutia like that. Like, well, I should weigh 100 times my weight or whatever. Like, we're talking orders of magnitude to where that is irrelevant. What you're talking about is irrelevant.
We'll get to magnitude because I know what the magnitude is.
Okay, well,
I'm asking, does it bend? Basically, does it bend?
On a micro scale, you do get amounts of refraction, but it doesn't come into the equation of what we're talking about because it's so minute that, like, the point, if we're seeing things at 40, 50 miles, right? 10, 20, 30, 50 times further than we should, something's not adding up. There's not a physical barrier. Your refraction of micro amounts is not applicable to this, right?
I know how much it bends. Okay, we'll get to the magnitude. Yes. I know how much it bends. So we will get to the magnitude, but I'm just trying to get the basic acceptance that through a density gradient, you'll get curved light. Can we please move forward? Okay, so we do. Okay.
So is there a limitation to, let's say, how much curve should you be able to see beyond 100 feet, 200, 1,000? Like, what's enough to prove to you that it's not bending? If
it's a function of the density gradient.
What's your level? What's your level that you're like, wait a minute, now this is just too much? Is it 2,000 feet? Is it 1,000? What would be acceptable to prove you're wrong?
The density gradient can be as much to make the curvature of light match the curvature of the Earth, and it can exceed it.
Yeah.
Okay, measurements. We'll get to the measurements soon, all right? But as long as we accept that light does actually bend, we can move on.
It also sounds a little bit, Wolfgang, like you're going, if we see 10 times further, then light is bending 10 times as much. And I'm not sure if that's how the calculation goes. Because bending is going to be an angle, not what you're measuring.
What I'm saying is this should apply everywhere, not just on the ocean. It should apply to land as well. So if something's beyond a mountain, and I film the mountain, why do I only see what's in front of the camera? I only see the side of the mountain. I never see what's on the other side. Never, ever.
Well, but what if you are? What if you are by a
No, you're not. No one has ever filmed that. That's what I'm saying. Out of all the millions of photos ever taken,
how would you know? How would you know?
Because no one has ever shown one. I've never fucking seen one.
So hang on. If I say no one's ever shown me a video of an orangutan, therefore an orangutan doesn't exist, just I haven't seen a video of it?
Photos, dude. There comes a point where you have to accept.
Arguing from absence. He's arguing from
right. It's the point of reality. Have you ever seen an elephant fly? No. Well, I've seen Dumbo, the flying elephant. It's a fucking cartoon. There's a thing called reality.
Cartoons. I'm just saying you're arguing from absence. You're saying I haven't seen a thing.
No one has ever seen it. Is that because it doesn't happen. It doesn't happen.
Is that your only reason for
Dude, is there logic in your brain? Is there one cell that works? Is there one brain cell that fucking works in your head?
Well, I'm just asking you a simple question. You should be able to answer it. Is arguing
Because
from
it's
having not seen
non-existent.
something
No
a
one's ever
valid
seen it.
way, a valid way to conclude that something doesn't exist?
Yes, because it's never been ever witnessed by any pair of eyes in this world. Okay.
And that is a valid way to reach a conclusion.
I would say so. Yes.
Okay. Has anybody
That's
seen
called
the dome?
reality, dude. It's called reality that we
Has
all
anybody
observe.
seen the container? Right. I've got another
All
question for you.
observe
Has
reality.
anybody seen the container?
I have. Yes.
You've seen the container.
Yeah. Have you ever seen a rainbow?
That's the rainbow. I'm talking about the container.
Okay,
I'm
a
not talking
rainbow.
about the
Why
effects
is
of
it
the
bent?
container. Otherwise, we're talking about boats going over the horizon.
It is it's actually a physical phenomenon. There's actually a curve from. Huh?
What are you
There's
saying
a
now?
barrier. There's a physical barrier that's bending the light in a bow shape, and it's a prism because it's different colors. It's breaking the light down into different colors.
Can you see my
How do we know
screen?
it's not a
Okay.
steam?
A what?
I mean, I can make a rainbow in my backyard with a hose.
Right. And why is it in that shape? Because there's a structure above it.
No, because
Hang
I've
on.
got an eye that receives light in a single point, and
The light coming down,
equidistance from that single point is always going to be a circle.
It's reflected from the dome.
No,
that's
it's not. Anyway, watch my screen, Wolfgang.
So when I spray
Okay.
a hose in the backyard and I get a rainbow, you say that's me seeing the dome.
You want to know what you're seeing too? In the morning, before you see the physical sun, you don't see the outline of the sun at all, right? The golden hour for the film industry, there's no shadows. The shadows are straight down. You're getting a reflection off of the dome downward. You're getting indirect lighting.
So
That's why the light's
dome.
coming.
You're seeing a reflection.
Can I finish my sentence? You're getting, if I shine a light at my ceiling and it bounces down, it's called indirect lighting. You're getting a downward light. The light is coming downward. You don't see the sun. You don't feel the warmth. You have daylight, but not sunlight. You don't feel any heat on your face. You have light. You can go
But the
read
question
a
I was
newspaper.
asking is, if not seeing something ever is a good way to conclude that that thing doesn't exist, I'm saying, have you seen the dome? Twice what you've given me are, I see this thing.
I've seen
and I see
evidence
this
of
thing
it.
as an indication that there's a dome.
You're saying
Right,
that
so
light
you're
will bend.
still not showing the thing, are you?
You're saying light that will bend over a curve will make a ship come into view.
No,
I'm saying,
just
why hasn't it
investigating-
been
I'm
observed
just
over
investigating
land?
the logic of.
Hold on, dude. Can you quit cutting me off? Can you quit cutting me off? Can I
Both
finish
cutting
my
one another
fucking
off.
5 more words? 5 more fucking words. You never observed it over land. That's if no one has ever observed it, it's safe to conclude that it doesn't fucking happen. Okay.
And what is the thing you're
I've
saying?
never
Observe. Sorry, what is
that
the thing?
nobody's ever observed it about the dome.
Well, hold on. Ron? What are you saying that
saying-
people have never observed? What is it, writing?
But I'm just.
The dome.
I was asking a question. Is having not seen something a good reason to conclude that something doesn't exist? Is an absence of evidence evidence of absence of evidence evidence of absence? And it seems that Wolfgang's saying yes. And I say, have you got evidence of the dome?
I do
And he
have
said, well,
evidence. Okay, I have circumstantial
including
evidence. You have no
rain-
evidence at all.
So you've never seen the dome. We don't have any evidence of the dome.
I said
directly,
there is circumstantial
so it doesn't
evidence.
exist.
Do you understand what circumstantial evidence is?
Well, I don't really
Okay,
understand what the
let's say I don't
circumstance
catch
of
you.
a dome means.
If I don't catch you with a smoking gun in your hand, but I can trace your hand, okay, you've got gunpowder residue. The bullet fired into the dead person matches the rifling on the barrel of your gun. I have evidence against you, right? I didn't catch you red-handed, but all the other pieces of evidence prove that you've done it. You have no evidence at all, right? You say, oh, well, no one's ever seen it. Well, that's a pretty good fucking reason. If no one on this entire fucking earth throughout humanity has ever fucking seen what you're talking about, but you say it happens to ships. It happens to ships. We make them reappear.
Have you seen?
But never on land. Never on land.
So let me just ask a question. Have you seen the effects that globers point out to suggest that there is something obstructed by Earth curvature, like Ruhiv posted earlier, a ship?
The bottom half of the ship, what you're seeing there?
Yes, I think we're all fully aware of those. Yes, I think we've all seen many of them.
So that is evidence
No, it's
of
not
Earth curve.
evidence.
It's not the Earth curve directly.
This is not evidence.
So if you
Absolutely.
get evidence, and a rainbow
wait.
is matching the dome
Is there a
of the sky.
But
Here-
here's the
like
thing,
rainbow
writing you
doors.
can't have both. If you're gonna say that back to that topic, because we were talking about that earlier. If you're gonna say that boats are going over a curve, that argument has to go with that is the geometry of the sphere. Therefore, you could call it the quote unquote geometric horizon, as people often say. But if you're gonna say that the horizon is always a refracted, bendy, warpy, up, down, left, right, seeing over mountains, if you're gonna say it's that doesn't go with the argument that that's the Earth curve that's cutting off the boat.
Yes, it
You
does.
got to either concede one or let one of them go if you want to move forward with any logical.
Refraction exists with Earth curve. Please look at my screen, Wolfgang.
I get Ruhiv's point. I'm not making the same point. I'm not arguing for or against bottom-up refraction. I'm just trying to get Wolfgang to investigate this idea.
What I'm saying
if
is,
I haven't seen it, it doesn't exist.
Doesn't there come a point where the ship disappears completely over the curve? Let's say the bottom quarter or 50% of the ship is not visible, right? The bottom.
Riding, he can think that if he wants, right? I mean, if he's never seen it and he doesn't think anyone else has, he's going to say it doesn't exist. Isn't that his prerogative to think that way? If he wants.
Sure.
No, if he doesn't care about truth. Sure.
Can you provide one piece of evidence? Not just me. Not that I've ever
proven
seen
to me
it.
that I'm not the king of Sudan.
No one has ever
Otherwise,
seen it.
I'm just inviting him to think logically about it.
No one has ever seen it.
Recognize there are other good arguments. But
if it was not
ever seen refraction on a mountaintop, nobody's ever shown to me personally refraction on a mountaintop. Therefore, it doesn't exist. If this effect doesn't exist over land, where I think it quite demonstrably does, he just hasn't found the right videos or
nobody has. Nobody has. That's my
point. Let me ask you a question, and then I'll hand over to Ruhiv because he obviously wants to get you look at something. Could there be evidence of this refraction at mountaintop level that you just haven't seen yet? Could it be possible that I've got my finger hovering over the send button of a video showing that effect?
Yeah, it's a new effect. Have you heard it? It's called dark refraction.
Exactly. Like it could be a
like
bunch
dark
of explanations
matter,
for
right?
it.
Yeah.
It's not going to shift the argument one way or another. But is it possible?
By the way, I think I made that up. I've never heard dark refraction before, so if NASA comes out with it, then I started it. But all right, sorry, go ahead, Ryan.
You own it, Gio.
I mean, you immediately get the point, right? The moment I said, "Is my finger hovering over the send button?" I think somewhere inside you went, "Oh fuck, does he actually have a video showing?"
No, I said
don't,
no. You're
but
fucking
well
lying out your
that
ass.
I could have.
No, you're not. It would be like you telling me you saw an elephant that flew or something, and I'm like, yeah, get the fuck out. You haven't.
That I couldn't possibly show you a video of the bending of light by a 10th or a 100th or a 60th of a degree. That's just not possible.
No, I didn't say. I've seen that. I've seen a 10th or a 1,000th of a degree. I've seen minimal amounts of bending, which is not applicable to what we're talking about.
Yeah, we'll get to the amount of bending.
If Michael Jordan can jump, right? He could jump from the free throw line and he could dunk a basket. Does that mean he could fly? He could just get up and he'd never come down? No, it doesn't.
Can you see my screen?
That's what you're talking. Your amount of bending. You're like, look, he's flying. I've seen him. He's got air under his feet. He's flying. No, he's not.
You understand trigonometry.
Speaking of flying, riding, the argument you were saying earlier. So if no one's ever seen a flying pig, no one's ever witnessed one in the history of humanity, as far as anyone knows, and we've, et cetera, is it then fair to say that flying pigs don't exist in your mind?
No. It would be good to infer it, but not to conclude it. To go, I infer based on my.
Do you know what that's called? It's called logical. You're making a logical deduction. You're taking something logical and you're saying that this is going to be illogical.
Yeah. Kind of like a statistical.
Deductive logic.
It's like a statistical. It's
saying like, yeah. Well, inference is more statistical, where you're going the probability. Like this bus always comes at 9:05, so I'm going to presume the bus comes at 9:05 is an inferential thing. It's not proving it, right? Whereas if you're proving, if you're 1 + 1 = 2 because 1 + 1 always equals 2, then you're proving something. And the deductive logic is more proving something. It cannot be proven wrong. Like if you've done your deductive logic right, it is right. Whereas inferential logic is by its nature understanding, I might be wrong about this. The bus might be late today, or they might have cancelled the route without telling me.
Well,
what you're talking about, Wolfgang, is inferential, but not deductive.
You can use logic by saying I've never seen a bird without wings or an animal without wings fly. So you could say anything that doesn't have wings. You've seen things with wings and feathers, even bats. Okay, they have wings, they fly. Have you ever seen something without wings fly, like a pig, an elephant, a dog, whatever?
Sugar glider, maybe. It glides though.
Hey.
Doesn't matter. Anyway.
I'd put something without wings flying as a maybe, because I could easily imagine something so light that it could just be held aloft on gusts of wind. I certainly wouldn't put that in a. Therefore, I can confirm that it definitely doesn't.
There's insects like spiders that levitate. They do levitate, but it's something to do with the electrostatic field. The thing, what I'm saying is animals.
I've seen that
I'm
now.
not saying
There is a
insects.
spider that,
I'm not saying insects. I'm
there is
saying
a spider
animals.
that flies by releasing a web, right? It
Yeah,
releases
I'm not talking
a
about
web, and that
insects. I'm
gets carried
talking
on.
about animals, right? Animals that we all would consider
Insects
an
are
animal.
animals.
Insect. No, it's not. It's an insect. You just said it yourself. It's an insect.
Insects are animals. They belong to the animal kingdom.
Well, they're not.
Okay, let me Google it. Sorry, Rube's been trying to get you to look at a photo for a while.
Yeah, animals
All right.
are.
Anyway, can you look at my screen?
Insects are in the order of animal.
Yeah.
Hey, can I ask a question real quick?
Sure, your book's wrong.
Yo, hey, Eggshell. Eggshell, what do you think about my idea of like if the globe like updated its position on certain arguments, like they were willing to concede certain things, and you know what I mean? Like, what do you think about that? Like, for instance, the curvature one.
Yeah, I kind of agree, but I mean, I think it's sort of it assumes that the globe or the globers are all of one mind. Like we're very different. We've all got our own minds on it. But I mean, I do think conceding valid points is worthwhile. While I do, like, I agree with Rupert. If you, no matter how much you zoom in, you see a wind farm and some of the turbines are completely above the horizon, and then some of them further out are like, you know, the blade tips are dipping into the water. You would see that effect refracted or not. It's still behind something. I get Rupert's point on that, but I also get your point, which is like, if that effect, if there's bendy light and noise in that equation, and you're throwing out other flat Earth arguments based on bendy light, then it's better to sort of move away from things that require light to travel perfectly straight.
Well, it's like my thing is this: is that can, let's say, that windmill look that way because of refraction?
Yep, sure. I think that's possible.
So, like, if that's if that's agreeable, like, which I think it's perfectly logical, right? It's a perfectly logical. Like, I just think like if Globers were of the mind where they said, you know what, I don't really use that as a proof of of my belief in the globe. You know what I mean?
Anyway,
because I just think it
can
would
we look
make
at my screen, please?
would make
Rube's been trying to speak for a while.
Yeah, like 15 minutes.
Fair enough.
15
Yeah, it would
fucking
actually make their position stronger, at least as a position.
Right,
Anyway,
because all
Wolfgang.
the rest would be substantiated in its own right, and without having that as a. Because the biggest underpinning to it all is that you're saying, I could see curvature, but then the Earth's too big to see curvature. It's like what? What the fuck is going on?
Wolfgang, can you see my
That's
screen?
the point. So if somebody new hears that, they're brand new to this topic, and they hear that, they're gonna have that same reaction Issa had. Like, what the fuck are these guys saying? And it's gonna throw them off. It's gonna throw them off. It's gonna throw them off the globe. So if that's what you want people to go towards, then yeah, that Issa's saying it's actually be a good thing to update.
Now put the mountain in the middle. Put the mountain in the middle between point A and point B, and tell me you can see what's beyond the mountain, what's behind it.
Hang on, that one.
And the answer is no.
There you go. Done.
Okay, so you're going to see what's beyond the mountain. No, you're not at ground level. You're starting at the top, but I still don't think.
Doesn't matter where I am, but can you see that the curved path, of light, means that I can see over obstructions, including the horizon?
No,
this is a necessary consequence of curving light.
No, you can't.
Yes. Yes.
Prove it in reality. Prove it in
What?
reality.
Do you
Like,
want to?
you're saying?
Yeah, we
Do
get
you want to
there.
explain your? Do you want to explain your drawing, and then do you want me to share it on the live stream when you explain it? Because I see you do something.
Yeah, share it on the live stream.
Okay.
All right. Obviously, we have the observer on the left and then a mountain over on the right. Okay. And hopefully we agreed that light bends through a density gradient, but maybe we didn't. Okay. But if light does bend through a density gradient, and you've seen I've drawn the green straight path, that's like the geometrical straight line between the observer and the mountain. All right. The fact that the light is curving means that we can see the mountain due to refraction around a geometric obstacle.
No, you can't.
What do you mean no? Like
Let's see,
how
there's mountains
fundamental
in
is this?
France. You could see them like one time a year somewhere in France, or like 200 plus miles out. And otherwise, normally they're invisible like 99% of the year. But there's like
No.
1 or 2 days a year where they are visible just because the way the sun is backlighting the mountains.
We were talking about Canigou. You're talking about Canigou. I'm just talking about the fact that if light bends, then we can see around some obstacle. Can you see that geometrically? We'll talk about Canigou in a minute.
No, like, okay, let's say there is the mountain in the middle, right? And I
Right.
drive over it. You're not going to see me. You're not going to see what's on the backside of the mountain,
Ugh.
ever, never.
No. You're the observer on the left. The mountain is on the right. There is some physical obstacle geometrically, like geometric straight line, whatever. The
If
fact
the
that the
mountain on
light
the right is
bends,
shorter than the mountain in front of it, you're not going to see it.
the fact that the light takes a curved path from the
You will
mountain
not
to
see
my
that.
eye.
You will not see that.
Yes,
No.
you will, because the light is reaching your eye. You will see it. Do you
No, you
understand?
won't, dude. It's called
Yes, you
delusion. That's
will.
called delusion.
That's not an illusion. You're seeing the
Let's say
mountain. The
I'm 6
light
feet
is
tall
coming
and
from
somebody
the
is 5
mountain
feet
to
tall,
your
right?
eye. You are seeing it.
That's because it's a straight path to your eye.
It's not a straight path. Light bends through a density. That's why I asked at the start, does light bend through a density gradient?
Well,
We all know it does. You're not making a
Okay,
valid
so
point. You're not
this is
making a
an
valid point.
obvious, fundamentally obvious consequence of light bending. That you
No,
can
no,
see
it's not.
things that would otherwise be obscured.
No, you cannot. You cannot bend your camera focal around a curve. You can't
Maybe
bend
The
downward
light,
and bring the
listen,
light back into the orifice. You can't do
the
that.
light is leaving the mountain, taking a curved path, and reaching your eye. Are you saying you can't see it?
You cannot see over an obstruction.
I'm literally demonstrating how you do see over
No,
obstructions
you
with
don't. You're
curved
drawing a
light.
picture of delusion. It's not reality,
Do
man.
you agree that light bends or not?
Dude, I already told you. Now you're
Okay, then
talking
this is
circles.
fundamental. This is so obvious.
So let's put some. I think that might advance this. Look at accepts that it does bend, but not agree by how much.
Yeah,
Then
we'll get to magnitude shortly.
okay, what numbers?
Yep.
Yeah, what numbers do you think it bends by, and what numbers do you think it would need to bend by in order
Yeah,
to make this effect real?
We'll get to magnitude shortly, but
By
this is
1,000 times
fundamental.
and order 1,000 times order of magnitude.
Well,
We'll
yeah,
get to
Ruben,
numbers
I mean
shortly.
that curved line you have on there is very curvy, and
Yeah,
you've
it's
literally
exaggerated.
You also
but
see
this
how
is a
you've just.
fundamental thing, right?
I got you, but do you see how what you've really done here? Like you have an observer, you have a straight path, you have objects at certain elevations and certain distances. You've just taken that basic XYZ, matrix, level, horizontal, etc., vertical. You've taken that and just added a curve, and then just added this idea that it's just bending and making the curve there. So you're
But we
just
agree
adding
that
an
it curves.
assumptive curve.
Yeah, we can assume that this is on a flat Earth. By the way, we can do this on a flat Earth. All it needs
What
is
you're saying
bending
is
light.
you have this arc trajectory. If you aim your
Right.
camera upward at the sky, you're going to see behind a mountain. That's completely fucking insane,
No,
dude.
if you hang on, let me draw it again. If I point my camera,
Yeah, because we don't
in-
see that. We don't see over mountains, dude.
if I point my camera in that direction, I will see the mountain.
Get the okay.
What?
This is fundamental shit.
You're
This is
looking up at the
fundamental
sky
shit.
and you're seeing the mountain. Come on, man.
I'm looking in the direction that the light is coming into my lens.
Dude, what you're doing is pissing on us and telling it's raining. Like I
This-
see you pissing on me and you're telling me it's raining.
How fundamentally simple is this? Can a global weigh in and tell me how fundamentally simple this is?
Wait, what
this
is
is
the blue
unbelievable.
line?
Yeah, those images that I posted What are they? 21 minutes past the hour.
21 past.
That's an example of terrestrial refraction, where at one time of the day you can see the auditorium off in the distance, and another time of the day from the same position you can't see the auditorium, and that's the auditorium being refracted above the hills.
Well, you can see it on both.
That's a flying elephant you just posted.
You can see it on both, but you can just see a little bit more of it on one of them.
Right, that's exactly right. And that's due to refraction. The light's bending up over the mountains.
What do you think of that, Ron?
What's that?
At 21 after the hour, these two images that Howard posted.
Hold on, I'm trying to get out of this menu.
I've talked about these before. Yeah, they're like different times of day.
I don't see them. Where's he?
20,
I'm looking
21
at
after the hour.
Scroll up a tiny bit.
It's just scroll up a little bit. Two images there. It's basically looking out over like, you know, some terrestrial landscape with mountains and things. And then there's this.
Oh, I see. Okay.
Yeah, it's like a dome auditorium thing, right?
Yeah, because he's at higher elevation, dude. Look at the elevation.
No, they're from the same place. Those images
I get
are.
that, and I get it. And you're higher up above. You're higher up. You're looking downward at the auditorium.
He literally just told you it's the same elevation.
No, it's not. I could see.
He literally just told you it is.
So can I understand, how did you determine that it was from a different elevation?
I could tell this photo is taken from a hilltop. He's looking downward at that.
Yeah, but I'm asking how did you tell?
Because I could see the foreground is lower. The background's lower than the foreground. You could tell it's that he's above. He's higher.
Well, Ron, I think so they claim, I believe they're claiming that this was taken at the same spot, right? Right, guys? Same elevation?
Same place, just different times of day.
What's the
Right.
What's his
It's
auditorium?
a higher elevation than where that auditorium is. That auditorium
it's
is
not.
downward. Yes, it is. I can
Yeah.
tell it is.
So what you're
You're
saying,
picking on me and saying it's raining.
Oh, wait. Ron's saying something interesting. Ron's saying about the elevations, because that actually is taps into my understanding of it as well. Because what I think is happening, I don't think you're seeing over that. I think that you're just seeing it's a lot clearer. The one where you can see more of it down at the line of like right where the greenery and the trees and things are, that whole layer right there is creating like a duct. And then that duct either allows you to see more clearly, or it gets more obscured. But what Ron's saying is interesting is that if the elevation is actually higher, than the dome itself, as it were, then that would even prove even more so that if the elevation profile fits, that your line of sight, if you were able to see in clear conditions, that you actually would be able to see it, and you're not actually looking over the elevation of a mountain, but you're actually just seeing more of what already is there, just because you're
If you were to take a laser and shine it.
Two different photos taken from two different elevations.
No, the elevation.
No, that's
of the
not what I'm
photo
saying.
is
I'm
the
saying
same
what I'm trying to
conditions.
tap onto what. Sorry, Ron. What I was trying to say is that if the overall position of the elevation of this shot is at an area where you would be able to see that dome, that's different than if it actually elevation-wise is being hidden.
He's telling you he's taken it from the same elevation. Like, are you calling him a liar? Is that
No?
is that
Okay.
what we're coming down to?
What's the elevation of the observer? What's the elevation of the auditorium thing? That's what
I would have to go back and
then you'd have to.
I've got the link to the individual that took these photos, and all that information is in there.
And then you'd have to get the elevation, like whatever that mountain is that's in front, or like right, in front of the auditorium, whatever that ridge is. You'd have to know the elevation of that ridge, the auditorium, and the observer. And if those all line up in a way that you would be able to see that much of the auditorium, then what I'm saying is that you're not seeing over the mountain. It's not bending it up over it. You're just seeing more. You have a more clear vision, like putting glasses on, or you have a more clear sight of it, and that's why you're able to see it, because of the elevations match up that way.
The camera is higher than that mountain range in front of it.
Yeah, basically that's
Then why is the auditorium obstructed in the lower image?
It's not that it's
a bowl. There's haze in there. It's a bowl of fog, like it's haze.
Yeah.
Well, y'all can explain it away, I guess.
Yeah. Got a lighter flirt.
Interesting, Wolfgang, because you've said, I don't think it's lying, but you've said that these photos don't exist. But do you think that it's possible that this is how you assert these photos don't exist? Because when you are shown them, you reject them in some manner.
You're not showing me
Brown
something on the
dogs don't
backside of a
exist,
mountain.
but every time you showed me a brown dog, I went, well, that's not really a dog, or it's not actually brown, or that's just refraction, or something like that. Then I could maintain this belief that no brown dogs exist because I just deny.
We're talking about you standing on flat ground at the base of that mountain. Go back a while. If you're on equal level to the base of the mountain, you are not going to see on the backside of it ever. You've taken a picture from many miles away at a higher elevation, downward at something. Anybody with eyes can see that.
Why does it matter whether he's looking downwards?
I mean, yeah, if seeing over mountains was a thing, then there would be a lot of scenarios that we could see over mountains, but that really just doesn't occur. You guys are just using it as like a concept, a calculation concept.
No. Let's go back to my diagram. I want to hear from
because
Wolfgang
writing, I mean, what I was
why-
actually saying about that image, it was not about denial. You said a bunch of stuff. At least it wasn't what I thought we were talking about. Because what we're talking about with this image, it's just simply the elevation profile of the position of the camera where it was taken, the ridge, whatever that kind of mountainous ridge is, and then the elevation of the dome or whatever that auditorium thing is. If those line up in a way that you would be able to see it, then that would prove that you're not indeed seeing over the curve of anything or on the other side of a mountain, but you're just having a more clear visual field based upon the fog and all the haze. The one on the bottom looks colder, whereas the one on the top, like the one on the top looks like it's in like late afternoon. So it's warm, it's been daytime, the sun's been kind of cooking the environment. So there's a more clear shot. The other one looks like it's in the morning. At least I'm just saying what it looks like to me. And then that one looks a lot colder. Everything's kind of like the moon. It's more kind of contracted and the sun hasn't come and lit up the day. It even looks a little bit wet. So yeah, that's going to, like, if you play golf or anything like that, or you're looking long distance or just like done any, hiking, things like that, that's often how it is. And it clears up throughout the day. However, if the elevations match to where you shouldn't be able to see that, then that would be more good evidence for you guys that you actually are seeing over the mountain. But I would need to see those elevations to know for sure if that's even a factor.
Okay, Wolfgang, can you look back at my diagram? I want to hear. Right. So light coming from the mountain bends and hits your eye. Are you somehow claiming that you don't see the mountain?
I'm not I'm talking about what's beyond. If I have something taller in front of something shorter, and you're at a lower elevation or even elevation, you are not going to see beyond. You're not going to see the shorter object behind a taller object ever, never, ever, never.
Okay, so let's say the observer and the top, let's assume flat Earth, right? The observer is at the same elevation as the top of that mountain, and the mountain in the middle
I'm saying
is
the base,
obstructing.
not the tippy top. If I'm looking at a tippy top, if I'm at equal level to the top,
Doesn't matter.
You're not at equal
Doesn't
level
matter.
to the top. Yes, it does,
Right.
because your sand chips disappear over the curve, and you're at sea level. You're at an equal point. Sea level is an equal point.
That's
You see it
not the
going
point I'm
beyond
trying to
a curve.
demonstrate. That's not the point I'm trying to demonstrate. Okay, and I've put an obstruction in the straight line between the observer and the mountain. All right. Do you agree that I can see the mountain in the back?
I don't see what you're drawing. I'm not looking
My
at
drawing,
it.
right? So the
Hold on,
mountain in the background.
I'm trying to get into the menu. Okay, hold on. My phone is running slow.
Okay.
I can't see what
Yeah,
you're
I mean,
drawing.
essentially what Ruhif drew there is actually like pretty similar left lane to like the pictures, because basically you've got the observer, you have a straight path, you have obstruction, which in that case would be that like ridge, that mountain ridge. And then you have the thing that he's calling mountain. That would just be the auditorium thing that's visible. And yeah, what you guys are claiming is that the red line is essentially bending the light to where you can then see the thing that's behind it. And so that's why I was just saying it'd be essential to get all those elevation profiles in that picture to know for sure. Because if it's like the one Ruhif drew where the mountain would be in the way, well then yeah, at that point, then it would have to be doing that. It would have to be bending over the mountain. But if the elevations actually fit that you would be able to see the dome to that level, then in that case it wouldn't, because that's Ruhif's whole point here, is that it has to bend up and over something for his
The point of this diagram is to show that even if there is a geometric obstruction, the fact that light curves can help you see over that obstruction.
Yeah, so you'd have to prove that in the real world.
Well, we have a density gradient in the real world, therefore it's proved.
You've never done it. We don't have photographs of things on the backside of a mountain.
And that
We
does
have
sound
things
like
that should not be seen geometrically that are seen.
that sounds like an assertion fallacy, Ruhif.
That we have a density gradient.
just asserting something. Just asserting it.
It's like rinse.
I'm asserting that we have a density
asserting
gradient.
some
Yes.
other theoretical concept to prove the original theoretical concept that you couldn't prove in the first place.
No. It's a fact that we have a density gradient. That's a fact.
So it's another another theory on top. That's what I'm saying. Yeah.
Do you deny that we have a density gradient?
Dude, no one's arguing that point. Move along. Move along. No
so
one's
you
arguing
understand.
against that.
So the light coming from the mountain takes a curved path to your eye.
You have to demonstrate where that happens in reality. That's all.
Well, hang on. We started from first principles.
I'm not gonna draw like this ridiculous drawing and say that it's proof. You need to show us actual stuff, actual evidence.
We started from first principles. Light bends through a density gradient.
Dude, nobody is arguing that.
Okay,
Nobody is arguing against that.
Good. Okay, so the light coming from the mountain takes a curved path to your eye. Even though there's a geometrical obstruction in the middle, do you accept that we would see that mountain in the background?
No, I don't. I don't accept
No,
it.
why not?
Because you cannot prove it, and I've never seen it, and I'm not going to accept something that's nonsense.
You accept that light bends in a density gradient. So what is wrong with this diagram? Why can't we see it?
Dude,
Yeah, because you keep making
times,
stupid fucking objections.
making objections, you keep repeating yourself, dude, 1,000 fucking times.
Right. The light
you don't
travels.
have an argument.
The light travels from the mountain to your eye. Can you see the mountain?
If you're killing me over here, it's so funny.
I'm going to kill myself shortly. The light travels. The light travels from the mountain.
Ruif is brilliant.
The light travels from the mountain, Wolfgang. Takes
he
a
repeats
path
himself
to your
100 more
eye.
times,
Right, but I mean, I think what he
Can
was
you
saying,
see the mountain?
what he was saying, which I might say as well, I would say as well. Well, I can't speak for Ron, but the thing is you'd have to, like, if you validated this in the physical world with measurements and observations, that at least you would have to present that, because you haven't actually done that. Like, it's a theory, it's a concept, but you haven't actually measured the elevations properly to actually map out any one of these to prove that you actually are seeing over the actual elevation of something in the distance like that.
We're doing it from first principles, right? The light takes a curved path. The light travels from the mountain to your eye. Do you see the mountain?
Hey, what if like over?
It's a very simple yes. It's a very simple yes.
You know, I really, if you're I love what you're doing right now. But like, what if like over history, like the only reason that the globe argument took over was they just wouldn't concede ever. It's like, the only fucking reason that it exists is because
I think you're actually making my point for me, Isa. The fact that he can't concede that light.
You said see the mountain. Did you draw two mountains, right?
Oh God.
Can I see the light from the mountain is reaching
What is
my
the mountain?
eye?
What are you talking about? One is a mountain and one's not. Is it one a molehill? You
One
have
on
a
the
mountain.
right. The one on
What's
the
the
right, where the light's taking that red path. The light is
What is
reaching
the,
my
what is the
eye.
thing in the what is the thing in between them? Is that a mountain as well?
That's some obstruction. We'll call it the
An
obstruction.
obstruction, but it's not called a mountain.
No, we'll call it the
Let's say
obstruction.
it's a sand dune. It's a sand dune.
Okay, sand dune. Okay.
Okay.
But the light from
I
the
like sand
mountain reaches my eye. Can I see the mountain?
You will not see the. You will not see the mountain.
Oh, come on, Jim.
So can I ask if we just accepted for a moment this idea that things compress and distort towards the horizon as they get further away?
It's called the vanishing point.
You guys crack me up.
Vanishing point.
How is that possible except with light bending?
What it's called is angular resolution, and it varies. Hold on, I want to understand. Can you please? Can I give an answer? You asked for an. You asked me a question. Can I answer the question?
Okay. What do you think the question is, first of all?
You asked me that things compress at the horizon, right? Why do things compress at the horizon?
No. I said if they compress at the horizon, how is that possible except with light bending?
Okay. What it's called is angular resolution. It's just the way you see things, the way you see things through your eyeball. Your eyeball has a focal distance with a maximum range. You can extend that. You can increase it by getting a lens. right, to increase your angular resolution. The point is, what you're doing, you're expanding your distance, how far you can see this. So in other words, but there's limitations to this as well. People say, why can't I see France, right? Because there's limitations of how far you
No,
could see through.
it's still so far from the question I asked. I'm saying how.
Why do things compress? It's called angular resolution. I was explaining the angular
I'm not
resolution.
asking how do things compress. I'm saying how do they compress except with light bending. So you need to talk about the how straight paths of light.
It's called
manage
angular
to make-
resolution.
So
There's things that are not
bending or go
resolvable.
straight?
Writing, maybe like repeat your question.
I think repeat my question, Harry.
What is your actual question, Writing?
You asked us plenty of time. Like, let's say I see a wind farm, right? And no matter how far I zoom on it, increasing the angular resolution, half of the windmill thingy is hidden.
It's really hard to hear your mic right now, man. You're really distant and echoey. Can you get closer? Yeah, it's really hard to hear you.
How is that possible except with light bending?
Okay, now you're better. You're better now. So you might have to just start again.
Okay, I've got to stand side on. I'll look out at sea. If we're saying that light compresses towards the horizon, the angular resolution, blah, 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 but I zoom in and zoom in and zoom in with a massive telephoto lens and half of a wind farm is still hidden behind the horizon, how does that happen except with light bending? Because to me, both propositions require light bending. Both we see too far and the white swan require light to bend.
Well, I could suggest a way that it wouldn't be light bending. It would just be straight lines converging at the horizon. And the visual field is going to merge. The ground and the sky is going to merge because it has to. It's like the 0 point.
But are they not merging unevenly, right?
Yeah, they do
do
merge unevenly. Yes, depending on like the distance of things. It's all about the ratios of the distances of the objects and then the atmosphere and the conditions. Yeah.
Even parallel lines.
If they're merging unevenly, what that means is the bottom is compressing more than the top. So
That can happen too.
Except with
There's
light
water vapor. There's water vapor at lower, like say you're at sea level, there's more water vapor lower to the water, right? So if the further you get from the surface, the less vapor there is. It's like driving through fog, right? Say you're driving through fog in the valley of the mountains of Tennessee or somewhere, and you get a little higher up and there's less fog. You're down in that bowl where the fog is real thick. So that's the same thing. The water's evaporating off the more water that's evaporating near the surface, it gets diffused, and you can see water vapor. It mirages the bottom half. You're having it disappear.
Right, but I was just saying the windmills in general, like I was just saying like it doesn't have to be bendy light in the sense that like there could be bendy light and not bendy light, but essentially refracted light. I would more say that could be occurring in certain, like when it stretches out and some of the looming and some of those effects. But that's all just doing that to the actual field. But you don't even need that. Like in some of those windmill type pictures, if you're seeing land or water going out, and if those windmills are further back on further land that would be obstructed, like not obstructed, but not visible, I should say, because it's past the visible horizon, but they're coming up vertically, then you're going to see them vertically further than you see the land that they're over. So you're actually seeing a further distance of those, and that's why they are quote unquote obscured, because the sky and the ground are always coming to meet, and there's the ratio that's involved. They're always just the top and the bottom are meeting right at that 0 point. So that's how you get those windmill pictures that look like half obstructed.
Not only that, but if you've ever seen,
It sounds like bending
have you ever taken a class in art, like how to paint to give depth to a photo? You learn perspective. You could have parallel lines that can, right? Like railroad tracks, they appear to touch, but we know they're not. They're remaining parallel. We know the lines of the rails are parallel, but they appear. Dude, you're really good at talking over the top of me when I start getting 2 words in, dude. I mean, I'd like to punch you right in the fucking mouth, dude.
I think that's got it's a bit of a muting.
I would knock your fucking teeth out, dude. You're such a dick.
Yeah, that's enough of that, man.
Yeah. Anyway, would another flat earther like to answer the question?
If you
of-
want to have a
speaking of
conversation,
speaking of interrupting,
allow
actually,
both
Wolfgang.
sides
Speaking of
to
interrupting
agree.
people, how about you shut the fuck up? Speaking of
Okay.
interrupting.
Speaking
All
of
right.
interrupt, yeah, I just got one fucking word out, you cocksucker.
Anyway, I was talking.
Yeah,
And I-
you need to ease up, buddy.
Yeah. Anyway.
Well, you
the
guys,
fuck
it is kind of turns into a tactic if you're kind of just bowling over and interrupting people, meaning that like if you can't even get into an idea without someone, I guess we'll just moderate more. We can just do temporary muting, but it is kind of easy. It's ideal not to have to moderate like that if you could just respect each other and let them finish. But I think it also takes hold on, let me just say my final thought is just it also takes not monologuing. So because people do want to get in.
I make a short point. I don't fucking monologue. I make a short point for fucking one sentence. He can't let me get one fucking sentence out, and it's annoying the piss out of me, dude.
I waited for 3 seconds. I waited for 3 seconds and then was like 10 words into a sentence.
How many words can I say in 3 seconds?
And
fucking
you interrupt me again. You interrupt me again. Okay. Anyway,
Oh my God.
I would like to ask a short question.
Hold on.
Question.
All right, on the one that Left Lane just posted at 50 minutes after the hour, that one. See, that's my understanding of that as well. Like the horizon is still the meeting place of the ground and the sky. And the first one is, I think there's atmospheric magnification going on because you see like that lower layer of the water is really magnified there. And the fact that it's magnified, the vertical layer of the oil rig out in the water is going to be obscured because it's zoomed in. So you're seeing the horizon at a closer distance because of the atmospheric effects versus when you're able to see further and that magnification isn't there, then you're able to see the extended planar geometry.
Okay. So I would like to ask a question. Hang on, I haven't asked a question, Harry. Hold on. I want to know if any other flat earther agrees with Wolfgang that if the light from an object reaches my eye, am I going to see it?
Well, that brings in a whole question. Is it even light coming to your eye? Like, is that your belief of how you see?
Yes. Is it yours? Is it Wolfgang's?
Not necessarily, no.
Okay. Any flat earther want to agree with Wolfgang?
I mean, I think light is a rate of induction, so it's all.
I want to say photons and shit, right? Like photons are physical things. Like, no, you can't prove that.
I would almost agree that it's a rate of induction.
What does that mean?
Well, then you're almost
there you
right.
have it. Concession number one.
Yeah, like it's. Do you conceive of a photon as like a not matter, but like propagating through a field is how I would sort of describe that. Yeah, rate of induction, sure.
Well, now you're getting closer. There you go.
Yeah, I don't think that's in contradiction.
The question I had for Geo is, if something can be magnified, is magnification not just the changing of the angle at which light is coming? By bending light.
Yeah.
I couldn't quite hear you writing. Could you say it again?
I'm saying if what you're saying is that Left Lane's picture is magnification not just bending light?
Is magnification
how does a lens work?
bendy light?
Yeah, doesn't a lens work, a magnifying lens work by bending light?
No, it does. It refracts the light, meaning it takes straight induction rates and fractalizes them into a multitude of differing directions through the medium, and then it keeps doing that repeatedly.
So they're coming at one angle, and then they leave at a different angle? Is that what you're fair to say?
They're inducing through the medium in a direction that is linear, and then yes, at certain points, because of the state of the medium, are refracting into the different fields and then moving through the medium that way.
That makes so little sense to me. Could you simplify that? Because I don't know when you say field, I don't know what you mean, but certainly multiple fields.
Well, like, I guess you could say like maybe the idea, like if you have a medium, liquid, whatever you want to, just as an idea, but let's say just the air, the medium, the field we live in. If you had like a bunch of those little prisms all over the place, and then you shined light at it, you know, it would be bending and refracting in different ways. Now, if you did it with actual prisms, it might just kind of be going everywhere, or like a disco ball or something like that. But in a sort of similar concept, I'm referring to as the light is moving through the medium and all the different components that make up the medium, the heat, the pressure, you know, all of the different components of the atmosphere, including, you know, fog and haze and atmospheric pollution, all kinds of stuff. The light is going to behave in a similar refractive way to where the prism is. It's going to do that through the entire medium, and that's how it can then be kind of warped or deflected.
All right, can you simplify that again? What's up, Hero?
Sounds like it's a yes. It sounds to me like what I'm hearing is a yes. Yes, magnification
Basically straight lines of light,
bending or warping of light.
straight lines of light being refracted through the medium. They're always straight. They're always straight. They're just being they're always straight. They're just being refracted in different directions through the medium as it induces.
Well, that's refraction.
Right, but it isn't the light itself bending. It's the medium refracting the straight light. That's my understanding of it.
Well, how it happens is largely immaterial. It's just to me, we're now at a point where we agree that the path of light can change.
Yeah.
If you want to call it the XYZ coordinate path, basically. Like, can it change can it change XYZ coordinates and then quote unquote curve or bend or warp in that way? Is that what you mean?
Yeah, I'm just trying to. I don't mean to be wording it confusing. I'm just trying to use words that both of us would likely agree on their meaning. But yeah, like it's going in one direction. Do something to it, like put a prism in the way or some hot air or water or something, and then it comes out and going in a different direction.
Yeah, but I don't think there's any function of it that I don't think there's any function of it that basically allows that process of refraction to see, let's say, over a mountain or over a curve. My understanding of it is like if you're actually elevation wise, if you're between, you know, like an object out on the horizon, a mountaintop, whatever it may be, and there's a particular distance there.
Right. Yeah, I mean that's kind of the next question. If we agree it can happen, why in some cases but not in this particular one? Why not with the mountain, but yes with, like, you know, seeing a pencil in a glass of water?
Well, I guess what I was gonna yeah, no, I hear what you're saying with that, but like I guess just to finish the thought, just because it was still in my mind, like if it's between you and the mountain, there may be refracted. Like if your elevation allows you to see that thing in the distance, then the only thing refraction can do is maybe warp it, kind of stretch it out, you know, in a somewhat minimal way. I mean, it doesn't do it dramatically, but it, you know, like in the Skunk Bay footage where we see the horizon kind of going up and down pretty much and kind of zooming in and out, you're seeing more and less of the land. So that can do that, you know, between you and that object. So whatever bendy, warpy stuff, kind of like if you're in a bonfire and you're standing on the other side of it and you're looking through it and all the heat is making it all wavy. But the fact that it's making the other person look wavy on the other side of it is because elevation-wise, you are actually geometrically able to see them. It's just that there's the heat in the middle. So in the same way, if we're geometrically able to see something, that can have certain waviness and distortions and warping to it between you and that object. But I don't think there's anything that is going to allow you to see, you know, over a mountaintop in that sense. It's just refracting what's between you and the object in terms of the elevation in the actual environment.
And the last question is, like, do you think that this bendy waviness could do the opposite of making something, rather than making something that is obstructed visible, could it make something that is visible obstructed?
Yeah. Have you seen? Can you look in the chat?
Oh, just a second. Let me get my phone out.
This is something that over in Gems one day, many months ago, Chemo and I and some others were in there, and then we were talking about this, and then he made this little thing and he put things Chemo on it. But yeah, that shows how same location, different days, and you're getting the same effect of the Blackpool Tower.
Sure. So yeah, and I would agree that happens. I do think that it can refract. I think bottom up. Why would it? it's just for me, the logical thing would be to go, if it goes one way, it probably also goes the other. Like maybe it goes one way and not the other in different proportion. But why do you presume one thing does happen and the other thing doesn't?
Yeah, I mean, and at that level, like to just be super strict, if we're just talking about that part of like this kind of argument, as it were, then it's a moot point for the shape of the Earth. I think there's other things that give away the planar geometry. However, if we're just going off that part that you were describing, then it would just be like a tie. Like there's no delineation that can be, if you're just going from that level of it. Like you're saying that the way that it shifts and changes, because on a planar Earth, those are actually both on a planar surface, and there's an effect that's causing, or there's something that's causing the water line to be visible in a different position as it is on the one on the right. The one on the right seems to have that totally extended planar geometry. You can see it really clear. The one on the left is sort of obscured in that way. But what the globe earthers will say is, oh, well, the reason the one on the left is obscured, that's because of it's the curvature. The reason on the right, the reason that it's out like that is because essentially there's a refraction that, like Ruhif is talking about, where you're able to see over a curve or over something. So he's claiming that that bendy thing is essentially straightening out the visual field to make it appear planar.
Yeah, I think that's what both sides are saying, right? One side is saying light bends to make it look flat, and the other one's saying light bends to make it look curved.
I could see, yeah. I don't know that I'd fully agree with that, but yes, I do hear what you're saying there. Like that wording is, yeah, I see what you mean. Like I'm not saying I totally think that's the case, but it is. Yeah,
I'm just sort of going that if I were to, without trying to straw man them, if I was to minimize both sides' arguments, that's what they come close to, sounded like to the other side.
Do you see why it's an apparent horizon? Because it appears in two different spots, but it's still perfectly flat. It's still in both photos, left to right. It's perfectly flat and level.
You know, you'd have to have writing. This is really, at the end of the day, this is what it'd be. Imagine like a tube about 5 inches in diameter, okay? Like a 5-inch plastic bendy tube, okay? And the thing's 30 feet long or whatever. If you put that tube out straight and level and you look through it, you're going to see the other side, right? You're going to see the little hole. And if somebody's got their hand there, you can see their hand, etc. You could even put a camera through that and zoom in, you know, the whole 9 yards. Now that is, you know, it makes sense. We're just seeing over a straight planar thing. Now, what you guys are claiming, or what is being claimed on the globe side, is that what actually would have to be happening is that tube would be curved, you know, like a rainbow almost, like that tube would have a curve to it. And when you then looked in the hole, you see the other thing lifted and displayed perfectly on the horizon, like horizontal level planar geometry, that even though the whole tube is curved, when you look in it, you just see whatever the other person is as just an extended. So he would have to somehow take that whole curve and remove the whole curve, extend it in a planar stacked way, because it's like stacked. You know, you see the water, then you see the first oil rig, and then more water, then the second. So he would have to stack that image and make that curved tube, you know, visual field all of a sudden just be completely straight and allowing you to just see in a curve.
That's a good analogy. Yeah, if you did have a tube like that and you bent it and you think you could look out the other side, that's just delusional. That's delusional.
That's what they're believing at the end of the day.
Even if you bent the tube, it's 30 feet long. If you bend, let's say the tube is 1 inch in diameter. If you bend it 2 inches, you're not seeing out the other side.
No way. Yeah. I've never witnessed anything in any sense that's allowed to see around corners like that.
That's completely illogical. Yeah.
And that gets back to the question we were talking about before, which is which Ruhuf's conversation was going to go on to, which is then if we agree that it bends a bit, then, and your assertion, Wolfgang, sounds like sure it bends, but not enough. It's thousands of orders of magnitude off. Then what are those numbers?
Right, so you're going to go with like a degree, like try to make it sound like 1-2 degrees. Therefore, you'd have to imagine that tube is only, you know, a very slight curve versus a more severe one. But I mean, some of these distances are very curved.
I don't know the numbers. So
I do.
I'm not going to try and make it sound like any Ruhuf does. Yeah. But to say like it needs to bend by thousands of orders of magnitude is like, I would feel, for me, if I were to make that statement, I would want to be confident that I know both of those numbers. Otherwise, I'm like going, hey, that
because there's
that much.
There's a point. there's a point at which something should be completely behind the curve of the Earth, and we know we've seen well beyond. Like, in other words, like at 10 miles, it's 66 feet. At only 10 miles. So if you're, let's say you're in a rowboat, you're in a rowboat and it's like 5 feet off the water, and you should be behind 66 feet, and I see you, something's not matching up.
Right. So that would like be like if you took one of those tubes, like a 5-inch tube, and you made it 10 miles long, and then you raised it 66 feet in the center. Do you think?
Right.
Yeah.
How would that?
That's what you guys are believing.
You're saying should be hidden. When you say should be,
66-foot tube in the middle of 10 miles. Could you see the other side through the tube?
when you say should be hidden, are you ignoring refraction or accounting for refraction?
Howard, I you got to at least concede to that, dude. That's just the facts of the geometry.
No, the tube just bothers me because that's like you can't see it through a tube.
Sure, you can.
It's line of sight. It's line of sight. Your line of sight. You're not.
Yeah, but I mean, if
You're
the
the one
tube
claiming
obstructs
it
your
bends
vision,
like that.
you can't see through it.
No, I mean 10 miles would be ridiculous. The original analogy I brought up was just, on a smaller scale. But I'm just saying, if you take it to that level, I mean, that is what you're claiming. I mean, if you're 6 foot off the water line and you're looking at something that's also at 6 foot elevation, and you're seeing it over 66 feet, hundreds of feet over a proposed curve, then that is not that dissimilar to literally having a tube or just some thing right at your eye, and then you have to raise it 66 feet in the middle. Like there's a 66-foot hump that your eyesight has to travel at a different elevation upwards, and then it has to curve down at a different elevation downwards in terms of the XYZ axis. And in just 10 miles, I mean, it would have to make a hump of 66 foot that you'd have to somehow, your vision would have to be traveling over to perfectly fit a planar observation.
You know what's
But
funny?
the thing is,
This to me is
a lot of
important, which is I've asked for numbers, and we do have numbers on the 66 foot over 10 miles. But then when I say, well, how much would light need to bend to make that possible?
Yes, that's my point.
Wait, bending, you can bend light in a pretzel. You could take a fiber optic and bend it in a fucking knot, right? I could shine the Geo's tube example. I could put a flashlight in that tube and light come out the other end of the tube. It doesn't mean I can visually see what's on the other end of the tube.
But I mean, I know, Howard, you've been trying to get in. Sorry, but just real quick with fiber optics, like it's not actually the light bending through the tube. It's what I was describing before. It's straight paths of light that continually get refracted and reflected to where it travels that way.
Well, the minutia of the argument, what I'm saying is you could shine light out the end of the tube. The example Geo made, light will come out the other end. It doesn't mean you can visually see. The way the light is traveling doesn't mean that your eye works that way as well.
Yeah. Go ahead.
Yeah, but we're talking about the amount of refraction required to make these observations we're talking about is only like a half a degree, if that.
Well, even less.
That
way less,
allows
yeah.
to make these. Yeah.
On Earth, it's like 1/10 of a degree thereabouts.
Right, but a degree is not really that relevant when you're talking about actual miles and feet and meters. When you're actually measuring. So, the actual geometry. We're talking about real geometry. Like if you set up in a football field, you had real geometry in it. You have humps and elevation changes. Those are very real things. Like that. I mean, unless you just believe the Earth is not physical.
But what do you mean? A degree is not real, but feet and inches is?
Well, a degree is a part of a larger circle, which is a massive thing that you're trying to relate that to. So what I'm saying is just calling it 1 degree doesn't really minimize the fact that it's, miles, hundreds of meters, hundreds of feet, etc. of curvature that's missing.
But the only way to determine if it's missing at an eye is, as we keep talking about, angular resolution. Angular resolution is an angle which is measured in degrees.
Yeah.
So unless we've got the degrees measurement, we're missing a fundamental. It's like we're trying to calculate, do trig, and we go, we've got one side, but we're going to ignore an angle and then figure out the other side of this triangle.
I know, but just using the 1 degree,
you need an angle.
That would be like if someone was 100 years old and then they were like, you know what, guys, from now on, 100 years is actually 1 year. I'm just 1 year old. It doesn't really make them.
I'm talking about trigonometry. Trigonometry is.
No, you're trying to say, it's only 1 degree of curvature, as if 1 is a low number, just trying to use that number. And I'm not doubting it has a degree if you want to measure it as a part of a larger circle or sphere, even if you use a celestial sphere and a level planar surface in the middle. However you do it, Yeah.
Sorry.
But Wolfgang made it clear it's about angular resolution. And the question I've been asking for, it feels like 30 minutes now, is
What's
okay,
focal
what's the
distance?
best
It's a
angle?
focal distance. Angular resolution
Sure,
and
that's
focal
the base of the
distance.
triangle?
What?
Sure, that's the base of the triangle. What's the angle at your eye?
It all
Really
depends.
important question.
I mean, there's variables to that. Like not everyone's eye is the same, but let's say on average it's 3 miles for a 6 foot tall person is where your eye is going to converge with the horizon on average. You might have better than normal vision and you might see a little further, but it all depends
That
on
angular resolution. It's like not 2 arc minutes, isn't it? 2 arc seconds or something like that.
2 arc minutes, yeah.
0.02.
2 arc minutes. So that
0.02 degrees.
0.02 degrees. So
Yeah, resolution has nothing to do with this debate.
But the original thing we were saying, however you, well, the original thing we were saying, I mean, however, whether it's through degrees or through, elevation, distance numbers, at the end of the day, what we're talking about is that it's still the actual geometric elevations and distances and the amount of curvature, whatever the degree is claiming, you still have to somehow come up with a concept of your vision traveling, up over a mountain. And then and it's fine if you want to believe it. I hear that as an explanation because I guess it's the only way to kind of rationalize these observations on a globe. But at that point, you then, if you're wanting to actually validate it in the physical world, that would have to be done to then even validate that that's happening. And if you can't do that, then it's kind of just an empty theory without any actual isolation or conclusion.
I find it strange that.
No, I agree with you. It's just that's not the argument I'm making. That's the argument Wolfgang's making. I'm not supposing anything does or doesn't. Excuse me, Wolfgang, you didn't get very happy when I interrupted you, which I am sorry about. Please don't do it back. But the point is, Wolfgang's making this point that relies at its core on knowing that angle. It doesn't know that angle.
We actually talked at the same time. You could say you talked first or I did, but whatever. I was gonna make an analogy to what Gio said about the tube. If it was a garden hose and you put a flashlight to the garden hose and you bent it, the light would come out just like water comes out. It doesn't mean you can see on the same way that the light travels. Your eye does not see around those curves. Just because the light is shooting out doesn't mean you can see around the curve. You're saying, "Oh, light travels to my eye from that." No, it doesn't work that way.
Seriously.
I'm not talking about
They can do that with fiber optic cables, where the inside of the cable is like a bunch of reflective, surfaces, and then they shoot the actual fiber optic. So it's going left, it's going up, down, left, right. It's bouncing all around, and then you can bend the cable because there's so many refractive transfer of the data going that even if you curve it, it's still just refracting on its way, like it's still bending through the thing. So yeah, you can do it that way now, but that's not really how they're even explaining it. They're not trying to say that it's like that, the way fiber optics works. They're using a different kind of idea of bending.
They're saying it's doing through air. It's refracting the same way as a fiber optic through the physical air, and we don't observe that. That's my point.
No, fiber optic cables, it's reflection, basically.
Right. Yeah. But what I'm saying is that you can have a fiber optic cable that is bent, let's just say at 8 inches per mile squared, if you wanted, and the light would come out the other end. The signal will come out the other end. Now that's kind of what you guys are claiming, meaning you're on the shore or wherever you're at, you're looking out, there's actually a huge curve there, 8 inches per mile squared, but actually the light is coming through, as it were. It's coming through to your eye. It's kind of a similar way you guys are describing it.
Not 8 inches per mile squared. Like there'll be some curvature to light ray, which we're going to get to at some point today.
You could wrap it around the cylinder.
Like on the job today. He's got a whole curriculum.
You could do a 100-mile coil around a cylinder and shine the fiber optic light out the other end. It doesn't matter how much you bend it.
Yeah, that's not refraction though, right? That's reflection.
No, what I'm saying, you guys are claiming you can do the same thing through air, which is nonsensical.
I thought you agreed that light bends through a gradient.
If you're going to repeat the same thing 100 times, dude, you're still not making a valid argument.
So can I try and summarize questions to get where you and Rudolph are going on?
Mike is kind of going out again, writing your mic.
Don't worry, I'll wait till I'm not in a windy street again. I'm wandering around because I feel weird if I sit down in one place. Somebody will just log out and be like, "Hey, flat Earth."
Yeah, we know you're roller skating in very short shorts right now.
My shorts are pretty damn short, actually. Actually, let me just try and turn sideways. So it sounds like you're agreeing, Wolfgang, that light band is in a medium.
Nobody did.
Great.
Dude, how many times I gotta say? I don't. Nobody is arguing that light does not bend. Nobody's saying that.
Then you disagree that I can see the mountain.
Look at what I'm saying is bending light. We just even talked about. I made an example. Bending light seen through a visual curve is two different things. You could bend the light through a tube, through a hose. That doesn't mean you could see out the other end of the hose. Just the way, oh, the light's coming out, therefore I can see through it as well. No, you can't.
The light from an object reaches your eye. Can you see that object?
We even argued this earlier. You said, what
I
is the
know.
light? Is the light a photon? Is a photon coming into your eye? Is that what light is?
Whatever you think light is, however you think we see
You're
things.
making the claim that something's traveling into your eye. That's not how that's not how your eye works. I mean, we can agree to disagree, but
Okay, so let's ignore curvature of light. How do you see things?
how does your eye work? I don't know. I don't know how an
Okay.
eye works. It's got rods and cones, but I'm not sure on God's design. I don't know how it works.
The current theory, right, is that light is photons and they interact with the cones and rods in your eye, and that's how you
And
see
I don't
things.
think that's true. I don't think that
Okay.
there's physical photons bombarding my eyeball.
Okay, but however you think we see things, right? If there is a path of light, if light has a path, and that path hits your eye, do you agree that we see things? We'll see that object.
You will
If that's
see
how light works.
it's in alignment. Like you will not see something beyond a physical obstruction. If let's say we're on a salt flat and I dump a 30-foot tall stack of sand. You're on the back side of the sand dune. I'm on the other. We're on a salt flat. We're even with each other, but there's an obstruction, a sand dune in between us.
Right.
I'm not going to see you. You're beyond an obstruction, right? There's an obstruction between us. I'm not. There's not enough. There's no such thing as bending over and seeing something on the backside.
Well,
Doesn't
there is
happen.
in my diagram, which you agreed light bends.
Your
So
diagram
what is
makes
wrong with the
sense,
diagram?
dude. Because it makes no sense. Just like bending
Well-
light through a hose doesn't mean you can still see through the tube or the hose. Just like Gio said, as soon as you bend it, you just because light will pass through doesn't mean you can see it. Doesn't mean you can see an object. Just because light travels through doesn't mean, like, I could look in the tube and see light. Like, oh shit, there's light. It doesn't mean I'm going to see an object on the other end of the tube. If I put a quarter in front of the tube, you're not going to see the quarter.
Yeah, I think the tube analogy is good.
Yeah, it's rock solid because you can't argue it. Just light will come through. Yeah, I could look through the tube and see light. Oh, I see light on the other end. It does not mean
Right,
you're gonna
and
see it.
especially like if you're at like let's just say 6 foot elevation and you're looking at something and the target is also at 6 foot elevation and it's a far enough distance and so on. That means that if you're going to claim that it's light coming, doing all that, then yeah, basically your eye, let's say your little 3 inch diameter eye socket is receiving that path in that idea. And if you're at 6 foot elevation and the target is at 6 foot, then essentially there's a 5 inch wide patch of space, if you want to call it that, or atmosphere that goes from your eye at 6 foot elevation exactly. If you want to, if they're going to say it's curving around a curve, of course they're going to say that. But yes, it would have to do that, curve all the way around the curve, and then go right into the 6 foot elevation of the target. So you would then have to, it's the same concept as a tube that's that long looking in that 5 inch diameter, thing. And if you put a huge hump in the middle of 60 feet or 100 feet or 200 feet, you have to claim that somehow your vision is making that actual curved thing through the environment.
What does the pipe achieve? Like, does the pipe interact with the path that the light takes? Or does it just...
No, not the light. We're not talking about the path of the light. We're talking about your physical line of sight. Once you obscure the physical line of sight, your eyeball does not see what's in front of it. Once I've obscured it, light will travel through the tube.
If you have a tube...
Yeah, it could be
bent.
referred to as like the visual corridor, let's say.
Okay, if you have a tube that is slightly bent and it's bent in the same same radius as the curvature of light, then you will see what's out the other end.
No, you will not.
Yes, you will. Why would you not?
Go buy a tube and see if you can do that. Go bend a piece of tubing and see if you can look out the other end. Light will travel through. I can look through the tube and see light on the other side. It doesn't mean my line of sight. My line of sight is obscured by the bend.
Right, but the light's not touching the edge of the tube. So what does the light? What does the pipe
Passing
do?
light or something does not mean it's visual. Does not mean you can observe it.
Yeah, but the light's not touching the walls of the pipe, so it doesn't
already
need to
agree
be
how
there.
does an eyeball work? We don't know how an eyeball works. You're saying photons? We don't actually know.
We do know how an eyeball works. As a matter of fact.
We do?
Yeah.
Well, this is a
Been
little
known
bit
for a long time.
It's a little bit similar. Did you guys hear the other day when Stanley said, when I was asking him about another way to measure the Pontchartrain Bridge outside of the way he did it with the GPS signals? His response was, build a straight vacuum tube and shoot a laser through it.
Yeah, LIGO, exactly.
Right.
LIGO's a great proof, I reckon.
It's a
In my
similar
top 5
type
now.
of idea when you have a tube like that. In his case, a laser, but of course, a laser is not our vision. But that's kind of the thing, though. Think if you had that let's say that let's say you had a tube like that with the laser, but it has to curve to 8 inches per mile squared. What you then would have to believe, same idea, is that you build a tube that isn't actually straight, but it goes to the curvature of the Earth, and you shoot a laser down it. We know what's going to happen. The laser is just going to right when it curves, it's just going to shoot into the side of the pipe, and it's not going to go any further. But somehow you have to claim that it's bending. It's bending.
Sorry, the laser's bending or the pipe's bending?
The pipe would have to bend if it follows the curve of the Earth.
Right, and it would hit the side of the pipe. Correct. Well done.
Right.
Right.
But you're claiming that we see in curves. So even though we don't see in a straight line like a laser, but then you got lasers bending in sugar water. There's all kinds of contradictions here, Ruben.
Yeah, the amount of refraction is generally far less than the curvature of the Earth. There's an actual ratio called the K factor, which is that ratio of the curvature of light compared to the curvature of the Earth.
It's just a jumbled mess.
It's like what you say we don't understand.
It's like a bunch of papers.
It can be made into one.
It's like when you got all these papers on your desk and they're all just mixed up. Like it's a lot of contradictions and disorganized.
Zero contradictions. Only misinterpretation.
What you're doing is mixing.
I've understood something now, though, which is that when Geo and Wolfgang say, I don't understand how the eye works, and we sort of go, okay, well, let's move on to the light thing. I think that's quite important because something I think is clarified for me that is that if you say, well, light doesn't see photons coming into it, then the path they travel to get to your eye is somewhat of a moot point because in their view, I can now see why they can be obstructed by the bending of light, which happens potentially within my eye. But you couldn't show something that isn't there because my eye sees the world as it is. So I can warp it as it is, but it can't change what is. Whereas if you see
you're
light
equating light
in paths,
Correct, Jesse.
He's equating light and sight as equal, and they're not. Just because you see light does not equal sight. Your line of sight, just light will travel that path, does not mean your line of sight will also travel that path.
right. So in the conventional model of physics, that is exactly what that means. I think what you're talking about with like, if I shone light in one end and I saw like scattered light reflected on the edges of the inside of a pipe, therefore I'm seeing light. I think that's a very different kind of thing to like
that was my point.
Bulb of the torch beam.
That was my point about the light hitting the side of the pipe.
Yeah. But I think
Let's say you have a tube, like Gio was saying, and you're outside. Let's assume you're in a completely dark room, completely dark. Let's say like a dungeon, and you just have this pipe coming in, and the pipe is bent, but there's light on the other side of the pipe. You could see light coming through that pipe. The light will come through that tube. It doesn't mean you can see through it and see what's in the other side, what's on the other side, and where the light is emitting from. Doesn't mean you can see
reflected light.
Like say I put a candle at the other end of the pipe. There's a candle there. Doesn't mean I could see that flame. Light will come through the pipe, but I can't see the other way. So
it's reflecting off the sides, right?
Right. So if it's coming out, it doesn't mean that, okay, the light is bending, therefore your line of sight is also going to bend and see over this curve because the light does that. The light is traveling in the curve.
If the pipe follows the same curvature of the light ray, then it's not going to reflect off the sides, and you will see whatever is in the other end.
Well, try and demonstrate that in reality. That's what Geo, I would like to see you do that. Put a camera on that pipe and then bend the pipe. Bend the
How
pipe,
long would you like this pipe to be?
bend the pipe 1 diameter. Whatever if it's 1 inch, bend it 1 inch and see if you could see out the other side. Bend it 1
inch.
diameter.
This is why I keep asking about angle. 1 inch is not a bend. Right?
Not a bend.
One inch is
We'll
not a
call that.
It's just not a measurement. It's not how you measure a bend.
I'm saying bend it 1 diameter. I said 1 diameter. I said if the pipe was 1 inch, bend it upward 1 inch over its length. That's all you have to do. 1 diameter
And
width.
I'll tell you how long the pipe would have to be.
It doesn't matter how long. If you bend it
It
1
does.
diameter, you're not
Yes,
going
it
to see
does.
out the other end.
Let me work out how long it has to be.
Whatever the diameter of the pipe could be, it could be a 5-inch pipe. You bend it 5 inches, you're not seeing out the other end.
Hang on a second.
That's why I kept saying in these bend things, you need to be talking in terms of not just like
I said
inches or diameters.
One diameter.
that's-
Do you understand that? 1 diameter unit. Whatever unit the pipe is, it doesn't
I'm still
matter.
speaking. Wolfgang, I'm still talking, mate.
You're talking over me.
No, I was still talking and you jumped in to say
What
one
you
diameter
do is you
right
pause.
as I was
You jump
conceding
in.
that I
You pause. You have these pauses and you jump in when I interject. So I wasn't done speaking. I'm not done speaking.
I was clearly still speaking. Sorry if you weren't able to recognize that.
All right, you guys have canceled each other out, so let's reset and go. What were you saying? Someone was saying something.
Oh, Jesse tried to say something. Could we put the bent pipe in the sugar water so that it would be more practical?
Yeah, that'd be good. Yeah, short pipe in sugar water. Or just make a mountain, like a little sand mountain in a sugar water tank. But I mean, this is what I'm saying. This whole point is moot because we could show that, but there we go. That's still not how eyeballs work.
Yeah, so Jesse, for you, seeing a laser that's refracting like that in sugar water, what does that do for you in terms of helping you understand the observations we make on the Earth and how that links to what the shape of the Earth is?
It shows me that refraction like that would allow you to see over the top of something that was geometrically between you and what you were seeing. And I demonstrated that actually with a weak prism.
And I think like to me, what I imagine when I see the laser is not. I think a lot of people put it as like my eye is the laser. Like no, I imagine myself when the laser hits the other side of the tank. If I dove down there with a scuba mask on, what would I see? And I think I would see the laser and the hand holding it and the little laser pointer. So not just the red dot as if it was dead ahead of me, but I think I would see the whole shebang, the hand and all. That would be the cool way to test it, actually. Film it from end rather than just a cross section, film it from the end as well. Yes. I can kill the conversation just in here.
Gio, when you said 8 inches per mile, that's the curvature rate of the Earth, not the curvature rate of light. So this pipe would need to be about a mile long. Say again, Harry?
Which is what would be required if your eyeball were on like the surface of the lake, but if it was above it.
Oh no, we're talking about looking through a pipe that is deflected by an inch, and the pipe would need to be about a mile long to be able to see, straight through it.
Let's get a mile long dead straight pipe.
Yeah, and bend it an inch. Easy.
That is, I don't know what these eggheads at LIGO were complaining about.
Yes. LIGO's a
The
great
curious thing
proof.
about that for me is like, how do you know that it's straight?
Yeah, I mean, ironically, yeah, you guys, you know what's interesting, Jesse, as well. Yeah, like just right into that. You guys, this is another huge contradiction.
Or a huge misunderstanding from your behalf.
You will claim that the laser is bending in sugar water, which correlates with why we see over bendy mountains and stuff. However, if the laser is in a tube, it's not bending anymore, and it wouldn't curve around it.
Not in a vacuum tube.
No, the tube isn't the thing that makes it doesn't not bend. It's the removal of the gradient.
Even if it's not vacuum,
It's just there to facilitate the move.
Never going to do that. You're never going to get a laser to do that, to bend perfectly like over the curvature.
When you say bend perfectly, you keep saying those words as in like the rate of curvature for the light is the same as the rate of curvature of the Earth. It's not.
Well, it has to be pretty darn close to be able to see land masses and things that are at ground level at the incredibly far distances we're able to see them.
No. 7/6R. What?
It would have to a degree.
Day to day.
But the typical value is about 1.2. Typical value is about 1.2 times the radius. What you think is an infinite radius, that things appear flat, and it just doesn't.
Well, no, there just isn't a radius to a plane. I mean, there is if you put a point in the middle and make a circle on it, but
right. Yeah, but if light bent at the same rate as the Earth curvature, then everything would look flat all the time. It doesn't.
Bandsaw.
These guys actually presume that images travel in packets of information like that.
Yeah. They're told where to go. That there's like out in the air, there's like the spirits of Newton and Galileo, and they're all just telling them go around the curve. They're shifting it around the curve.
Yeah,
but do you guys think it doesn't travel? Is that
this olive tree that I see in the distance isn't actually leaves and wood, it's actually light, right? And this light that makes the olive tree now travels magically through the air, warps, torts, and contorts itself to my eyeball.
Do you guys think light doesn't travel? Is that the point?
Believe that.
Like how does a radio transmitter work? How does a radio transmitter work if light doesn't travel?
We're talking about what we see. It's a physical object. We're not talking about light itself. We're talking about an image that we see.
Okay.
This is what I was saying, Rui. There are many people in the flat Earth thing that don't subscribe to this idea that light goes from the horizon,
point A to point B,
travels from there into my eye.
No, you're saying that the light is the image that we're seeing.
What?
What does that mean?
Maybe I don't really understand what that means.
That the light contains a package of information in an image that is traveling through the air.
I mean, I think an image is comprised of light. I think without light, I don't see it.
Yeah, because it's dark. Turn the lights on and you can see it. Hello?
Right. So it seems like light has something to do with vision.
No. Well, you can see things because it is illuminated. But the actual physical object itself is a physical object where we see it where it is. It's not traveling through the air to us.
So the Skunk Bay thing, you know, that one, I don't have it at the moment, but like it's like a river or something and it's shooting a sort of spit of land that's wibbling up and down. How would you describe what's happening in that picture? You know, that GIF with the sort of the shore is kind of going wobble, wobble, wobble. It's like sped up over a day.
Oh, I read that. Yeah. Well, what we see it where it is. how
Both
I would
moving?
explain it. Hold on, Ronnie. We see it where it is. All right. Now, what's immediately around that image, say an olive tree or a boat or whatever it is, the atmosphere directly around it, being that water vapor and all that sort of stuff, the image is then reflected onto those air particles, water particles, gas particles immediately around it, right, in its immediate vicinity, right, but not in the light traveling through the atmosphere bending, right, towards us. It's actually reflected in place. Like there's all these little mirrors all the way around it. That's how I see it.
Hey, Geo, can you go to voice check-in?
Who's there?
Devil Eyes wants voice verification.
Yeah, I'll just move her down here because I'll just give it to her. It's all good.
All right.
Yeah.
I don't know who VOMD is. We'll find out in a second, I guess.
No. Oh, voice mod.
Of my dick.
Yeah, voice mod.
Oh.
You believe this dick?
Devil Eyes, yeah, you're unmuted.
Oh God, I started being gross in that.
Come on.
Every time I behave myself well for months.
Yeah. Doopy-doo, doopy-doo. Where were we anyway?
I was thinking
Hold on.
You're
a bit low, Devil. You're a bit low.
I was pinging computer.
Okay. Anyway, we can hear you. Where were we?
I'm in Bali, and they love
You're in
flying
Bali.
kites here. And twice I've seen kids flying a kite. It's just a little dick. I'm like, it's
Oh,
like
really?
a 7-year-old kid that's flying it.
Oh,
As a
cool.
result, I've now learned the Balinese word for it.
Mm-hmm. I've looked on your channel writing. You haven't eaten anything crazy yet. What's going on?
But in Bali, they have been, I don't want to say boring, because that sounds really rude, but like even the Balinese complain about it. We were like in the first car, in the like first little taxi on our way from the airport. We're like, what do you guys eat here? And he's like, it's nasi goreng for breakfast, nasi goreng for lunch, and nasi goreng for dinner, which is just the word for fried rice. It's like all they eat is fried rice.
No way. Oh, God.
Like little sambals and stuff that go with it that are slightly interesting, but like, yeah, if you want standard Balinese fare, it's all the same food. So when I get to Thailand, I'll definitely eat some bugs for you.
Yep. Oh, nice.
Oh, lordy,
Crocodile
lordy.
crossing. We did up in the Northern Territory, and we're riding along for like ages down this closed road, and we're like, an hour from where we need to be, and if we have to go back, it's like 6 hours, and we end up camping in the bush overnight on a like we just wouldn't be able to turn back. It's a river that's like 50, not quite 100 meters long, and like thigh deep water with a sign next to it saying crocodiles spotted recently. Construction efforts are underway. I'm like, oh God.
It's like how recently. Like how recently is like I'd like to know.
Yeah, well, I actually did have a little date stamped on it, or like, what was it, 26th of May, which was 6 weeks before when we were there. But I've never been quite so tense in a river crossing in my life.
Oh no. It was good to see you worked out your travel from Darwin over there.
Is this
Had a bit of a hiccup.
Yeah, pretty low, Devil.
Yeah.
Is this a flat Earth server?
It is, yeah.
Yeah, pretty much.
Half of us are flat earthers, half of us are globers. Boldly defending the shape of the earth.
We're all flat earthers. The other half are just flat earthed.
We're just pretending to be globers.
Yeah.
Some of us are still in denial.
Yeah, exactly.
Just we're not sure which ones are which.
I think I know.
Yes, well, I know where I'm
Andy's in
pointing my
denial.
finger. I know where I'm pointing my finger, or my fingers.
Yeah.
And remarkably, we all know where we're pointing our fingers, and it's all away from us. But when you point a finger away from you, are there not 3 pointing straight back?
Exactly, exactly.
So, Devil, what's your view on the shape of the Earth? And follow-up question is why?
Yeah.
I do be drinking.
You got to speak louder because you're, yeah. I can barely hear you.
Yeah, you're pretty low volume. Sounds like maybe you're. If you try getting closer to the mic.
Speak up a bit, get closer to the mic, and jack up your input volume.
Yeah. I'm going to play some poker, I think, people.
Well, make sure she consents first.
What? Oh, very good. Very good. Very good.
I had a few drinks tonight, sorry.
Yeah, right.
I think Riding asked you, what do you think about the Earth? Like, what do you think the Earth is? Devil Eyes.
Can I answer tomorrow?
Sound like you need to go to bed.
Yeah, yeah. That's fine. That's fine, Devil.
I guess you'd have to ask Riding. Is that all right, Riding, if she answers tomorrow?
Sure, that's fine by me. I don't have to answer at all. There are some people like Merle who seem to change his view on a weekly basis.
He's agreeable to it.
Yeah.
He's a glober.
So what? Merle is?
Merle's not here.
No, Merle's not here. So, but Bandy, when you were saying when Ruhuf was saying before that you switched sides, was that a historic one you talked about ages ago, or is that a recent one?
Yeah, we spoke about it a long time ago. Yeah, way back in the day, in the very beginning. Yeah.
Now
Like
I
4
see
years
what
ago,
you're
wasn't it?
saying. Keep bringing it up.
But did you ever debate? For the globe? Did you ever champion the globe?
No, no.
Okay, that's a key point.
Yeah, no.
There's a difference between like
fun's at.
there's a difference between like maybe thinking it's the case, whatever it may be, and then there's another thing of like pushing it.
Yeah, no. I did go on onto Nathan's show once and give him a bit of a hard time, but that's only because he kicked me off his show one day prior to that.
In what way?
Rowan's in here.
Sorry,
I've been kicked
Devil?
off there a dozen times, I
Yeah,
think.
really?
Rowan is in here.
Rolling my boulder.
Yeah, yes, he is. He might be here, but he might not be here too. He might be.
Honestly, Ruf, I'm surprised you lasted as long as you did.
Yeah.
You really
I got
toughed it out.
pretty silly. Got pretty silly there for a while.
And then I got banned, and then QE banned me.
Where? Where'd
When
you
you're a
get?
Glober or as a
No,
Dog.
as a flatty, I got
Where
banned.
did you get banned?
Oh.
Science and pseudoscience.
Can you invite me?
Yeah, I got banned from there like a week ago. Who can get me into 24/7? Like I got banned from there like 3 years ago.
I can.
You can like have a chat to the mods.
Yeah.
That'd be
if
glorious.
You didn't get me in science and
I can't get you in there because I'm banned from there. But if anyone can get me into the 24/7, that'd be lovely.
I got banned.
Who's talking? Who needs to get into 24/7?
Me.
Rui. Rui.
Rui wants a shot at the title.
I don't even know who's in there. Like I've just heard so much
get
about it,
back
and I got
in,
banned
but-
within 5 minutes.
The Glober is given
Well,
the
last 5
7K.
minutes.
Is Rui
Yeah.
gonna do it?
Yeah, I
I'll
can
see
get
it.
you back
Like
in.
people who are experienced in the arguments.
I
I
think
can't
you're. I
guarantee
think
a
you're.
shit though.
It's definitely within a 5-minute ban. I would say.
Yeah.
Yes.
Yeah.
Have you been banned previously, Ruhith?
Yeah, I
can look
got
through
into
the
the
ban
voice
list.
check-in. Yeah, I got into the voice check-in, and Crit was in there, and Crit had like a not a huge go at me, but like a little soft little
A
jab.
little bit of a vendetta going on.
Yeah, and it was like let's agree not to talk to each other because you talk shit, and it was just like it was us agreeing not to start any shit on the server, and this guy came in because I said something negative about Crit. This mod just came in and just went, "Yep, you're out, done, banned." It was like it was such a piss weak interaction. Anyway, so yeah, I've never actually been in a voice chat in 24/7.
I asked and they said nope immediately. They never say no to me. That's
Jeez. Oh,
Well, I'm not a mod over there, but I am just one level below a mod, so I can verify you and all that kind of shit if you need.
not
Well, I've got to be
that he's
unbanned
banned,
first, right?
He's banned. And I
Yeah.
know the mods, they simp for me, so like
Okay.
they said no.
There you go.
They said no.
Your representation preceded you.
Is this live right
Well,
now?
yes, it is, Devil. Yes, it
Fuck
is.
that. Fuck that.
I'll keep listening, but I'm about to go back into my room, so I'll not be talking anymore. Lovely to talk to you guys.
All right. Yeah. Have fun writing. Have fun, mate.
Yeah.
Will do.
You may have to soften your approach if you want a shot at the title, Rui.
Yeah, I will. But I mean, I will answer as emotionlessly as possible. Let's see how I go.
Yeah, I don't know what those guys like kind of know of you or think of you or whatever. If they even, but I imagine like if I had to predict, I would imagine you could probably get into the voice chat at some point, and then basically you'll be banned whenever a mod just does it, So like they'll probably kind of let you in there, and you might be able to get like a couple minutes in, or maybe even a discussion. But you're gonna get to one of them. It's a ticking time bomb. But you could.
Oh lordy.
Yeah.
No, I posted the chat that
They said you eat crayons.
I got to post the conversation I had with QE that he actually banned me for from his server or from Betty's server. Let me find it. I got to put it in my Flat Earth folder actually.
Well, we don't really need drama from other past things in other worlds. Other servers, is that really needed?
Anyway, there it is. Oh, it's there anyway.
If it's like, especially if it's private DMs, he probably wouldn't want that. It's just not needed.
No, it's it was in the woodshed room, and he literally asked me to give him back up my claims about this video that I made, and I did exactly that. And then he just goes, "You're banned. You're banned for cause." And I was like, "Okay, champ." Anyway.
Well, it looks like you said bye bye Snowflake.
Yeah, that was after he said you're banned.
Right. Oh, yeah. Okay. Well, so he basically, let's see here. It's just the information you were providing, and then just insulted you and banned you.
Yeah. Yeah. So in the center of the screen, I said, anyway, like I said to Betty and Righteous Force, clear evidence that QE citations have been corrected, but the smart money is on QE kicking me out of the server when he's been shown to be wrong. So, of course, he saw that as a jab, which it was, but, still.
Am I roboting?
No, you sound fine.
No, Jess.
He sent a GIF of you. He sent a weird GIF he made of you.
Sorry, QE sent that, or what? Who sent what?
Yeah, he said, "How many times have I said fucking definitions are meaningless?"
Oh, that, yeah. So what that means is that definitions are how people use words. They don't dictate. They don't prescribe how you use words. So words are just the sounds that our mouths make. They don't actually have inherent meaning. To album. What earth? There we go. Whoa.
Bro, you can't make enemies with them.
Well, yeah, that's that's kind of how this arena is.
Apologize. You say sorry.
I'm not going to apologize to QE. Apologize for proving him wrong. That'd be a bit.
Yeah.
Well, I mean, this is all based over what other people said or claim to have said. So it's not even over the actual information itself, which is in and of itself seems a little bit inane to me to just be trying to do that, you know, in that sense, because it seems like that's what you were like, quote unquote, proving is that these like mainstream sources made one quote that he quoted, and you said, oh, but they changed it later. It's like a debate around like the propagandized part of science.
Yeah, like you know, the Globers all say science can't prove things, right? I was taught. It's actually in here. The recording that QE put into one of his numpty clips was from here, right? So it's me saying science doesn't prove things, and as part of that video, he got 4 citations from the internet saying science does prove things. 3 of those citations have since reversed their view. Or at
Yeah,
least
see, that
corrected
right
their
there
view.
is sketchy. Like, why do you
What do you mean?
trust them when they just U-turn their shit?
I don't. Like, I don't give a shit about citations.
But you do, because this is a whole thing about why science doesn't prove things, because all these guys reversed their idea. They just 180.
Yeah, these were QE's citations.
Right?
These were QE's citations. Right? He's using citations to so-called hashtag prove his point. Right? And now his citations disagree with him. And I pointed that out to him.
Okay, well, obviously, like the veracity of the sources would have to be analyzed and all of the rest of it.
Right.
But I mean, the bigger question I was saying, if these guys are just U-turning from in their positions, then you know, that's its own thing. But
they made a mistake. They weren't careful with their words. That's okay. It's like 10th Man has all these books on celestial navigation and all these citations, all these citations on celestial navigation. Some of them are wrong. Some of them are just blatantly wrong. Citations can't win an argument. It's putting it into practice. A demonstration wins an argument.
yeah, I mean, I would just simply say that, I mean, the word science is used for so many different things in today's world, you know, that's just the whole situation. But if I'm just going to use it, I would say science absolutely proves things, seeks to prove things, and aims and is the entire thrust of it, because the goal would be to acquire a database of knowledge or truth, ultimately truth. But knowledge is also a pathway to truth and can be kind of the intermediary as developed, you know, as those are put together, like truth itself, and then how the kind of compilation of that. So the scientific method, experimentation, and approach is all about trying to distill a body of information that is, you know, true or as close to the truth as possible. If the truth can be absolutely verified to be 100%, then great. Like you know, vitamin C cures rickets, you know, stuff like that. Like if you can get a direct, you know, truth like that, that's great. But that's the whole goal, is to prove the efficacy and the effect of whatever it is you're testing or, you know, creating.
But science doesn't. Your example of vitamin C cures rickets, right? My hypothesis is that if I give vitamin C, rickets will cure, right? You give vitamin C, your result is that it cures rickets. If you form that into a logical syllogism, you will be affirming the consequent. It's a logical fallacy, right? My hypothesis predicts X. I do an experiment and I get X. Therefore, my hypothesis is true. That is a logical fallacy. That's why science doesn't prove things.
Say it again.
Close to it.
Say that part again.
Okay, so the basic What science does is it's in the business of providing explanations, right? So if my hypothesis is true, then I will get this result in reality, right? I get that result in reality, but if you then say, therefore my hypothesis is true, you're committing a logical fallacy.
No, you're not.
Yes, you are. That's the textbook affirming the consequent.
No, as long as you form your hypothesis has been formed and structured correctly, then you can confidently go forward after that and claim you've proved something.
No, put it into a logical syllogism, an explanation, so an inductive explanation, and DM it to me.
Well, just think about it. You've got a hypothesis that consists of a very specific independent variable, which is the thing that you are claiming is going to cause the effect that you're studying. And then you do an experiment to test that, and it does happen, then that's it.
No.
Like,
I've got magic green pixies that are sitting and watching you, and every time you wiggle your independent variable, they actually change the dependent variable. That's what's happening. Have you disproved that?
You're talking about magic green pixies, man.
Yes. Have you disproved magic green pixies? They exist, right? I know they exist.
Show me one.
No, I just know they exist. You haven't disproved they exist.
See, now
Therefore,
you're
it's
using
possible.
a ridiculous.
I know it's ridiculous, right? It's to demonstrate a point that you cannot isolate the cause of something. You might think you can, and you can get pretty close, but you can't logically rule out something else.
So who stated that? Like, why? Let's start with the first part of. I was going to say like one thing I was going to ask just to start off the bat. Where are you coming up to the conclusion that with science you have to first start with some theory and then prove that theory right or wrong, or not prove? That's okay. You don't use that word, but try to show evidence for that theory. Where do you have understanding of where that's actually the roots of the actual of the word science and of how to apply the scientific method?
Yeah, my definition of science would be the practice of systematically not validating explanations for how the world works.
Validating explanations.
Yeah.
You mean like identifying the specific cause of a particular effect?
Yeah, or tentatively at least identifying it.
Could we say conjuring?
Conjuring? No.
You're conjuring an explanation?
There has to be an inductive leap in an explanation, right? You see something in the world and you go, what could possibly cause that? You make a guess. There we go. Writing in eggshells. The Feynman quote is the best for this. Yes. In fact, let's play that clip. Can you play that clip, Gio?
Yeah, but that's why systematic experimentation and then a very specific independent variable along with control variables and a dependent variable, all of these components all together as a part of a test are all necessary.
Hang on. If you know what I mean. Did you control for magic green pixies?
I don't understand what you're trying to do with that example.
Okay. Well, yeah, you cannot control for every variable because there are variables that you don't know about. Yeah, play that. Play the clip that Harry's posted.
I would just disagree with like forming a hypothesis and then conducting an experiment and confirming my hypothesis as being.
Yeah, you should try and disprove it. Yes. Yeah.
Yeah.
You should try and falsify it.
It's like saying if I get the flu, I'll have fever.
Yeah.
I have a fever, therefore I have the flu. That's an
Yeah,
affirming
that's affirmative consequent. Yeah. Yeah, you should be trying to disprove your hypothesis. Yes.
Yeah, I think that just sets you up for a whole boatload of problems, and it also opens the door for all kinds of deception and interpretation, which is pretty much what's happened to this modern day scientism propagandized.
Gio, can you
psyop.
play that clip? Can you play the clip that Harry just posted? It's pretty short.
Play it on the live stream?
Yeah, and share it or whatever. Yeah, whatever. Play it to everyone and we can watch. He nails it. And everyone in the audience laughs when he says it.
All right, let me
The first minute. It's in the first 10 seconds, actually. There we go.
Can you see it?
I can see it. Your YouTube is muted, though.
Wait, hold on.
Do you want me to just read out what he says? There you go. Yeah.
There. All right. Yeah, you can see this now?
Yep. So
Well,
just
this
the
is
first 10 seconds.
a whole 10-minute clip, so
Yeah, just play the first less than a minute, but in the first 10 seconds, he says what I want to hear.
Oh, so it started from the beginning?
Yep.
Discussed how we would look for a new
All right,
law.
tell me if you can hear it.
In general, we
Yeah.
look for a new law by the following process. First, we guess it. Then we well, don't laugh. That's really true. Then we compute the consequences of the guess to see if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong.
The end.
In that simple statement is the key to science. It doesn't
There
make
we
a
go.
difference how beautiful
100%
your
agree
guess
with
is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, it's wrong. That's all there is to
There you
it.
go. We can pause now. All right. Notice what he didn't say. He didn't say if it does agree with experiment, then it's right. So he's made a guess, like you guess the law, or you have your hypothesis. You go and test it. All right. If it's right, it doesn't mean your hypothesis is true, because if you did do that, you'd be affirming the consequent. But if you test your hypothesis and try to break it, and you can't break it, then you have like some level of confidence that your hypothesis is true. It
Yeah,
still may be proven false later.
It's all about building a statistical confidence, I think.
Yeah, that 1 minute
Maybe
clip.
falsified later,
final.
like
Yeah, but here's the thing. If we talk about like boiling water and we make a hypothesis that heat boils water, that is going to be true. Can other things cause water to boil? Sure. Pressure, right?
Yep.
No, but in your experiment, you'd have pressure as a control variable. So you're isolating a specific cause that you want to test for, and when you do your test, you find out whether it is going to cause the effect or not.
Right. So in this
you
case,
can't control for everything. You didn't
So in
control
this
for magic
case-
green pixies.
What do you mean?
appeal to incredulity fallacy.
Right. So in this case of boiling water and the statement heat causes water to boil, would that be an incorrect statement?
I believe it to be true. Right? I believe it to be true. You can't 100% prove it with formal logic.
The tests have been done. They say that water will boil at 100 degrees centigrade with the caveat of at a specific pressure at 14 psi, barometric ground pressure. So, you know, at that pressure, when water reaches 100 degrees centigrade, you can do heat is what you're going to need to get it to that temperature. You know, there might be different ways that you can heat it up, but unless you get the water to 100 degrees centigrade, that's what is necessary for it to boil. I mean,
is it logically possible? Is it logically possible for some other factor to cause the water not to boil at 100 degrees in standard pressure? Is that logically possible?
No, I mean, you could.
No, it's not.
Yes, it is. Yes, it is.
Listen,
no, it's not.
You haven't ruled out magic green pixies.
Do you not
magic
know
green
what a
pixies?
Regress
fallacy. No.
Show me a test where you've gotten water to 100 degrees centigrade and it's not boiling.
This is not about me doing a test. This is about logical consistency.
Listen, that's why when you
but you're bringing up logically lunatic. Like
I don't care whether they're crazy. It's logically possible. Do you understand the difference?
But the things you're talking about are illogical. Green pixies.
It's not illogical.
Green pixies are not logical.
They're not illogical. It is hypothetically possible for magic green pixies to exist. You think they're unlikely, and I do as well. You think they're very unlikely and probably don't exist, and I agree, but they are not logically excluded. Do you understand?
We understand that you live in a world where you infinitely regress, yeah.
Yeah.
Okay, thanks.
May I say something, please?
Welcome, by the way.
Yeah, Silent Zero's trying to say something.
Go, Harry.
Let me just say this real quick.
Oh, Zero.
That's why, Ruhif, when you formulate your hypothesis, you don't put a lot of
Why don't you turn down
independent
Zero?
variables. Okay.
I do, sorry.
Yeah, you may have me muted. But what I'm saying is that's why when you do formulate your hypothesis, you don't put two independent variables, because you will not know which one is causing the effect. That's why in your independent variable on your formula, you have one independent variable. That's the one you're testing. That's it. If let's say if you formulate an independent, if you formulate a hypothesis, Rufif, I cannot come in the middle of your testing and say, oh, but what about this? You're gonna say, no, man. And in my formula, I have this specific one that I'm testing to see if it causes the effect that I want, that I observe in nature.
Okay,
you don't go ahead and put sugar, salt, and all kind of bullshit in your formula. You put one to test.
There's a great example of this whole thing you're talking about, where this guy makes a quite funny, breathless TikTok about it, where he's talking about do bees tell time, and he still mistakenly uses the word prove at the end of it. But he talks about, like, some scientist goes, oh, bees always leave the hive at the same time each day. So what about if I don't let them be able to see the sun? Do they still change time at the end? They, like, come out at the same time every day, or like? And he keeps changing all these different variables. If I put it in a light box, do they come out at a different time? And somebody else was like, oh no, but what about this? And then then they eventually, like, ship a hive of bees across the world so that they're in a different time zone. And then he's like, at the end, they've proven that therefore bees can tell time. But the whole point, which makes me laugh at it so much, is what he's demonstrating is that it hasn't proven it, because each time there's like 5-10 different iterations of this testing different variables. Is you won't know, as the Ruhif's point about green pixies, is you can never get to the end of the variable.
All righty.
Yeah, and I've got
you guys are so wrong.
I've got a good example for Rams in a minute. I'll just sit out from poker.
Scientists agree with us.
So basically, we can't prove that the Earth is a globe that spins. Awesome.
Correct. Can't prove it. You can't prove flat Earth either.
Can't prove it. Yeah.
That's awesome.
I mean, flat Earth can't be proven because it's
It's another concession. It's another concession. It's
Yeah,
been
yeah. If you want to call it a concession, that's fine.
it's been a day
We're
of
not-
concessions today for the globe
Yeah.
Earth.
Anyway, Rams, do you want to hear another hypothesis?
No.
Let's hear your hypothesis. I want to hear it. I want to hear what kind of hypothesis you guys formulate.
Is this for how you can't prove the globe, Ruhif?
No, it'll illustrate a point when I get to the end of it. But yes, it's about the globe.
Well, go ahead and try.
Okay, cool. My observed phenomenon is the sunset, right? And the sky sort of rotating. And my question is like, is that the Earth rotating, or is
You
it
already
the,
have too many things there, buddy.
You
sorry,
mean
yeah.
the phenomenon is the movement of the sun?
Yeah, in the sky. Like
Okay.
it's rotating,
the
and I want to know.
rotates? Okay.
Well,
Yep,
no,
I wanna ask-
you can't say rotating. All you can say is that it's moving.
It's moving, yeah.
Well, it goes in a circle.
No, you cannot see a
Have a
circle. You
circular
just see it move in a straight direction. I don't know from where you get the circle.
Let me know when
Believe?
silence finished.
Well, it depends on what you're talking about.
Well,
You're
you can take time lapse.
stars like around.
time lapse. It circles around the poles. Let's.
Is that what Ruhif's
Yeah, it's just, we all agree that the
That's
sky
an
moves,
assumption.
right? Like it's
All right,
apparently.
From the ground,
The sky-
you
we
could
all
say it
agree the sky
appears to make an arcing motion.
Yes. Okay, that's all I need, right? That's my observed phenomenon. And my question is, is that us rotating or is it the sky rotating? And my hypothesis is that the Earth is rotating. That's my hypothesis, that the Earth is rotating.
Why? Why is that your hypothesis? What evidence led you to that?
I don't need it, right? Did you listen? You missed the Feynman clip. I don't need any.
Oh, okay.
Right?
Yeah, the
The
hypothesis.
Feynman
Yeah,
clip
you're right.
basically says to discover a new law, you make a guess, right? And my
Yes,
guess,
exactly.
my hypothesis is that the Earth is rotating. All right. To test my hypothesis, I have to calculate the consequences, as Feynman says, of what would happen if my hypothesis is true. Okay? If my hypothesis is true and we are rotating, then it follows that there will be centrifugal force, and then it follows that there will be a differential in weight corresponding to latitude. Okay, so my experiment to test my hypothesis.
This is all just predictive guesswork based on a model conceptual explanation for this. But whereas the only actual way to prove whether this is true or not would be for us to somehow be able to leave the Earth and the reference frame of it and its movements and observe it from outside so that we can actually, tell what's actually happening. So that would be the only way.
Hang on. My hypothesis.
The only way to test it is something we can't do.
I've got a way to test
It's
it.
the reference frame thing, right?
No,
like
I've
if
got a
you're
way to
if
test
you're on
it.
a train and the windows are all blocked, and another train's next to you and it moves, you can't tell whether you're moving or it's moving because you
I'm
need to
giving you
be
a way to test it.
outside of both reference frames to be able to have any, concept of what's actually happening.
No, I'm giving you a way to test it without leaving the Earth, right?
Okay,
So my
let's
hypothesis.
pick up where he was just but that if the Earth is spinning, there'd be centrifugal force and there would be a weight distribution relative to latitude. Go ahead.
Yes. Yeah, that's my experiment. I'm going to wiggle my latitude, my independent variable, and my dependent variable will be the weight of the object, right? My experiment shows that there is this correlation, right? That correlation does exist. Have I proved my hypothesis? Yes or no?
No, because I'm actually
Correct.
about to just completely. Wait. Can I please just expose him? Okay, actually, that doesn't happen though.
Yes, it does.
So good try. No, it literally
Yes, it
doesn't.
does.
There's
Oh,
huge,
it does happen.
Yes, it does.
No, I bet if you guys keep interrupting me, then I won't expose your worldview.
Okay, keep going.
So actually, within your own paradigm, there are huge anomalies where the weight distribution is incorrect. including the entire country of Canada, majority of it, all over the entire world, from top to bottom, there are huge anomalies that aren't consistent with actual rotation. Go ahead.
Okay, it does exist.
What
That correlation
are
does
they?
exist.
Oh,
It's
you're
been
just
done.
going to
what-
skate past what I
have-
just said? You're
Have
just
you
gonna skate
any
past-
have you any evidence of these anomalies with it?
Yeah,
Yeah,
and left
I'll
lane, when I give it
post,
to you,
I'll
are you
post
just
some.
going to stop talking, I'm guessing? Because you're not going to be like, oh, wow, what's it, you're right. We can never talk about this again because it's a lie. You'll just wait till I leave and talk about it again, I'm guessing.
Oh, I'll post mine.
So, Ruhif, have you ever heard of these discrepancies?
No. Have you ever heard that we've
So you think it
verified
works
this
perfect?
multiple times?
So you think it works perfect?
Oh, it matches the predictions of the globe Earth. When you say perfect, do
No,
you mean within what tolerance?
there are
There you go.
huge discrepancies that don't match the predictions.
Huge discrepancies. I would love to see some huge discrepancies. Anyway, I've posted
what I was
mine.
asking
Okay, I'm
for.
about to show it to both of you, and so when you find out that actually the predictions don't match what is observed, what are you going to say then?
I
Or
would
you're gonna
see why they don't,
disavow
because I know that
Let's
they
look
do.
at it. Let's look at it.
I'll answer
I've,
that
I've
with
posted
it.
critical
They're
things,
gonna
and many
say
other people
that
have done it as well.
they're gonna say that the test was not properly done, as they did to me.
It was done by
When
the
I
government.
did my weight
It was done
test
by the government.
from one place to another, they say that I was doing it wrong. So at that point, what
Yeah,
do you do?
but look, he has a YouTube video. I'm citing the government. So.
Oh, we all trust the government, don't we, Witsit? We love the governments.
Oh, okay. So wait, time out. Let me just double check. So the government can't measure the weight of objects as efficiently as this guy on YouTube. Is
I'm
that
sure
your
they
claim?
can, but it's just funny that
No,
you're
we're
going to
just
accept the government.
surprised.
Well, let me help you guys out. So you guys are so ridiculously off here that you think a scale is a sufficient way to do it because you don't understand your own paradigm. But actually, the weight change is very minute. You have to use a gravimeter within a very controlled vacuum chamber system with interferometry. So you don't ever know what you're talking about. You never know what you're talking about. So anyway, when you actually do this, there are huge anomalies and discrepancies. Canada is a perfect example. Majority of Canada is drastically missing gravity as to what's supposed to be there relative to the latitude. So
Okay, post
why
your
do you
evidence.
guys say things? Why do you
Post
guys
it,
say
Witsit. Fuck.
Okay, I
Yeah,
will.
I'm looking
I will.
for
My
it.
question is, why do you guys say things that you don't know anything about?
I've literally posted the critical think video.
Yeah.
I've posted evidence
All
that
right,
it's correct.
You're going, I do have
I'll
something
get it for you,
that
buddy.
does debunk you. Why are you guys so wrong about everything? But I'm not going to show you. Like, show us, and then we
Well,
can
I'm just
discuss.
Yeah, then we gotta look at it.
I'm gonna. And then what are you gonna say? What are you gonna say whenever it shows
We gotta
that the
fucking
predictions
look at
aren't
it,
right?
Witsit.
It doesn't
For fuck's
matter.
sake, you're an idiot.
Doesn't matter what we're gonna say.
I'm an idiot, and you just posted a YouTube video with a dude using a physical scale. You don't even know how
Right.
it works. You have to use a gravimeter. You don't even know
You
how
don't
it
have
works.
to.
You do.
No, you can use
literally
a
do.
scale. You can use
The
a
scales are
scale.
super
Sensitive
inconsistent.
enough. Yes, you can.
I'd just quickly
Oh,
like
is it
I
is
think
it better than a
Ruhif's example that he
gravimeter?
gave just a minute ago was just ridiculous because it was an affirming the consequent itself because
Well
he was
done.
saying that if
Well done.
the Earth is a ball and it's spinning, then that's why the sun is moving the way it moves. Well, no, that's just affirming the consequent. The only way for you to
Hang on.
confirm that is.
Which part?
The only way for you to confirm it is to be able to actually get out of the Earth and see it from an outside perspective.
You're
to
saying
know
I'm
the reference frames.
You're saying I am affirming the consequent. My whole point is that if I said that proves the Earth spins, I would be affirming the consequent. Do you understand?
Yeah. You're on it, man.
Okay.
Yeah, you've got it. You've got it.
Yeah.
Well done.
All right.
Yeah. We're in violent agreement.
Okay, cool.
All right. Is that your that's your article, Witsit? All right, let's have a look.
Oh, don't worry. We got plenty more coming. Just don't hold don't get too excited. I just think it's funny that Glovers never know what they're talking about. They send a YouTube video with a scale and they're like stupid flat earthers. Try a gravimeter, buddy. And by the way, gravimeters actually have algorithmic corrections because they oftentimes get readings way off the glow prediction also. They literally have algorithmic predictions to get it within the window. What's up?
In
I
other
agree,
words,
though,
it's all
does
BS or what?
actually does this
It's it.
work?
Yeah, it's an elegant affirming the consequent fallacy. Yeah.
Yeah. PhD Tony has a gravimeter as well.
Oh, did he go to Canada and figure out why your predictions are completely wrong? Because when you
I
brought up
haven't
your
seen.
hypothesis, you're like, wait. I just want to make a point before I go get this other thing, which I'm just on my phone in my treehouse chilling, you know. But anyway, I just want to point out that, like you said, I see that the sky moves. I have a hypothesis that it's actually the Earth that rotates. And my hypothesis is, if that's the case, then because it's centrifugal force, it will be weight distribution relative to latitude, and that's exactly what we see. So now, once we falsify that claim and show actually the predictions that would be required if that were actually accurate don't exist, and actually we have anomalies contrary to that claim. If you apply your same logic you invoke to teach all of us about how this works, you would then disavow your positive claim that the Earth is rotating. But you will not do that. You will not do that. So you're going
I'm
to
not seeing.
show
I'm
to
not
all
seeing
of us
anything in
that
here.
you're not being honest.
I'm not seeing
Well,
anything in your article that contradicts.
Yeah, the thing
gravity
is, we're talking
corridor.
about weight change, and you're talking about a gravimeter, and that's kind of like we're talking about weighing things on a scale.
No, I think what's happening here.
Dude, oh my God, did you just say that?
Damn.
Okay, a
Did you
gravimeter.
just say?
Listen, buddy, listen, dude. Gravimeters measure downward acceleration with interferometry.
And so
Okay,
does a
you
scale,
think
and
it has
so does
nothing
a
to do with
scale.
weight?
We're talking about
You just said
weighing
we're not
things
talking
at
about
various latitudes.
gravimeters.
They both measure the weight of or the gravity. Yeah, right.
Yeah.
Which one measures them better?
Gravimeter. But I'm trying to read your article, trying to figure out how you think this disproves weight and latitude.
But who all has a gravimeter?
Let me
No,
try to.
no.
I think I do.
I'm reading your
Yeah,
article.
what's it saying? And I think it is, if I were to split the difference, is because there are fluctuations in it, because there are because it's not completely uniform, that throws out the weight versus latitude. Could you
Yeah,
not
that's what I'm thinking as well.
weight versus latitude is fairly standard, but if you zoom in and look at it even more finely,
Well,
you
yeah.
find
If
that
there's
line is
fluctuation,
slightly
how can you predict the eggshells?
Yeah, that's
You
all I think
cannot
it
use
is.
that.
Is the
You cannot
deviation
use.
from.
You can't
it's going to be.
eggshells. You
I can
can't
predict
use
it's going to
that
be warmer
as
in
a proof of
daytime
anything
without
or
knowing it.
to validate anything.
All right, let me help you guys out. Okay, so
You're not listening. You're
for
not letting me
one,
answer
there
the
does
question.
appear to be
You want me
some.
to
There does appear to be.
answer the
There
question?
does appear.
I guess
There
I'm
does
not
appear to be.
going to be answering the question.
Well, I'll just. Okay, go ahead. Clearly, the Globers don't know what they're talking about. But go ahead. You just know how to regurgitate talking points. Yeah.
If I predict it is, broadly speaking, going to be warmer during the day, does that mean I know exactly what temperature? Generally true. Do I need to know the exact temperature? Yes or no? We all know
Complete non sequitur, because in the current subject, you would know exactly what the difference.
Even with wiggliness in the data.
That's non sequitur. You would know exactly what it is.
This is just a silly
Scale
fallacy
thing.
of expecting it to be exact and having no error bars.
Oh, nah.
Well, then it can't be probability based, then, can it? You can't just make a probability based prediction.
I just think it's so funny. You guys don't even know what you're talking about.
Rams.
I think we do actually.
What about if you?
No, you don't.
What about if
No,
you
let's-
found that the weight difference versus latitude? So the question, Rams, is what if you found that the weight difference versus latitude was an order of magnitude more than this gravitational
Exactly.
anomaly in a part?
Exactly.
What if you found that
Hey, I got
the weight of that latitude was like 100 times more than this anomaly is measured, which is why you need a gravimeter to measure it, whereas the latitude can be measured with a scale you buy for $50.
No, gravimeters are used based on latitude as well, buddy. Try again. But hey, if there was a correlation, could there be another explanation, or does that prove that the Earth is rotating?
I've got a question for you in a minute. Actually, let me think
Oh, you mean like
Let me-
electrostatics, which is inherent in all matter, and whenever you are within a different part within the field on top of the Earth, and you would have that based on your position in accordance with the composition of the ground beneath you, if there were certain type of magnetic materials, etc. Which is, by the way, literally what we see. That's literally what we see. So,
All right.
also, there are mountains that have more mass, but there's less gravity. Something's not working out in your model. It's just as weird.
All
All
right.
the evidence shows us that your claim is wrong.
Question for Whitson, right? How do you know, or how do you show that the weight versus latitude amount has not already been taken into account in these gravimeter measurements that you're talking about in Hudson Bay? Because that's what's happened, guaranteed.
Okay, listen here, buddy. Okay, we have anomalies on the Earth where the differences in weight do not match the predictions based on latitude.
Right. And what Harry said, what if these differences are orders of magnitude less than the weight versus latitude amount?
Okay, I
Would that
said,
imply that those differences have already been taken into account when they say it's missing? Do you understand?
I do understand what you're saying. I'm explaining to you that it isn't because the Earth is rotating. There's a slight correlation to weight and latitude, but it's inconsistent. And which part didn't you understand?
said that's inconsistent.
That's what you said. Why is so hard for you to understand, Ruhif?
He just didn't think that Whitsitt was conceding that before, but it sounded like Whitsitt, to me, like Whitsitt was conceding that, but saying there are anomalies in it. What I think is also interesting is that the way
That's
they measured
correct.
this was using satellites.
Well, okay. I think it's funny your own
Oh, they
paradigm
did.
says, "Oh man, our maps don't work. Our maps don't work." You think that flat earthers think there's nothing in the sky? You think I can't know the Earth isn't spinning because I don't? I actually have brain cells that work, but I can't. I didn't therefore have to say nothing's in the sky. Humans can't put stuff in the sky because the Earth doesn't spin. Is that what you guys think's going on here? That you just get any? I think that no, they're not
It's
30,000
kind of
miles away in a
strange that
vacuum.
you're using evidence that you don't even believe in as evidence.
Now you're strawmanning me when I just prefaced and said I don't have to exclude all things that come from satellites because things can move in the air over a flat Earth as well, Laflane.
How?
Yikes.
Proposes a whole bunch
How?
of really difficult questions. How does something move
Well,
that fast?
all right. Let me enlighten you. So, actually, in your paradigm, majority of satellites are geostationary. So, I guess we're just going to throw all
I
those
wouldn't
out
say the
because
majority
you
are.
can't be talking.
No, that's not true.
No,
Oh, really? Really?
Vast majority orbit massively. Geostationary orbit is quite difficult to get to. It requires a whole bunch of delta V to get out that far.
Okay, you know what you're talking about. So, the satellites that are up in the air.
You just had 3 Globers correct you on something, and you tell all 3 of us that we're all wrong. All 3 of us
Well, yeah,
instantly went no.
I bet when I get to rebut it, then we could continue the conversation instead of you just chanting. So anyway, actually, majority of satellites that have any type of long-term duration are geostationary. Maybe go read your heroes at NASA before you talk so much on Discord. Secondly, that they have longer durations of flight. Secondly, they all require geocentric coordinate systems. All of them.
Okay.
All of them. Okay, so for one,
Require?
this isn't
What do you
proof
mean
that
by
the Earth is
require?
moving. Wait, this is in context of the Earth moving, and you have to use a stationary Earth to do it?
No, you said the word require. Are you saying you can't represent with a coordinate system that's also rotating?
Wait, are you saying that? Okay, can you please cite a satellite that doesn't use a geocentric coordinate system?
No,
Please,
it's
right
not.
now.
It's not whether about what it does use. Does it require it?
Yes.
No, it doesn't. I can
You
describe
want
a
to know why?
satellite's path using the rotating Earth. I can just do that
Okay, but
transformation.
no, you can't actually
Yes, I can.
do anything with the satellite.
Holy
Stop.
moly! Now you're into satellites.
You can't do anything with satellites without a geocentric coordinate system, and
I
NASA
can
agrees.
represent the path of a satellite in any coordinate system you like.
Okay, but NASA says they have to use geocentric coordinate
They don't
systems to
have
put them
to.
in the air. Oh, so NASA's wrong and Ruhif's right.
They don't have to. You can
Well,
represent any coordinate system you like.
So cite one satellite that was put into orbit using
I'm not.
heliocentric.
I don't have to. I'm telling you, I can transform any coordinate system to any other coordinate system. I can describe the satellite path in that other coordinate system. That means
right, but
that it's not required. The end.
Okay, no, I'm sorry you're not very smart, but maybe you'll listen carefully, okay? So you have
Smart
to
enough not
use
to go to fucking jail with it.
Oh, got him. Oh, I got arrested for weed in 2021. That's something to make fun of someone about. Oh my
Yeah.
God. Yeah, you're a douchebag if you think that smoking weed is something that makes you better than other people. But anyway, here's the point, okay? You have to use a geocentric coordinate system to put the satellite up, yet then can mathematically transform it to reify and describe it within your paradigm. But the initial step of actually putting it up requires geocentric coordinate systems. Do you understand, Ruth?
I've explained myself quite clearly.
Oh,
We
you just got
understand
destroyed.
what you're
You just got
saying,
destroyed.
but it doesn't.
You just got destroyed
Are there any
because
geostationary satellites in a geostationary orbit where their inclination is not on the equator? So are there any geostationary, say, over Norway?
No.
I
don't
think
mean pointing at Norway, I mean over Norway.
but my question is, are there any satellites that were launched without using geocentric coordinate systems?
Doesn't matter. Did I not
Can you answer
explain
my
myself
question?
clearly?
Can you answer my question?
I don't know and I don't care. It doesn't
Well,
matter.
after you answer mine.
I don't even know what his
The
point
question I
is.
asked.
Oh, no one can answer. You guys are imploding. Hey, is there any satellites up in orbit that were launched not using geocentric coordinate systems?
Why would they not be? I mean, they're launching from Earth. You need to know where from Earth they're launching.
Because
Why
they're
would you
launching
not
into a
launch from a point?
heliocentric solar. Because they're launching into a heliocentric solar system.
Well, they're orbiting. They're orbiting
satellites in a
the
solar
center
orbit.
of the Earth.
They're orbiting us.
Yeah, they're. Of course, it's geocentric.
Oh wait, so satellites
Latitude and longitude.
never venture away from the Earth?
Well, but I mean, they start at the Earth. It
You mean
takes a
the
long
IBEX
time to get out of
mission or
Earth.
the Voyager 1 and 2?
Anyway, I'm going to watch the video back in 6 minutes.
Okay, here's the objective reality, right? So everything that NASA does, they have to use a geocentric system.
Of course, it is because they're orbiting the Earth.
So you're saying that we couldn't, if we couldn't use a heliocentric system to launch a satellite?
They're not orbiting the sun, are they? They're orbiting the Earth.
Well, if you wanted to
hold
be
on. The
most
Solar
efficient,
Parker
then you
probe.
would. If you
The
wanted to be
Solar
the most
Parker
efficient,
probe orbited the sun, right?
yeah.
So
Why
I
did
imagine what they did was launch it into a parking orbit, right? You launch it up, you get it into a parking orbit, which is like 150 kilometers above the Earth, where it usually does some sort of transformation thing up there, some sort of staging happens. So all of that first stage, first, second, up to third stage, will be just around the Earth. Then it will need to do an
Let's
extraordinarily
look at the
powerful
path of
burn
the
to escape the Earth's orbit.
Wait,
Once it's out of the
can we
Earth's
just
orbit, sure. Now
can
you
we
can
just read?
cross into some sort of heliocentric coordinate system.
They don't.
But
No, they don't.
why?
You just made it up.
So you know that that's
You just made it up.
so what
Can you
happens to the
cite
ones
it?
that go into
Can you
solar
cite it?
orbits?
Can you cite it?
Sure, yeah, Kerbal Space Program.
That used heliocentric coordinate system? Can you cite it? Doesn't exist.
It's just you do the coordinate system around whatever body you're orbiting. You're launching it from
You can't even
southern Earth,
mathematically
so
make it work.
Just interrupting
Wrong.
me to
Well, I'm not trying to interrupt you. I have kind of
usually
bad
you're
service.
good. Usually you're good, but you're just like filibustering and saying you're wrong and asking irrelevant questions in the middle of other people
What's
speaking.
that? Flatsroid gave you a shout out. He says he wants to talk about, the ether and flatness or whatever.
Okay.
So how many satellites are in geostationary orbit?
It's not, maybe I'm wrong about that. I don't know. From my understanding, any satellite that has a longer duration is geostationary. Like majority of longer duration satellites are geostationary.
A geostationary
So
satellite
the
is.
further you are from the Earth, the less of the junk around the Earth you will be hitting, so that'll last longer. Whereas if you go with the internet thing that Musk launched, those satellites will only last a couple of years each. You've got to keep relaunching
Starlink, yeah.
because they eventually start. Yeah, they slow down and burn up. Whereas geostationary orbit is very clean. There's very few molecules out there for it to run into, very few micrometeorites. So they last a lot longer, but they haven't been the majority of that.
The Globers
Okay,
don't believe in Occam's razor. I mean, you've seen a helium balloon float in the corner of your room after a birthday party for weeks. That's what a geostationary satellite is. It's just up there floating on stagnant ether currents, basically. It's just floating over the flat, motionless Earth. That's
yeah,
much more
duh.
Occam's razory.
Just like whenever we had to give internet to a remote area, they launched the Google Loon project in 2018 to give them internet. They didn't use satellites; they used balloons. Yeah, and I actually watched the Starlink launches. So I know all about them. They are hilarious. They are very slow and very low, and they take forever to get off the ground, and they arc over at a very low altitude compared to the other launches that I've also watched, because flat earthers go and do things. And I'm not impressed by your Starlink, but I do know that the Starlink launches use geocentric stationary Earth coordinate systems. Just like your predictions for eclipses, require geocentric coordinate systems. You then describe it in the heliocentric paradigm with a transform equation, because you can't actually predict it without the geocentric coordinate systems. This is coming from NASA. Then you get on Discord and you have Globers disagree with NASA, but that's not the really relevant.
Nobody's disagreeing with you on that, Witzer. You keep making that point as if it's like a debunk. All of us are happy to agree with it. Like you need
No,
to know
but
where you're launching the satellite from. You launch it from near the equator, pointing east, invariably. For that, to know what the equator is, you need to know that you're at zero latitude. To know what east is, you need to know what east is. All of that comes from where you are standing. You're not
wait,
saying anything that should shock or surprise anybody in this room.
wait.
You're
Are you saying that
repeating it like it's a debunk.
Well, what I don't understand is if it's just so objective that the Earth spins and revolves in this heliocentric model, then why can't we just use that model to predict eclipses?
That's what we use for the Saros cycle. I mean, the globe cope came later. The globe's not really necessary. It's just an added extra step that just gunks up the process and really doesn't add anything.
It doesn't even work, Lemon. Like, it doesn't even work. NASA admits they can't predict eclipses with a heliocentric coordinate system.
That's not true, man.
Oh, okay. Oh, it's not true. Cite it.
They do predict eclipses. It's predicted
Globe
way out.
cope. It's globe cope.
Cite it, Left Lane. You're making stuff up.
Have you abandoned
Like you've never seen it.
I've
Yeah.
dropped over 40 links in this room alone, unless it was Facebook with McToon, I can't remember, about NASA predicting eclipses with geocentric coordinate systems. What's up with that? Oh, but they're orbiting the Earth. They're orbiting the Earth, so of course they're using No, we're talking about eclipses. So what's your excuse for that one?
Well, the Earth curves at 8 inches per mile squared, so show the 8 inches per mile squared mathematic calculation or whatever in their argument. Otherwise, you guys just really don't have a case. It's just flat and motionless, and the globe cope comes later as an unnecessary step.
How is it 2022 we give them 20? How's it 2022 we give them $20 billion? We give them $20 billion a year, and they can't even predict eclipses with the heliocentric model, and you guys are just going to skate right past it.
We're not skating right past it. Lemon just changed the topic.
Well, can you address that? What, don't you think that's weird?
Sure. When an eclipse will happen, and where on the Earth, like if the Earth was just a sort of anonymous uniform ball, I think you absolutely could do that with the heliocentric system. To know where it's going to cast that shadow, as in, is that shadow going to pass over Paris or Sydney? For that, you would need to have the Earth's coordinate system to know where Paris and Sydney are, to know where that shadow is going to be cast over. So I don't know how you could say, I know which part of that ball is going to be casting shadow when I cast a shadow in front of it, unless you've also got a map for the ball. So again, what you're saying isn't a debunk of anything.
Yeah, it is.
See, hey, to know where something is, do you need to know where things are?
No, it's not just the shadows on the Earth. You just made that up ad hoc. It's the actual eclipses, right? So they use a geocentric coordinate system, and they get declination readings of the moon and the sun relative to a stationary central Earth. So relative to a stationary central Earth, they get declination readings, and that's how they predict eclipses. They can't do it with the heliocentric model.
I'm back. And
If you can show me the
the
bit that says the last part, that we can't do this with the heliocentric model, that would be interesting. If you're just saying we need to know where things are on Earth, then no. Again, I will still stick by what I'm saying. You need to know where you're standing on Earth to know whether an
all
Earth is going
right.
to happen.
Can I just report back after the video? The weight change versus latitude is 2 orders of magnitude larger than the missing gravity in Hudson Bay. The end.
Okay, so
What's his name,
well, I already addressed it. I guess you guys didn't listen, but that's not new. So, we were actually in the middle of a conversation.
So weight change correlates with latitude.
I already said that there's some correlation. We use gravimeters, which actually have algorithmic corrections, and the changes are very minute, but the correlation to latitude does not prove that the Earth is moving because, in fact, just as Einstein himself said, just as Einstein himself said in a letter to Ernst Mach in 1913, if actually the Earth is stationary, but rather the sky and the universe is rotating relative to it, then you would also account for a Coriolis effect or some type of centrifugal and centripetal relationship that would happen from the inside to the outs. Therefore, any type of correlation to latitude doesn't actually prove it is the Earth that is moving. And that is Einstein saying that.
I agree
Okay,
it doesn't
so-
prove it. That's the point. But
It
my
doesn't- no, it doesn't
scientific
even-
hypothesis was that there is a correlation. So it does sort of validate my hypothesis, but it doesn't prove it. The
Well,
end.
your hypothesis was if the Earth is rotating, then there would be a correlation. I just explained to you that Einstein says that. I just explained to you that Einstein says if the Earth wasn't rotating, there would still be a correlation. Were you not listening?
Why would there be a correlation? Send me that.
Okay, yes. So it's in a letter to Ernst Mach, right? And it's about the effect of the rotation around a stationary Earth would cause a relative reaction to the system inside of that rotation. So they're interchangeable coordinate systems. It's nothing more than a coordinate system preference. So you did not in any way add exclusive evidence to the Earth spinning by showing correlation with latitude. Secondly,
So given, all right.
Go ahead.
I said, given you've messed up this Hudson Bay thing, right? What's the chances that you messed up the Einstein thing?
I didn't mess up the Hudson Bay thing because I explained. No, because if you had to listen to me, which there was another Glober in the room who did listen to me and even corrected you, and you still are understanding it. I explained from the beginning there is a correlation to latitude. It's just inconsistent. And we have anomalies, and we have drastic anomalies with the gravitational distribution.
The anomaly of that Hudson Bay is 0.005%. Right?
did say
The difference
that from the
between
beginning,
weight at the equator and the poles is 0.34%. That is 2 orders of magnitude bigger. Do you understand?
Okay, yeah, I understand that
Okay,
all the changes are. You're, dude, you're not listening. Okay, so I said there is a correlation with latitude, right? But even that correlation is inconsistent, and the overall gravitational distribution predictions are oftentimes inaccurate. I just explained to you that just because there's a correlation with latitude, that doesn't prove that the Earth is moving unless you want to go against Einstein and basic logic. Fourthly, you'd actually have to accurately define weight, which is coherency specific, location specific, etc. You don't account for any of these things, so you don't even know what weight is. So whenever you have your gravimeter, which is a vacuum
Don't
chamber,
even know what weight
it's not
is.
filibuster. Yeah. So
Yeah.
hey, left lane is
Make your sentences
weight
shorter.
Okay, here you go. Is weight coherency specific? Yes or no?
I have no idea what that means. Coherency
Okay, so does that make
specific.
me dumb?
Does that mean like you don't understand
you
it
have to pull out
incoherent,
fucking
or what do you
phrases.
mean?
Okay,
make yourself understood. Don't blame other people that you're not able to make yourself understood.
Yeah, and don't try and make yourself look smart by pulling out phrases that I've just Googled and cannot find those 2 words together. Coherency
yeah.
specific.
Okay, so you already know I'm wrong, but you don't know what I'm saying. Is that correct?
Did you
Is that a good
say the
summary?
words? Did you say the words coherency specific in sequence with it?
Yeah. Do you know what that
Yeah,
means?
right. I've just Googled those in sequence. I got 371 results from Google. Do you know how close to 0 that is? Right, so you're trying to make yourself look smart by just making up
Oh my
shit.
god.
Way.
Okay, buddy,
Screw him.
buddy. Here's the deal. I made up the phrase myself. Okay.
Right, so
Having a
why the fuck do you think I would know it then, idiot?
Oh man, someone needs to get laid or something. So here's the deal.
Yeah, your mum will
Specific
sort me out
means
tonight.
listen. Yeah, for sure. That was creative. So the point is, the word specific means that something is specific to it. Do you not know what that means? It means that it's a contributing factor, right? It's something specific. Do you not understand words? Okay, so that doesn't make me dumb that you Googled it because you can't think for yourself. Okay,
Yeah,
so
you're making shit up to make
coherency.
yourself look smart. It's pretty
No,
obvious.
I know you're about to get destroyed. You think you think I don't know what I'm talking about?
Who's the guy in
Okay,
the
watch,
chat?
watch.
Get
Okay,
on
so
with it. God
all right,
dang, get on with it.
okay,
Yep.
so you can hand wave dismiss it. Gotcha. So incoherency is whenever there is a lack of or synonymous directionality within the molecules of a piece of matter. So simply, when you have a magnet, it's coherent, right? So if you want to make a magnet, you can introduce electrical voltage, and that strong force will overwhelm the weaker force within that matter, and then it will send it all in the same direction. All the molecules will begin to move in the same direction, and that will create coherency. So incoherency is when they're discombobulated, moving in all different directions, and coherence when they're all moving together. Weight, quote unquote, is coherency specific, meaning relative to coherency. You can prove it because when you drop a magnet over any type of ground with composition that has metal in it, it'll drop faster. So coherency changes acceleration. So therefore,
No one's
weight.
listening. What's it?
Okay, see, you can't rebut anything I said.
No, that's not
It's just
true.
gibberish.
But
That was dude,
Wow.
that's not fair for
CGO?
you guys to attack him, dude. That's not fair. That was awesome, man.
Yeah.
You guys interrupted him too, dude. Austin, that was on point.
That was pretty good way it said.
It does sound though with it like it's affirming the consequence.
Well, no, you can actually manipulate the coherency of an object and see if it manipulates the weight. So how is that affirming the consequence?
Because you're saying, does coherency affect it? Then you're affecting the coherency, and then you're saying, therefore, it is coherency is affirming the consequence.
Correct. Well done,
No.
Harry.
When you manipulate the variable of coherency and it changes the effect of weights, you have proven that the coherency affects the weight.
No, you haven't.
Oh my god. Oh my god.
That is definitionally affirming the consequence. It was before you got into the room. There was a long discussion on this. If you say, I presume X happens, and if X happens, therefore I'm right, that's affirming the consequence.
Well, no, here's the deal. If we control all these variables and then we manipulate the variable of coherency, the weight will change. If I don't
Can't
manipulate
control all variables.
I didn't say control all the variables.
Okay,
See,
so
now
then
you're
there's
just,
a possibility that another variable. Yeah, but there's another variable that could be responsible for it, and you cannot logically rule it out.
I'm not
That's
claiming
the
to
point.
I'm not claiming to want to rule it out though,
Good.
buddy.
Then you can't prove something.
Oh, listen carefully. I know you're no, you want to get back to trying to run over my point. Okay. So
Yeah, you're right.
I made it very clear that coherency was just one of the variables, right? So weight's also location specific, which is what you've been talking about. So it's location specific, it's coherency specific, it's medium specific, right? So whenever you have this rigid dogmatic definition of what weight is, but you don't account for the variables we know affects weight, then you're just wrong. And ironically, you're the one that's saying, oh, there's all kinds of other variables that could be in play, but then simultaneously think you know exactly what weight is. Thanks for playing.
But hang on. But hang on, you can't go with it from starting. This whole thing about weight started by saying we can't define weight, and now you're saying we dogmatically define it in a single way. Which is it? You need to pick one of those.
Yeah, you guys think you know exactly what weight is. I'm saying you don't even properly define it because you don't account for all the variables that can be proven to affect the weight of an object. How is it not being understood?
We don't define it.
You define it dogmatically, but it is misdefined in your paradigm.
So that's now a third thing. Have I defined it?
It's all the same thing.
Defined it and right, or haven't defined it, which is it?
Okay, listen carefully. You think you know what weight is. I'm saying that your claimed definition of weight is wrong.
I mean, weight, I think, it goes. To me, weight's the amount of force something causes pulling down.
Yeah, you think weight is mass times gravity.
Did I say that, or did you say that?
I'm asking, what do you think?
And I just answered, and then you just told me I think something different. So do I think
Wait.
what I think, or do I think what you tell me I think?
Well, I didn't hear what you said. You don't think W equals mg?
I think weight is the amount of force something causes pulling down.
Okay, so that's very vague. You're not actually getting into the causal agent there.
Because I don't know the causal agent. But if we all agree on that, right, and we don't know the cause of it, and we say, depending on latitude, weight changes, and it's going to be between, I'm going to make up numbers and not even put a proper number on them, it's somewhere between 100 and 200 at this given latitude. And then you see a wiggle, it's sitting at 150, but sometimes it's 155, sometimes it's 142. Have I disproven the first statement that it's going to be between 100 and 200? Have I shown that statement to be false, yes or no?
No, you just shown your statement to be useless.
Have I shown that statement to be true or false? Sorry, have I shown that statement to be false, yes or no?
Obviously not.
Okay.
That doesn't rebut
So
anything
when we
I
say
said.
that weight is dependent on latitude, and we say it is between these parameters, and you give error bars, because every good measurement has error bars, right?
Non
And
sequitur.
then you go, but there is a small amount of wiggle within those error bars. Have you disproven that measurement or those error bars?
You're just going to keep asking the same question?
Well, so let's go back to it. Is weight dependent on latitude?
I said that it's not dependent on latitude. There's a correlation between weight and latitude, but it's not completely and entirely consistent. That's like the 10th time. Now, here's what I'm actually saying. Maybe listen to what I'm actually saying, okay? So when you make a claim that weight is corresponded to latitude and you think you know why, because the Earth is rotating, I'm pointing out that you don't, because the first step would be to fully understand the phenomena of weight. If you want to understand what is causing the weight difference, you need to fully understand the phenomena of weight. I pointed out with specificity how your paradigm generalization doesn't account for all the variables we know to be in play, so you cannot pretend you do know what weight is. Do you understand?
I don't pretend I do know, but I'm doubtful that I know, but I'm also doubtful that you know. Because what you said, I don't even think makes full sense to you, but I also will hazard a guess it doesn't make a jot of sense to anybody in this room.
Okay, well let me give you another example. So I said
Anybody else on this
coherency.
planet, maybe.
I said coherency. I told you how you make a magnet and you create it. You create coherency when you make a magnet, and then you can drop it over something with a composition of metal. It'll drop faster. We can move to the other one I said, which is medium specific. It's weight is medium specific. You can understand this one, I promise. So if a little 3-year-old goes over to a sumo wrestler and tries to push him over, she won't be able to do it. But if she goes over to the sumo wrestler while he's in a pool of water, she'll be able to push him. Now, what changed? Did his weight change?
The medium.
None of
The
what you're saying
medium.
is at all.
The answer is simple,
Yeah,
Eggshell. The medium.
I'm well aware of that, but I mean,
Well, answer the question, bro.
But how does-
It has more to do with
communication keeps
inertia than it
going.
does weight. Has more to do with inertia.
Expand.
It doesn't at all relate to the thing that we discussed. It's like we're
Yeah, I said weight is coherency, location, and medium specific.
right.
Your
Nobody's arguing
equation.
whether it's easier to push somebody when they're in a pool, right? How does that relate to latitude? Maybe that's the link.
Oh, okay. Well, there you
It just
go.
sounds
Well,
like you
yeah.
just want to say things and talk down to things.
No, I just get real fed up with straw man arguments. They're very remedial fallacies. So you asked him a good question now that I'm glad we've made progress. How would that be relevant to the conversation of latitude? That's a great point. Okay. Yeah, we have an electromagnetic field, and the dispersal of that field is relative to your latitude. It's relative to the central point of that field, right? So you're within that field. And so if it's coherency specific, obviously the coherency of the field and the magnitude of the field you're within will affect your weight, as will the composition of the ground underneath you, which is why you have quote unquote gravitational anomalies, because you only account for mass. You don't account for the composition, because the composition of the ground should not change weight. In your paradigm, it should be the same based strictly on mass. I'm probably dumb. Oh, now no, let's just huff and puff and act like I didn't say anything.
It should change based on what's under your feet. Why
Yeah.
don't people answer?
you've got a really rude attitude today with it. You're just like
Actually, no, it shouldn't change actually because high pressure moves to low pressure. Same with high density and low density. So you're not actually taking into account your own dogma. High pressure moves to low pressure, so the mass should be consistent.
What? I'm saying that weight isn't just dependent upon mass. In your paradigm, it is though.
No. I'm not saying to you. I'm saying to the guys with the baseless refutation.
Okay.
They're saying, "Oh, the mass isn't equal across the Earth. The mass is and it's not an equal distribution of mass." Well, it will be an equal distribution of mass because density and pressure equalizes.
Well, this is why they claim they have anomalies. And to the other person, I wasn't trying to be rude or talk through you.
Is rock? Hang on. Is rock not more dense than water?
What's the relevance?
Is rock more dense than water?
What's
Because
the relevance?
what old chap with the Garten Avatar said was that it is yeah, I'm explaining. That there is not uniform density under our feet. There is sometimes rock and there's sometimes water. So if
Hey, are we
it's not
gonna
uniform,
just?
then you don't expect uniform distribution.
Are we just gonna complete?
Read it on non-uniform.
Sorry, I'm not trying to interrupt you. It's like you're kind of low and maybe delayed. I don't know. Maybe it's my service. I don't know.
Oh, your mic is doing that thing again, Ryan. We can't really hear you very well.
But what? But why are we going to skate past what I just said, which is in the globe paradigm, weight equals mass times gravity, but we actually have numerous variables that affect weight that we can prove that isn't accounted for in that equation. Meaning, in modern academia, there does not exist an accurate equation for the phenomena of weight objectively. So if you want to, maybe I'll get my Nobel Prize and I'll come up with the proper equation. Also, if I have an object on a scale and it weighs a certain amount, but then I introduce electrostatics, I can make it float. So I manipulated the weight because now it doesn't weigh anything because it's not on the scale anymore. So that goes back to coherency, though, of course. And so again, it's medium, location, and coherency specific. It's also vector specific, right? Which is direction with magnitude.
But what if you
Good.
What if you put a Faraday shield around the whole scale and everything, and your electrostatic field is outside that? Does it still affect it?
Are you saying if a Faraday cage completely eliminates electrostatics?
Well, yeah, by definition.
No, it objectively doesn't. So if you can send me a link to a Faraday cage that claims that it attains zero, that would be awesome.
A Faraday.
Yeah, can you send me a link to one that claims it attains zero, please?
Can I ask a different question? Can you use this dielectric thingy to make predictions? So could you have predicted that there would be lower gravitation in the Hudson Bay area before finding that there was lower gravitation yet?
Well, that's a good question. I've actually looked into this in depth, and so I knew the first step was to have to figure out exactly what gravimeters are. And we have a big problem there because gravimeters actually incorporate algorithmic correction, and they actually factor in assumptions of latitudinal change, which is funny why he's like thinking he's smoking me by saying that it's a greater magnitude of change. The gravimeter just assumes it. It just assumes the change.
That's
So
totally
my
totally
answer
to the point
is
I'm making.
my answer
The
is
point
it
I'm
would be
making
very
is
complex prediction because you have to know the you'd have to know an entirely accurate composition of the ground in each place and the differential between area to area very specifically. Since quote unquote science is not geared in this direction at all, you're basically telling me that I need to go do something across the whole world myself and have billions of dollars or something. So the answer is yes, you could in theory, but it would be very complex.
I'm not saying you do need to. What I'm saying is that the Earth spinning is one of the crucial things about the whole hypothesis that we presented before, was it made a prediction and tested that prediction. It sounds like what you're saying is I'm not able to make those predictions.
They didn't test the prediction. They just reified the prediction. But yeah, if you have a magnetic field within a background medium and it's dispersed relative to the center of that field, so i.e. the center of the surface of the Earth where all the compasses seem to face, even though they actually use magnetic declination lines, but that's a side subject. So you would have a latitude relevance, right? It would be relative to latitude, better said, because it's dispersing relative to the center, which is what latitude is. So yeah, so basically it's like me saying, oh look, I see weight differences at different latitudes, therefore I proved that there's an ether with a drift central and that the weight is relative to the center of that field. It's the same thing. It's just the same thing. It's just affirming the consequence.
I mean, anytime you say this, it's affirming the concept. It's the whole discussion we had before you got here, which is you're just attempting to disprove it, and if you disprove it, it's wrong, and that's all that science does. It doesn't prove it.
No, yeah, that's right. Because all globe proofs are just affirming the consequent. It's like, you know how we know the Earth's a globe? Because the sun sets. And that's because the Earth rotates. That's called affirming the consequent. You know how we know there's gravity? Things fall. And that's how we know they're going to the center of the mass of the globe. And that's because of gravity. That's called affirming the consequent. You know how we know that the Earth spins? Because we know that...
Nobody's saying those things here. You're the one saying all those things. You do these long
Wait, so-
filibusters and you tell other people what they think. Just let them say what they think and you tell them what you think.
Yeah, my whole point has been that we don't prove things. So then you're telling us that we do? Like, what the fuck?
Okay, yeah. So is there any evidence you guys can provide for the globe Earth that spins that isn't affirming the consequent?
Weight change with latitude. That's evidence.
I
yes.
just explained how it's not.
It's a prediction of a rotating globe, and it is currently does not have an explanation for a flat Earth. Therefore, it's evidence for a globe. I missed that. So, how is it predicted by a flat Earth?
Yeah, so your weight distribution relative to the central aspect of the field, which is over top of a flat
Where do you
station.
find these guys?
Oh man.
Where's the center of the field? Is it at the North Pole?
But wait, this is crazy. I said, can you give me evidence of the globe without affirming the consequent? And then he says, weight distribution with latitude because the Earth is spinning, which is literally affirming the consequent.
No, that's evidence, right? Evidence, not
It's affirming
proof.
the consequent.
Come on, Wizzy, you know that's all they have.
I didn't say the word proof. I didn't say the word proof.
Right. And I didn't affirm
So
the
what-
consequent. You asked for evidence, right? And evidence is a prediction that comes true on one model and not another, not predicted by another.
That thing was changed, I guess.
No, you did
No,
affirm the
that's-
consequent. Basically, you used the Earth already being a globe to say why the weight would be more
Affirming the
at certain
consequence when you
latitudes.
say, I predict, therefore I prove not. But if you say, this is what should happen and it does, so it's good evidence that that is probably the case, that's not affirming the consequence. That's just
Right.
But that could also happen. That could also happen on a stationary Earth, though.
Why? What's the prediction on a stationary Earth?
Okay, so latitude is relative to the central point. That's how you get Cartesian coordinate systems, right? Longitude and latitude. It's relative to the central point. Well, if we have an electromagnetic field on the Earth, which we objectively do, and magnets have a central point, which they objectively do, then that means that you would have an effect on your weight relative to the central of that magnetic field. And I just explained to you, you can actually prove that coherency will alter weight. So actually, I'm the one
Show
that
me
has
your
real evidence.
experiment. Show me your experiment that tested this.
Okay, so it's very easy. Listen carefully. If we make a magnet and you take a piece of metal that's not a magnet and you take the magnet and you drop them over a piece of earth that has composition of any type of metal, the magnet will drop faster. If I introduce electrostatic charge to an object in via a Van de Graaff generator, it will actually levitate and its weight will change prior to its levitation. So I've proved that coherency affects weight. Do you need any more?
Yeah,
Well-
you've said that. You said. Yeah.
Oh, well, no, you haven't actually proved that the coherency affects the weight. You've only proved that you can create an attractive or repulsive force against it, because whatever weight that you think you removed from your weight, you're adding to the electrode.
There's no such thing as proof by your own omission.
I was just
Yours by omission.
I was just using his terms for his experiment and showing that there's something that he did not account for, so he can't prove it.
No, see, this is the problem,
Oh.
though. What you don't understand is that in your paradigm, even though it's not a force that can be thought of as a force, and it's the attractive force that causes weight in your paradigm. So if I manipulate the attraction or the alleged attraction, that would be in your own paradigm manipulating the weight. Secondly, I've already explained that you don't even properly define weight because your equation is W equals mg, but you do not account for numerous variables that we know to be in play because weight is coherency specific, location specific, vector specific, and medium specific. Vector specific, medium specific, location specific, coherency specific, none of which are in your equation.
What's it? Show me your like equation or prediction that will predict the weight of a 1 kilo mass object at 3 different latitudes, and your experiment should demonstrate that that actually comes true in reality.
Okay, yeah. So
I don't want to interrupt too much, but I just gotta say, Witsit says science words like an auctioneer.
Yes, it's just fucking garbage. Absolute rubbish.
So are you saying that things? Are you saying that things way? Are you saying that things way more? What's the actual observation of the claim here? Is it that things way more at the equator, or what's going on?
Less at the equator. Less at the equator.
Less at the equator. Shouldn't they weigh more though because of the bulge?
No.
Like in my pants.
No. When things are rotating, right?
That would probably affect it a tiny bit, but the rotational effect outdoes it.
Yeah, centrifugal force is away from the axis of rotation. So the bigger the radius, the more centrifugal force, and that will cause you to weigh less. Like it'll counteract gravity more.
I mean, shouldn't that mean that, like, let's say at the North Pole, things should be weighing like drastically more?
No, it weighs a predictable amount more.
Is it? Can you show me the? I'd really love to see. Is there like a paper on it?
Yeah, loads of papers. One of the simple ways to check it is gold. So gold or things that are very high value in very low weights. Obviously, you don't want to just get it scaled at its head to a local location because otherwise you go and buy all your gold at the equator and sell it near the poles and make a profit. So in those kind of fields, they do take it into effect. In fact, if you buy a sensitive enough scale, it just says it in the pamphlet when you open it. By the way, make sure you reset and check this scale at different latitudes because the weight will change.
Yeah, correct.
So Witsit scale you can buy for $50 confirms it.
Witsit claims he has evidence of this, whatever his fucking gibberish was before, right? So make your prediction of what an object will weigh at different latitudes with your fucking gibberish explanation.
Well, before he does that, you should really be providing him the equation and the method by which you would do it with gravity first.
Sure, I will post my little spreadsheet in the
Yeah,
chat.
but he just doesn't understand.
Yeah,
I already explained to him. Let me explain it again. So I've already explained to you that Einstein would explain that either the Earth rotating or the universe rotating relative to the Earth as the absolute frame of reference would give you the same effect. The only difference is that if the Earth was rotating, that the forces would be pseudo. They'd be fictitious, but they would be actual forces if the universe was rotating around a stationary Earth. Now, that's because Einstein actually understands your religion. He's the one that helped create the modern version of it. So if you understand that, that's not my problem, because it would be exactly the same predictions if the sky was moving relative to the Earth.
Is it Chepper? How do you say your name, Chepper?
Yeah, that's right.
Chepper, all right. So I posted my little, yeah, it probably is, obviously.
Is it? I mean, it's a table, but does it show the method by which it's calculated?
Oh, if I show the formulas in there, I guess. Yeah, it is pretty simple.
I think it's in the engineering toolbox one. I mean, I posted it very quickly without reading it, but usually there it gives you, yeah. It gives you fairly simple.
I'll post it.
Half AGT squared or something like that.
I'll post it with
well, you
the
understand
formula.
that the results are
formula
the
in there.
same. If the results are the same if the sky is moving relative to a stationary Earth, though.
Why?
That's what Einstein
One
said.
thing I did want to ask you about yours with it is, where's then the South Pole?
Where's the South Pole? You mean the place that you can't privately go to? Can you give me a 90-degree zenith angle measurement? I would need a 90-degree zenith angle
in your whole
measurement.
thing about there being a magnet and the field is
is, is causing this thing at the equator. That makes sense to me thus far, with this whole dielectric thing that you're talking about. My question is, where physically is then the south? Because all magnets have a south, correct?
Well, I think that we could have a quadrupole magnetic field. I don't actually know what the full magnetic field is, because I'm smart enough to know that when you can't go verify something, you can't know it.
But isn't that a crucial part? That's half of what you're talking about. Like, every magnet has a north and a south. I don't know of any quadrupole magnets. And it's not like what you were saying before, is unless you know something completely, you shouldn't speak on it. You're saying
Well, my answer actually, buddy, my answer's actually got many variables, right? So I explained to you that if the Earth is stationary, but the sky is rotating around it, then the system would be affected by the external motion inside of it. This is just objective. And even Einstein said this in a letter to Ernst Mach, where he apologized to him for all the ridicule he had received because people miss it. I haven't posted it. I'm on my phone. It's on my computer, which is actually in the shop. I did do a whole presentation on it. You could just look it up, I guess, or not. I don't care. Actually, to be honest, it's super hard to find. I had to find it in German, in a German professor's paper, and get it translated by numerous people. But either way, I mean, you can look it up. 1913, Einstein to Ernst Mach letter. And really, an honest person would be like, I wonder why it's so hard to find this. I wonder why it's been scrubbed from the internet effectively. But you won't do that. And in fact, in his letter, what he says is it would cause the pendulum to drag around equally the same as if the Earth were rotating. Uh-oh.
I mean, that's a lot of words. The question I asked was...
you just, I'm going to get out of here.
Oh, you gotta take your word for it, right?
No, you
no one
guys
can
just
see the letter, only you know it.
None of the things I heard, it sounded
I showed the letter to thousands of people alive, buddy.
letters between.
I showed the letter to thousands of people live. So when you say you have to take my word for it, no, I just said you can go look for it.
Okay, 1913, Einstein to Ernst Mach. I can't find it.
I know, and I'm telling you, it was very difficult to find it. And if you were an honest researcher, you would be like, why is it hard to find it? But you're not an honest researcher. And you think that if it doesn't pop right up as the first result on Google, it can't be true. I don't care. I don't care if that's what you want to think.
In this conversation right now, only thing we can do is take a word for it. That's what I mean.
Okay, so now let's do a hypothetical, just to show you guys have no intentions of being honest right now. Hypothetically, if what I'm saying is true and that letter does exist, what is your rebuttal?
Yeah, we're asking you to give it to us. We're asking you to give it to us. I'm saying I can't find it.
Here, we'll try it again.
Yeah.
Let's play an intellectually honest game, okay? Hypothetically, if the letter I'm alluding to does exist, what is your rebuttal?
It would be great. I can read it.
You would have to read it and try to understand why it's saying that, so we can have a rebuttal. We can't have a rebuttal to something we don't even know.
Yeah, you can't answer it.
I just did. I said great, so we can fucking read it. Holy shit, Witsit.
You're asking how is a rebuttal to something you don't know what it is?
Why do you have to read it to know what it says when he's telling you what it hypothetically says?
Yeah,
exactly.
It doesn't explain anything. That doesn't explain anything.
He fucked up the Hudson Bay gravity thing, so obviously he's fucked this up as well.
No, I didn't mess that up either. You just didn't understand what I was saying.
Okay, let's say hypothetically he didn't fuck it up. Hypothetically he's right in his explanation. Then what?
Could I?
We've got to read it. It's like saying if he's right about the Earth being flat, then what do we say? Then we say the Earth's flat. That's literally what you're asking.
Different explanations will have different implications. If we don't even know the explanation, we have no idea how to analyze the implications.
Let me explain it for you, okay?
All right.
So, if you had a hollow sphere, right? And then you had something inside the hollow sphere. If you spun the hollow sphere, whatever's inside of the hollow sphere would be affected by that movement as well. There would be a translation of motion to the interior portion of the system. This is what Einstein said. I happen to know most of you guys don't even understand this stuff. But the point is, I didn't make the letter up, bro. You can go find it or you can't.
No one's saying that. No one's saying that. We're not accusing you of making it up. We're just saying we don't have access. We can't. We can't judge something we don't have no information about.
get angry at people for not reading something you haven't showed us.
No,
Yeah.
no. What I
You're
said
telling us
was,
it's hard to
You're saying
find and we
I'm not.
can't find
No,
it.
see, listen carefully. I'm not angry.
If you
I'm not
rotate a
angry.
sphere, it would have two points of
Wow,
rotation.
eggshells, don't
Let's
do
be
that,
real.
man.
Let's be real. He wouldn't lie about something like this, because then he'd never be able to live it down. I guarantee you, he actually has this letter. It's probably on his computer or whatever.
We're not accusing him of lying.
Let's be
We're not
smart
accusing him
about
of
this.
lying, right? We want to read the paper. We want to read it.
Okay,
half
but
an hour ago we played this game about Hudson Bay measurements of gravity, and he was saying, what if I've got this thing that debunks the whole latitude versus weight thing? And we did this whole game for half an hour before he presented the link, and what we said before he presented it was, what happens if it's orders of magnitude out? Sure enough, he presented the orders of magnitude out. So it
okay,
means
so
that we end up
actually,
wasting his time playing this
see,
what if game rather than just
this
going
is
straight
why I've
into the
decided this. Yeah, this is why when I start my YouTube channel back, I won't be talking to you guys anymore, because you do stuff like that where you just blatantly misrepresent what actually happened, and then you chant and laugh and act. See, I said from the beginning that there is a correlation with weight and latitude, but that
Right.
the globe's predictions are drastically wrong because there are anomalies.
No,
It did.
Holy
no,
shit.
that's wrong.
He did.
Your little discrepancy is 2 orders of magnitude smaller than the deviation due to weight versus latitude.
All right, now, Ruif, listen carefully, okay, buddy? So the anomaly that I cited,
You said
dude,
drastically.
oh my God, the anomaly that I cited used a gravimeter, which uses an algorithmic correction for the globe Earth latitude assumption. Okay, so the difference is a difference that isn't predicted, which is my point. You keep talking about something else, thinking that it's refuting me, but it's not, because since the beginning I said there is a correlation between weight and latitude, although not entirely consistent. But the globe Earth's prediction is not the adequate answer, because their prediction has other predictions encompassed within that, and we see tons of discrepancies and anomalies with that gravitational prediction chart. Now
Okay,
you're
so
going to
you're-
skate
oh,
past
fuck,
everything
hurry
I
up.
just said.
No, I'm going
Go
to
ahead,
ask you,
skate past
does your gravimeter take into account the rotational centrifugal force, which you seem to say yes to that?
That's right. The gravimeter assumes
Holy
that.
fuck.
You think you're winning right now. It's because you're not very bright, bro. I don't know how else to say it.
Holy
I'm not
shit.
trying to insult you, but it's like you just don't understand
don't
what
you?
I'm saying. So
The,
anyway,
the centrifugal force is already taken into account, and then after it's taken into account, there's a very, very minor deviation from gravity in Hudson Bay. You're a fucking retard, Witsit, seriously.
okay, so I'm sorry you're still not understanding, but you know what's hilarious, Ruf, is you call me names about my insult my intellect, but I'm clearly smarter than you. So
Clearly.
the point here, yeah,
Like I
Ruf,
said.
listen carefully. Pull your crayons out and write it down this time. Maybe you'll get
Yeah.
it. This is about the 5th time. Okay, listen
Yeah,
carefully. The assumption of centrifugal force based on axial rotation. I know I'm talking too fast because you have slow processing speed, but you're going to interrupt me if I don't. Okay, so the centrifugal force that you presuppose based on axial rotation and that having to do with the weight distribution relative to the latitude is nothing more than the assumption that the Earth is spinning. I told you, and even cited your priest, Einstein, saying that in fact an axial rotation is not the only causal agent, because you could have an external motion inside of, let's say, a hollow sphere. You would have the same exact effect, and it would cause the same exact quote-unquote Coriolis effect. The only difference would be it wouldn't be fictitious, it would be absolute and actual. Do you have a rebuttal, or are you going to pretend I just didn't say anything, or are you going to say that didn't make sense, or you're just going to laugh and then chant? It's just
No, you're speaking to.
My rebuttal.
I've agreed with that multiple times. There could be, while it does appear to be the rotation of the Earth, to conclude that it is the rotation of the Earth would be a very inconsequent fallacy, and it's not, because it could be a variety of other things, including the dielectric field or the rotation of the planet. Absolutely, that could be the case. It just lacks any predictive power, which means we can't test it, which means it's unfalsifiable. Therefore, there's no way to go. Once
no, we
in a
do
way
have
that is
predictive
falsifiable,
power,
then
though.
we can test it, and we can test it using to make predictions. Then we can go somewhere.
You missed
but
out
you're
on
still not
rebutting the first bit
Yeah,
that
my
Richard
rebuttal.
said.
Yeah,
Riff?
my
Wait a
rebuttal
minute,
is
Ruff.
that. Oh, sorry.
I was just going to say, Richard keeps going on about the way he talks and everything, and he was going, "Oh, if I speak too slow or too fast," and I was saying, "Well, that time when he just said what he said, you're speaking too slow. I think you've got to speak a bit faster."
Yeah,
Richard.
just use fucking less words. Anyway, my rebuttal is that you just admitted that those gravimeter measurements already incorporated the centrifugal force, and then arrived at Hudson Bay being very slightly less than normal.
So he
You've
still
just
doesn't
fucked
get
your
it.
own argument.
He still doesn't get it, bro. Okay, let me say it again. Okay,
You said that
dude, listen.
you
Accounting
agree that
for the
there is a
centrifugal
correlation.
force. Listen carefully. The accounting for the centrifugal force does not give you any type of exclusivity because the sky rotating would give you the same effect.
Okay, you've got to bring that paper, right? I don't care how. This is the whole affirming the consequent thing, right? Huh? Yeah.
I care how. Like.
Oh,
it's
he's
like,
got to
to
produce
me,
the paper though.
Well, I mean, it doesn't even need to be a paper, but it needs to be something coherent
Or whatever.
that I can understand. Oh, sorry. Like, when I don't want to keep using the word coherent because you mean something different by that, but like comprehensible that I can understand. Because a lot of the time when you go to explain things with it, I'm like, okay, I understand all of those words, but the way you join them together doesn't make sense to me.
Okay, if you take a bucket of water, and spin it around your head, does the water inside the bucket get affected by the motion of the bucket?
Due to friction, yeah.
Spinning things will have effects like that. It'll create a pseudo force that holds the water in the bottom of the bucket. But what you sound like what you're talking about is, will the spinning of the bucket over my head affect my head? That's the bit that I don't understand.
No. See. Oh, so what it'll
the water in the bucket will be affected. It'll be lopsided.
Yeah. So the point is that whatever's inside of a system that is rotating will be affected by the external motion. Holy shit! And this is
The water will get affected by your head will get affected by the water if you stop the bucket halfway.
I want to understand this.
That's one.
Now you asked for a simple explanation.
So
I just gave you one of the most famous ones in the world.
The planets and the stars. Planets and the stars are rotating overhead, and they appear to be going in sort of straightish lines at the equator and tiny little circles near the poles. And that is affecting weights directly under them. So the closer you are to the poles, the more things weigh. How? What's the relationship between the thing above our head and the thing in my hand weighing a little bit? That sort of thing.
Okay, yeah. So we have a sidereal rotation relative to the Earth. So everything in the sky has a sidereal rotation relative to the Earth. So either the sky is moving relative to the Earth, or the Earth is moving. Now, the movement is consistent. It's a sidereal rotation. We have the same one forever. It happens day in and day out. So we have the same exact rotational beginning point. Okay, we have two options, and to use Einstein's word, it's a coordinate system preference. Either the Earth is the absolute frame of reference, and it's at rest, and the sky moves relative to it, or the sky is the absolute frame of reference, and the Earth is moving relative to it. They are not different, other than the intricacies. The coordinate system preference is the only difference. They attain the same outcome. Do you understand and agree?
Yes.
Thank you.
Though
So
I
that's
think
what
as a
Einstein
third
was
option,
talking about.
it could be that both
percentage.
That was
That was
percentage.
That was percentage.
I don't think I would agree with that.
Why wouldn't you
both
agree
are
with
moving?
that?
Well, I would agree that it works as a coordinate system. Not the physics would be the same.
Okay, the physics aren't the same, but the outcome is the same.
Yeah, the relative
How
motion
is
is going to be
if
the
the
same
physics
regardless.
different? Wouldn't the outcome be different?
Okay, because the physics is different because in one scenario it's the Earth
I
moving.
feel like you say
And
lots of words and then skate away from the question I asked.
oh my
He does
god,
that.
dude, I'm gonna have to
He
go.
does say
I'm
a
gonna
lot
have
of
to go.
words. He does
Okay, just so
indeed
you
say
guys
lots of
know.
words.
Well, the question
Just
no,
what's up?
answer the question though before you go with it. Stationary plane, rotating stars and the planets, whatever they are, lights in the sky, whatever the fuck they are rotating over our head, and I'm holding a 50-gram weight in my hand, and it weighs differently depending on where I am. You've gone on and talked about this coordinate system and stuff, but I feel like you do this a lot. You use a lot of words to skate away from just answering simply a question. It must be a relationship, right? When the sun goes mostly around the equator, roughly speaking, and the thing weighs less there. Why? What is the mechanism?
Okay,
What's the
so
prediction?
holy shit, you
Super
guys will
simple
never
question.
understand it. You guys will never understand it, and that's why whenever I go into my house and my computer's actually in the shop, but I'll go to the YouTube and I'll screenshot my presentation on Globebusters and I'll drop the letter in here and you guys can just cry about it, but I'll explain it one last time before I leave, okay? So we have celestial objects that move relative to the Earth and our position on the Earth. and it's a consistent sidereal rotation. If it is an external motion, it'll translate to the internal aspects of the system, just like Einstein said. I gave you the Pell experiment because even a fourth grader could understand it. And Einstein's letter, he literally alludes. Okay, well, you think so you think Einstein's stupid. So you think Einstein's stupid. But here, can I have to? I'm going to go to sleep now because.
Yeah,
Hey,
go to
can I
sleep,
just?
dude.
Can
You
I
sound
please just
exhausted.
finish?
Hold on.
Can I just finish the point? Can I just finish the point, buddy?
Okay.
Okay, so in Einstein's letter, he's writing to Ernst Mach, and he's like, "My sincerest apologies for any ridicule you've received over the years, blah blah blah, because I have come to the realization that, in fact, you were correct, based on the Machian principle, etc. That actually the external motion of the sky would cause the same quote unquote Coriolis effect. The only difference would be that it would be an actual effect, not a pseudo effect, and that the forces would be actual and not fictitious, but they would be synonymous if the Earth was stationary but things were moving around it. And in fact, that would cause the pendulum to drag." And he alludes to Newton's Pell experiment, the bucket experiment, as an example of how it ties in. I've now said all those things. You guys have ridiculed me and called me stupid, but your hero Einstein said all of them. And I'm sure in about 2 minutes it will be in the voice text, and you guys can pretend it doesn't say what it says. And I'll talk to you later.
All right, peace then.
What is voice text?
Does Wizard come with
chat.
subtitles or?
Yo,
I can't-
Einstein is a dickhead, bro.
I'm lost.
Yeah.
Oh, he just talks fucking rubbish. Absolute rubbish.
What was rubbish about that?
Yeah, I don't
Man,
understand.
if you look into this stuff, you gotta realize Einstein was a fucking
What's rubbish
asshole.
about that is it's like the same as you said, what makes a car go? And I said, well, fuel is
No, you explain how a cake. You explain how a cake's
once I
baked.
saw a letter from the head of Shell.
What?
Well,
Listen,
riding,
it's simple. It's simple. You have relative
There's a
motion.
mechanism.
You have relative motion. Whether it's the stars moving and the Earth stationary, or the Earth moving and the stars stationary, the relative motion is the same. Okay. The idea is now that the way you should distinguish between it is if the Earth is moving, there's going to be some, like, as a result of its rotation, it's going to be carrying some of the atmosphere with it, like kind of like a blender or like the pail.
There'll be centrifugal force.
There's going to be there's going to be not just centrifugal force, but as a result of the friction of the Earth, like its effect on the atmosphere, there's going to be some sort of effect to that end, which there isn't, and that's why he's bringing up Einstein in this letter or whatever, because of, like, I guess he was conceding to, I don't know who the dude that he said, I forgot the name, but I guess he was conceding that this isn't observable.
I thought we were talking about
It doesn't sound
differential
like-
gravity.
Yeah.
On the Earth.
Weight with latitude.
That doesn't
was
sound like the point
Yeah,
he was making.
Exactly.
What percentage said doesn't seem to be what Wizard was saying.
A good explanation for a different thing.
Am I? That's not how I understood it. Like, observably, you can't tell the difference between these two things.
There's a 40-minute conversation in a word.
Actually has a lot of lag for me.
But that's fine. But
Yeah.
if we say
Yeah, your mic is kind of hard to make out. But the
No,
other
I
thing
think
I was
he has
going to
a very
say,
big delay.
Riding what you're talking about before, it's like a dartboard, in terms of, like, you have the center and then you have different concentric rings coming out from that center, which is essentially what the whole sky is doing as well. And once you have those rings, you can have it's a different part of the field. It's like a different spectrum of the field. And then, of course, the
Right.
equator
But
is
then-
like the midpoint. There's like it's like
do you think, Gio, you can put that into a prediction to say, if I'm at this latitude, I'll get this weight? Do you think Wizard could do that?
like map out the whole field basically, and then
I can answer that one.
That would be cool.
Yeah, I can answer it as well. But I mean, the whole point of what evidence is like, I have a hypothesis and I have a prediction. My prediction came true, and I don't know of any other model that can make the same prediction. Therefore, my result is evidence for my model. All right? Whitsitt says he can explain it, but there's no chance he'll be able to put it into a prediction. And I guarantee you, this paper or this letter that he's going to bring up will have nothing to do with weight change with latitude, and won't be able to
and
explain
it
it.
needs a mechanism.
To be evidence too, it needs the mechanism. Like
Yeah.
percentage perfectly gave a mechanism which is friction. And you just go bang, there's friction, and immediately you go, okay, now I can dig into it. Now I can make predictions. Now we can have a discussion. But if you just go, oh, but it's this and it's that, and it's, oh, did you know so and so wrote a letter to that person who said, I'm sorry, I'm so wrong. It's like we're not getting a mechanism through that. But
Yeah.
friction's
Oh
the
yeah,
mechanism. Magnetism is
that's
the mechanism.
interesting as well. Everyone here, hopefully, everyone agrees here that centrifugal force is a necessary consequence of rotation. Whereas Witzit's shit, no one knows what the fuck he's talking about. Like, yeah, the mechanism basically that Harry's getting at.
You're not really giving any like actual critique of anything Witsit said. You're just throwing ad homs. It's pretty weak.
Because he speaks fucking gibberish.
I think he's a wonderful person. I'm not ad homing him at all. I'm describing exactly what I asked repeatedly for a mechanism for a physical effect, which means it's probably got to be a physical mechanism. He didn't give it. He repeated ad nauseum. He repeated a thing about a letter from Einstein, which isn't a mechanism for why the stars affect weight.
I thought he gave two. I thought he gave the pale one and then one before that.
The pale one, again, lacks a mechanism. What he's saying is if you spin a bucket, there will be effect in the bucket. But what he's saying is if there's stars spinning but the Earth's stationary, we should see an effect on the stationary, which is the opposite of a bucket spinning affecting the bucket, because the bucket's spinning in the bucket one, right?
Hang on, he's posted the letter.
False analogy.
He's posted the letter. Let's have a read. It's in fucking... hang on.
People are starting to stare at me, so I've had to move further away from humans.
Let me have a read.
I remember one time I was in an airport and I was like in like this heated discussion. I was like over sitting in like my own little area that and I was like near the windows and stuff. And I was like, I had it on speakerphone and I was just like at high volume. It was funny. Everybody heard the discussion. I mean, not really.
Oh yeah, I do that all day long. I'd be shouting in absolute public, like, by the way, the world is flat.
Well, actually, like in this scenario, like I was by this windowed section. It was almost like a little bit of an auditorium, sort of. So it was like just if I spoke a little louder, like the sound kind of reflected, and it wasn't like excessively loud to really bother people, but it was funny just that it was that heated. It had to go down that way. I mean, not really heated, but just lots of like spice.
Oh, nice one.
Lots of fire.
Nice one, carnivore.
I'll be like at the grocery store, like the lady will be ringing up my items, and I'll just be like, "Yeah, why is water always level?" Telling the grocery store.
But Ruhif, to what you were saying,
the effect that he's got in the thing he's posted here. Sorry, Gio, then I'll pass you. Is basically the effect of gravitation on an object below it, which I would agree with, right? The moon passes overhead and it causes an effect on the tide, and that's kind of what he's talking about with the spinning pail. But that just means, and he's got the effect in there. He's got the word gravitation is the mechanism of the effect we're seeing, not the effect, sorry, the mechanism. All you need to say, gravitation. He just, I think, didn't want to say that, or there was some other reason.
Sorry, Witzit just wrote, "Make sure you run away." I'm like, I'm the one that's still in the fucking voice chat, jackass. What a joke. He's a joke of a human.
What are you talking about, man?
He said, I ran away. I'm the one that's still here.
I don't know what's going on between you two, but I get some small penis energy.
Okay.
Both you guys are like trying to one up each other, and it's kind of low.
Well,
we have history. He's a fucking jackass. So
it's kind of his style, right? Like every time he's arguing against someone, he's also making provocations in between the arguments.
I think it depends
he
on the person he's talking
pretends that he
to.
doesn't.
I'll speak
To be fair, I
slowly
think
because
it's
I know you guys are slow.
Yeah, like
Kind of stuff.
No, but it depends on. He's not normally like that, depending on the person.
Because he does.
You know, Rufus
Like I said,
did it,
we
so
have
he
history.
reacted, and that's what I said. It's both of them were kind of guilty of that sort of behavior.
Yeah, but I mean, he did that to me. I never did that to him. Like, I think the first time I spoke to him, I just entered him as an argument, and then he told me I didn't have a girlfriend or something. I was like, what the heck?
Yeah, like he said something. He
I don't
said,
know. I wasn't there.
You gotta get
That's
laid
pretty
tonight.
funny.
Something. You need to get laid tonight. And I said, yeah, your mum will sort me out.
Yeah. I don't mind them too much. Like when they get to like the I'm gonna bust your teeth in, it just gets a little bit.
Yeah, that was pretty poor. That was
room poor, but I don't mind the odd bit of stuff. I
yeah.
still don't think I was
Amuses
doing
me.
ad homs though, Gio. I think I was directly responding to his argument and his style of discussion.
Yeah, there's a very big difference between an ad hom and an insult. I rarely use ad homs, but occasionally I'll
Is a
insult
fallacy
someone.
which is reaching a conclusion based on an insult, whereas just insulting somebody is not an add-on.
Yeah, it's just
like
an
the difference
insult.
between saying you're a dickhead and you're wrong because you're a dickhead.
No, an
Yeah,
ad
exactly.
hom in a sense is ignoring the actual argument and just throwing a personal attack. So exactly what you're doing is just that, meaning that like you'll be going back and forth. He'll, one guy will say something, the other guy will say something, and then Ruhuf will be like, "Well, yeah, that's just because you're an idiot."
But that is an ad hom.
But that's like because
I
you're
don't
going
deny that
because you're going back and forth in some level of an argument. You've just resulted in this guy is an insult name. Meaning you didn't actually respond with any content. Oh no, I think what you're saying is something different, or you didn't actually respond with any information. You just threw in an insult, and then you're trying to get the other person to do that. It's a complete derail tactic fallacy of the actual discussion at hand.
Right, but the guy before, what was his name? The guy that said, if the path of light reaches your eye, can you see the object? And he said no. Like, where else do you go from that but to say you're an idiot? Like, honestly.
Now you've gone from saying I don't ad hom people.
So then, I mean, if you're in a position, if you're in a,
It's not an ad hom, that's an insult.
We're saying he doesn't do it, and then explaining exactly how he does it.
I remember the first mechanism riding. The first mechanism, well, the one that I heard at least, was the hollow ball. The hollow ball with like water in it or whatever, or with air in it or whatever it is, and it's spun, and then because of I imagine because of the gravitational pull, you could have the analogy of gravitational pull of a ball. You would expect that the thing that's closer to the ball would have more of a grip on the outside air.
Nailed it. But you've done it again. You've done exactly what I was asking for, which it didn't do in the discussion. You've done it twice, which is there could be water in it or there could be gravitation. You've just described two possible different mechanisms.
No, but but that analogy that he brought up, like with sound, I guess like maybe if you needed like the dots connected, he implied the rest. That the air would be moving with the ball, just
water.
like it doesn't. Well, it could be air or water inside the ball. It doesn't really matter.
Right. You said water or air. Fine. He said hollow. So when he said
a hollow ball.
I wanted to invest. Yeah, I wanted to invest.
It's not a perfect vacuum inside of it.
Okay, so then
he said hollow just to show that. Yeah. Go ahead.
But that's fine. Like if there's air inside, and he says there's air inside, and I go, okay, it's friction. Fine. But he's deliberately not saying that because that's not what he thinks it is. But I think he thinks it is some sort of electromagnetic effect. I don't think he thinks it's friction.
No, that was just the analogy that with the movement of one thing, then like you could have a force that's causing a disturbance in the medium, right? So gravitation with an Earth would be the same thing. As the Earth's rotating, the gravitation is stronger towards the center of the Earth, right? So you would expect that there'd be a variance in the atmosphere. And the point is that we don't actually observe this thing, so
I didn't get it.
I don't know what to tell you, man.
So yeah, but again, it's simple. You're describing mechanisms here.
That's what I understood from him, but maybe like he needed to elucidate it, step by step.
Just say it.
Sometimes things need to be explicit as opposed to implicit. Who knows?
Well, I mean, if you say friction, it's one word. If you continually spend 5 minutes describing a letter between people, it's not useful. It's not conducive to a good discussion.
He felt I'm not sure if I understood that, but it seemed like he was saying you can flip the you can make the rotating frame of reference inertial one, and everything else is rotating, and we get the same effects. There would be actual forces. I don't feel how you get to that. No. Like let's say you put a camera looking to, you know that when you rotate an egg, it stands up, right? If you like rotate an egg pretty quickly, it stands up. If you do that with the camera pointing at it, if you flip that and just rotate the camera around the egg, it's not gonna rise up. It's not gonna stand up just because you're rotating a camera around it. Like just I don't know. Maybe I misunderstood him. But you can't just flip the
So
frames of reference and get the same result.
yeah, I'm curious though, like, so we can talk to people who are in the room. Percentage, do you hold to his thing that there is spherical star luminaries, whatever you call them, around Earth, that is spherical?
No, you can't.
Who are you asking?
Percentage, but yeah, more percentage.
Sorry, go ahead.
Agreeing on. Do you think there is spherical, like heavens or stars or luminaries around us?
Do you think there's a celestial sphere?
Yeah, I do.
Yeah, yes.
Okay, that's a problem for flat Earth.
Yeah, it's kind of what I wanted to dig into, but we can discuss it. So if it's rotating, would you agree that any object, regardless of shape, any 3D object, regardless of shape, when it's rotated, has an axis of rotation, a single line along which it is rotating?
If it's rotating, does any object have an axis of rotation?
Yeah, if it's rotating consistently, so it's not.
You mean the
tumbling
celestial
around
objects or objects on Earth?
No,
Yeah.
any physical object. It could be a beanbag. It could let's say it's a rigid object, so it's not changing shape. But like, it could be a chair, it could be a table, or it could be a sphere. Any object that rotates, would you agree it has an axis of rotation?
Sure. Yeah.
Would you say that that axis typically would mean that there is two ends to it, two extreme points at which that is circling around?
Yeah.
Where is the southern one in the celestial?
Well, it'd be the opposite to the northern one, or if it's east or west, depending on the axis of rotation.
Would you agree that the Southern Cross points at it?
As far as I know, I've never been south, but like there are time lapses that I hold, reliable. So I don't deny that there's a south celestial pole.
So where would you put that on a flat Earth?
Where would I put it on a flat Earth? That's the question. I don't know whether or not, because there's different models, and that's I always say that the south celestial pole is one of the strongest proofs for a globe, but there are different theories. One actually Geo showed me was the 5 pole theory, basically, where you had 4 southern poles with a central north pole. So I don't know exactly how it works.
Yeah, but
I've never went down and mapped it
If
out.
we then go, do you know any object that rotates around 5 axes? Do you know any way that something could rotate around 5 axes?
No, I wouldn't.
Yeah,
say-
quadrupole magnets.
There's a different problem with that.
Quadrupole magnets create that structure in the field.
I'm not
You
familiar with
know,
those.
Orion, the Orion constellation. Half of it is in the northern hemisphere. It's above the equator, and the other half is below the equator, right? And that constellation can be seen by people all the time, as long as the sun is not as long as the position of the sun is not too close to the constellation. Every country can, not every country, but there's always someone that can see the constellation at the same time. So if the southern stars have copies of it, and the northern don't, how exactly that works for a constellation that is both in the northern and the south?
It's the southern ones. You're talking about the middle range. The middle are the same.
Right, but he's saying what he's suggesting is for it to curl away, for the like, I get to see Orion and I see the Southern Cross. Southern Cross is a tight little circle in the sky, while Orion is a big loop across. And how does it not break in half in order for it to circle me south of Sydney, and it to circle somebody south of Perth, and it to circle somebody south of Christchurch, and South America and South Africa?
Yeah, in between those southern rotations in the sky, you'd get like some stars going up, some stars going down in the between of them, because if they're rotating in the same, if they're all clockwise and they're next to each other, then one's going down, the other's going up. Like you don't ever see stars doing that. Right?
Yeah. Regardless of my conception of the world, Witt said, he was clear when he was saying that he agrees that there is a change, like a difference in weight or in gravitational pull with latitude, right? He said something about like gravimeters not being perfectly reliable because of some sort of thing. But the point is, there is change of gravity or whatever, gravitational pull with latitude, and because of that, he was saying that you should see this effect. You should see that as you go towards the equator or whatever, you're gonna have a stronger pull, and that should be indicative, and would give you the answer between what's the Earth moving relative to the sky versus the sky moving relative to the Earth. And since we don't see that that gives you your answer.
His explanation
We
was
do
all
see that,
no prediction.
and the problem is the same for what I'm asking you about your conception of the sky, which is it's fine if it gets stronger towards the north, which is the center, but it doesn't explain why it gets weaker or whatever you call it. But it doesn't explain why the same effect happens going south. Because magnets, if you snap them in half, very quickly conform and find a new north and south. And the new north and south are remarkably close to equal and opposite. Whereas if the north is north and the south, if the north is a point and the south is the extremity, that is the opposite to how every other magnet we've ever seen operates. They don't usually go north, tiny little point, south, giant ring. They would usually, on something circular, be a flat thing where the whole top of that flat is north and the whole bottom of that flat is south. The underworld would be the south.
And electromagnetism doesn't affect all materials in the same way. But when you're weighing them,
materials.
Go on.
No. Sorry. Shut up.
Yeah, when you're weighing them, like it doesn't matter what they're made of. If you weigh a kilogram of wood and you go to a different latitude, the amount that is going to get lighter, if it's a kilogram of wood or a kilogram of lead, it's going to be the same thing. It's just proportional to the weight. It doesn't matter what's made of. And if it was an effect of electromagnetism, that I don't see how that could be the case.
Well, the way I think it's functioning is similar to the way the sun has a spectrum. You have like ultraviolet, visible light, et cetera. There's the whole spectrum, and the infrared fields, X-ray, et cetera. In the same way, there's an electrostatic, electromagnetic spectrum of the Earth's field, and that Earth field is its own frequency, as it were. It's like its own layer. So it's not the exact same as just charging something with what you might think of as electricity or a magnetic charge in that way. It's could referred to as perhaps like a geostatic field, an earth static field, but it would be a field that the Earth itself functions within, and physical matter would then be correlated to it. So if it had a positive or negative charge, which means it would either go down to the ground or up to the sky, it doesn't mean it's necessarily the exact same type of charge as, for example, like the Van de Graaff generator test, where that's basically pulling static directly from the environment. Well, obviously, if you just add static to a person, it's just going to shock them. It might not necessarily completely raise them. So there's something happening with the Van de Graaff generator with the two plates and the fact that that thing is very light to be able to do that. So there's an overlap, I would say, with the actual field that causes, what you might call gravity or buoyancy, that can overlap with the standard static field, like in a Van de Graaff generator. However, just because it overlaps there doesn't mean that actually isolates that that's what it is. So, yeah. So I'm pausing. I know I said a lot there.
I'm not sure if I understand that.
For example, if the buoyancy or gravity of something is connected to a charge, if that's a positive or negative charge to what degree it is, that could be the actual charge that it has with the geostatic field, like the actual geostatic charge to that spectrum of the field. So something that's heavier or lighter has a charge related to that field. So it's not the same charge as if you just plugged a voltage meter into it and pulled that charge. It's not that, even though there's some overlap there, it's not the exact same spectrum.
What do you say, geostatic field? I don't know what that is.
Yeah, I was just calling it that. Yeah. just geo meaning earth, static meaning static. So geostatic electric field. But really geomagnetic and geostatic electric field.
Says Geo himself.
Well, yeah, I mean the fact that my name's Geo on here is not really related to that, but
Yeah, I'm just kidding.
well, it came from geocentric, the word that the name that I had, and then ended up being Geo. But it was the name was Geocentric Love originally back in the early days, like on YouTube and whatnot. And then when I came to Discord, at some point I changed it to Geo Love, and then at some point it just ended up being Geo with the emoji.
Oh, the heart is what's left of love.
Yeah, essentially, because it was Geo Love and then it was Geo Heart.
Get it.
But anyways, no, I mean, to refer to something like if you have infrared, for example, that's its own spectrum. Certain things can interact with infrared, but infrared is still its own spectrum on its own field. So what I'm suggesting is that if we use the term geostatic, the Earth static field, that is its own spectrum. And so things that have weight or buoyancy have a charge, but the charge is based on that spectrum. Now, the real reason this is all being hidden from us is because the free energy technologies. So they've hijacked that from people and are hiding that from us. So they've had to delete the idea of the static field of the Earth, the ether, all of that, in order to replace it with this completely fake outer space story to hide the free energy, which of course is linked to power. So I think it's being hidden on multiple levels, because if you start to unlock this, like the actual geostatic field, well, now you can alter physics. You can do things like UFOs, like the gravity or the kind of physics that UFOs are doing. You can create electricity free out of the environment. You can create matter out of the environment. So it's a huge thing to have. And so they would want to hide this field from us and not giving us the tools to utilize it the way that they've, from what they've actually hijacked of that technology.
Yeah, I don't have a response for that.
I mean, it's actually kind of similar because in gravity, they claim.
Yo, can I get a mic check?
The factors that are involved in gravity are also involved in static fields. So they're kind of renaming it and then trying to use it in their paradigm.
Which factors, Gio?
Is that Nate?
Yeah. Can
Yo,
you hear
what's
me?
up? What's up, man? Yeah. Your mic's a little echoey, but yeah, I think I can. Yeah. What's up?
My bad. I'm driving. Yeah. So which factors in gravity have they used to replace static electricity?
The bending and warping of space-time to start with.
What's that got to do with static electricity?
Because that's how they correlate buoyancy and density.
So buoyancy and density is also the bending and warping of space-time?
That's part of the current model, yeah. I mean, because it used to be Newtonian, but they've really replaced pretty much all of it with the Einsteinian idea. Yeah.
Yeah, but even. Sorry.
Oh, go ahead.
Yeah, even with like Newtonian gravity, like what did that have to do with static electricity and the bending and warping of space-time?
Well, the acceleration that they claim is occurring is an actual static pull. But but instead of that being what they're utilizing, they replace that with the bending and warping of space-time, but they use similar vector math. So that's why some of what you guys say actually is true, or not you, but just, the mainstream about gravity. There's parts of that are absolutely true. Like the certain mathematics and certain components of the vector, like what I would say of the geostatic field. So of the actual field of the Earth itself, the ether, if you will, etc. There are certain mathematical there's certain mathematical structures that are built into that, which is based on like sacred geometry and the fractal nature of consciousness and reality, etc. So it's all connected to like the sacred geometrical. But anyways, some of those vector mathematics that they use are accurate and are true with what we experience when you drop something, for example. but they're using that part of it that's true to then trick people by linking it with stuff that is, basically just based in fabrication and pseudoscience.
How come no one's able to figure this out? Like, no one's able to see this trickery. Like, what's going on there? Why isn't the trickery so obvious? Like, how were you able
Gio's got the inside scoop.
Well, I mean, that's a bigger question. Yeah, it's a good question.
How are you figuring this out, Gio, when no one else did?
Well, I certainly wouldn't say no one else at all. And I'm not really claiming anything of myself right now either. But I think when demonic forces infiltrate human consciousness, they can wreak havoc on people's willingness to accept concepts that were fabricated. It's like a demonic trick, and it can be very deceptive, and it can look very alluring and seem solid on the surface, but it's just how it functions. And there's more to it, why this many people are, sort of bought into some of this mainstream. There's a lot to it. Sorry, I'm trying to not talk for like 10 minutes. I don't want to just like hog the mic, because there's a lot to, why people are going along with this and all of that. But I mean, well, a lot of it they can't really validate, like even the people that are in like the astrophysics fields and stuff, they're like reading books, regurgitating information, and then, like I said, some of the tests they're doing are accurate, but it's applied to a false model. So they just don't know the whole worldview is false that they're applying it to. So they're doing real world stuff with real world intellect, but it's being applied to something that doesn't exist. And it's all done through a hierarchical system of science with money and grants and all the corruption and all the rest of the administrative shit that goes on within these, kind of major institutions that are kind of behind, all of this.
So why would they make up some?
I think you cut out, Nate, or I cut out. I don't know.
Yeah, no, it dropped out from me.
Okay.
Am I cutting out?
Yeah, but you just came back now. Oh, maybe not.
Yeah, no, it still sounds non-existent and/or sketch.
Yeah,
Show in the
we can't hear you, Nate, if you're trying. Oh, he dropped out. I mean, they need the pseudo-physical model to support the outer space story and to convince people of that. And they need some of the true vector mathematics and actual truth in there to convince people that are intellectual people that the rest of it is also true.
Yep. We need all that model stuff that reflects reality and makes predictions that match reality. That's what we need.
Yeah, you need to, even if it's fake, you need to be able to make it so convincing that the layperson can make a prediction, buy $50 set of scales, and fly to different latitudes to test it, and it hold true. Because otherwise, simple predictions, lay people.
Am I coming through now?
Yeah, he's still pretty rough.
No, I think it's better though. I mean, we heard you say that.
Yeah.
It's like.
Testing 1, 2, 3.
Yeah. You can hear that you're saying testing 1, 2, 3.
I'll try it later. I'll try it a bit later.
All right.
You want to hear what you got to say?
Yeah. Bit calmer in here with that Witsit, isn't it?
Be quiet,
Also,
you're the last one to talk.
Oh dear, we do have history. We do. Back to Brandon's server, actually. Holy shit.
With who?
What?
Oh, back in. Yeah, I know.
Oh,
That's where we used to fire up. Yeah.
Yeah, but who are you talking about? Talking with who?
Me and Witsit.
Oh. Witsit was on Brandon's? I don't think he was on. He
Pretty
was
sure.
on. I don't believe so.
I reckon. All right.
I mean, I guess.
Long time ago.
Okay. Maybe on
Anyway,
Jim.
doesn't matter. Oh, maybe I'm wrong. Doesn't matter.
I've had a few reasonable discussions with them. That's why I sort of get confused when he suddenly starts being like, "You guys are too stupid to understand this." I'm like, where the fuck's that coming from? I'm not calling you stupid. What's going on right now?
Oh man, but the amount of dribble that comes out.
Yeah, see those kind of comments, just those disparaging kind of just taking a shit on people comments. It just creates such a bunk vibe, you know, like.
Yeah.
And once you start doing that, other people then start responding, and it's just that constant like. It's like the difference between actually hanging out with people and like having fun, and even like kind of sparring, or like it could get heated. Difference between that and like actually just like just trying to put each other down, you know? Like, are you drinking a beer and having a good time, or are you just like actually trying to just
Yeah. It's like me versus Bandy is very different to me versus Witsit.
Sociopathically insult someone and just looping circles.
Yeah, but like there's obviously a different vibe. Like I said, me and Bandy have a we can like argue stuff, but there's a very different vibe compared to like me and Witsit. Obviously.
Right. Yeah. There's an alchemical activation.
Yep,
of conscious
like
and unconscious and unconscious sources through eons of time of past and future lifetimes of all of your interactions with whomever it is you're interacting with.
Indeed.
Actually, I married in a past life.
Like this life, or what do you mean?
No, Witsit and you used to be married in a past life.
Oh, right. Okay. I was going to ask. Even the translation that Witsit posted, like a rotating shell. I don't quite understand how that makes the forces that it's meant to. Like I can understand if there's a sphere in the middle. Does anyone have any ideas of what he was talking about?
But the top one seems to hint at the mechanism, which is gravitation. That there is due to the mass, there is an attractive force.
Yeah, but specifically a rotating shell.
Around what?
Around the Earth. I think that's what he's saying.
Yeah, dude. I mean, the thing is with like, okay, just with the, I don't know if you're still on this because I was kind of doing something else for a second, but the weights at the latitude thing. I mean, the thing about that is that if you do that, and let's just say for the moment that you do the weights and you do it with multiple different scales at multiple different locations with, you know, multiple ways of doing it. And let's just say that you verify it, you map out the whole thing, you map the anomalies, etc. So now you're looking at whatever that is, whatever that looks like, whether it's almost like a tide map or there's different level, you know, areas and different or different tides in different areas and so on. So let's just say you have that all mapped out and whatever it looks like, it looks like.
Yep, we already have it.
Sure. So I'm just saying if this is right, if this is in front of you, and to then claim that, oh my God, dude, what you're actually claiming, the amount of centrifugal force that actually would be present on the globe would be massive. But you claim that gravity is sticking things to the ball for the most part, but there's this little bit of difference. There's a little bit of difference in to make the weight just a little bit, almost like the Coriolis effect, just a little bit off, right? And that's what you're claiming is causing it. Okay, let's go with that. Let's just say, oh my God, this is it. The thing is, I would not say, from my viewpoint, you may think differently, it's fine, but just making that theory doesn't prove that that's what it is. On the vice versa, if I said, well, it's part of the electric field and this and that, without isolation, neither of us have the isolation for actually what's causing that. I would actually say that I do because there's actually ways to do it, but that's a separate thing in terms of the field because you're actually in the field, so you can measure it and correlate it, and clearly the field is a factor. Whereas what you're claiming it is the Earth rotation, we can't test that. It's untestable, unfalsifiable. It's just an idea. So neither of us in that just going on a basic level, especially you, have not isolated that's what it is. It's just a theory of what it could be. Now let's go with the theory. Okay, maybe he's right. Okay, well then you'd have to support it with other things like curvature, et cetera, and we don't have any of that. So then it's kind of loops back to that.
Well, but beforehand, we can already tell what's the difference going to be. I think that's relevant. Like one
Sorry,
thing
I
is
was
to
going to
map.
respond. You go.
Wait, yeah, one thing is to map everything and then try to explain it. Like, how can I explain that? The other thing is like, oh, I already have something that could produce that. So let me see what the data should look like given this explanation. And then if with the data you find it matches that, I think that's good evidence that you
It's not.
already get it right.
No, it is.
If you come
The
up,
difference.
if you just come up with a model, and I mean, first of all, Witsit was pointing out all the anomalies, so you don't have some kind of perfect centrifugal thing going on. So even you're gonna now have to admit, well, it's not really perfect. There's all these huge areas where, and that's why it's a good point to bring that up. If it really was a sphere with your even gravity and your oblate and all this stuff, whatever Ruhif is trying to describe, you would think it would be consistent and it would be regular. If it's based on the medium, you would consider it to be, you would expect it that it could have variations because there's, and especially if it's based on the electric field, you would actually have a very real correlation to how close you are to the North Pole, something that's actually real in reality, not just an outer space or a sphere kind of concept, but the fact that you're getting closer to the North Pole or further from the North Pole is a direct correlation to the latitudes. So that's something you have in reality that you can actually correlate. Yeah.
That would absolutely be a really effective debunk of somebody saying that. But the problem is nobody says that. Nobody says that latitude perfectly down to whatever degree you want to go to is to a millionth percentage points is going to get it right.
Well, that's pretty much how it's sold. I mean, Fight the Flat Earth does his little video where he shows it. Look at this. We got it down to the degree. Bada boom, bada bing. I mean, you know, the guys on the globe side, I'm not saying you if you don't think that. They use that all the time.
I don't think that. Let me finish. If we're saying this is accurate in all places, but as we know, all measurements have error bars, and it's within those error bars, then showing a deviation that is within those error bars isn't meaningful of anything. It's like saying I know how fast my car's going, but if you don't know down to the sort of hundredth of a kilometer per hour, then you don't really know how fast your car's going, and your speedometer doesn't really work. It's silly, right? Because, like, let's say we demanded the same degree of specificity from your model and said, if you can't show us that exactly down to a hundredth of a percentile, you've got nothing. Like, it doesn't, as I pointed out about the rotation thing, that it sounds like percentage kind of conceded and then.
Well, I don't think anyone said anything about that level of percentile. I don't think anyone was saying anything about like some kind of exactitude. I mean, the way it's usually described is that you guys get it within the, you know, the error margin, and if you do it at these different latitudes, it's consistent. And in general, it's sold as this idea that it's quite accurate at all the latitudes. And so if it's not, then now you have a problem. You either have something more you need to explain. You need to say, oh, well, on this globe Earth, there's this and that, and there's something else that's happening over here, and so you'd have to start to at least answer why that is even occurring, because otherwise you don't have a very direct physical correlation at all, and you don't even have a working predictive model. You have a hacked up, ad hoc, partially working one that you're just asserting as being complete.
No, I think it's quite accurate. It's accurate within our bounds.
Exactly. Yeah. It's going from this thing of going, well, there's this kind of wibbliness that's well within the bounds of the prediction, to then go, oh, but there's wibbliness. It's like, well, we know that there is no 100% accurate speedometer in a car, but if you're like GPS and your speedo read the same thing, you go, oh, the GPS is roughly accurate. If it's not getting it to within 100th of a kilometer an hour, we don't say it's wrong. But it seems like it's going from this thing of going, we've got a total black spot in the whole South Pole. It seems like almost every flat earther admits that. Giant gaping half of the sky / Earth has a big problem, but we still hold to it. But unless you can explain this weird 2 orders of magnitude weaker than the centrifugal effects of the rotation of Earth anomaly over Hudson Bay, then the whole model's out the window. Do you not see there's like a very big difference in onus you're putting on the 2 different models there?
Yeah, the
Can I interrupt
geoid.
real quick?
Oh, yeah, okay. Then me.
Oh, it's sort of off topic, but there are 2 satellites that we use to map out the gravitational field of the Earth. So to know where like is the strongest and weaker spots of gravity on Earth. And you know what's the name of the satellites that were used for that?
Grace.
Oh.
It was Tom and Jerry.
Nice.
Yeah, because the way it works is that when the satellites go over like a stronger field, the first one that goes towards it first, because of a stronger field, it speeds up a little bit, so it gets away from the one that is still coming, and the one that's still coming then accelerates and pick up the distance again. So the way they measured it was the variation of the distance between the satellites.
Wow, that's pretty cool.
Fascinating.
Yeah.
Then that's
That
why
is very cool.
they're called Tom and Jerry, because of that. Like,
Nice. Because they're
satellite
chasing
one
each
is-
other.
Yeah,
Yeah,
exactly.
Fantastic.
The other, and they're always getting really good.
Cool. Who was I going to
Oh,
say?
it might be just a story. It's a fun one.
Yeah, the difference between what, like my hypothesis, so a rotating Earth will have centrifugal force, and we make this specific prediction, is a long way from what Austin Whitsitt was proposing. Here's my wordy fucking explanation, and here's Albert Einstein's letter. There's no prediction. Like, if I said to Whitsitt, okay, if I have a kilogram weight at the equator, what will it weigh at 45 degrees latitude? There's no way he's going to be able to tell me that, given his explanation. That's the huge difference. The end.
No predictive power. And I mean, like there's a whole bunch of problems with it. The fact that the thing is measuring gravity using satellites is
Yeah.
another big issue.
Yeah, I mean, one of the factors is that this thing is you guys don't have any way. Like it's an just like with Cavendish, it's an explanation for the phenomenon. So if the phenomenon in Cavendish is XYZ happens, the phenomenon with the weights is XYZ happens. Now the anomalies, we could get into all of that. So obviously you would have to explain that somehow, which I haven't really heard you do, but you would have to obviously sort of make up something with that as well. But either way, you don't have any way to create an independent variable situation. Now, what I would claim is that the general idea, I'm not going to speak for anyone else, but from what I'm saying, the general idea of it being related to the field, what's interesting with that is you do have an independent variable because you're in different areas and you can use various different materials and you can actually alter the medium. So it actually has the potential for actual validation of an independent variable in that sense, where it's just saying it's Earth rotation. You don't have anything else there's no way to add or remove Earth rotation to see if it's the cause, but you can change the medium to see if that relates to it, and it indeed does.
Yeah, we await your experiments.
Can change. If you stand on a
Sounds
pole,
good.
you have zero rotation. If you stand at the equator, you have the maximum possible rotation. That is the independent variable in that test.
Yeah, it is. But I mean, I think what Gio's saying is that there's, I think you're kind of stuck in the trap. Yeah, exactly. Stuck in the trap of quantum eraser. It's like, my hypothesis is the Earth turns. You must be able to manipulate the Earth turn, which is just rubbish.
Well, I'm saying the words I'm saying. I'm not saying anything about quantum eraser. Whether he had a similar idea, that's not really relevant. It's the point of actually the point of isolating something. If you're going to isolate something, there's a way. There's steps that need to be taken to do that. Like if you're going to isolate the temperature that water boils, etc., to where you can quote unquote make a prediction at this temperature, water is going to boil consistently, and so on. You have to be able to have a certain setup that can do that. Meaning, if I said the old thing with the things weighing differently, if I said it's green pixie spirits from the spirit world, you might say, okay, well, and then I say, yeah, and in my green pixie theory, at the different latitudes, the pixies are fatter and thinner at the different latitudes.
Yes.
So when they pick the thing up, you know what I mean? It doesn't quite go for the fatter ones, pulls them down. And it's like, I could tell you that, and I could say, hey, dude, I can predict it. Like at this latitude, the pixies will lift it up this much and so on. That's basically what you're doing.
Yeah, it's a logically possible explanation.
It is that. Yes, I agree
Yes.
with you. It's a logically well said. You and I agree. That's it.
Yeah.
It's a logically. Say it again.
It's a logically possible explanation. Yes.
Yeah, but that's then, dude. That's it. You have a logically possible.
But that's the difference.
But you don't have the actual proof. You don't have the actual golden eggs. You don't have the actual validation.
That's why it's
Yeah, right.
important.
You just
to
have a
come up-
possible thing. Well, I have a possible thing. It's green pixies. Boom. So that,
Yeah.
so it doesn't. So if you're trying to then assert Earth spins because of it, well, you're basing it off something that wasn't isolated and wasn't validated. It's just an assertion.
Right, I can't prove it. That's the whole
Well,
point.
to be fair, there
All right.
are
Well, fair enough.
experiments. Well, there is an experiment that you could do, and it is like basically like Foucault's pendulum, but doing it properly, or Cavendish, but doing it properly, and that would basically boil it down to this attraction, matter attracting matter, whether that be via electromagnetism or on account of how much matter there is and like gravity or what have you. You can't possibly discern between the two. You can't distinguish between the two. It's inextricable, right? But you can do an experiment to show that there is this variation with latitude and with different masses and what have you. It's never been done for whatever
Yes,
reason.
it has. It's been done plenty of
It's
times.
never actually been done, like, you know, a bona fide experiment wherein they took the same, for instance, the same Foucault's pendulum at different latitudes, or multiple Foucault's pendulums at the same latitude, or with Cavendish where they did a vertical Cavendish and they, you know, had it isolated and they just introduced the mass above or below. You know, they've never once done that.
All right, I thought you were talking about like have people taken weights different latitudes, which they obviously have.
I mean, that's not really, you know.
But don't the Foucault pendulums around the world demonstrate where they are at? Isn't that cumulative
No, the idea
evidence?
is if your claim is the latitude is the independent variable, right? The only thing you should be changing is the latitude. You should have the same pendulum with the same balance, the same, like, you know, imperfections and micro deviations and divots and same whatever, and then just change latitude with that. That's never been done.
But there are other variables like the air pressure and the altitude and that sort of stuff that you
Ideally,
know will
you
have
would
a
also
slight
have it in a
effect.
container, you know, where you're counting for pressure and temperature. But my point is,
but-
even the rudimentary side where you just have the same pendulum, pendulum in different latitudes hasn't been done. So,
Right,
I mean,
but we know what some of the things are that will affect the weight of an object, and the pressure is one, and altitude and that sort of shit. So yeah, they're
And
minuscule.
if we, for example, we can tell you what the precession rate is going to be just based on your latitude, we can guess that very accurately without knowing any of those other variables, then those other variables aren't being an issue. Aren't being
Right,
relevant.
but you're just
That's a
reverse
claim.
pulling that from the fact you're reverse engineering that from the fact that the sky rotates. So once again, you haven't isolated it. It's just another assertion.
No, what I'm saying is if you can guess the rate of precession just based on the latitude.
Yes, because you're
and then
going off the way that this whole system moves. It's not
No,
a.
no,
It's
even
not
if-
an
hold
Earth.
up.
That's not my point, Gio.
Even
That's
if
not
they're
my
not
point.
looking up at the sky, let's say they're in a building and they can't even see the sky, it's not always going to be processing at this degree at that location. You know, you can have different pendulums that are processing differently on account of their structure, on account of their balancing and stuff like that. You can't tell me that they're all going to be processing at the same amount, because, and like I said, if you have multiple
Why
pendulums
not?
at the same latitude, that would be good evidence. But I've never seen that. Have you?
Yeah, but that's the thing. Okay, maybe that would be even better. But I think if I can tell you what the precession rate is going to be just based on your latitude, that means that the other variables that you're worried about are not significant.
I would agree with you if you actually had pendulums, like multiple pendulums at the same location with that precession that you could point to as confirmation. But you don't have that.
What do you mean you agree with me? My point was you don't need that. You can't say you agree with me, but you
Well,
would
where'd you
need
get the
that.
precession value in the first place then?
The pendulums.
From the
The
from
pendulums that I'm asking for. Yeah.
yeah. So, no, when I tell you that I can, you tell me your latitude. I tell you what's the precession rate is going to be, right? So you're not telling me the pressure. You're not telling me the
but
temperature.
how can you test that though? Do you have multiple pendulums at my latitude where
Well,
we can
every
confirm
time
you're
someone
correct,
does
your guess?
every time someone does the Foucault's pendulum experiment, it matches their latitude.
That's
Like,
not
you
true.
can-
That's not true, man.
Okay.
Did you see the
If you
one?
say so.
Did you see the? It was a recent video of Mitchell from Australia.
Mitchell. Oh yeah, you guys wait for that. Yes.
I only skimmed through it. I did watch it, but I kind of watched it on fast speed, so I didn't like.
Yeah.
So I haven't really analyzed the whole thing, but yeah, that one didn't even work at all.
Yeah, that's going to be glorious.
It just it processed a little and it just stayed stuck. Like it didn't even do it.
Yeah, a lot of times people like
What do
they
you
buy the pendulums on like eBay and stuff like that, and they have
Oh, those
issues
small pendulums?
doing it.
Like you know, like you need a
It's
very
super
tall
sensitive.
ceiling, right? Yeah, it's super. You can't like just buy one on eBay expect it to work. You need to wait a lot of time.
Well, there's some good
One of
ones
the
on
problems
eBay
with
too.
it that I would somewhat agree with what percentage is saying here. When I read into the Foucault's pendulum, I don't know if they're better nowadays now that have like nailed down a method, but when it was first happening, I was reading this thing. I think it was on Wikipedia where like pendulum mania swept the world, and people were like doing it in sort of market squares as like an attraction that they'd ask money for afterwards, and they were getting wildly different results, and it was like. And it does, I somewhat see their argument with it, which is like, well, anytime the results didn't match the latitude, didn't process the right way or the right amount, they would be like, well, that's a dud result. And it's like, well, how do you know
You
you're
just
not
did it wrong.
throwing out good results? Because, yeah, maybe you did it right and these results aren't consistent, but they look consistent because you always throw out the bad ones.
Yeah, but I mean, like the way the stars rotate, like you know how when you look at the northern star rotation, you know how they're all moving like in concentric circles.
Yep.
Well, if that's coming out from the North Pole, then all the GPs of those stars are also going out in concentric circles. So we have like the latitude longitude system of of the sky. Excuse me, of the actual sky, the latitude longitude of the sky, and as those concentric circles are coming out, all those GPs are lining up with parts of the Earth. And so the idea that a pendulum would process differently already correlates with the latitude of the actual sky itself. The fact that those concentric circles are coming out from the center.
Sure, yeah.
And that's something, again, that's in reality that we can verify as well. That's actually here. It's not in some theoretical ball or outer space idea.
But what's the explanation for Coriolis on a flat Earth?
And the challenge to go with that explanation would be, how does it explain how it starts to happen south of the equator? Both the stars and the pendulum suggest decreasing lines of latitude.
Or converging lines of longitude.
Yeah.
Yeah, it's because they converge at that pole.
Yeah, but that's a globe, Geo.
No, it's not.
If the south
No, it's
latitude
not.
lines converge, that's a globe.
Yeah.
South longitude, sorry. Yeah.
Yeah, take a look at that, Ruhiv. I'll be ready for your concession.
And those are 8 teleporting portals in the edges of the
Yeah.
map.
Is it a Pac-Man map?
No, the only thing I'm pointing it for, it has nothing to do with Pac-Mans or anything. I'm pointing out that on a flat plane, you can have the latitude and longitude lines track. It's precisely like these do. Now, in the southern regions, you're going to have a lot of extra space because if you cut out those southern regions and then pulled that down, you could wrap it around a ball. So the southern regions, obviously, like kind of tagging on a little bit to what Riding was saying, that's where the mystery lies that we'd have to verify and validate. But in terms of the actual latitude and longitude lines and the stars making this pattern of the convergence at each pole is exactly how a quadrupole field functions.
Yeah, those longitude lines at Harry's, yeah, they're not converging in those circles.
Diverging. They're getting
Correct.
far further apart. They're doing like a turn. And many of those places, particularly if you go, hang on, I've got to try and find.
Go to Sydney to Auckland. How far is that flight?
Sydney to Auckland is not just that, but they don't really show up on a map this small. But
well, this is all a non sequitur.
Okay, so you reject this map.
It's also populated, and so there's many people in Polynesia, which is that top circle I've drawn on the map, would have divergent lines. So what should happen there?
Yeah, we'd have to go to the southern oceans. We'd have to go to the southern oceans and see what we see.
Wait a minute.
I've got a question, a hypothetical.
You're still going to see stars moving across the sky everywhere on Earth, no matter where you are.
Right, but I've got a hypothetical. For any map you show us, and we say, "But what about this flight?" Do you then instantly go, "Whoa, this is not the right map"? Is there a map where you won't do that?
I don't know who you're talking to, but we weren't. It's just that we weren't talking about flights. I said it was a non sequitur.
Okay. But my point still stands.
We were talking about how the latitude and longitude lines, how they get smaller in the south. I was simply showing how, as a general patterning, that can be done on a planar surface as well.
Yeah, but they don't in the circles that Harry's circled.
What doesn't?
The longitude lines don't converge in those 4 areas.
Have you been there in any way, shape, or form to verify those areas?
No. The point that we're saying is that if longitude lines converge, then the Earth is a sphere.
What?
If longitude lines converge in the
No,
southern
you don't gotta
hemisphere,
repeat
then the Earth
everything.
is a sphere.
No, dude.
Yes. 3 hours.
Yeah,
No,
I wonder
would
how
say
it'd be
if
like.
latitude lines converge to
Longitude.
1 point, then you could claim it's a sphere.
Right.
Yeah,
That's my
someone in Africa could be seeing like the same star in the like duplicated in the sky, right?
Yeah, I mean that's
From
why I said
that position.
originally.
In
Yeah,
southern
that's
If
why,
they
that's
if they converge to a quadrupole, not just to 1 pole, then it's not indicative of a sphere.
Yeah, but then we're not saying that longitude lines converge, then are we?
Well, the thing is, Ruhif, you see, like if you're in the north, you see the northern star circle, you know, the rotation, and then when you're in the south, you see the southern star rotation. Now, if you take that map that I posted and look in the south, the way that those latitude lines and longitude are functioning, if you imagine the stars, then that obviously goes to its own circular circle, which is what could be called the southern crux, and so on. The southern, you know, that. So they're all going to points, and they're two, you know, circles moving in exactly the way that a vortex one goes clockwise, one goes counterclockwise. So it's really the same, except it's 4 corners rather than 1. And the thing is, whenever the Earth is so huge that whenever you're in one of those southern regions, you're only going to see one of them at any one time.
So New Zealand is seeing different stars to me in Sydney.
Although I would like to get into those southern oceans and really see what's going on there. That would be amazing.
Yeah.
Oh, people sail there, don't they?
If you were like anywhere in Polynesia, like I realized actually I was wrong about Polynesia. I didn't realize where New Zealand was until after you had said that, Ruhip. Yeah, it's 3 hours, and it's like would be closer to get to London than it would be to fly New Zealand.
So good.
But that's the point Ruhip was making, Joe. Not that it doesn't work, but that any time any model is presented to explain one problem, it breaks a bunch of other things like flights. But all you'd need to do is just like go to any Polynesian island in the middle of that hump or where I've written 3 hours, and what you should see is one Southern Cross suddenly split apart and turn into 2 different Southern Crosses.
Yeah, you should see 2 rotation poles, right?
Yeah, well, that's why I mentioned.
Or the start of a divergence.
That's why I mentioned the Orion constellation, because it's both in southern and northern part of the sky. So you would see the bottom half split, but not the top one, and it's always been visible by someone. So someone would have to see that happening.
So that map that I posted, it's called the Pierce Quincuncial projection, and the thing about that, like I said, if you cut out those areas, if you cut out those southern areas with like a pair of scissors, like let's say you printed that thing out and you literally cut out the southern areas, and then you take that, you know, it would look like a cross at that point, kind of, and then you wrap that around a sphere, and then you touch it up a little bit, you know, this and that. So the difference between a sphere and that projection I posted is a dramatic difference in the southern region. So much that it's, as we know, it's like 2, 3, 4, 5, 10 times longer, etc. It's way longer. So it shouldn't be that hard for us to validate that ourselves.
Yeah, validated or invalidated with the flight from Sydney to New Zealand. The map is wrong. It's not a flat Earth
Yeah, I'm
map.
not talking about sitting on someone else's aircraft. I'm talking about actually verifying it in the real world.
I met 2 Chilean people just the other week, and they're from Chile, but they're in Bali, and they work now in Australia. And they said, we got the first flight, because you know that Chile-Santiago-Sydney flight was cancelled for a bunch of years. They said we got on the first one out. And so let me draw that on this map.
It's over the North Pole.
Yeah.
Anecdotal evidence.
Yeah, literally
Hearsay.
any map you give us,
Objection,
we
Your
will
Honor,
we will
hearsay.
destroy it with flights.
Or fix the flights.
Yeah, and there's so many. I mean, yeah, Flat Earth Banjo wrote an entire 16. Yeah, he went through a lot of them. And
But debunks 12 of them. His first
there's
12.
there's multiple ideas on that. But what I'm talking about is that
To Australia's.
that added amount in the south, along with how the sky would look different, would give it away to, and if you guys did that and actually did it independently and verified it, then you'd perhaps have something to actually go off.
Yeah,
What do you mean that added amount and how the sky would look different? What do you mean, Gio?
I think if that was the case, celestial navigation in the southern hemisphere would be really different. Okay, would be
Have you
a lot
watched my
messier.
videos, Gio?
Some flat earthers do claim that happens. That's
Have you watched my videos, Banjo? Sorry, Gio, about Banjo.
Did you go through all 16 of them?
These first 12. The other 4 are in his book, which I haven't really looked at much. I didn't make a video, at least, on them.
Okay.
Yeah, so address 12, the first 12.
Give us the
Most of them.
synopsis.
Yeah, most of them, he just gets the Great Circle route wrong. He just doesn't draw the correct Great Circle. That's it. That's the explanation for most of them.
That was kind of anticlimactic.
It is.
So you're just using the great
I'm
circle,
not surprised.
the great circle deception, and just throwing it on there. That's it.
What do you mean, the
You gotta-
Great
Well, if
Circle
he's-
deception?
he's
trying to
if you're
validate
saying
the
that you're-
globe.
Yeah, if you're trying to test whether great circles are right, then you've got to get the right great circle, right?
Yeah, if you know Banjo's work, I've heard him talk about the great circle, and he is correct on it. So I would say you guys are incorrect because I've already heard what he has to say about it, and I've already verified it as correct.
Well, you
That
can
his
watch
Great
Rio's
Circles are
videos.
correct.
No, that his understanding of how the great circle route was deceptively altered to, of
Jesus.
course, fit the globe.
It's
model.
literally pulling a string taut across a sphere. That's all it is. You can do it yourself. If you go and buy a $10 globe from somewhere, and like one of the flights is from Taiwan to LAX.
Can you imagine the feeling of buying a globe and walking out and just knowing what you just bought? Yeah, I'm not going
Yeah,
to that one.
but if you did it and you pulled a string taut between Taiwan and LAX, that would be the Great Circle route. And you will see how badly Banjo does it in his videos.
Yeah, but that implies an assumed curve.
He's testing the globe model. Of course it does.
Right. You're just bending a string over a theoretical concept.
Yeah, that is the shortest distance between 2 points on a globe. Yeah, he has to assume it to disprove it.
If you go back to our whole idea of like the scientific method and whether proving or disproving things, the whole method to disprove it is accept the model in its entirety and then test it accurately. If you're not testing it accurately as it is, then what are you really doing? What are you disproving? You're disproving your understanding.
Massive straw man.
I agree with that.
Yeah, complete straw man.
I haven't looked at any of this like flat Earth Banjo stuff at all, so I don't know if that's what he's doing. But your sentiment right there, in and of itself, I agree with.
Yeah, he gets the Great Circle routes wrong terribly.
Let's say I disprove flat Earth by saying, but all the other planets are spheres, right? And you go, well, hang on, you totally misunderstood our model. So you haven't disproven anything, right? You've just not got it right.
Yeah, and then you mention like, well, in our model they're just lights in the sky, and then we answer by, well, then you're begging the question because you want to assume the flat Earth model to prove the flat Earth model.
Yeah.
I don't think it's assuming any quote unquote flat Earth model to
I
say
agree.
that the lights are lights in the sky. That's just a very basic, simple. It doesn't really imply anything else.
Yeah, that wasn't my point. That was me showing him how that's not a valid point. Because we hear that a lot.
We're agreeing with your rebuttal of other Globers' criticism of the flat Earth. If that makes sense. We're siding with the flat Earth on that.
Yeah, Globers are attacking a straw man.
Welcome to flat Earth.
Yes. Good call.
Yeah, I mean, Globers can be wrong and the globe still be right, just the same as flat Earthers can be wrong and the flat Earth still be right.
Yeah, I guess
Flat Earther does not disprove the flat Earth.
Yeah, I mean, this tendency to try to be grouping people and then saying things that someone said and then trying to link it to other people that didn't say it. It's kind of a lame process.
Hang on. That's what you just did.
Being
You said,
honest,
we agreed with you.
straight
That's what
honesty
you
on that
just
one.
did.
I mean,
And
it's
then
just
we
like,
agreed with you.
yeah, I try to always take the person at what they said, the best of my possibilities. Now, sometimes I probably do generalize in certain ways because sometimes we are actually talking about, you know, the argument for the Earth being a sphere or the argument, you know, whatever it may be. So yeah, there are like collective energies that there are certain ideas that are shared, you know, sort of collectively amongst the group, either purposefully or just synchronistically.
I would love for you to watch my 2 videos, Gio.
But yeah, because it sounds like Bacon just said a thing that someone said that there's lights in the sky, therefore it proves a flat Earth model. Is that what I heard Bacon actually say? Were those his words?
That was,
Where's
again, what
Taiwan?
I'm trying to express to you is that is the opposite of what he was saying.
That's exactly what he actually said.
Right, but oh my god,
You
what he's
said
saying
right.
is that
Right,
is
but
that is a bad representation. It is a bad way to debunk. So he did say some of what you're saying, but he presented it as this is a shit argument.
fair enough. No, I don't think he's in the VC, so we probably shouldn't keep assuming what maybe he said.
No, yeah, that's what he meant, Gio.
I'm quite confident that's what he meant.
He was trying to like emphasize on Writing's point.
Agreeing with your position on it. Yeah, we're saying people make bad globe Earth arguments that they think are debunks, but they're debunks of strawmans, and he gave that as an example.
Nice. Yeah, I may have missed something because I'm always multitasking and I'm kind of tuning in and out. So yeah, maybe I didn't, but I did. I just heard part of what he said. But he does it all the time, so that's kind of why I was saying that because it's like a common thing, and that was just a variation on it. But anyways, I mean, I just find that sometimes when a point is brought up, someone is saying some assumption of what someone else said in the past, and then linking what I haven't even said yet to that.
Isn't that exactly what you just admitted you just did? I've heard him say that in the past, so I assume that's what he meant now.
No, that's different. What I'm saying is that it's different. He may have heard someone else on some other server who calls themselves Flat Earth or whatever he's using that term for. He heard them or a multiple of them say a certain thing, and then when him and I are talking in this example, he then pins that on me, so that I somehow have to now deal with the fact that like that isn't, you know, that's something that someone else had stated and not myself. That's different than something he stated. If he stated it earlier, then yeah, I mean that's its own thing too, but anyways, the weight by latitude, just because you guys have a model that you're attributing to it of a sphere Earth doesn't actually isolate or verify that it is a sphere Earth. So
right.
So I guess, Rue, if you were even admitting, like, yeah, maybe so that one's just it's no good anymore for globe.
No, it's evidence. It's not proof.
It's like,
Holy
yeah,
shit!
If you see that somebody has fingerprints inside someone's house, does that mean they murdered them? No. But if they're bloody fingerprints, and they also posted on TikTok about how they just murdered somebody, and they've also the gun rifling matches, all of these stacks of evidence match up. Do they prove that they committed it? No. But does it become so overwhelmingly probable that they committed the murder? Yes. So it's evidence, it's not proof.
So that's how they got you. They got you to believe in enough of their quote unquote proofs, or not even, well, fine, not proofs, enough of their statements, whatever evidence you think, enough of it to kind of bombard, like enough reverse engineered conceptual concepts that link enough to reality for you to then basically buy the whole shtick.
Yes.
Yeah, if I ask
the globe makes so many predictions.
And once you're bought in, that's it. You're bought, and you're going to defend it until your ego shifts from it.
No, I'll question it again, but like I'll ask the questions that should split the difference between flat and round or this and that. And if it offers explanations, whether I can test them or not becomes a bit of a different challenge. But if it offers coherent explanations with mechanisms that are falsifiable, and I keep looking at them, and each time I try and find one that might split the difference, it keeps leaning one way, then I go, this is probably the case. Whereas if I turn around and I go, hey, what does your model have when it comes to the entire south bit? And it's like, well, mysterious. You can't go there. Oh, it could be a quadrupole. And all of the answers are like divergent and different because there's many people who like you seem to agree with it, but there's many people, flat earthers, who do not agree that weights vary by latitude. So if the answers are divergent in that way and not very comprehensible and lack mechanisms and aren't able to be tested, that's when I go, it's probably a globe.
Okay. Well, I can see that you and I go about it in a very different way because now that I'm kind of seeing the way you're, the way you're explaining your mind works in that way. Yeah, I get kind of how you're saying it. I guess for me, I'm looking to get to the truth. So I want to isolate it down to it being verified. Whereas it sounds like what you're doing is kind of trying to take these different ideas, kind of weigh it up, and then just sort of like go with one for just because it seems to weigh a little bit heavier, rather than actually finding the truth.
Always consistently matching reality.
Rather than actually finding the truth through proof.
So I don't, close. I think we're getting close to an accord. I think that objective reality exists, but it's like a course. Let's say I'm trying to sail at 275 degrees, right? So I'm trying to get to bang on due west. Am I ever going to be able to get my ship to go exactly on that path? No, but if I keep testing using different mechanisms, can I like sort of guide it in pretty much the right direction? Yes. So truth to me would be bang on 270 degrees, which is impossible. But can I use multiple different methods to get it going in very close to the right direction? Yeah, and what that involves is constantly questioning and constantly going, I might be wrong. And
right, but it sounds like you're making an
that one says 275.
But it sounds like you're making an educated guess rather than coming to truth.
Yeah, we have different ideas about coming to truth. I don't think that's possible. In fact, I think that's antithetical to getting more accurate because I think what people do when they do that, and I think this is true of all people, definitely not just flat earthers, particularly people who have a very fixed worldview, so globers are included, but as are like lefties or right wingers or religious folk, is if you've got a very dead set worldview, you just shove everything through that filter. Some stuff becomes propaganda, or that's just what they want you to think, while other stuff becomes unequivocal evidence of whatever my worldview tells me to believe. I still have that. I can't get rid of it, but I try to fight against it.
That's cool, man. No, I got you. Yeah. I understand that worldview. I mean, that's kind of the, in a way, kind of the standard paradigm, the Newtonian Cartesian kind of modern day sort of science and scientism and everything that kind of has gone along with all that. But yeah, they kind of convince you to not really actually get it proven, but just kind of like weigh up all this information that's being put in front of you and then kind of put it on a scale and just be like, I'll just go with that because it's a little heavier.
A lot heavier.
No.
A lot heavier.
Don't go with that. That's what most people go to. Mine is don't go with that. Lean that way, but keep questioning.
And then there's a lot of like social stuff. A lot of social stuff is said in that.
Well, let me
That's
ask
the
the Globers in the room something. Then, do y'all believe in dinosaurs?
Sure.
They're probably true. The idea that big things used to exist, sure.
And that we dig up mineralized fossils of them. Yep.
Yeah, like.
Well, there's a difference between big things and dinosaurs.
Are they definitely dinosaurs? Are they definitely 240 million years ago? No, but probably, yeah.
All right. I found a lot of information pretty much that goes against dinosaurs ever being what they call dinosaurs, you know.
Creationist material.
But if you've never came across that information, I can't judge your position.
I'm pretty sure I've come across it. Like I just went, if you look at my YouTube, I just went and chatted to a creationist chap at a.
But my point is, since you believe in dinosaurs, then my point can't be made because I would then say,
oh, you don't believe in dinosaurs, so you know. I
think I
can't
missed
make
your
that
point.
point though because you believe in dinosaurs. Sorry.
Well, I think that probably exists, but I mean, you can make whatever point you want. I mean, if your point requires somebody to already agree with you, then maybe
No, it's
you're
just
going to
it's just the
question that
idea
point.
that there is a convoluted, oversaturated concept in reality that isn't real. You know.
Yeah,
No,
exactly.
it's not
Like,
real. Could
okay,
it,
so
could it possibly
if
be
if
real?
if the bones they're finding are actually other things, like other creatures, God knows what, right? And if they're trying to hide that and then use the dinosaur story to basically cover up the fact that people are finding all kinds of bones and things, getting them into these museums as quickly as possible. And the one thing that I find lacking about their dinosaur story is, as far as I'm aware, there's never been a full set of bones brought together. It's always just parts, and then they kind of assume and they build it out. So they're all fake. They're all fake structures that are theoretically that are theoretically associated with real bone structures, but just a total fabrication on top of that.
And to
It's not true.
piggyback what you're saying, the
clarify
Smithsonian has come out and admitted to doing this. I should find that video.
To clarify something quite important about this, nobody finds dinosaur bones. Even many people who believe in dinosaurs get this wrong. Nobody's found dinosaur bones. Exactly as Ruhip said it. What you find, what the actual scientists say is what you find is mineralized deposits that are found in the shape of bones that once existed there. So the idea is that the body, the flesh of the dinosaur decays, and the bones which are harder are left. But then the bones eventually decay, and what's left is a void of where the bone once was, inside otherwise rock. Then minerals leach through that rock and find that void and fill that void uniformly, so that you then get a void of a different kind of mineral, a different sort of rocky deposit that is in a sort of, it's like making a plaster of Paris mold of something, and then you dig up that plaster of Paris mold. So there's nobody suggests that when you find it, like when they go, oh, they found a dinosaur skull, they didn't find the skull, they found a rock that was exactly in the shape of what was once there, which is what they presumed to be a dinosaur skull.
That was the longest definition of fossil I've ever heard in my life.
Yeah, I didn't mean to spiral this into like a dinosaur topic.
But they kept saying digging up bones, right? No, they shouldn't say digging
I
up
wasn't trying to steer away from what the conversation was about. I just wanted to point out that there are things that are just inflated lies. Okay? And just because there's a dense amount of information doesn't mean that any of it is true or verifiable.
Right, but you're saying they make up the structure of a dinosaur, right? If you find, let's say you find 100 different fossils and there's like a decent amount of overlap in the structure of all of them, right? And together you might make 20 full, skeletons. Is that enough for you?
And there have been full skeletons found.
Yeah, but I mean, let's say one's missing a toe, right?
As far as I know, there's
it's
not
not
a
even
single
like
full
that.
one.
You
There's one
think
that's
that
like
they're finding
99%,
an
that's
entire
about it.
skeleton of a lizard and it's just missing a few bones? No, they're literally okay.
Are you saying that never happens, or let's need to clarify here. Sometimes they just find a skull, or they find like a hip bone and a thigh bone and this and a that, but they don't get a full skeleton. Are you saying they never get a full skeleton, or are you saying sometimes? Because indeed you might be right. There are sometimes like they had like really weirdly shaped dinosaurs because the guys had just put them together in whatever shape they could figure out. But as they dug up more fossils, but like there's one in this video, I'm going to share it right now. I went and chatted with a guy at a creationist park and he's a creationist and a geologist made this park actually. He agrees that these fossils exist. He just disagrees on how old they are. But he's got one of these plaster of Paris molds of a fossil.
Well, it's definitely pretty shady how the whole dinosaur story like fits into the heliocentric story and a lot of his historical timeline that they
Bone
give.
race.
Yeah, it's pretty shady just right off the
So
bat.
T-Rexes, about 50 T-Rex skeletons have been unearthed since the species were identified in 1905, but only a quarter of them are considered nearly complete, meaning more than half the dinosaur bones were retrieved. Sue's skeleton. Sue is the T-Rex. Sue's skeleton is rare and valuable to science because it is the largest and most complete.
So 50.1% of the bones means it's mostly complete.
They're more than half, right? And how much overlap
Is that what
do you
you
think
said?
is in them to make a full one?
It's dishonest the way that they say it.
They're being very explicit. Only a quarter of them are considered nearly complete,
Nearly
meaning more
complete,
than
nearly
half the
complete.
bones.
Yeah,
Yeah,
so
meaning more than
nearly
half.
is 50%.
Right?
Come on.
They're very explicit.
Nearly is not 50%.
Okay, so
That's
so-
half
so
complete.
I've just posted a picture, which is a plaster of Paris copy of a fossil that has been found. This creationist chap who's talking to us agrees is an actual fossil of an actual once living animal. Would you call that complete? For me, I see it head all the way to its tail. I can clearly see it.
Bro, I could just imagine if
Over its
Kosho
forelegs.
was a flat earther, like how awesome that would be. He would be fucking killing it.
So this is all supposed to be one kind of excavation. They found it
That's
all
true.
like this.
That's totally true.
Yeah, all
in
of
its
it
form?
exactly like that is his claim, this chap's claim. I don't know that particular fossil or anything about that, but his whole explanation is it must have happened rapidly because its neck's bent back, and that's what happens when things suffocate. Would you call that a complete fossil?
I don't know if all the bones are accounted for, but I would say it's, that one's a nearly complete one.
Okay. Happy days.
But it seems like there's a lot more than half the bones there, or half the
Exactly.
what would be bones. I wouldn't say nearly for 50% by any stretch.
But they were explicit, right? More than half.
I know, but I'm saying the way they said nearly complete, the classification, like without them expounding that it's 50%, and even the fact that it is 50%, but that's not as bad since they actually said it afterwards.
Right.
It's slimy.
They
Say
were
half
so
complete.
explicit. They were
Don't
so
say nearly
explicit.
complete. Something that's half done isn't nearly done.
You can tell how honest they are, how dishonest they are because they're honest.
Yeah.
No, they could have been more dishonest by just leaving out the second part.
Right. But they
just
were explicit, right?
The verbiage is bad.
Yeah, I hear where you're coming from, that they said nearly complete, right? But they did explicitly say that means more than half.
Yeah, and in no world does nearly mean more around
I
half.
hear you, but they were explicit.
Right, and it's kind of tough because how many of these fossil of these different structures, Ruhif, have you ever seen or analyzed?
Oh, zero. I've seen a few of them, but haven't analyzed any of them.
Right. So, what position does that put you in into being able to know whether they're actually what they claim they are?
Right. He's making a claim that we're sort of extrapolating from a couple of fucking bones into a full skeleton. That's incorrect.
Yeah.
Who said that?
Electric.
Okay.
So what's the difference between a dinosaur and a giant lizard?
What did I say?
I don't know.
Right, like a giant, like a reptilian. You mean like a giant reptilian type creature?
Yeah.
Yeah.
Why not call that a dinosaur?
Well, they've woven those in. Yeah, they weave it into the dinosaur.
Well, because dinosaurs they hold as different species, and they give them different names and stuff like that. Instead of saying it's a giant chameleon or
Can I say
a
why I
giant
brought this
gecko.
up?
Right.
Can I say why I brought this up? Specific dinosaurs that they say that they have on display in the Smithsonian. They clearly state, like the Smithsonian will tell you, like, we didn't find these bones along with the supposed species of this bone. This is actually just supposed to look like what we think it looks like. But, there's nothing that backs any of that up.
In the
Again,
museums
they've
I've been
found
to, they
50.
usually show you which bones they've found. Like at least the one at the what's the museum in Natural History Museum in London. That when you go up and look at it, there's some that are like brown and some that are black or something. So it's like quite close, but they deliberately make them a different shape so that when you go up to the sign, it shows you quite clearly these are the ones we've dug up, but this is how we think they're fitting together.
Yeah.
Now, I
also,
should
another
find
question.
that video.
Let's say
I gotta
find.
find a video. I'll post it tomorrow.
Yeah,
I
you
don't
need to
have time.
find evidence for what you're saying.
Let's say you find a T-Rex 75% complete, but it's missing like the right back section. Do you think it's okay that we make a
So that's
mirror
not,
of the left?
that's not, they don't find the full structure of the, like when you think that they're finding like the foot and the ankle and the thigh and the wing and then, oh, we could put it together like a masterful puzzle piece, right? No, they'll find maybe a skull and then the rest they'll just improvise. You can't
And that
picture
certainly
them
happens
finding an entire
historically.
skeleton because that's
That
not what
happens
ever happens.
sometimes. That happens sometimes in the past within
Not when it comes to
context.
dinosaurs.
Initially, that happened in the
My-
past.
my-
Is it your suggestion that is always what happens still up to today? Or is it your assertion that that happens
Suggesting that these
sometimes when we
creatures
have
that
very
were walking the
few?
earth like 200 million years ago and they're finding full intact skeletons and able to determine like how big they were and what they ate and all that stuff, like you're tripping balls. Like they're not doing that, dude.
Did you see the fossil I posted? The copy of the fossil I posted. It's a picture in the chat taken from the video I made. I think I could determine.
Yeah, it looks like a giant gecko.
Yeah, I think I could determine that the thing probably stood on its hind legs, probably stood about 3-4 foot tall. If I got to zoom in on its mouth and I found sharp teeth, I'd probably presume it was carnivorous. I don't understand what about looking at that would make me go, oh, I've got no idea how big that was. Cock could have weighed 400 ton or 40 grams. I just couldn't tell. But the assertion that some fossils are incomplete, it seems reasonable. The assertion that 0 fossils are complete.
Most of these fossils they assume resemble birds. So that's why they give them the rest of their bodies to resemble bird type creatures. They're not telling you that they don't actually know, like when they find a bone, they don't know what the rest of the body is supposed to look like. They just assume, and then they'll make fake bones and work around like maybe 1 or 2. It's not like they find 200 and then have to add in like a toe and a fucking finger. That's not what they're doing.
One of the main points, which is what Ruhip was just raising, is if you've got an animal and you've got its right leg, you've got a pretty darn good idea of what a left leg looks like. That fossil there looks like it has both forelimbs and at least 1 rear limb. Are you saying that we've got no idea what that one? I'm talking about that one now. It's 48 minutes past the hour.
How would you know it's a
got no
leg?
idea what that one looks like?
How would you know it's a leg?
Lopsided legs. How would I know it's a leg?
Yeah.
Okay.
How do you know a thing doesn't have 8 legs?
How do I know that thing? We're both looking at the same picture, right? 48 minutes past the hour. How do I know that thing doesn't have 8 legs? Is that the question? Is my mic working?
I mean,
so you guys
to be
are
fair,
right
for
to
that
put it this way.
photo, right?
They
You have
assume
to
the
like give the
species
benefit of
based
doubt
on,
that
like,
that's
1 or
how
2
they found it in the
bones,
ground.
and then they'll make
that
the
was like
rest
a
of the
bullshit.
skeleton.
But that's what I'm. I mean, we've got to
I think y'all
accept
had it.
that presumption to happen.
Yeah, if we do accept
Otherwise,
that,
we can
if we
just
give the
go,
benefit of the doubt and
how
say
do
that
we
they,
not know they didn't just
yeah,
make
that they
that?
did a bulk excavation and they found it all in the ground just like that, then I don't think there's anything wrong with saying the ones that look like where they'd be like on the legs or whatever they are legs.
I mean, yes. I'm saying for the sake of discussion, if we accept that that was dug up in that way, we can have a different discussion about do we know that was 240 million years ago? That's a valid discussion to have. But we're questioning whether we know the shape and size of a thing. And it sounds like somebody's going, it probably or possibly has 8 legs. Or is that somebody saying it having not looked at the picture yet?
I think maybe you just didn't look at the picture. That being said, that doesn't mean it's a dinosaur. It could be like a long Komodo dragon. It could be a number of different things that aren't what they're trying to say. These prehistoric animals, which are all extinct and have different like species and different names, terminology, and classifications and stuff like that.
Yeah, the guy standing in that photo is telling us why he thinks that is less than 6,000 years old. So absolutely, somebody could make that argument. But the argument that we have that we're deciding the entire shape of all dinosaurs based on one bone and then making it up, and we don't really know the size and shape of them is just silly. I mean, started, you can make some pretty good inferential arguments. If you go, this bone is thick as my
Point
forearm,
is, there's a bunch of
information. There's a bunch of
point is, all right, guys. Point is, there's a bunch of information about dinosaurs that's inflated, full of lies, lots of researchable, scholastic studies you can partake in. and learn so much about these creatures, and it'll all just be based on like nothing.
Yeah, I
That's-
agree with that. There's a lot of bullshit that they kind of try to passing off as fact, stuff that they couldn't possibly.
There's a difference
have
between
validated.
truth and scholastic knowledge. Know that.
Yeah, it's funny because a lot of scholastic books that they have for kids in school and stuff like that, they have all these different specimens and different, and they actually give the flesh and how it looks and the exterior and everything like that, and all that shit is made up.
Yeah, did you hear the thing about the it was a discovery like a year or so, like relatively recently, but a year definitely before Jurassic Park was made as a movie, and they've actually apparently put quite a bit of research into this. And one of the things they now think about, I'm not sure if it's most or all dinosaurs, but certainly many of them, like the raptors that they had in that film were definitely among these. They were like, we actually think they were covered in feathers because they're related to birds. In fact, the correct way to refer to dinosaurs is non-avian dinosaurs, because technically for some reason birds are dinosaurs. And they're showing like why they think that, because some imprints on fossils. And the people from Jurassic Park knew this, but whenever they tried to model it, they found that firstly their budget for the CGI went up massively because they had to have flappy things, and they also looked ridiculous and not scary. So they went, we're just going to make them smooth skin, make them look like reptiles. But yeah, they didn't.
With those weird looking frills to make them look scarier.
Yeah. I wouldn't be surprised if those frilly ones didn't even exist. I remember hearing something like that at the time.
T-Rex definitely fucked up T-Rex. There's no possible way that they have that like weirdly imbalanced creature as being real. There's no fucking way.
I think it was pretty real, but I do think that there's actually
Man, you couldn't even stand like that.
Whether it was a fearsome apex predator, because I think the suggestion was it would be so loud and so lumbering and slow and easy to get away from by going through a tight gap that it probably mostly feasted on carrion. So it just ate things that were already dead.
I have returned.
You're telling me that creature right there wouldn't fall forward? There's no way that it's not using its arms to like support itself. If it is,
You've seen a kangaroo, right?
That's bullshit.
Have you seen a kangaroo?
Pretty close to a kangaroo.
Yeah, kangaroos don't they stand straight.
Right.
Have you seen
They
a
rest on
kangaroo
their
bounce?
tail, and they're not leaning forward like this weird fucking.
But look at the difference between the size of the kangaroo's head and that.
There's not a chance in hell that T-Rexes are real like they claim they are.
Anyway, Flatzoid's here.
In that orientation.
Hang on, he's pretty quiet.
Mind you, that's the most complete, as they claim, T-Rex that they have. That image I posted.
Is it? And how many of those bones were made up? Well, that's the actual. Oh, they've only shown the bones.
No, those are. It's probably a replica. There's not a chance in hell they'd show the actual fossils if they exist in like an actual museum. They have them in special kind of environments under lock and key for the most part.
Yeah, but I mean those.
You recreate.
The bone there is the bone they claim.
Yeah, they say that they have, I think, 90% of the full skeleton.
Oh, it's got ribs on its belly. That's super weird, isn't it?
Yeah.
Interesting.
I've never seen a creature like that, by the way, with this inferior ribs.
Because I know when I was
maybe that's the
studying
thing,
art
I
for the one museum, we actually had.
was gonna say, who knows? Maybe that's a common characteristic amongst lizards and snakes and stuff.
Anyway, while Flatzoid here, do we want to talk about celestial navigation?
Yeah. And if you want to.
Yeah, that'd be lovely.
How's it going?
There you go. Your audio's a bit shit.
How's it going?
Lovely.
Sorry, I'm a bit far away from my Wi-Fi because I'm busy picking up grass.
Oh no, it's your microphone. Anyway, where do you want to start?
Yeah. Where do you want to start?
Celestial navigation only works on a globe. Discuss in 250 words or less.
While you show elevation angle has nothing to do with the globe.
Elevation angles do not reference the shape of the Earth. Like you don't need to reference the Earth to measure an elevation angle. All you need is some way to make something perpendicular to your down vector. All right, so I hang a plumb bob. Did you watch the debate with me and refracted curvature?
Yes, I did.
Okay, so I hang a plumb bob, and then I just hold a set square against the plumb bob, and I look along the set square. That is 0 degrees elevation. Did I reference the surface to do anything?
It's perpendicular to vertical, so you have to have a straight horizontal.
Right, that's the set square. That's what the set square does. Did I reference the
Yeah.
surface of the Earth?
No, because you created a horizontal reference.
Good. And I've measured an elevation. If I then hold like a protractor up against the plumb bob, I can measure the angle to something in the sky relative to that horizontal. That's an elevation angle to whatever that thing is.
Yes. Yes,
Okay.
and that thing would have a distance over the horizontal, correct?
What do you mean a distance over the horizontal? We're not
Away
looking
from
at
you.
distances. Well, it would have a distance, but I mean, we don't need to know that distance to measure the angle to it.
No, you don't need to know the distance. I'm saying it would have a distance over the horizontal
What do you mean over the horizontal?
because it's a vertex line. It's the vertex part of the angle line. You got two straight lines. The one to
This
the
argument's so
luminary.
weird to me. You have to use the Earth to reference a flat level. Like, that's what you're using to reference level.
I'm not using the surface of the Earth. I'm hanging a
Yes,
plumb
you
bob.
are. So,
No,
so
I'm
then
not.
anything can be level at that point.
Let's say I'm standing on the side of a hill, right? So that the ground is most certainly not flat. I hang a plumb bob, and then I hold something at 90 degrees to it. Did I reference the surface in order to do those two steps?
You needed a surface to stand on.
Right? But it doesn't matter what shape that
obviously-
surface is.
no. Yeah, but you have topography. So, but that's what I'm saying. You created a horizontal reference based on your
Yes.
vertical.
Yes, exactly.
Yes. Okay.
Right?
Okay.
Is that proof of flat Earth?
Yes, because you had to make that based on each
Hang
angle.
on, which step is proof of flat Earth? Hanging the plumb bob or holding the set square?
Did you have both of them? You have a 90 degree
Both of
angle.
them individually or both of them together?
Yeah, and individually. Doesn't matter. You have a 90
So hang
degree
on.
angle.
Hanging a plumb bob is proof of flat Earth?
Yes. Because remember, horizontal is perpendicular. Horizontal is perpendicular to your vertical.
Hang on. Just
It's
repeat
90
again. Just
degrees.
repeat for me again and just say the words hanging a plumb bob is proof of flat Earth.
Hanging up top is proof of flat Earth because it's a 90 degree angle.
To what?
To what? The perpendicular to horizontal. You wouldn't need to create a horizontal.
This is going to be very short.
You wouldn't need to create the horizontal if you could create the angle on the space. You
So
understand,
hanging a
bro?
plumb bob. Just can I record this?
Yeah, it's recorded anyway. It's live, isn't it?
Oh, that's right. It is too. Okay. Just so everyone heard, Flatsoid said that the act of hanging a plumb bob is proof of flat Earth.
But I
Yes,
want to
it
hear
is.
why.
I'm trying to get there.
Yeah.
The reason it is because it's perpendicular to horizontal, which is 90 degrees.
Right.
You have two straight lines to
does
get
that
your angle.
How does that have anything to do with the shape of the Earth? Establishing a horizontal.
Because you are. What is vertical? Is there any assumptions when you make a vertical?
Just the direction of down.
Thank
Whatever
you.
down
So
is.
what's 90 degrees from vertical?
Horizontal.
And you're standing on the ground, are you not?
I'm standing on the side of a hill, which is most certainly not flat and not horizontal.
Horizontal
I'm sitting here
has
listening to what
topography.
you're saying. Can I respond to what he's saying, please?
No, I want to hear.
What?
Sorry, I want to
Wait,
hear
please,
Flatzoid
bro,
actually
have patience
explain
with me.
why.
Wait, just let me respond to what he's saying, please. You're saying that if you hold up a plumb bob and if you draw a perfect 90-degree angle against it, that is going to match if I were to do it any other way, right?
Sorry, match what?
If I were to try to find level.
That is horizontal. What you've just done is establish a horizontal.
Right.
And apparently
So-
establishing a horizontal is proof of flat Earth.
Yeah.
I want to hear why that
Okay.
is.
Are you saying
Yeah.
the ground isn't level? Is that what you're saying?
I'm standing on the side of a hill.
You're standing on something.
Yeah,
You
but-
deliberately picked the place that is not level. I want to hear Flatzoid's reason for
I just don't understand how a plumb bob disproves anything. I just don't get it.
Well, apparently it proves a flat Earth, so it must disprove the globe, right?
Okay.
Exactly. It's necessary. I mean, they're both. To me, they're possible on both. I want to understand. How
I just think that like
globe.
the globe arguments are so weird. When I come in here now, y'all are stuck on like
Sorry.
horizon.
You
and
think hanging a plumb
refractions
bob is
and
proof
plumb
of flat Earth
bobs
is
and
not weird?
gyroscopes, and these
No,
arguments are so weird.
Can I explain it?
I don't think he knows
Go
that
ahead.
Flatzoid is a flat earther. He's arguing against a flat earther, right?
Can I-
No, I'm just
can I
trying to
explain it?
understand like
Yeah,
what.
go flat side.
If you're trying to understand,
Go
then
ahead.
shut
I
up.
don't even care. I honestly don't
Fuck's
even
sake, man. Good, then shut the fuck up.
Go flat
Okay.
side, come on.
The reason I'm saying that is because that star that you are referencing for your co-altitude angle is based on the distance over that horizontal. Correct?
I'm just measuring an angle to it. I don't need to know any distance or even I don't need to know anything about what I'm
I'm not
pointing it at.
saying you have to need to know the distance, but it's laying over a distance on horizontal reference. That's how angles work.
What are you talking about?
We've now skipped to step 2. Step 1 was plumb bob.
Still
Yeah.
part of it.
Hang on.
So
I think I
why
know
is
what
it
you're
plumb?
talking about. I think I know what he's talking about. Let me draw it.
Because you set your horizontal now based on your vertical. No assumptions, anything. So you've got your 90 degree. Now you're taking your measurement to the star, which has a GP, obviously, which is based on a distance over that horizontal.
Hang on. No, wait. We're not talking about GPs. We're just measuring an angle, right? Just measuring an angle,
Yes. Yes, you're measuring the angle.
right? So
And
what
that-
does that have to do with the
okay.
GP?
The star.
What are you talking about?
Where the,
We're literally
where
just
the
measuring
star-
an angle.
Yes, you're measuring your angle over horizontal surface.
What does this have to do with
No,
anything?
I'm standing on the side of a hill.
And
And what's that got to change about the horizontal?
yeah, I don't get it, dude.
It's got
Like,
nothing to do with the surface.
It's got
this
everything
is
to
my
do with
point.
the surface.
This is my point. If you're going to make a reference to level, then it's going to end up
Horizontal.
also being the level that you find on Earth. Period.
Horizontal.
Yeah, it's going to be level. Level is level, no matter where you do it or how you're getting it. It's going to match the Earth level. Is that incorrect to you? Then you're a psychopath to me.
Horizontal does not match 0 meters above sea level on Earth. No.
What
One's
the
a curve,
fuck are
one's
you
straight.
even arguing this for?
What?
I don't understand why you're arguing this. Why?
Then it's not level.
Horizontal, right, is not parallel to the 0 meters above sea level datum because that is curved.
And
horizontal is not.
Oh, because curve. Oh,
yes,
because curve,
So
guys.
horizontal-
You hear that?
so
Horizontal isn't horizontal because of curve. Got it.
So horizontal curve.
0 meters above sea level
No,
is a
that's
curve.
not what you just said. Got it.
What is a 0 meter?
0 meters above sea level is a curve. Horizontal is a straight line.
What 0
Yep.
degree?
Bro, I think you're a
Second.
smart dude, and I think that if you understood the implications of flat Earth, you would be a great. You would actually do great. But you're arguing from home.
You're just not
Electric.
not contributing.
Yeah, just be quiet. Flat side, go again.
Okay, Rube, what's a
I don't
0
even
degree?
fucking care. All right, peace out.
What's a 0 degrees? Elevation?
Yeah.
Yeah, it's
Yeah.
just horizontal.
Yeah.
Horizontal.
So let's say from point B on that horizontal line, is it 0 degrees from left to right?
You cut out a bit. Go again.
So let's say point A to point B on that horizontal, it's 0 degrees straight through.
Where's point A and point B? Are they just points on the horizontal?
Yes.
Okay. Yep. Sure.
Okay. So where's the curve there?
Horizontal doesn't curve. Horizontal is simply perpendicular to down.
Exactly. So when you are making assumptions that there's a new vertical at a different place, that's you making an assumption that it's a globe. You've already begged the
We're
question.
not even. The point of this conversation right now is to establish that measuring an elevation angle is not proof of flat Earth. Okay, it's not proof of a
It
globe
is.
either. Well, demonstrate it. Please explain why it is.
Can I
I'm
try
trying
and
to.
split the difference here? Can I ask you a question, Flatfoot? If you accept the entirety of the globe model for a moment, and you simplify it down to your vector of down is always pointing towards the dead center of mass, which is the dead center of Earth, would you accept there that in that model, if you accept it just for the sake of this discussion, a plumb bob would always point down, and 90 degrees to that would always be local horizontal?
You want me to beg the question that's the New Zealand?
We want you to accept for the sake of argument. Yeah, the sake of argument.
Okay, fine.
You don't have to agree with it in your heart. You just need to
Yeah,
accept
that's
that
fine.
if the model is true, would the model predict that down is down, essentially?
Yeah,
Yes.
can down exist on a globe and a flat Earth? I think we agree that yes.
Down can exist on a
Your audio shit again.
So down can exist on a donut if it wanted to.
Okay, sure.
Right. So does hanging a plumb bob prove flat?
Yes, because you're not having any assumptions.
You just,
They got a
you
90
just
degree.
agreed,
Listen,
Flatsoid, you
listen,
just
listen what-
agreed that hanging a plumb bob is possible on a globe, and then Harry asked
Listen
you,
what I'm
is
saying.
hanging a plumb bob proof of flat Earth, and you said yes.
It
That
is
is
proof of flat Earth.
contradictory.
Listen what I'm
Has
saying.
two explanations. If something has two explanations, and you haven't split the difference between them, like let's say I go, my phone screen is black. It could be because my phone's asleep, or it could be because my phone's dead. Does having a black screen on my phone prove either one of those propositions? If both would satisfy the condition of my phone screen is black.
You would have to test it to see which the reason it is. Then you can come to a conclusion. Like,
Okay.
why it's
So
black.
the simple
difference
question
is,
Flatsoid, is
Yes.
plumb bob if the Earth is a globe?
Sorry, you broke up there.
Sorry. If the Earth is a globe, am I able to hang a plumb bob?
Yes, you are able to
Okay,
hang
so
a
it
plumb
is
bob.
not proof of flat Earth then. Hanging a plumb bob is not proof of flat Earth if it is possible on a globe.
You can hang a plumb bob on an Earth, on your globe Earth, but it doesn't make it false for a flat Earth. The problem is,
I agree.
when you hang your plumb bob on your globe Earth, you're already begging the question that you can have a new zenith vertical somewhere else. Understand?
We're not assuming.
you're creating-
Not
listen-
assuming that there are
listen.
different zeniths, right? We're not assuming that. We're just
Yes, you
hanging
are.
a plumb bob. No, I'm not.
You
We're
are,
just
because you're
hanging
saying
a
that-
plumb bob,
because you're
regardless of
giving
the
a
shape of the
horizontal-
Earth. We're
giving a
just hanging a
horizontal-
plumb bob, right? Can that happen on both a flat Earth
Giving
and
a
a globe?
horizontal. Being sure, you can hang a plumb bob on a donut if you wanted to. Down is down.
Yes. Okay. But can I do it on a globe?
The problem, you can hang it on a globe if you wanted
Okay,
to.
so it's not proof of flat Earth.
It's still proof of flat Earth because you created
Well,
a
then I
horizontal.
can't do it on a globe. For fuck's sake, this
You
is
can
such
still
simple
do
logic.
it. You can still do it on a. Listen, you can still do it on a globe. The only difference is you are having new zeniths for your
No,
globe.
we're not assuming
So that
like
have
non-parallel
different
zeniths. We're just hanging a plumb bob. We're not assuming that if you hang a plumb bob somewhere else, then they're not parallel. We're standing on the side of a hill somewhere in the world, just me. Can I hang a plumb bob on a globe?
Yeah. Okay.
Yes. Okay. So
You're
that's
assuming
not
a globe.
proof of flat Earth.
Listen. Okay, let's assume no shape at all. You hang a
Okay.
plumb bob, which is down, correct? Hello?
Yeah.
Okay, now you have a horizontal to that down.
Yep.
Now you're measuring an angle which has a distance over that horizontal, correct?
What do you mean distance over the horizontal? I don't care what distance away these things are. I'm measuring the angular separation between that horizontal and whatever the thing is that I'm looking at. I do not care about
it's over
distance.
the horizontal. So it's over the horizontal.
It's relative.
Over the
The
horizontal
angle
plane.
is relative to the horizontal.
Exactly. So
Okay.
you have to admit that horizontal is just straight line. It's a
Yes,
straight
it is.
reference. It doesn't. Okay, great. Now, to have a distance over a horizontal to your vertical means you have
I
two
don't
straight
care.
lines.
I don't care what
Means
the distance is.
I didn't say care, but I'm saying it means you have two straight lines. Correct?
Yeah, like the horizontal is definitely a straight line, and then I'm just measuring the angle between that and whatever the angle is that the light comes in from the other object.
Right.
Do not care
So
about distances at all.
I
We're
never
just measuring
said
angle.
yes, and that angle lies perpendicular on the lines,
Perpendicular to what? Where?
vertical and horizontal.
You're going to have to draw this. Where's this perpendicular? The only perpendicular is the perpendicular between vertical and horizontal.
Vertical and horizontal, exactly. Which you're standing, which is your zenith.
Right.
Right. Now look at it as a L square as a square. That
Square?
star
Why?
that you are measuring, I'm just saying, just look at it as, imagine it as a square. That corner, you in a corner by a square, that luminary is in another corner, that star.
So you're drawing a
star-
big square and a triangle. Two triangles.
Yes, two triangles.
Okay. Why?
Because I'm showing you that it lies perpendicular to one another.
But the corners of that, the other two corners are off in fucking space somewhere. What's the point of that?
They fall on the same plane of reference.
Let me draw what I think you're saying.
Because that star is on the same 90-degree horizontal than yours, because it's over the same horizontal plane.
Let me draw what I think you're saying. That's all.
That's why when you guys beg the question, you have to stick it to the center of Earth to have the parallel.
Yeah, take a photo of that and I'll post it in the chat.
Now, just tell me when it's in the end of the side.
Yeah, one sec. All right, it's in the chat. All right, what the fuck is that corner? That's what I think you're trying to describe.
Livestream chat.
Yeah, it's the GP.
That's not the
Let's
GP.
see.
That's not the GP's on Earth.
Well, I don't know what that.
Okay,
circle,
yes,
I don't know
yes.
what that
That's-
circle
okay.
is. That circle.
Okay,
Circle's the Earth.
Ruf, I thought you said there's got nothing to do with the ground. So why are you putting a circle underneath the man?
I'm showing you what it would look like on a globe, and you're trying to draw this triangle, right? What's this triangle?
So the GP of the star doesn't touch your globe at all, then?
Yes, the GP is on the surface. It's not a
No.
triangle. That's what I think you're getting at. You think this is a triangle. It's not.
Sorry. Is
It's
everybody
not a
seeing what I'm
triangle.
seeing here? First of all, you said you're not having any globe underneath. You put a globe under guy.
Right.
Then you're saying the GP of that star is touching the globe, and it's not touching the globe at the same time.
That
You drew a
corner of that
triangle.
triangle, right? That corner of the
triangle and
triangle,
said it's not a
WTF,
triangle.
is not the GP. Do you want me to show you the actual geometry for celestial navigation?
No, don't do that because
That's not
what's
it.
his name
That's
told you
not
what,
it.
remember? Do
yes,
you remember? Do you remember the other day, Quantum Eraser told you about this stupidity that
All
you
right,
pursue?
now check the chat for the actual geometry of celestial navigation.
Oh yes, that's the one you sent. Remember when I
Yes.
said you put it to the center of Earth? You know, okay, you know where that 0 is? Where O is?
Yeah,
That
center of
also
the Earth,
has
yep.
okay. That has a parallel vertical as well. A parallel horizontal. Correct?
But then if you extend it to the surface where it like hits the equator, then it's not horizontal there. It's just a parallel line to that horizontal. It doesn't become a horizontal to
You see what
that
I'm saying?
observer.
You duplicate. You're just duplicating the angle you measured in a plane reference frame. That's all you did. You just duplicated it.
I've moved the angle down, right, to work out the distance between the observer and the GP, right? That's how you work out the distance.
You've duplicated it.
Yeah, I've moved it down so that I can
yes.
work out the distance from the observer to the GP.
So let's break it down, Ruf. So let's work. No, Ruf, you don't even need to do that to work out the distance. Once you've
How do you
measured
work
your
out the
angle,
distance?
yes, once you've worked out your angle, you're literally just taking your angle and timesing it by 60 to get your nautical miles. You don't
Why?
even need to do that.
Show me the geometry for your 60 nautical miles per degree. How do you get 60 nautical miles per degree?
Easy, it's a distance. I can make it Zoid links if I wanted to. It doesn't matter. The distance is simply what you measured in the sky. You're already moving away from...
Sorry, what you measured in the sky. How did you measure a distance in the sky? Did you go up there and
with a
count
90
it out with a
degree.
ruler?
Every
You're going to have to
degree...
draw this.
Every degree is equal to a nautical mile, correct?
Every minute is equal to a nautical mile. Where do you
minute
get
of
that
degree.
ratio from? Where do you get the ratio from? You're just making it up as if you traveled like 1,000 miles into the sky and measured it with a ruler. How do you get the nautical mile per degree?
It's called calculated.
How? Show me how. My diagram shows you how you get 60 nautical miles per degree. How do you get it?
Yeah, after assuming a globe after you've already...
Yeah, fine. But that's where it comes from. Where do you get it on a flat Earth? Show me how you get 60 nautical miles per degree.
You've taken you're measuring a celestial object in the celestial sphere, correct? That's the distance you're actually measuring. It's angular measurements.
How are you getting the distance? How are you getting the distance?
Then you've duplicated it to bring it to the center of your Earth, and that's how you've just transposed that angular distance down to distance on your ground.
Where are you getting the distance? Where are you getting the distance from? Where does 60 nautical miles per degree come from? I've shown you where it comes from on a globe. Show me how you get it on a flat Earth.
I just did, times 60.
Yeah, do you not understand the question? Where does that ratio come from?
We can hear that question. It's a simple
Where does the ratio come from? I know where it comes from. I've shown you in the geometry there.
Yes, you showed because you used the hover sign, do you not?
That's not the hover sign.
I'm not even looking. I'm not looking, but you used the hover sign.
That's not the hover sign what I've drawn. This is just a circle, right? And there are 360 degrees in a circle, and the circumference of the circle is 24,875 miles. Therefore, for every 1 degree, it's 69 miles or 60 nautical miles. That's where it comes from.
Is a circle flat or is it 3-dimensional?
A circle is 2-dimensional, but it has rotational symmetry, so you can treat it as a circle even though it's a sphere.
Right.
Okay. Where does 60 nautical miles come from? Show me the geometry. Celestial sphere is a sphere.
Celestial sphere a circle?
It's a sphere.
I'm trying to explain it to you.
Draw it.
Trying to explain it to you. Is it a 2-dimensional sphere or a 3-dimensional sphere?
3-dimensional sphere. It's a sphere.
Okay, but when you measure it, when you measure the angle, is it 2-dimensional or 3-dimensional?
The angle is 2-dimensional.
Okay, thank you. So 1 degree, you're treating it as a circle or circumference, are you not? What you're measuring in the sky?
What's the circumference of the celestial sphere? Where are you getting? This is such a basic question that you guys have not thought about. Where do you get 60 nautical miles per degree from? What is the geometry that explains
Have
it?
you guys noticed how he's trying to obfuscate from him first making a flat baseline to get his angle measurement, sticks his globe in afterwards, and he wants to claim
Quantum Eraser told him off the other day. He got his ass kicked by Quantum
Where do you
Eraser
get 60
last
nautical
week.
miles per degree from?
I just explained it to you, a circle.
But he's a liar.
Please explain further, because mine's a circle.
Mine's also a circle. My circle that I'm measuring is a celestial sphere, not the ground.
Okay, but where does where do you get 60 nautical miles per degree from?
I just told you the relationship between 360 degrees.
And what? Is your circle also radius 3959? That would be pretty funny.
Why not? Why not? Because it's right. Yes. You know why? Why say?
Just let me get this straight. You're using a circle. You're using a circle with radius 3959 to get 60 nautical miles per degree.
Celestial sphere, yes.
No,
because
the celestial sphere is effectively an infinite radius. Right? That's not.
According to your globe it is, not against the flat Earth. There's a difference. Remember the reference.
Can I just
The
clarify
reference for your
what I just heard?
the reference.
Did you just agree that the rate of a radius of 3959?
No, I did not agree with that because there is no radius. I'm saying the celestial sphere apparent radius is based on that, and you guys might want to pay attention because soon Brian, Logic, and Q and them have quite an interesting thing that's going to demolish that whole argument.
Oh, I'm sure it does.
We actually had a
I'm sure
meeting
it
about
does.
it 2 days ago.
Yeah.
So it's still not getting to where you get
Yes,
the 60
because
nautical
it
miles.
shows your radius to be talked about.
Yeah.
Easy.
So we're,
Explain
so
to
we're
you.
at the center.
A circle.
Apparently, the
What is a
observer's at the
circle?
center of a sphere, and that sphere has a radius of
No.
3959.
No.
No. Okay.
No.
How about you have a think about it
You
for
are-
5 minutes, and I'll get some dinner. Yeah.
If you actually listen to what I'm saying, you'd understand, but you don't want to understand.
You need to draw it, I think, is the key. Anyway, give me 5 minutes. You have a think about it, and I'll be back in 5.
I think even for your own sake, you need to draw it.
If you have an X and Y inside a circle to circumference, every angle between, you get your every degree works out to be your 60 nautical miles. It's as easy as that. Like I said, I can make the distance voidless if I want to, because it's called nautical miles. Flat.
And because you're measuring your distance, with you moving across the surface, you can't do that on a flat surface. Thank you.
What? You can't do it on a flat surface? Since when? You can only do it on a flat surface. He just measured the distance using the flat surface, remember? That's how he got his angle. He agreed that you had to have a flat surface. You guys are literally taking a flat baseline measurement and then just duplicating it to the center of your Earth to get your so-called zenith distance. That's all you're doing. You're taking it from flat.
If you'd thought about this with any amount of depth, so you would have an answer to that simple question of
I have
how
been
do
answering you 10 times.
backwards or forwards, how do you get 60 nautical miles per degree? It's just, you would need
Draw
an
a circle.
answer to that. Why do we get a linear measurement?
Take a
Draw a
circle.
circle. Yeah, show it to us. I'm not
Okay.
going to be able to draw a circle in my head.
I can't
Your
right now.
number.
I'm outside.
You
Draw a
draw it.
circle.
Draw it out and explain it. Draw the lines and show how you get your relationship.
Take your
Or
circle.
stop lying about it. One of the two.
Take your
I don't think
circle.
he's lying. I just don't think he's thought about it.
No, he knows. He knows.
Kind of crap. You can take a circle and you can measure it. That's how it works. It's a trigonometric function. That's all it is.
Sure, but trigonometry doesn't yield a linear function. 60 nautical miles per degree is a linear function. So if it's trig, then it ain't linear. If it's linear, it ain't trig.
So you're saying you can't do trig inside a circle? Are you saying you can't do trig inside a circle?
No,
Well, that's how you get. Wow, that's exactly how it's worked out. And now you're telling me you can't do it that way.
No, that's not what I said. But that's like you've effectively disproven your misunderstanding of what I said. That you're right. That is not what I said. Right? If you're using trig, you won't get a linear function. If you get a linear function, you're not using trig. Otherwise, why would you have trig? Why would you have sine, cosine, and tan if you can just times it? We've already got multiplication. Why would we come up with these weird wave functions? Right, you've seen cosines, sine waves. They're wibbly as fuck. Why would you have that? You have wibbliness when a line works.
All right, have returned. Have we figured out where 60 nautical miles per degree comes from? I want to see a drawing. I want to see geometry.
What about a different way of asking it, which is you can use the Earth to get to the Earth's circumference to get to 69 nautical miles per degree, or you can use the 69 miles to get to the circumference of the Earth.
So even if you can't figure out where you got it from, you can figure out where you're going to, right? You can do it the other way around. Can you do that? What happens, Flaxoid, when you get to 360 degrees? So the same
You just
star
work.
is now dead ahead above you. How far have you traveled?
You traveled against your circle.
Right. Have you traveled, say, I don't know, 24,000 miles?
If you take it as a circumference, you're just taking it to reference of what you made. Listen, you're taking it
So
to
what you've
reference of what you
moved
measured in the sky.
across the surface, what you've moved across the surface of the Earth, come back to where you used to be standing and found a circumference.
Listen, point A is where you're looking in the sky. That's the start of your circumference. You're measuring the sky circumference because it's perspective. It's dipping down. Do you understand? That average of 1 degree is literally what you are looking in the sky. You going on the surface of ground is not got nothing to do with how the stars are shaped in the sky or the ground shaped underneath your feet. If you're walking straight, it's perspective that you're measuring.
Anyway, my questions are in the chat. Can you see my questions? I'll read out the questions anyway.
Yeah, I read out.
Yep. So question 1, what is the geometry that justifies dip correction on a flat Earth? Question 2, why is there a refraction correction in the almanac if angles require straight lines? Question 3, what is the geometry that justifies 69 miles per degree on a flat Earth? And question 4, on what map are you drawing your circles of equal altitude? Feel free to address any of them.
Can I make a video of it for you? Be
That'd
much
be
easier to explain.
fantastic. Yeah,
Much easier to explain.
that would be fantastic, yes.
Awesome. But I'm glad we've already established that you do not use the curved Earth to have
Demonstrate. You actually going to demonstrate finding your location using flat Earth math?
I have already. By
Oh,
the way.
Did you
That's why
claim?
Mactoon. That's why Mactoon keeps running away from me.
Did you claim what's
He
the
gave me
solution?
He gave me 2 locations, which I got right. He conceded I got right after running away for a while. Then told me I'd use globe map without explaining how I used globe map to get it.
Make a video. Make a video showing how you got the solution to his challenge, and we'll show you where you use globe math for sure. You're really low,
Getting the
Howard.
solution right. Getting the solution right's awesome. Well done for that.
Yeah, that's how I know you're lying to people. You're not being honest.
Getting the solutions right is fantastic. But I mean,
Yeah, show us how you got it.
If you're using 60 nautical miles per degree and you can't answer Ruhif's question 3, then you've got to concede to
Okay, let me do it this way.
An explanation.
Let's do it this
you
way.
live on a sphere and you're using that spherical geometry to find
Okay.
location. So
Yeah, the circle of equal altitude is the killer.
Okay, you take your 90 degrees, you minus the angle measurement of the star, then you're going to minus or plus the declination depending on the time of year, then you're going to get your latitude. With your latitude, you can be able to get your distance. Simple as that. It's a grid system. Latitude and longitude is grid system.
Okay, so given
That's how you
those
get your
3
distance.
angles, given the 3 angles that MC Toon gave in his challenge, show us how you got to your solution. Make a video. That'd be fantastic.
Going to differently. Like I said, just make them up PC. I can make a proper video.
Yeah, that'd be fantastic.
Great.
And we'll show you where you use the sphere. Say again,
Did I,
Harry?
use a sphere, did I just use a sphere by explaining to you?
Say again?
Did I use a sphere now by explaining to you? I'd get the distance.
you failed to explain it.
Yeah, when you
90
draw
degrees
circles,
minus.
when you draw
90 degree minus your angle, elevation angle.
right,
Then you're going to plus or minus your declination angle depending on the time of year you are. You get your latitude. Latitude and longitude are just literally, latitude and longitude are just simply grid systems. You get your distance through the grid system.
yeah.
There we
Put
go.
it
No
together.
globe need.
Put it together in a video.
Yeah, probably so. Because I already did that. You can actually go check that. Triangulation from the sun, that's the one video. And the other one is declination on the flat earth.
No, solve MC Toon's specific challenge. Not doing like meridian passes of the sun.
Okay.
All right,
Yeah,
that's not the challenge.
Yeah. No, this wasn't the challenge, obviously.
Okay.
But
All right. Well, we know that we can get
told me.
the latitude from the declination of the sun. Yeah.
Ah, there we go.
Yeah.
And did I
But
use
it's
the globe
not.
to get it?
Did you use the globe to get it? Yeah.
Hmm?
That's a good
Did, what
question.
did I use the globe to get it?
Yeah, I don't know. I have to think about it. I mean, the declination of the sun would actually incorporate the 60 nautical miles per degree as well. So I'm going to say you probably
Yeah, it
did.
does.
No.
Sun's just got a GP at any given point. If you're using 60 nautical
Yeah.
miles, like that's the trick with McToon's challenge. The way he's got it, you can't use 60 nautical miles. So if you're using that, you fail.
Yeah, I'm happy. I'm happy for you to use it anyway. Like some flat earthers go, oh, it's an observable fact that if you go back 60 nautical miles, then the thing will drop by a degree, right? That's fine. The killer is that you will not be able to draw circles of equal altitude.
Why? Because you're taking a. You think that people are using distance maps.
I missed that.
Because you think someone's using
draw them on a map.
Yeah, you got to draw them on a map.
You've got to have
Yeah.
a map.
I'll put it on a map for you. It's fine. It's
Okay.
not going to be a Gleason's though.
Okay, I bet it won't. I bet it will be a globe. If you get a solution, you will have used a globe.
Have the bill, please.
A globe is not a map. A globe is not a map, by the way.
Whatever.
It will definitely not be drawn on a globe.
Well, if you're going to get the correct solution, I
It'll be
guarantee
drawn
you
on a
that you
grid
will be.
system.
Okay.
It'll be
And they're
drawn
going to
on
be
a grid
circles?
system.
Are they going to be
Obviously,
circles?
that's what we call
Okay. It's like you and Brian's Logic and whoever are going, oh, we've got this big trap for him, and I'm sitting here going, like you're going to use a globe.
I've got no trap for anybody. I got no trap for anybody. Is
You,
what I'm
you
telling
keep
you.
covering
Yes.
your microphone.
No, like I said, sorry, I'm outside. I'm busy picking up the
All right.
and stuff.
Anyway, I very much look forward to a video actually solving MC Toon's challenge. And yeah, I guarantee you that you will use a globe if you get a solution.
Okay, you say so?
Yes.
You mean the celestial sphere?
No.
Yeah, celestial sphere is based on horizontals, and they're still ignoring that though. But
Based on horrors, this like in the debate, did you get to the point where John clearly had no idea what the celestial sphere was?
I watched the whole thing, even when he ran away.
Yeah. Look, he said that like it contradicts the celestial sphere, and then I asked him like what are right ascension and declination, and he had no idea. Like he doesn't even know what the celestial sphere is, but somehow claims it's a flat Earth model, or some things contradict the celestial sphere model. Like he clearly had no idea what it was.
The thing is, the celestial sphere is based on a horizontal plane. That's
No,
what's
it's
flat
not.
Earth.
It's a sphere. It's a sphere.
No, no. The observer takes the horizontal plane and then to the sphere.
You cut out again. Go again.
The observer takes from the horizontal plane, measuring to a sphere. That 90-degree GP sits on that horizontal plane.
The GP does not sit on the horizontal plane.
In
It does
celestial
not.
navigation, that's why you created a duplicate angle.
You guys think that this is all a big right angle triangle. It's not. It will not work. I would love for you to try it, but it will not work.
Well, it has since the dawn of time, Ruhif.
Show us how it works. I'm telling you it doesn't. Please show us how it works with a big right angle triangle.
One thing I do like about you, Ruhif, though, is you're very just calm and collected and talk. So I do like that. I appreciate it.
Thank you, Flatsoid. I did get a little bit fiery. That was fun. Anyway.
Oh yeah, Ruhif and Witsit went at it for like an hour.
Oh no, that was me actually having a go. Yeah.
You guys were having a go at each other. It was
that was fantastic.
It was a brawl.
Yeah. What can I say? I might go and have some dinner. But yeah, Flatfoot, I would love to see a video where you actually take his challenge angles and my 4 questions, address those 4 questions.
Awesome. Yes, I'll definitely do it for you.
I've
That
enjoyed
would
the
be
chat as
magnificent.
well, guys. I gotta drop off.
Yeah, I'm gonna have some dinner. All right, I might be back.
Okay,
soon.
enjoy.
All right, see you.
Okay. Cheers. Dude. Ugh. It's actually difficult to explain it like this if you can't really draw it out.
Yeah, I posted a couple ones I had in the chat there. I'll repost the one again that kind of just fits, I think, the basic structure. So Flatsoy, do you think the 3959 number is the field of view that we have?
Yes, definitely. Yes, definitely. It's all got to do with your perception. I mean, if you got the angle of the star going down into the limiting angle, which is just based on perspective, obviously that's all you can see.
Right. And that's
because
what
remember
that's like you said, they invert it. They use that to the celestial sphere, and then they transposed it, like you said, into the globe, and then reverse engineer the radius to come from inside the globe, and then just assume the curve.
Exactly. They just literally duplicate that angle to the center of the Earth. That's why their reference is from Polaris to the equator, and that's how they've got their circumference. They've just duplicated the layer. All they've done.
Yeah. So inside of a stationary, like on a stationary plane within some kind of larger system of spheres, really, because you would have your field of view sphere, and then you have whatever the Earth is beyond, the like larger size of it, like if whether the whole thing is a sphere, like a toroidal field. But yeah, they've just taken, and that thing is spinning to some extent, because I mean, the sun, moon, and stars are moving, so there is some kind of a spinning vortex to it as well. So it's like being on a stationary plane within a spinning sphere, within a spinning like celestial sphere, whereas they invert it and say we're on the outside of a sphere, and then they have to make the stars infinite light year away. Then they have to start to make the Earth spinning, and it's just like a complete inversion of like spinning sphere geometry and planes.
Back engineering, yeah.
Yeah.
Just back engineering. Exactly.
Yeah.
That's why he doesn't understand when I say, okay, you've hung your plumb bob now, you've created your elevation angle, which is 0, which is horizontal. It's got nothing to do with the Earth underneath, as you say. But then straight after that, the measurement you took on that horizontal plane is now transposed to the center of Earth.
Right. Yep. Exactly.
It doesn't make sense. You've taken it on a flat base, and now you've put it onto the center of Earth and said it's globe.
Yep. Yeah. Like add those into the calculated model.
Exactly.
And invert the geometry, because like there's also the idea that the sun is 3959, but that would be a little tricky because it wouldn't always be that, depending on like your position on the Earth. Whereas like your field of view, actually could be 3959, because if your eyes just have that max limit, then it's like a perfect sphere around you. But of course you're on a plane, so you're only going to kind of see the bubble above you.
Yeah. Yeah, it's all got to do with the field of view. That's why that's what those problems when they try and prove their physical curve. That's why people say why they have to reverse refraction so much. Because your field of view is why you have the curve in the first instance.
Right, and then they've inverted the perspective into a sphere as well.
Mm-hmm.
Which is part of the celestial sphere kind of as well, in terms of, well, celestial sphere could mean like that the whole thing, like the whole stationary plane is surrounded by a huge celestial sphere, but then there's also the one that would be like your little area, because we know like if you're on one part of the Earth, you're only going to be seeing that little section of the sky.
Mhm. Very simple. But they don't want to, then they ignore it totally.
And then their spinning sphere model kind of works because they're inverting the geometry of the actual spinning sphere that's surrounding the stationary plane. Essentially, the sky, the way the sky moves.
Mm-hmm. I mean, that's why when we say, okay, when you're looking at the sky, they're measuring the distance on the ground, or going that distance to the GP. They're calling it now a curved Earth. They don't understand that that 1 degree ratio is based on the sky's celestial sphere, not the ground. The ground's distance can be a triangle if it doesn't want to. Its distance is distance. It's just the point A to point B. They're taking that nautical mile now and saying it's using a globe. Because you're saying that nautical mile. Because the relationship between 1 degree in a 360-degree circle.
Yeah. Yep, and they're getting that, I suppose, because they're assuming the stars are so far away. They do still say that they have a celestial sphere. I think even the heliocentric, they even they say it's like the sphere of stars, even though they're light years away.
But that's why they have to push them light years away. Otherwise, it won't work.
Right, they have to make those lines parallel to the stars in order to then make the Earth a sphere. Because if the light rays are actually, or rays, I'm not even saying there is rays, but if the light is actually coming in that more hemispherical pattern, which is what it would.
The sad thing, I don't know if you guys have watched a Twin Peaks video. Do you know Twin Peaks?
Yeah.
Yeah. He's
Wakey,
actually
wakey,
modeled. He's actually modeled out some of the ways the stars would be with the degrees on them. It doesn't go close to each other to be able to even triangulate into that known position that they give it. They actually separate from each other with distance. They don't go close to each other. This is why they have to lie with some parallel sun rays as well, where you can see it's diverging. They stay it so far away that it looks parallel. In the meantime, it's not. Further away with something, it diverges more.
Exactly.
It's total opposite.
Yep, it's like a complete inversion. Wow, yeah. Isn't it kind of wild that the geometry of the actual Earth does at least fit a globe for them to even pull it off? Like, what do you think of that? Like, how is that the case?
Well, we were globies at a stage, remember?
Yep. Oh yeah, for many years. Although, I would say I generally accepted it, but I would not say that I deeply thought it was true necessarily or even resonated with it. Like I did accept it, I was like, yeah, but really I questioned it even when I was like a young child. I questioned the globe concept. So I feel like I always questioned it to a certain degree. But yeah, I did accept it and I understood it, pretty well, the whole way, the solar system and yeah, I mean, it can be kind of seen that way. Like the sky, you can make the sky into that if you want, but it is kind of in similar geometries that they can just invert a little bit and then still get some of the same actual alignments.
Yeah, I was the same. I didn't defend the globus with it. I just accepted because it was what I was taught. But I mean, I studied art and stuff. I majored in art. And when I actually checked perspective and stuff and standing at the beaches and stuff, I said, but hang on, something's not right. Then somehow I came into looking at the flat earth. And from then I just realized, no, something's not right. And well, yeah, I didn't defend the globe after that.
Back. I'm eating, but I'm back.
Hey, Ru.
Hello.
Hey, Flutsoy.
Platsoy's going to make a video of solving MSU2's challenge without using a globe.
Yeah.
Oh, I think his method, at least the one he described to me, only works for when the celestial bodies are at their highest position in the sky. If I understand
Sun
correctly.
triangulation. Sun's triangulation.
Oh, that would be
I know.
triangulation.
Yeah, because
Like,
you worked out
yeah,
the GP.
yeah. If you know the sun is at high noon, then you know
Yeah.
the longitude of the sun is the same as yours, so you're not triangulating anything, right?
Of course, you triangulate. You completed a triangle to get your latitude and longitude based on observing the sun in the sky at a certain time of day.
Well,
And your
you
distance.
didn't do any trig to do that, right? How are you doing triangulation without any trig?
Go and look. Go and look at the video that I said for Mr.
Well,
Two
you already
Suns.
explained your method.
You'll see it.
Yeah, you already explained your method, right?
It shows me
And
two on there. It says 2 suns with the question mark.
Sorry,
It shows the
your,
trick there.
your video, Flatwood?
Yeah,
What's
my
it called?
video.
And what's it called?
2 suns.
Two Suns.
yeah, well, the thing I already brought before is that you can't know exactly when solar noon if you don't know your location. The reason why it worked for you is because you already had your location, so you already knew when the sun would be at its highest point in the sky. So that makes things a lot easier.
But you could sort
No,
of just
you
measure
can-
the shadow multiple times, right?
No,
You-
if you're in a
sorry.
boat, you don't have that luxury.
Okay.
You can see where the sun rises and sets on a boat, do you not? And at night, you're obviously going to see which constellations you see. So you'll know if you're in
Sure.
the southern hemisphere or the northern hemisphere. And usually, when you're on a boat, you have a compass and time with you. So I feel sorry for someone who
Yeah,
doesn't want to
but
take a compass with it sailing.
no. Even if with a compass and with time, the only way to be sure when it's solar noon is by taking like many readings of the sun when it seems to be getting at its highest point in the sky.
Yeah, you're just observing it. When you see, okay, it looks like it's starting to go down now. This
Oh,
seemed
now
to be the
it's
highest
kind of
sun.
too late, right? If
No, not
it
actually.
seems that it's starting to go down, it's
Yeah,
too late now.
yeah, where I'm in the south, you can easily see when it's solar noon because it literally looks like it's going up and down. You can see when it's at that highest point. It's not like it just takes a second and it's going down all of a sudden. It takes time, so you've got more than enough time to take multiple
So
observations.
that makes it
In
more
solar noon.
complicated because the
No, it
slowest
doesn't.
the sun is, the harder it is to notice when it's at noon.
But you will know when it's solar noon. It's when it's the hottest time of day, when it's on the top. What's the problem?
Yeah, but like the sun moves,
And you're gonna
moves
have,
very
and you usually
slowly.
got, and like I said, you usually got time with you. I mean, if I got my watch and I know, okay,
That
I
doesn't
know
help.
it's between 12 and 1 o'clock. I know I'm in the southern hemisphere. See, this is
But
dark noon about.
That's for that's for the time zone of where you were when you had your clock. That's not for anywhere on Earth. As you move to a different longitude, the time of solar noon is going to be different. And 1 hour gives you a huge difference in the position of the sun.
Yes, but you got more than enough time to do your observation in that hour.
Yeah, but if you do in the beginning of the hour, or in the end of the hour, or in the middle of the hour, those are going to be very different values.
You think if I'm going to take it, let's say 20 minutes difference, it's going to make such a difference that I'm going to be off course?
You're going to be away.
20 minutes,
your
how many
margin of
degrees
error
of rotation is that?
Rotation of the sky, the sun.
20 minutes is a third of an hour. That's 5 degrees.
Yeah.
5 degrees of rotation.
Of the
Yeah,
sun.
which is, let me see, 300 nautical miles. Yeah, that sounds like way more off than what people usually get with celestial navigation. But anyway, I feel like that's not even the point. The point is that the method you described only works for solar noon, right? So if
Yes, that
the
was
sun-
specific for the sun, for solar noon. Yes, I agree. I didn't say any other.
right. So I mean, talking about celestial navigation in general, where we usually take star sites that are not going to be at their highest points in the sky, how would you then find your position?
I'll make the video and I'll show you.
Yeah.
You
But
can describe it
simple.
now?
It's
No,
the
he's going to
same.
make a video.
That's why you have the declination.
Yeah,
Yeah.
you'll find that it won't work. But anyway, let him go. Let him try.
All right.
Yeah. Let him try, not let him off the hook.
Well, when you told me you got the declination in that video, you said you didn't use the almanac, right?
No, you get the declination. Even your almanac's declinations is based on observations through centuries. It's not got to do with the globe, though. It's simply this is the time I see this GP. The difference is on a flat Earth, it's got to do with the distance the sun or star, whatever, has moved away, and based on perspective, that's how low it is in the sky, based on the season. With your globe, you guys are just transposing that as the curve.
How declination?
Why?
How declination has to do with perspective?
Easy. Declination is based by looking at the observation in the sky. That declination is how low it's sitting at a certain time.
Altitude, really.
Yeah. The difference is on a flat Earth, it's because of perspective why it's converging into the horizon. With you guys, it's because of the curve and you guys are rotating away. Understand? It's still exactly the same.
Perspective is observer dependent, and the declination
Yes.
of the sun is the same for everyone.
Yeah.
So I'm not getting it.
If I'm seeing something at 35 degrees and someone else sees it at 35 degrees, the perspective is still the same. The angle is still exactly the same. You're just seeing it from a different side of your circle of equality, you could say. Yeah, I have to go.
Sure, but that's not.
Gotta get to the shops.
That's not what I'm asking.
All right, we'll await your video with bated breath.
Okay. Cheers, guys.
Cheers.
Thanks for the chat. Definitely.
No worries. It was fun.
Will you just send those questions and stuff also to my private chat, maybe?
Yeah.
Awesome.
Yes. All right.
Thanks, man.
Cool.
Okay. Cheers, guys.
All right. Yeah. Cheers, Flatsoid.
Private. Hang on. Whoops. Do. Hopefully he's a regular. Excuse me.
I don't understand what he means by declination.
By what?
By declination.
What he means by declination.
Yeah.
It's the angle. That's what makes the angle.
What angle?
The angle between the GP of that object, your feet, and your eyes, and that star.
The declination is not. Yeah. The declination is not observer dependent. Right. It's celestial sphere. Center of the celestial sphere. Latitude,
so,
basically.
for example, if first, like he said, he used the declination of the year, of the time of the year, and it turned out he was referring to the declination of the sun. So, for example, at the time of his observation, the declination of the sun was 10 degrees. What that means is that the latitude of the people that can see the sun overhead is 10 degrees north. So, I mean, that's not observer dependent. Like, it's 10 degrees. That's just where the sun is. What's the latitude of the sun? But he keeps referring to as, every time I ask if that's the case, he agrees. But he goes on and then talks about declination as if it was something observer dependent. So I don't understand what he means.
Yeah. I wonder if he can do a transformation between, right ascension and declination into altitude and azimuth. I wonder how he'll do that.
Well, the method that he described actually does work, but the problem is it required both latitude and longitude, because if you're sighting the sun at solar noon, then the right ascension of the sun is already your longitude.
Yeah.
I mean, not the right ascension, the Greenwich R angle of the sun, because the right ascension is sort of
The opposite direction.
fixed. Right? Yeah, it doesn't. No, and it doesn't move with it doesn't move with Aries.
Yeah. It is the relative position of Aries, right? So.
Yeah, relative to Aries. Yeah.
Yeah. What else was I going to say? Yeah, his idea of declination is a bit odd. I mean, who was I saying to the other day? Actually, it was in the debate, I think, where
It's just more simple than this, dude. Like, it really is simple. Like,
if it's simple, then show us how it works on a flat Earth.
X, Y, Z coordinate system. That's it.
Okay.
Like at the end of the day, it's just like the Earth obviously extends out with level water and land coming up out of the level water, sans the tides. And we just have elevation, declination. We see within a 3959 radius sphere, and we're within a much larger, perhaps, sphere on an even larger level. But that's where the 3959 comes from. It's not the radius of an Earth. It's just your
If
field.
you think it's simple,
Which
then
of course
show us how it's done.
makes pretty good sense too. Because if you take about an 8,000 mile stretch, that's about what you would be able to see when it comes to the sun and so on. So it's actually fits.
Right. But if you think it's simple, then go and claim MC Toon's 10 grand.
Well, I have no interest in anything he's offering in that sense, but I think I've said probably so many times that whatever you're referring to him and his thing, what I've said multiple times is this: you have to have the correct map first, and then you could do sightings on cue.
Mm-hmm.
So let's just say you and I were just washed up ashore one day and we're just boom. We have no idea where we are. We're just on the ocean. So we build a boat and we start going around. And we start taking angles to stars. We take a little coconut or piece of wood. We carve it out. We make these little holes in it. And then we start navigating around. And if you navigate using right triangles, declination, the whole 9 yards, like those ones I was posting earlier, just that the plane, X, Y, Z axis, etc. All of the things you're describing that you think fit a globe actually fit that. And that's the way humans have been doing it since the dawn of time. And continually drawing those right triangles with the GPs and the distances, you're able to map out a region. So if we did this with our little coconut sextant, we're out in our little boat we made, eventually, as we keep just angles, measurements, you keep doing it and you start to build out a map. Once you then have that map that you verify with the GPs, circle of equal altitudes, all verified to the actual land, then someone could say, hey, where am I if it's this angle and that angle? Then you could give them the correct location. Now, you would have to say it's this dirt over here. You can't just call it like something that the globe map claims. I'm saying like the actual physical dirt that's in that section. And at that point, you then would be able to do what he's talking about. Because what you guys are doing is you're taking the one given to you and then using that as an assumptive coordinate system that you then think is proving that coordinate system, but you don't have any verification for that coordinate system in the first place. So you have no way to decipher whether it's just a spoofed system and it's just a made up model or whether it's reality, but you somehow want to push it as reality.
Okay, so we need a map. All right, do we have that map?
Who's we?
Well, does humanity possess the map that you're talking about?
Humanity? Are there humans that are aware of this map? I would say yes.
Okay, do navigators on the ocean for the last 400 years, are they in possession of that map?
The real one?
Well, whatever map they're using, right? People do celestial navigation. What map are they using? Are they all in on it?
They're using whatever they're using. What does that mean?
Or are they using a globe or some secret flat Earth map?
I don't know what they're doing. If they're really doing celestial navigation with a sextant, then you don't have to start with any map at all. You're actually making the map.
No, we've known what the map is for a very long time. And the geometry of celestial navigation requires a sphere. When you try to do it yourself, you will understand why it requires a sphere.
A celestial sphere. Your field of view.
The Earth being
how
a sphere.
the whole system works. The declination angle, azimuth, the distance, the altitude, elevation angle. It all works within the coordinate system of the XYZ axis, where if you do XYZ, those lines are all going off. I mean, you could draw a sphere at any point. You could draw one close in or far out. So that just naturally makes a sphere because you have XYZ, you have, vertical, horizontal, etc. So you have that which is like the way a gyroscope is, etc. There's a lot of correlations with that structure. But once you have that XYZ axis, then by default you have a sphere around you because that makes arguably infinite spheres going out from those lines. It just keeps going sphere, sphere, sphere. So whether that's your field of view or whether that's your, your aura, other components that are layered like that.
Okay. So when I said that the only way for you to figure out that that it requires a sphere is to do it, you kind of went into a bit of a monologue.
It doesn't really require a sphere. It uses the celestial sphere of the field of vision because that's how humans are designed and that's how this world is designed. That every time we walk outside, we look up and we see a consistent section of the sky. It's almost like our eyes are animal eyes and they have a certain way of working. They're able to see a certain distance in addition to the conditions, because obviously if it's super cloudy and rainy, you're not going to be able to see very far, but if it's really bright and sunny, you might see much further. So obviously with it, that component as well. But we all know what it's like to be out on an incredibly clear day. It's a consistent circle field of vision. Call it a hemisphere, call it whatever you may want. And that's been known about since the dawn of time. And that is used in the fundamental geometry of how celestial navigation works and how perception of how the ground links to the sky is interconnected.
So between the two of us, one of us has gone through the process of celestial navigation. Do you know who that is? That's me. One of us has not gone through the process.
I'm here laughing at your just...
Well, it's interesting that whenever I say that if the only way for you to understand why it needs a sphere is for you to do it, and then you launch into a monologue without saying, oh, yeah, okay, I'll try and do it. That's telling.
Well, I don't know why you're assuming what I haven't done, and I don't know why you're using some strange...
I know that you haven't done it because you're a flat earther.
Passive-aggressive little move.
It's not passive-aggressive.
Oh, my God.
I know that you haven't done it because you're a flat earther. Do you not find it interesting that not a single flat earther has done it?
I think that will be an ad hominem.
Yeah, you're just making random attacks, not even based on anything
not that it's
related.
It's not an attack. It's a fact. It's not an attack.
Not even related to anything related to me, so I'm just kind of letting you just vent until we can move on and actually talk about something.
What are you saying, Bacon?
I wanted to make a slightly different point.
It's just an inversion of the sphere, dude. We were just talking about it. They've just inverted the spherical geometry. If you're still tricked by it, I got you, but it's just not what the Earth is.
Okay, then do it with an inverted sphere. Do it however you like. I did. I messaged that to him.
It seems to me that...
We will definitely do it, my friend. We got to keep you healthy so you can stay alive for at least another 10, 20 years so you can be on the journey with us. But we'll do it all, man. Absolutely. All right. I've got... Just getting started.
What I got from your response is that our coordinate system, the way we describe Earth, is not correct, right? So the latitude and longitude system, right? The thing is,
it's a patchwork. It's a patchworked thing. Yeah, it's a patchwork system. And then they inverted the geometries of perspective, and they inverted the geometries of the spherical field of view that we have, and inverted those geometrically, and then pushed a model based on assumptions to convince people and trick people.
Okay, so if you would need a map, the correct map to do that. So how are guys like Flatsoy doing that if they don't have that correct map, correct coordinate system? When they get to a result, they get to a fix, what does that mean? Like they get a latitude and longitude, for example. If they're not using the system that we're using, because that's not the right one, So
Yeah, I don't.
what is it useful for?
Well, I mean, you mentioned Flatoid. Obviously, he's not here, and I'm not going to speak for him, obviously. So you'd have to ask him about that in particular. But the way that, if you want, his perspective on it. But I would say, that what I was saying originally, that all you need to do is create a, like I said, a GP and start making circles of equal altitude, and you'll be able to create that matrix, and it will work on a planar coordinate system. So all you have to do is do that within enough of a range of the Earth to see the actual planar geometry. And they know that the reason they're doing the globe deception is because they know that you're not going to actually do that. But once we do,
so that wasn't done yet, right?
Yeah. So I mean, if you already have a map based on that, then you could just go off that. But like I've said before, like if you were building, I mean, dude, it's pretty easy. Like all you have to do is start traveling towards a star. So it's that easy. You just get in a boat and you're like, I'm going to that star. You take a freeze frame of the sky, let's say like 3 a.m, freeze frame. Then you have to adjust it for 4 minutes every day to account for the sidereal day and the 4-minute difference between the stellar day and the solar day. So you just adjust for that 4 minutes, and every night you're getting one. If you adjust for that 4 minutes, you're getting the exact same snapshot of the stars. Every night you're getting a reminder of it, right? So right at that moment.
How's the use?
And now you have a grid system that every star has a GP on the Earth. So all you got to do now is just start traveling towards one. Get in your boat and just go. Now you can actually go off course, like even in a 24-hour period. Like let's say 3 a.m, you start aiming at it. You do your best to set your compasses, your default things and all that on your compass. And then even though it's daytime and you can't see that star, you're still going in that direction. You got your compass thing set. You're keeping it generally on track. And then at 3 a.m, you look again, and then you get readjusted, and then you readjust your equipment, and you keep going. So as you're doing that, you're running a circle to that GP. Once you get to that GP, you have a spot on the Earth that particular star is connected to. Then from there, concentric circles infinitely going out in a planar fashion are going to all interrelate with the other celestial field in the sky in a planar matrix.
We already know the
I feel like
GPs.
that's already done because, for example, if you pick an almanac, so you pick any random star and you see that in the sky at some point in the day. So say 0 day from now, it's going to be at that exact same location. And you can just look at what's the GP of that star in the almanac. Call someone that lives in that GP and ask them, is that star right overhead? And they're going to tell you, yes, it's right overhead.
Right, but
so
you
you already know
the distance. You haven't verified the distance. You're taking various things on just assumption face value here.
We're not talking about distance. I'm just saying that you don't have to figure out where the location of the star is. We already have a mechanism for that.
No, but that doesn't, just because they call that section of Earth whatever they call it, I might call it GP intersection point number 592B. They might call it what they call it, whatever they're, a city, Chicago, whatever it is, whatever that location on the Earth is, they're claiming a certain name to it and a latitude and longitude correlation to that. So it's based on their coordinate system. So you'd have to then understand how they've taken the coordinate system of the actual sky over a planar Earth and reversed it to be able to make that level of a accuracy to where you or Ruhif could walk outside and take an angle to a star, and it'll tell you, oh yeah, it's within a block of my house or whatever. That is because the whole system. I ultimately think it's piecemeal. It's kind of like a pretzel. Those like big pretzels, and they have those big chunks of salt on them. It's like all the chunks of salt are like these little piecemeal parts of it that you're within, and you'd have to really link the whole thing together by doing a big project of actually measuring the Earth to really find that part of it. So anyways, that's the deeper discussion of how they've taken that coordinate system and inverted the celestial sphere and made it to where those angles are going to match the general cities that you might be trying to do. That are on and those cities are already on their grid system, put with their distances and their map. So
I still don't see why we need to do that, because if the GP happens to be at Chicago, for example, and you can call someone that lives in Chicago and ask if the star is overhead. So regardless on what the coordinate system is, where it says the star should be overhead, actually is overhead, and you can confirm that whole longitude. So if you the whole latitude, because that star that is over a certain latitude, you should keep on that latitude the whole sidereal day. So you can call anyone that tells you that live in that same latitude and asks if that specific star passes overhead, and all of them are going to confirm you that yes, that star passes overhead, and that is what actually that latitude means. It's the latitude that star passes overhead. So you're that's confirming what the latitude of the star is, and you can do the same for longitude. So longitude is just like how long it takes for that star to pass over your head. So if it takes
they're just inverting
12
the
hours.
celestial sphere physics and putting it onto a fabricated globe model system that you haven't
No,
measured
that's
the
not even a
actual
globe.
real distances between these places. So you take that, you kind of take that as like, you take it for face value. Like you're like, okay, you assume that part of it's correct. And that's fine. I hear you. I mean, you could even say that that's quote unquote reasonable, I guess, just with the modern day like programming and stuff. But in reality, it's an unconfirmed piece of information for you to then make a whole assumption that the entire Earth is this other thing.
And what I was saying so far has nothing to do with Earth being a globe or not. It just confirms that the latitude and longitude assigned to the stars are actual locations.
Yeah, you don't have to assume latitude and longitude are globe coordinates, is what he's saying, I think.
Yeah, exactly. You can just confirm that where the almanac says the star is, the latitude and longitude that the almanac tells you the star is actually is where the star actually is, and the latitude and longitudes actually correlate to the motion of the sky, the way we say they do, regardless on being a globe or not. Even if it's not a globe, it would still correlate to the celestial bodies. That's confirmable. Then we can try to figure out what the
we've got the GPS, Geo.
Yeah.
That sounds like a name of a song. We got the GPs.
Yeah.
Oh shit.
I mean, that's confirmable. I mean, that's easy to confirm. I think
I mean,
maybe I wouldn't.
I understand how they've done it, so I don't know what else quite to say, or if there's anything else we could move on to. Something. I mean, I know how they've done it, and I know that you are seeing the system they provided, and it seems to match up in your mind. I do get that. Obviously, it matches up because they've pushed this globe model on the whole world, and there's a lot of intelligent people that would catch certain things, but it's kind of amazing how much they've missed as well. But there are astronomers, there's Stellarium, there's a Google Earth and maps and so on. So they've definitely had to take the celestial sphere of the sky. They've mapped those longitude and latitude onto certain regions of the Earth, are fudging certain parts of it, using planar sections for certain parts of it, all piecemeal together, and then selling it as a complete system that actually doesn't correlate fully with reality, but it correlates enough to kind of trick the layman, as it were.
But until you do it, whatever you say about it is meaningless to me. And probably any glober as well.
That reminds me of that guy on Shark Tank, and he's like, "You're dead to me."
Oh, what's his name? Kevin O'Leary.
Yeah.
Well,
Anyway,
there's only one way that it can be, Ruhif, because there is no curve, and this place is not moving, man.
Okay. Earth's flat and stationary. Anyway, I had an idea. Someone brought up the seeing stars through the moon a couple of days ago. I wouldn't mind sort of making some software in Stellarium and predicting when a star will go behind the moon and
Yeah, dude. Snap it.
And then we can actually get the telescope out and watch the star disappear as it goes into the moon, behind the moon.
I think George said that the
Did he?
dark part of the moon isn't
Oh,
isn't the moon. Like the moon is changing shape. It's not
geez,
there
that makes me
anymore.
not want to do it though.
And I said, well, you can actually see the dark part of the moon. And
Yeah.
he said that he can't, but like you can't. I mean, maybe he lives somewhere with too much light pollution. But
Oh, you can
like
always see
every
the dark
night,
side of the moon. The dark
Hmm?
half of the moon, yeah. You can always see the dark side of the moon, like at night time. You just increase your exposure.
oh,
Easy.
no, I mean with your naked eye. I can see with my naked eye.
Oh, okay.
Imagine for a moment, you know, like the difference of oblateness of like the globe or whatever, like the idea that's like, okay, it's like oblate and then it's, you know, okay. If you were to make it way more oblate, right? Like you were to like quadruple the oblateness, they could fudge that into a coordinate system and do a similar thing than they've done already with the way that they've made it spherical instead of planar.
We were discussing
No,
ellipsoids the other day, weren't we? Me and Bacon.
Yeah.
That's
For that to work, we
Then
would
there's
have
the idea
to.
that this whole thing is essentially like a toroidal field, like an ellipsoid.
Oh,
you know, the
we
way
would
that they
need
claim like an oblate spheroid, that's actually what this whole realm is. That
to
idea.
make it more oblate. Earth would have to spin faster. That would change a lot of stuff.
Well, if you're gonna tie that vector into it, I guess so. But yeah, I was just kind of going off the.
Right. Well, because the oblateness, let's say, keeps the verticals perpendicular to the surface. So if Earth would just become more oblate without anything else change, now plumb lines would diverge from the surface. They would be all diagonal, except for poles and the equator.
Well,
unless Earth spins faster, then they would line up again.
Yeah. Hydrostatic equilibrium. Thank you, Bacon.
You don't really need it.
You're welcome.
You just GPs and circle of equal altitudes. The circle of equal altitudes will all match on a planar coordinate system. And that's it. It's not curving.
No, I mean
the more
I know
oblate
they
it gets.
And if
Yeah,
it did it on spherical, then I could say the other way, hands down. That's it. It's, you know what I mean. So I'm not saying it is that, but I'm just trying to give you a beacon of light of hope.
If it got really oblate, then celestial navigation wouldn't work as well.
No, but I'm just saying, if you actually did it and built the circle of equal, it's pretty straightforward. If you're at a GP and you start making concentric circles out, planar concentric circles are going to make a plane of circles. And then if you're when you do another one, that's going to be a plane, etc. So all those coordinates, the planes that are all intersecting with each other, all of those little dots like spider webs all overlapping, all of those little dots are literally forming a geometry. Now, if they're planar, they're planar. If they're spherical, they will show that. So
yeah, they do. 60 nautical miles per degree.
Right. You claim that, but that's not
geometry.
That's
it's geometry.
That's just the celestial sky. No, that's a whole different thing.
If you have a linear relationship between your distance and the angle to a celestial object, it describes a circle. It's a sphere.
The celestial sphere surrounding you, yes.
No, the Earth is a sphere. The only way this works, and this is the only way you're going to figure out that it works, is to do it, right? But the only way it works is if light is coming in parallel and the Earth is a sphere.
Yeah, dude, it's just a sham, dude.
Well, show us how it works on a flat Earth, and we'll take you seriously.
Like total snake.
I'll listen to you.
It's like it's a bunk product. Like it just all you're doing is assuming and asserting it without any actual verification.
No, I've done it. I know why it requires a sphere. You haven't done it, and you're just
what do you think you
talking
did?
gibberish.
What do you think you did?
I drew circles of equal altitude. That's the big one.
Okay, then why are you discussing it?
I'm trying to get you to do it because you keep saying it works on a flat Earth.
Oh,
and
we'll
what
do
it does that.
Oh, we'll do
Okay.
it. Absolutely.
Let me try to
We'll do
address
it
something.
fully and completely for the first time in over 150 years.
Okay.
I mean, this was all usurped in the 1800s and even the late 1700s when everything happened then. So
What do you need to do it? What else do you need in order to do this? Given that we have the GPs for everything, we have the stars mapped out. You know that we have.
Yeah, you have a false coordinate system model re-engineered.
No. Bacon's point was that the latitude and longitude of the GP is correct, regardless of what transformation you want to do on it, whether it's the AE map or a globe or whatever. We have the GPs. We know the spot on Earth at which it's overhead. So what else do you need?
Okay, let me address something, because the circles of equal altitude cannot work on a flat surface because they already work on a sphere, and they cannot work on both at the same time.
Correct.
Because if you try to map
Well,
a
then
sphere
just,
on
I would say hang around long enough until we get it done for you.
Okay.
And in the meantime, you'll hold your position, I'll hold mine, and that's
What's
it.
that book? Waiting for Godot.
I was trying to give you the reasoning why it's like mathematically impossible for it to work on both. So if it works on one, it cannot work on the other one, because the distances of a sphere, the distances on a flat surface, are necessarily different. And the
Right,
circles.
but you're going off of information given to you.
Let me just
We're
give you
going
the
off
reasoning.
what works. Yeah, go.
You're just going
Yeah.
off of like a model and a structure, but you haven't verified it in the physical reality in any substantial way. So you're kind of just using it. You're just
Again,
inserting it. It would almost
Let
be
me
like
just give you my reason.
Google. It would almost be like taking Google Earth and being like, "Look, I can find you on the latitude longitude matrix." Like that's not proof of sphere.
Yeah, that's, I'm not trying to say it's proof of sphere, but let me just give you my reason. So,
well, if it's like evidence that's supposed to sway you one way or the other, yeah, I am negatively swayed by that.
okay,
It's of no use to me.
I still want to make my point. The distances on a sphere and on a flat surface are necessarily different. There's a very easy way to demonstrate that, is that you can have 4 points on the surface of a sphere. They are all equidistant to each other. That's not possible on a flat surface. So those 4 points cannot be on a flat surface, and
Why
vice
can't
versa.
4 points all be equal distance from each other on a flat surface?
Because that forms a three-dimensional space, three-dimensional shape. If you have 3 points,
Not if they're all on a planar coordinate system.
Just if you put 3
4 things
points
on
that are
a plane,
equal,
they're just 4 coplanar points.
No, 4 points that are all the same distance from each other.
You can't have them being
why not?
equidistant and coplanar. Let me try to make it visual. If you put 3 points that are equidistant on a flat surface, that gives you an equilateral triangle, right?
Yeah, I mean, plop a point in the middle, of course, and get everything you want. Yeah, there's all the.
Yeah, but then they're no longer all equidistant, because the middle one is closer to all the other 3, more than the other ones are to each other. Like now you have. Let me try to show it with it.
You got a triangular pyramid. It's necessarily a 3-dimensional shape.
Yeah, so if let's say you have this triangle, it doesn't look like they're all the same, but let's pretend they're all the same. If you put one in the middle, the lines that connect the middle one to the previous ones are shorter than the lines you already had before. Those lines are not all the same size. They can't be. So you can't just do that, because the middle one is closer to the other 3 compared to the outer ones and their neighbors. Does that make sense?
Yeah. But if you look at that second picture as a 3-dimensional shape, like a pyramid, you get it now? Gio?
Yeah, I'm barely listening to you fellers right now because I'm fully aware of all of the geometric relationships within a circle and within spheres. Yes, I'm fully aware of how all of these structures fit within each other. And what I just posted right there, the luminaries within a circle of the sky like this, put in this form, all the wandering stars, the sun and the moon, are all making indefinite geometric relationships within that circle. It's making squares and rectangles and triangles and oppositions, all of these different angles. And even some of them even make up, like they have like certain names for them, like a triangle, which is three angles that are 120 degrees. So 3 times 120 is 360. So it's just like a perfect triangle. It's called the grand trine, because 120 degree aspect is called a trine, and that's called a grand trine. But they even have ones that are called like mystic rectangles, because it's like a rectangle with it's like a certain shaped rectangle with like 2 triangles on the top and bottom. It's pretty awesome. So there's all these different geometric relationships that are formed, and a lot of them have very specific names. So yeah, there's like a fundamental like fractal geometry that works within circles and spheres and straight lines.
Okay, Bacon said if you have 4 equidistant points, it must be a 3-dimensional shape, and you disagreed, which means you don't know geometry. So please show us 4 equidistant points on a flat plane.
No, he was saying they're equidistant from each other.
Yes.
Yeah,
4 of
that's
them.
not possible.
It's not possible on a 2-dimensional thing.
I thought he was talking about in a square. Like, let's say you have like each toothpick is like 2 inches long. So 2 inches, 2 inches, 2 inches, 2 inches. Is all equal from each other. So it's a perfect square.
But the corners, the opposite corners of distance. Yeah. Holy shit! It's 6:30. A few bacon.
Yeah.
Oh dear.
Still not sleepy.
Hey, you guys
Jeez,
are.
all right.
It's been a
about to go to bed.
Yeah, I should. Anyway, yeah, you guys have a good day or night or whatever.
Good night, Bacon.
Yeah,
Good
I mean,
morning.
I think eventually, Bacon, I think where you'll crack it is seeing how the celestial sphere is how they have reverse engineered the geometry to then assert a spherical model, and then using some of that legitimate geometry, using that to just assert the sphere with a whole belief system attached to it, and then gotten people hooked in through that.
Just words.
As soon as anyone presents any other way it can work, I'll be
That was
open
well
to that.
put, Theo.
This is why Flat Earth has become boring. Because it's just fucking rhetoric and empty bullshit.
That's why you've been on a marathon for the last 12 hours?
Oh, no, I'm fucking procrastinating.
Ruth, tell me
Ruth's
why
been
you're...
on here for like 17 hours right now, I'm pretty sure.
I'm procrastinating like a motherfucker.
Tell me why your claim refraction is not just words.
Because
How
we
you know
demonstrably have...
We're looking around a curve.
We demonstrably have a density gradient. Do you disagree that we have a density gradient?
I'll give you the density gradient, but I'm saying that the refraction is negligible.
Does light bend through a density gradient?
Under good conditions, 0 refraction. Okay, go.
No, incorrect. Does light bend in a density gradient?
Light will bend in sugar water, but it won't bend in the atmosphere enough to cause a mirage under good conditions.
We will talk about magnitude, right? But do you agree with the general principle that if there is a density gradient in the air, that light will bend?
For the most part, no. Like 0, 0, 0, 0. It's equal to your Tor vacuum. Okay, go.
Okay, so go ahead and see whatever videos you want to see, like the Mick West experiments, the Deng Joss ones.
Well, tell us all what was the result of the Mick West experiment? Did they have to use hot irons, or what?
No, he had a flame that he would bring closer to the line of the laser, and that would, it would induce a density gradient horizontally, and it would shift the laser.
So notice that you have to use I don't want to say ridiculous, but obnoxious effects to bend your light, right? Obviously, there's no flame torch happening in reality. Right. So I'm asking,
we're demonstrating a principle.
Can we do this with a natural observation, without flame torches, without irons?
However, we would like to induce a density gradient that demonstrates the principle. The end. Do you disagree that the principle has been demonstrated?
There could be a principle, but the principle is a fallacious a fallacious analogy because that's not happening in reality. If you need a flame torch to tell us the Earth is bending, then without your flame torch, it's not bending. Do you see that?
Whatever way we use to induce a density gradient seems to affect the direction of light. Whether we do it with a flame,
I'll give you a flame
nitrogen,
torch and irons will
or sugar
light.
water.
Since that's not happening in reality, you cannot use that example. This is
We're
like logic,
demonstrating the principle, right? We're telling you this is basically a law of reality, that if there's a density gradient, then light will refract. We've demonstrated it.
It's a science trick. You're getting a laser to bend because you're using an extreme example of something that never happens in reality.
If you disagree with the principle,
if there was a bonfire, you would do the observation on the other side where there's no bonfire. So your example is fallacious. Okay, go.
If you disagree with the principle that light bends through a density gradient, then do whatever you have to do to satisfy yourself that it does, and then come back and we'll do the next step.
I'm giving you that light can bend in sugar water and other gradients. But I'm telling you that if that's not happening in reality, you have a fallacious example. That's what I'm saying.
Yeah. When you accept the principle, let me know.
With normal conditions, then that would be more acceptable, wouldn't it? Not what I call obnoxious conditions, flamethrowers and hot irons.
When you accept the principle, let me know that light bends through a density gradient.
So you can't prove that that you're seeing around the curve under normal conditions.
It's been demonstrated.
Flamethrowers.
The principle has been demonstrated countless times. When you accept that principle has been demonstrated, let me know and we'll move to the next step.
I accept that you can do a science trick and get light and get a laser to bend with flamethrowers and irons. What I'm saying is that doesn't apply to reality, because in reality, those observations are without those conditions.
Yeah, I've said what I want to say. When you accept the principle, let me know.
Tell us how you can prove we're seeing around the curve without your math.
Yeah, we have a density gradient, and light bends through a density gradient.
But
you reject the second one.
How would you know how much light bends in 10 miles?
Yeah, we'll get there. We'll get there. That's the next step. But what's the point if you reject that light bends through a density gradient?
The point is that I'm saying that it would be negligible. The point is I'm saying that you're saying that every observation is basically a mirage or a tremendous refraction. Every long observation is 10 miles or 20 miles. You're telling me that we're seeing around the ball. But I'm saying the only time you're going to get a mirage or a great refraction is in a very specific and rare conditions, not happening normally. So in normal circumstances, no refraction. Okay, go.
15 feet. Oh, I'm not going to change what I say. Like when you come back with, you accept that light bends through a density gradient, then we'll talk about the magnitude.
How do you know it bends under normal circumstances without flamethrowers and without iron?
Because the principle has been demonstrated countless times that if we induce a density gradient, the light will bend.
So without inducing it, it won't bend. Fair?
If there's no density gradient, it won't bend, right?
So there's no light bending.
If we don't have a density gradient, then it won't bend.
No, you're bending. No. This is not what's happening. I want to show you your logic. You're bending a laser with the flamethrowers or with irons, okay?
Mm-hmm.
That is not a standard density gradient. That is an obnoxious example.
Is it a density gradient? It is a density gradient.
Throw it out. You have to throw it out.
No, it's demonstrating the principle.
Listen, you're not using the density gradient. You're using irons and flamethrowers.
Right. Does that induce a density gradient?
I just want to use what you're saying. I want to use your density gradient and show me you're seeing around the ball without irons and without flamethrowers. Can you do that?
I'm demonstrated the principle. If you don't accept the principle, then come back when you do.
I accept that you can do a science trick where you can get a laser to bend with a flamethrower.
Whenever you're ready, Godric. Whenever you're ready.
I'll give you that. But I'm saying is, since that's not a normal observation, you can't use it. You got to throw it out.
15 feet.
This is. I know you get this. This is basic, like, I don't want to say common sense.
5280.
Well, let me ask you this: how can you know it bends as much as you're saying it bends? Can you show me a real example of it happening? Maybe like over between 5 and 15 miles.
Yeah, we'll get to magnitude when you accept the principle. There's no
So
point in me going through the magnitude.
Okay, we're here. We're going to be stuck there for now, and that's okay. I'm saying that you're using a fallacious example, and that's not normally happening in reality, so you have to throw it out. And you're saying you're using a good example, even though it doesn't happen in reality, but the principle has been demonstrated, so it must be true. And since it's a gradient, light must bend down.
The typical gradient, yes.
But I'm saying you can't show that in reality.
Sorry, I can't show a light bending in reality?
Well, I'm asking you, can you?
Yeah, there's been laser tests where it bends.
Can you show me a thank you.
Sure.
I'll look at that. I'll look at a laser bending around the ball. Can you show me
No,
that?
a laser
no
bending.
Flamethrowers, no hot irons, right? Just
There's
real
a
life.
laser just bending. In fact, the FE core one. Where's the FE core one? That's a great one.
If you can get it to a short video, I'll be glad to watch it.
Oh, posted the
Let's know
screenshot in the chat. I've posted a screenshot in the chat.
Okay, let's see what you got.
Is that laser bending?
Yes.
Excellent. So lasers can bend in reality. I wish I had a better one, actually, because I know there's a better one out there.
Okay, so I'm looking at this laser. This is a green laser.
Yep.
So is this concave Earth?
No, it's just bending up.
But that's an indication of a concave Earth, no?
No, just an indication of an inverse density gradient.
Oh,
an upside down density gradient.
It's inverse. It's an inverse?
Yeah. It's light bending up because it's now less dense at the surface and more dense higher up.
We were talking not that long ago, and you promised me. I said, "Can light bend up?" You says, "No, it cannot bend up. It has to bend down."
No, I did not say that.
You said it cannot bend up because
Did
it's
not
dense from
say
the
that.
bottom. It has to go down. Has to bend down. That's what you said.
Did not say that. Light can bend upwards. How do you think we get inferior mirages?
Wow. Okay.
Did not say that.
So light can bend up.
It can, yes, when the density gradient's inverted.
Okay. By the way, what length of observation was this taken?
This was 16.4 miles.
16.4 miles.
Yes.
Yeah, well, I believe light can bend up and bend down and bend left and bend right under certain circumstances.
Not really
But
left and right, but up and down.
What you want to do as not scientists, but just as like laymen doing basic experiments, everyone can do. Okay, you want to do these under excellent conditions, right? Where the atmosphere is refraction is the most controlled.
Yeah.
Okay?
Yes. You're talking my language. Yes.
So in this example would be, whatever happened here, light bending up, obviously, but see, we can control that to the maximum, right?
Yeah. You're talking my language, Godric.
Okay. So now, where do we go now?
Yeah, we go above 100 meters. That's what we do. Because that is where refraction is most predictable.
How many feet is that?
300. See the one I posted in the chat now?
Well, that's okay, but we're going to have a problem with that because...
I'm sure you'll have a problem with whatever I say.
Because how do you get that high?
Climb a mountain.
You know what I think this is? I think this is a big dodge because you know that the average person can't go 300 feet in the air.
Oh, no, Godric, listen. When I say get above the surface, right, what I mean is so that your line of sight is, for the most part, more than 100 meters above the surface, right? So look across a valley, something like that. Not fucking getting a fucking hot air balloon.
Will it work if you go on a little hill and then you're looking over the ocean and you're looking at a skyline, kind of like Chicago skyline?
Yeah. What's your elevation? Yeah.
Well, it should be 100 meters.
Yeah, that should be good.
And we'll get negligible refraction.
Not negligible, predictable.
Hang on 1 second. Okay, so here's my contention with you. You're saying predictable refraction, or I've heard you say standard refraction. Yeah, I don't think that's happening. Okay, I think with excellent conditions, there's little to no refraction.
No,
and enough that
you'll always have refraction.
Enough that you can measure it pretty concisely, and there'd be no curvature, for example, if it was a flat plane.
No. What I'll guarantee you, Godric, is if you're above 100 meters, light will not bend up.
Wonderful. But it will bend down?
Yeah. It will always bend down if you're above 100 meters, like 99.9% of the time. Probably more, probably 99.99.
You're looking when you're getting 300 feet up, then you can start seeing around the curve. Is that your trick? You have to be that high?
That's where light will almost never bend upwards if you get above that height. See these graphs? How many graphs would you like me to post?
You posted those weather balloon graphs, which I thought you took, right. But you borrowed those. Okay.
I made the graphs. I borrowed the data.
And
But how many would you like me to post? Oh, there's one. I actually posted one. Look, there's a blue dot on the right-hand side of 0. That's one. Fantastic.
We don't know. You're making a claim, okay? But you haven't proven the claim, okay? The claim is you're saying lights. We're saying, I don't even know if it's the light bending down. I'm gonna say it's our field of view, okay? Because I don't know if our field of view will exactly follow a laser. Like if I have a laser pointer, I point it across the street. It's pretty straight, right? And let's say you get that laser pointer. Let's say I'm going to give this to you. Let's say you can get it to bend down a little bit. I don't know that our vision would be the same thing as a laser pointer. Can we talk about that?
Oh, we can talk about all these graphs I'm posting, and I've seen one dot, one single solitary dot to the right of 0 that's blue. What that means is, for these graphs, is that once you're above 100 meters elevation, light always bends down 99.99% of the time.
Can I say something? I think only you can read these graphs.
Yeah, maybe you could listen to me explain them.
We have 4 colors. We have purple, we have violet. Well, 3 colors. We have red. We have red.
We have red and blue. 2 colors.
You have only red and blue?
Yep.
So when it's purple, then they're overlapping?
They're not overlapping.
When it's purple, they're not overlapping?
It's not purple. They're just red and blue next to each other.
I'm looking at 3 different colors: red, blue, and purple. You don't see purple?
It's just red and blue next to each other. It's the same color.
And I said, are they overlapping?
They're not overlapping.
Then they would be either red or blue. They wouldn't be purple.
Right, there's no purple.
Okay, well, you're looking at different charts. I'm looking at all your charts have purple.
No, they don't. It's red and blue. It's just 2 colors, Godric. Holy shit.
There's 3 colors, bro.
No, there's literally 2 colors.
If they overlap, yeah, blue and
they don't overlap.
Blue and red make purple if it overlaps.
Yeah, they don't overlap. Okay? It's 2 colors. 2 colors. It's your eyes turning them into purple.
Fine. So you're saying that it's a red blue together, and that makes purple.
I'm saying they're not together. There are red bars and there are blue bars. They're not overlapping. They're not purple.
Okay, fine. So now explain.
Okay.
What's happening with these blue bars and red bars?
Okay, so these are histograms. So a histogram is like a counting graph, like a frequency graph. Okay, so if I'm looking The first one, right? First one is Cold Bay. Actually, not much data there. Get the second one. Second one is Cancun, right? It's got really steep peaks of the blue graph and the
Cancun
red graph.
95.
Yes. All right. There's not a whole lot of data for this one, which is unfortunate.
Just a suggestion. Just a suggestion. Do you have like Los Angeles 22? You know, or do you not have?
I've got Santa Monica 2020. Like I did these in 2021, so most of the graphs will have 2020 data.
Okay, go on.
So Cancun. This graph, the x-axis is the refractivity gradient. Okay, so this is how much the refractive index changes per kilometer vertically. All right, so anything to the left of 0, light is bending downwards, and anything to the right of 0, light is bending upwards. All right, the red and the blue. The red bars is the gradient between the surface and up to 100 meters. All right, because these weather balloons, they take measurements as they go up. So one of these dots on the red might be the gradient between the surface and like 50 meters above the surface. Right, that gradient.
Okay, you made a claim. You made a claim.
Mm-hmm.
You said that light's bending.
Yep.
How do you know light's bending?
Because there's a density gradient, and light bends through a density gradient.
How do you know how much light bends through a density gradient?
Yeah, we'll get to magnitude, but it's basically the reciprocal of the refractivity gradient. That's the radius of curvature.
So let's say under standard refraction, right?
Yep.
How much?
Yep.
What would I see at 10 miles?
At standard refraction, that equates to light having a radius of about 44,000 kilometers. So that's a pretty big circle. And then you basically incorporate that into your curve calculator, and that's your answer.
So can you give me the result of what I would see at 10 miles?
You can put that into the curve calculator, right? Standard refraction. 10 miles. The difference between refracted drop and geometric drop is about 115 feet. And that over 10 miles, 52,800. That means that the apparent position has shifted 0.12 degrees. So it's 0.12 degrees higher than it otherwise would be. And the hidden results in an extra 6 feet of hidden. Well, sorry, 6 feet less of hidden. You can see 6 feet more.
Wait. You said feet. 6 feet?
Oh, that's inches. Shit, whoops, my bad. That's way wrong. Way wrong. Hold on. That was inches.
I thought these
9
numbers
feet.
would roll off your tongue with all the experience you have.
9 feet. 9 feet. I'm in metric here. So the amount, the apparent shift in its position is 0.0097 degrees, which is fuck all. Over 10 miles.
I'm sorry, how many feet would I be looking around the curve?
How many feet extra do you get by refraction? You can see about 6 feet more of the object at 10 miles.
Okay, because this is where you want to put your math to the test. I'll say math because I don't know it's happening in reality. I'm just call it math. Because on the standard calculator, let's say the global calculator, 5 feet observer height, you have 45.
Okay, that'll change.
You have around 45 feet at 10 miles and 5 feet observer height. So if you want to subtract or add 6 feet to that, it's not gonna help you. You still don't have a ball. So now if we're testing your numbers now, they're not working out. Then
how are they not working out? You asked me what
let me be more specific. Okay, so let me get the global calculator. Not Walter Business bullshit.
Metabunk's fine. I like Metabunk. Yeah.
And I'm gonna put in 5 feet observer height.
Yeah.
10 miles.
Distance 10 miles. Observer height. How much?
5 feet.
5 feet.
Which is standard. Look at the standard. Okay. So I have 35 feet of curvature.
35 feet hidden geometrically.
Yeah, I'm gonna give you the picture. Hang on. I'm putting.
I've got it here. 35.16 feet geometric hidden, but refracted hidden, you can see about 7 feet more.
Hang on a second. Let me just put it here. Okay, 1 second. Okay, put it right there.
I have to go in like 2 minutes, by the way. Yeah, you're ignoring refraction.
I'll let you go on 1 minute. Let me do this. Let me do this one more thing. Let me copy my calculator.
All right. But you're ignoring refraction in that one, right?
Hang on a second. Okay, so under the globe calculator at 10 miles, 5 feet over height, we should have 35 feet. Can we say the bottom of the building should be 35 feet hidden?
You're ignoring refraction, so no.
Without refraction?
Without refraction, fine. Yep.
Okay, good. Now, adding 6 feet to that does not help you, does it?
Adding 6 feet to what?
To the 35.
Taking away 7 feet due to refraction, you can now, there's now 28 feet. There's now 28 feet hidden, right? You can see more of it.
Right, so 28 feet doesn't get you to 0, does it?
No. What's the problem there? Like, did I say it get you to 0? Like,
yeah, you would have to get your globe.
Why?
Because we have anybody who do an observation at 10 miles under good conditions and get no curvature. And
yeah, this is standard refraction, right?
Hang on. No. You added your standard refraction. You're saying...
Yeah, but then you're saying that you can see the base of something.
Hang on.
Right?
You're saying there should be 28 feet of curvature. You just said that.
The hidden amount will be 28 feet.
Now, I'm gonna dig up, but hopefully a few, more than one, hopefully, observations at 10 miles. Right. And if we get to the bottom of that building, or the bottom of the mark.
Do you want me to end this right now and say you're 5 feet above the surface? That is the point of the graph, is to not do your observations close to the surface. That is the point of those graphs.
Wait. Do we have to be 300 feet up?
To have predictable refraction, yes. That's the point. That is literally the point.
Okay, well, I will let you go, but let me do this.
Okay.
Well, as you do that, I'm going to put in 300 feet. Now it's not working now.
Okay. Anyway, I gotta feed the dogs. So, yeah, enjoy.
Okay. Talk tomorrow.
Yeah, he just wants to sneak in that calculation, you know?
Hey, Gio. So according to this, at 300 feet, it's 0 hidden height. At 300 feet, there's 0 hidden height because the horizon's at 21 miles. So we'll have to do, let's say, 30 mile distance, and then we'll get 51 feet of hidden height. Let's see, we do 40 miles. Okay, so here's the text for Ruhip. Okay, all right, I'm gonna post it. So he's able to basically run away from all our 10 mile observations at 5 feet 0 height because it's refracting too much. So we have to go 300 feet up. But the problem is, now, if we do a 40 mile observation, 300 feet up, we're gonna have 235 feet of hidden height. So we'll have to do a 40 mile observation, 300 feet up. And I'm pretty sure, I hope someone can do that. I don't know if they can or not. But I'm gonna post a picture. And that's when his math will be debunked. Because, oh shit, I posted the wrong one. Delete. Because Because according to him, there should be curvature.
You gotta give Ruhif some points for creativity. I mean, he's pulling balloon data and just like adding calculations to it and then making graphs. He's dedicated.
Yeah, he's committed, man. He's doing work.
Yep.
Okay, I'm gonna go. Talk later tomorrow, maybe. Good night.
All right. Yep. Later, Godric.